Hey everyone, welcome to this video on AWS full course. We will begin this full course video with what AWS is and how AWS services work, and we will be looking into a bunch of AWS services like EC2, Lambda, S3, IAM, CloudFormation, ECS, Route 53, Elastic Beanstalk, VPC, SageMaker, CloudFront, AutoScaling, and Redshift. After this, we will do a comparison of popular cloud providers like AWS, Azure, and GCP. Moving further, we will also see how to become a solution architect. We will also guide you through AWS certification exams, and in which we have explained how to choose the right certification for your career. We will then conclude this interview by discussing the essential interview questions and answers to help every individual crack an interview. By the end of this video, I can assure you that all your AWS career related queries would have been answered. For this training with me, I have our experienced AWS specialists Sam and Rahul. Together, we will take you through the various topics of AWS. So, let's start with an exciting video on AWS full course. Before we begin, make sure to subscribe to our YouTube channel and hit that bell icon to never miss an update from Simplilearn.
Meet Rob. He runs an online shopping portal. The portal started with a modest number of users, but has recently been seeing a surge in the number of visitors. On Black Friday and other holidays, the portal saw so many visitors that the servers were unable to handle the traffic and crashed. Is there a way to improve performance without having to invest in a new server? Wondered Rob. A way to upscale or downscale capacity, depending on the number of users visiting the website at any given point? Well, there is. Amazon Web Services, one of the leaders in the cloud computing market. Before we see how AWS can solve Rob's problem, let's have a look at how AWS reached the position it is at now. AWS was first introduced in 2002 as a means to provide tools and services to developers to incorporate features of Amazon.com to their website. In 2006, its first cloud services offering was introduced. In 2016, AWS surpassed its $10 billion revenue target. And now, AWS offers more than 100 cloud services that span a wide range of domains. Thanks to this, the AWS Cloud Service Platform is now used by more than 45% of the global market. Now, let's talk about what is AWS. AWS, or Amazon Web Service, is a secure cloud computing platform that provides computing power, database, networking, content storage, and much more. The platform also works with a pay-as-you-go pricing model, which means you only pay for how much of the services offered by AWS you use. Some of the other advantages of AWS are security. AWS provides a secure and durable platform that offers end-to-end privacy and security. Experience. You can benefit from the infrastructure management practices born from Amazon's years of experience. Flexible. It allows users to select the OS, language, database, and other services. Easy to use. Users can host applications quickly and securely. Scalable. Depending on user requirements, applications can be scaled up or down. AWS provides a wide range of services across various domains. What if Rob wanted to create an application for his online portal? AWS provides compute services that can support the app development process from start to finish. From developing, deploying, running, to scaling the application, up or down based on the requirements. The popular services include EC2, AWS Lambda, Amazon Lightsail, and Elastic Beanstalk. For storing website data, Rob could use AWS storage services that would enable him to store, access, govern, and analyze data to ensure that costs are reduced, agility is improved, and innovation accelerated. Popular services within this domain include Amazon S3, EBS, S3 Glacier, and Elastic File Storage. Rob can also store the user data in a database with AWS services, which he can then optimize and manage. Popular services in this domain include Amazon RDS, DynamoDB, and Redshift. If Rob's businesses took off and he wanted to separate his cloud infrastructure or scale up his work requests and much more, he would be able to do so with the networking services provided by AWS. Some of the popular networking services include Amazon VPC, Amazon Route 53, and elastic load balancing. Other domains that AWS provides services in are analytics, blockchain, containers, machine learning, Internet of Things, and so on. And there you go. That's AWS for you in a nutshell. Now, before we're done, let's have a look at a quiz. Which of these services are incorrectly matched? 1, 2, 3, 4. We'll be pinning the question in the comment section. Comment below with your answer and stand a chance to win an Amazon voucher. Several companies around the world have found great success with AWS. Companies like Netflix, Twitch, LinkedIn, Facebook, and BBC have taken advantage of the services offered by AWS to improve their business efficiency. And thanks to their widespread usage, AWS professionals are in high demand. They're highly paid and earn up to more than $127,000 per annum. Once you're AWS certified, you could be one of them too.
Let me start the session with this scenario. Let's imagine how life would have been without Spotify. For those who are hearing about Spotify for the first time, Spotify is an online music service offering, and it offers instant access to over 16 million licensed songs. Spotify now uses AWS Cloud to store the data and share it with their customers. But prior to AWS, they had some issues. Imagine using Spotify before AWS. Let's talk about that. Back then, users were often getting errors because Spotify could not keep up with the increased demand for storage every new day. And that led to users getting upset and users canceling the subscription. The problem Spotify was facing at that time was their users were present globally and were accessing it from everywhere, and they had different latency in their applications. And Spotify had a demanding situation where they need to frequently catalog the songs released yesterday, today, and in the future, and this was changing every new day. And the songs coming in rate was about 20,000 a day, and back then they could not keep up with this requirement, and needless to say, they were badly looking for a way to solve this problem. And that's when they got introduced to AWS, and it was a perfect fit and match for their problem. AWS offered a dynamically increasing storage, and that's what they needed. AWS also offered tools and techniques like storage lifecycle management and trusted advisor to properly utilize the resource, so we always get the best out of the resource used. AWS addressed their concerns about easily being able to scale. Yes, you can scale the AWS environment very easily. How easily, one might ask? It's just a few button clicks. And AWS solved Spotify's problem. Let's talk about how it can help you with your organization's problem. Let's talk about what is AWS first, and then let's bleed into how AWS became so successful and the different types of services that AWS provides, and what's the future of cloud and AWS in specific. Let's talk about that. And finally, we'll talk about a use case where you will see how easy it is to create a web application with AWS. Alright, let's talk about what is AWS. AWS, or Amazon Web Services, is a secure cloud service platform. It is also pay-as-you-go type billing model where there is no upfront or capital cost. We'll talk about how soon the service will be available. Well, the service will be available in a matter of seconds. With AWS, you can also do identity and access management, that is, authenticating and authorizing a user or a program on the fly. And almost all the services are available on demand, and most of them are available instantaneously. And as we speak, Amazon offers 100+ services, and this list is growing every new week. Now that would make you wonder how AWS became so successful. Of course, it's their customers. Let's talk about the list of well-known companies that has their IT environment in AWS. Adobe uses AWS to provide multi-terabyte operating environments for its customers. By integrating its system with AWS Cloud, Adobe can focus on deploying and operating its own software instead of trying to deploy and manage the infrastructure. Airbnb is another company. It's an community marketplace that allows property owners and travelers to connect each other for the purpose of renting unique vacation spaces around the world. And the Airbnb community users' activities are conducted on the website and through iPhones and Android applications. Airbnb has a huge infrastructure in AWS, and they're almost using all the services in AWS and are getting benefited from it. Another example would be Autodesk. Autodesk develops software for engineering, designing, and entertainment industries using services like Amazon RDS or Relational Database Service and Amazon S3 or Amazon Simple Storage Service. Autodesk can focus on deploying or developing its machine learning tools instead of spending that time on managing the infrastructure. AOL or American Online uses AWS, and using AWS they have been able to close data centers and decommission about 14,000 in-house and co-located servers and move mission critical workload to the cloud and extend its global reach and save millions of dollars on energy resources. Bitdefender is an internet security software firm, and their portfolio of softwares include antivirus and anti-spyware products. Bitdefender uses EC2, and they're currently running few hundred instances that handle about 5 terabytes of data, and they also use Elastic Load Balancer to load balance the connection coming in to those instances across availability zones, and they provide seamless global delivery of service because of that. The BMW Group, it uses AWS for its new connected car application that collects sensor data from BMW 7 series cars to give drivers dynamically updated map information. Canon's Office Imaging Products division benefits from faster deployment times, lower cost, and global reach by using AWS to deliver cloud-based services such as mobile print. The Office Imaging Products division uses AWS such as Amazon S3 and Amazon Route 53, Amazon CloudFront, and Amazon IAM for their testing, development, and production services. Comcast, it's the world's largest cable company and the leading provider of internet service in the United States. Comcast uses AWS in a hybrid environment. Out of all the other cloud providers, Comcast chose AWS for its flexibility and scalable hybrid infrastructure. Docker is a company that's helping redefine the way developers build, ship, and run applications. This company focuses on making use of containers for this purpose. And in AWS, the service called the Amazon EC2 Container Service is helping them achieve it. The ESA, or European Space Agency, although much of ESA's work is done by satellites, some of the program's data storage and computing infrastructure is built on Amazon Web Services. ESA chose AWS because of its economical pay-as-you-go system as well as its quick startup time. The Guardian newspaper uses AWS, and it uses a wide range of AWS services including Amazon Kinesis, Amazon Redshift that power an analytic dashboard which editors use to see how stories are trending in real time. Financial Times, FT, is one of the world's largest leading business news organization, and they used Amazon Redshift to perform their analysis. A funny thing happened. Amazon Redshift performed so quickly that some analysts thought it was malfunctioning. They were used to running queries overnight, and they found that the results were indeed correct, just as much faster. By using Amazon Redshift, FT is supporting the same business functions with costs that are 80% lower than what was before. General Electric, GE, is at the moment as we speak migrating more than 9,000 workloads including 300 disparate ERP systems to AWS while reducing its data center footprint from 34 to 4 over the next 3 years. Similarly, Harvard Medical School, HTC, IMDb, McDonald's, NASA, Kellogg's, and a lot more are using the services Amazon provides and are getting benefited from it. And this huge success and customer portfolio is just the tip of the iceberg. And if we think why so many adapt AWS, and if we let AWS answer that question, this is what AWS would say. People are adapting AWS because of the security and durability of the data and end-to-end privacy and encryption of the data and storage. Experience. We can also rely on AWS way of doing things by using the AWS tools and techniques and suggested best practices built upon the years of experience it has gained. Flexibility. There is a greater flexibility in AWS that allows us to select the OS, language, and database. Easy to use. Swiftness in deploying. We can host our applications quickly in AWS, be it a new application or migrating an existing application into AWS. Scalability. The application can be easily scaled up or scaled down depending on the user requirement. Cost saving. We only pay for the compute power, storage, and other resources you use, and that too without any long-term commitments. Now let's talk about the different types of services that AWS provides. The services that we talk about fall in any of the following categories you see, like compute, storage, database, security, customer engagement, desktop and streaming, machine learning, developers tools, stuff like that. And if you do not see the service that you're looking for, it's probably is because AWS is creating it as we speak. Now let's look at some of them that are very commonly used. Within compute services, we have Amazon EC2, Amazon Elastic Beanstalk, Amazon Lightsail, and Amazon Lambda. Amazon EC2 provides compute capacity in the cloud. Now this capacity is secure and it is resizable based on the user's requirement. Now look at this. The requirement for the web traffic keeps changing, and behind the scenes in the cloud, EC2 can expand its environment to 3 instances, and during no load, it can shrink its environment to just 1 resource. Elastic Beanstalk, it helps us to scale and deploy web applications, and it's made with a number of programming languages. Elastic Beanstalk is also an easy-to-use service for deploying and scaling web applications and services deployed be it in Java, .NET, PHP, Node.js, Python, Ruby, Docker, and a lot other familiar services such as Apache, Passenger, and IIS. We can simply upload our code, and Elastic Beanstalk automatically handles the deployment from capacity provisioning to load balancing to auto-scaling to application health monitoring. And Amazon Lightsail is a virtual private server which is easy to launch and easy to manage. Amazon Lightsail is the easiest way to get started with AWS for developers who just need a virtual private server. Lightsail includes everything you need to launch your project quickly on a virtual machine, like SSD based storage, a virtual machine, tools for data transfer, DNS management, and a static IP, and that too for a very low and predictable price. AWS Lambda has taken cloud computing services to a whole new level. It allows us to pay only for the compute time, no need for provisioning and managing servers. And AWS Lambda is a compute service that lets us run code without provisioning or managing servers. Lambda executes your code only when needed and scales automatically from few requests per day to thousands per second. You pay only for the compute time you consume. There is no charge when your code is not running. Let's look at some storage services that Amazon provides, like Amazon S3, Amazon Glacier, Amazon EBS, and Amazon Elastic File System. Amazon S3 is an object storage that can store and retrieve data from anywhere. Websites, mobile apps, IoT sensors, and so on can easily use Amazon S3 to store and retrieve data. It's an object storage built to store and retrieve any amount of data from anywhere. With its features like flexibility in managing data and the durability it provides and the security that it provides, Amazon Simple Storage Service or S3 is a storage for the internet. And Glacier is a cloud storage service that's used for archiving data and long-term backups. And this Glacier is an secure, durable, and extremely low-cost cloud storage service for data archiving and long-term backups. Amazon EBS, Amazon Elastic Block Store, provides block store volumes for the instances of EC2. And this Elastic Block Store is highly available and a reliable storage volume that can be attached to any running instance that is in the same availability zone. EBS volumes that are attached to the EC2 instances are exposed as storage volumes that persist independently from the lifetime of the instance. And Amazon Elastic File System or EFS provides an elastic file storage which can be used with AWS Cloud Service and resources that are on premises. And Amazon Elastic File System, it's simple, it's scalable, it's an elastic file storage for use with Amazon Cloud Services and for on-premises resources. It's easy to use and offers a simple interface that allows you to create and configure file systems quickly and easily. Amazon File System is built to elastically scale on demand without disturbing the application, growing and shrinking automatically as you add and remove files, so your application have the storage they need and when they need it. Now let's talk about databases. The two major database flavors are Amazon RDS and Amazon Redshift. Amazon RDS, it really eases the process involved in setting up, operating, and scaling a relational database in the cloud. Amazon RDS provides cost-efficient and resizable capacity while automating time-consuming administrative tasks such as hardware provisioning, database setup, patching, and backups. It sort of frees us from managing the hardware and sort of helps us to focus on the application. It's also cost effective and resizable, and it's also optimized for memory, performance, and input and output operations. Not only that, it also automates most of the services like taking backups, monitoring, stuff like that. It automates most of those services. Amazon Redshift. Amazon Redshift is a data warehousing service that enables users to analyze the data using SQL and other business intelligence tools. Amazon Redshift is an fast and fully managed data warehouse that makes it simple and cost-effective to analyze all your data using standard SQL and your existing business intelligence tools. It also allows you to run complex analytic queries against petabyte of structured data using sophisticated query optimizations. And most of the results, they generally come back in seconds. Alright, let's quickly talk about some more services that AWS offers. There are a lot more services that AWS provides, but we're going to look at some more services that are widely used. AWS Application Discovery Services help enterprise customers plan migration projects by gathering information about their on-premises data centers. Planning a data center migration can involve thousands of workloads. They are often deeply interdependent. Server utilization data and dependency mapping are important early first step in migration process. And this AWS Application Discovery Service collects and presents configuration, usage, and behavior data from your servers to help you better understand your workloads. Route 53, it's a network and content delivery service. It's an highly available and scalable cloud domain name system or DNS service. And Amazon Route 53 is fully compliant with IPv6 as well. Elastic Load Balancing, it's also a network and content delivery service. Elastic Load Balancing automatically distributes incoming application traffic across multiple targets such as Amazon EC2 instance, containers, and IP addresses. It can handle the varying load of your application traffic in a single availability zone and also across availability zones. AWS AutoScaling, it monitors your application and automatically adjusts the capacity to maintain steady and predictable performance at a lowest possible cost. Using AWS AutoScaling, it's easy to set up application scaling for multiple resources across multiple services in minutes. Autoscaling can be applied to web services and also for DB services. AWS Identity and Access Management, it enables you to manage access to AWS services and resources securely. Using IAM, you can create and manage AWS users and groups and use permissions to allow and deny their access to AWS resources. And moreover, it's a free service. Now let's talk about the future of AWS. Well, let me tell you something. Cloud is here to stay. Here's what in store for AWS in the future. As years pass by, we're going to have a variety of cloud applications born like IoT, artificial intelligence, business intelligence, serverless computing, and so on. Cloud will also expand into other markets like healthcare, banking, space, automated cars, and so on. As I was mentioning some time back, lot or greater focus will be given to artificial intelligence. And eventually, because of the flexibility and advantage that cloud provides, we're going to see a lot of companies moving into the cloud. Alright, let's now talk about how easy it is to deploy an web application in the cloud. So the scenario here is that our users like a product and we need to have a mechanism to receive input from them about their likes and dislikes and give them the appropriate product as per their need. Alright, though the setup and the environment, it sort of looks complicated, we don't have to worry because AWS has tools and technologies which can help us to achieve it. Now we're going to use services like Route 53, services like CloudWatch, EC2, S3, and a lot more, and all these put together are going to give an application that's fully functionable and an application that's going to receive the information like using the services like Route 53, CloudWatch, EC2, and S3. We're going to create an application and that's going to meet our need. So back to our original requirement, all I want is to deploy a web application for a product that keeps our users updated about the happenings and the new comings in the market. And to fulfill this requirement, here is all the services we would need. EC2 here is used for provisioning the computational power needed for this application. And EC2 has a vast variety of family and types that we can pick from for the types of workloads and also for the intents of the workloads. We're also going to use S3 for storage, and S3 provides any additional storage requirement for the resources or any additional storage requirement for the web applications. And we're also going to use CloudWatch for monitoring the environment, and CloudWatch monitors the application and the environment, and it provides trigger for scaling in and scaling out the infrastructure. And we're also going to use Route 53 for DNS, and Route 53 helps us to register the domain name for our web application. And with all the tools and technologies together, all of them put together, we're going to make an application, a perfect application that caters our need. Alright, so I'm going to use Elastic Beanstalk for this project, and the name of the application is going to be, as you see, GSG Signup, and the environment name is GSG Signup Environment 1. Let me also pick a name. Right, let me see if this name is available. Yes, that's available. That's the domain name. So let me pick that, and the application that I have is going to run on Node.js. So let me pick that platform and launch. Now, as you see, Elastic Beanstalk, this is going to launch an instance. It's going to launch the monitoring setup or the monitoring environment. It's going to create a load balancer as well, and it's going to take care of all the security features needed for this application. Alright, look at that. I was able to go to that URL, which is what we gave, and it's now having an default page shown up, meaning all the dependencies for the software is installed and it's just waiting for me to upload the code, or in specific the page required. So let's do that. Let me upload the code. I already have the code saved here. That's my code, and that's going to take some time. Alright, it has done its thing. And now if I go to the same URL, look at that, I'm being thrown an advertisement page. Alright, so if I sign up with my name, email, and stuff like that, it's going to receive the information and it's going to send an email to the owner saying that somebody had subscribed to your service. That's the default feature of this app. Look at that. Email to the owner saying that somebody had subscribed to your app and this is their email address, stuff like that. Not only that, it's also going to create an entry in the database. And DynamoDB is the service that this application uses to store data. There's my DynamoDB. And if I go to tables, right, and go to items, I'm going to see that a user with name Samuel and email address so and so has said okay or has shown interest in the preview of my site or product. So this is where, or this is how I collect those information, right? And some more things about the infrastructure itself is it is running behind an load balancer. Look at that. It had created a load balancer. It had also created an auto-scaling group. Now that's the feature of Elastic Load Balancer that we have chosen. It has created an auto-scaling group. And now let's put this URL. You see this? It's not a fancy URL, right? It's an Amazon given URL, a dynamic URL. So let's put this URL behind our DNS. Let's do that. So go to services, go to Route 53, go to hosted zone, and there we can find the DNS name, right? So that's a DNS name, all right? Alright, let's create an entry and map that URL to our load balancer, right? And create. Now, technically, if I go to this URL, it should take me to that application. Alright, look at that. I went to my custom URL and now that's pointed to my application. Previously, my application was having a random URL and now it's having a custom URL. Let me help you understand about AWS EC2, a compute service in the cloud, through this video. Somewhere far in the country, a scientist has a lab far in the woods, and at one day he stumbled on a calculation that he had trouble solving. And he was very certain that his computer can handle it. And he asked his computer to do the math or the calculation for him. And the computer thought about it for a while, then took a couple of hours in trying to process the data. And eventually, at one point, it gave up and died due to low memory. And this old scientist is now clueless about how he was going to finish the task and complete his invention and let the whole world know about it. And that's when he was introduced to this new friend AWS, as you see on the screen. AWS was very handy in replacing his old machines, and it was able to give him the service that he wanted at that moment. AWS has been around for a while helping people with their computer needs, and now this new scientist friend in need is welcomed by the new and trendy IT technology AWS, and sure enough, his new AWS friend welcomed and walked him through the new way of computing. And this new happy-faced AWS friend talked to this scientist about AWS EC2 in specific, and walked him through about all the new innovations in IT and in cloud that he had been missing all these days. So his new friend AWS started the conversation about explaining how there is no need for any hardware units, no managing hardware or provisioning in AWS. And secondly, it explained increasing and decreasing the capacity as per the demand is just a click away. And the best part here is that there is no upfront commitment, and we only pay for what we have used, just like we pay electricity and water bills. And all this comes with complete control from our side. In other words, the whole key for this infrastructure is with us. And as if this was not enough, all this comes with enterprise-grade security that's beyond imagination in on-premises. And if this still does not excite you, then this definitely would. You can work from anywhere in the world. Now this really made the scientist to get excited, especially when he thought about working from home. Working from home, there is nothing like it, isn't it? Now this person, this scientist, is not tied up to a particular environment. He can work from home, work on the fly, work from anywhere. Still, the data and everything else in his IT environment is secure and safe. Now let's move to the next level of discussion. Let's talk about what is EC2 and some of the use cases of EC2. And this use case we're going to talk about, or this architecture we're going to talk about, it notifies a group of users about a new letter. And the components or resources this architecture would need be first EC2 instance, then SNS, a simple notification service, and coupling EC2 and S3 service together. That's all it would require to get an architecture that notifies a group of users about a new newsletter. And now I think it would be a good time to talk about what EC2 is. AWS offers plenty of services offered under different domains like compute, storage, database, migration, network, management tools, media services, security, business productivity, application integration, machine learning, game development, and a lot more coming up, out of which EC2 falls under the compute capacity. So what is EC2? EC2 is a web service which aims to make life easier for developers for providing secure and resizable compute capacity in the cloud. With EC2, it is very easy to scale up or scale down our infrastructure based on the demand. And not only that, this EC2 service can be integrated well with almost all the services in Amazon. And out of all this, the best part could be we only pay for what we use. Alright, let's talk about this use case. A use case here is that a successful business owner has a bunch of users and a successful product that's running, and now he has developed few more products that he thinks will be very successful, that he thinks his customers are going to like. Now how can he advertise his product to his new and prospective customers? Or the solution for this question can be addressed by AWS. In AWS, we can use services like Simple Notification Service, SNS, and EC2 for compute and S3 for storage. We can, in a way, integrate them all and achieve this business use case. And that sort of got this business owner very cheered up, and now he wants to use the service and he wants to get benefited from the service. He wants to advertise or he wants to notify his users every time the company creates a newsletter. Alright, so let's talk about what it would take to get this environment up and running, or what it would take to connect the environment and put the applications on top of it. Firstly, we would require an AWS account, and then for compute capacity, we would require an EC2 instance. And here's how we go about doing it. The first thing is to create an AMI, which is Amazon Mission Image. That's really the software's and the application packages we would need to run our application. And the second is to choose the hardware. In here it's the instance type. Depending on the workload, we would be choosing the hardware, and depending on the intents of the workload, we will be choosing the size of the hardware. And finally, we would configure the instances. How many instances do I want? Which subnet do I want them in? And what's going to be the stop or terminate behavior of the instance, and do I want to update any patches when the instance starts running? All those pieces of information go in here when we configure the instance. And then the first three steps is really about the OS volume and the basic hardware. Now it's time to add additional storage to the EC2 instance. That would be step 4. Here we add additional storage to the EC2 instance. And then tags, we use tags, or we would configure tags to easily identify an EC2 instance at a later point. We give it some meaningful names so we can identify, like which team it belongs to, which billing department it belongs to, what's the purpose behind launching this instance, stuff like that. In an environment where we run 700 to 800 or even more instances, identifying an instance and trying to understand who owns the resource, for what purpose we created, it could be an full-time work. So tagging comes to our rescue at that time. After tagging, as step 6, we would configure the firewall, which is also called security group, for the EC2 instance. And this is where we would allow or deny connection from external world to this particular EC2 instance. Well, it works both ways, from outside and from inside out. This firewall blocks the connection based on port number and IP address. And finally, as step 7, we review all the configurations that you have done, and we make sure that the configurations is what we wanted, and finally click on submit. That's going to launch an EC2 instance. Alright, this was just an overview of how to create an EC2 instance. Now let's talk about each and every step in detail. So to begin with, let's talk about how to create an AMI. Well, the AMI is just a template that's used to create a new instance or a new computer or a new VM or a new machine based on the user requirement. The things that go into an AMI are the software, the operating system, the additional applications that get installed in it, stuff like that. The AMI will also contain software information, information about operating system, information about access permission, information about volumes. They all compact in the AMI. Again, the AMI is of two types. One is predefined AMIs, or called Amazon provided AMIs. The other one would be custom AMIs, the AMIs that we create. And if you're looking at a particular AMI that you don't want to create but still want to get it from Amazon, there is a place or a portal called AMI Marketplace. There we get like thousands of AMIs in there available for us to shop and use them on a pay-as-you-go business model, and use them as pay-as-you-go billing. So there you can search AMI that you're looking for. Most probably you'll be able to get it there. Now let's talk about choosing the instance type. The instance type is basically the hardware specification that's required for a machine that we're trying to build. And the instance types is categorized into 5 main families. They are, to begin with, it's compute optimized. Now compute optimized gives us lots of compute power or lots of processing power. So if my application is going to require a lot of processing power, I should be picking compute optimized instance. And the second one is memory optimized. Now this is very good for applications that require in-memory caching. There are some applications that performs well with cache or through cache, or the application would create a lot of data that it wants to keep in cache for rereading or for processing, for lengthy processing, stuff like that. For those type of application, this memory optimized instance that comes with in-memory cache is a very good use case. And the third one is the instance that comes with GPU, otherwise called GPU optimized. GPU stands for graphical process unit, and this is very good for application that deals with gaming. This is very good for application that's going to require large graphical requirements. And storage optimized is the fourth option. Just like the name says, this is a very good use case for storage servers. And the fifth family type is general purpose. Just like the name says, it's for general purpose. If you're not particular about the family, then you generally would end up picking the general purpose, because here the services are sort of equally balanced. You'll find a balance between the virtual CPU and the memory and the storage and the network performance. It's sort of balanced. All the components, all the features that needs to go in a computer are sort of balanced in general purpose. Now these instance types are fixed and they cannot be altered because it's hardware based. We buy hardware. We do not have much control on the hardware that's being used. Well, we have options, but we do not have control on the hardware. And these instance types are divided into 5 main families. They are compute optimized, memory optimized, GPU enabled, storage optimized, and general purpose. Then as third thing, we have to configure the instance. Now here is where I have a lot of options about purchasing. What type of purchasing do I want to do? Do I want to go for a spot instance? Do I want to go for a reserved instance? Do I want to go for an on-demand instance? These are different billing options available, and that's available under configure instance. Not only that, here's where I'm going to put the EC2 instance. Do I want an public IP address assigned to it? Do I want an IAM role attached to it? IAM role is authentication. What kind of authentication am I going to provide? And the shutdown behavior. The shutdown behaviors include, do I want to stop the instance when the user shuts down the machine from the desktop, or do I want to simply terminate the instance when the user shuts down the instance from the desktop? So those things go in here, just like the name says, configure instance. A lot of instance configuration options comes in here. That's the third step. And not only that, under the advanced details or advanced tab under configure instance, I can bootstrap the instance with some scripts. Now bootstrap is nothing but the scripts that you want to be run in the instance before it actually comes online. Let's say you're provisioning the instance for somebody else. Instead of you launching the instance and then logging in and running some commands and then handing it over to the other person, you can create bootstrap shell scripts and paste it in a console option available under configure instance, and Amazon is going to take those commands, run it on the instance before it hands over to the user that initially requested for that instance. Now it could be a different user or just you. It sort of automates software installation procedures in the instance that we will be launching. And not only that, there are multiple payment options available under configure instance. The user can pick an instance under normal price, and that instance would apply normal rates applied to it. And there are also options like reserved instance, where the user can pay for an instance upfront before a year or before months, for a span of year or a span of months, and that way they can pay less per hour for using that instance. Not only that, you can also go for spot instance, like bidding for those instances. Whoever bids more, they get the instance for that particular time. Well, these instances are a lot cheaper than on-demand instances. And through bidding and buying, you can keep the instance as long as your bid price doesn't exceed the price that Amazon is proposing. And as the fourth step, we will have to add storage to the instance that we are about to launch. And here we have a bunch of storage options. I can go for ephemeral storage, which is free, or I can go for an external elastic block storage, also called EBS, which is paid and it's a permanent storage, or else I can integrate my EC2 instance with S3 for its storage needs. And the best part about storage is free subscription users, they get to use 30 gigabit of SSD storage or magnetic storage for the whole year. In this page where we are ready to add storage, we will have to mention or provide the size in gigabit and the volume type. Is it going to be an provisioned volume? Is it going to be an general purpose volume? Is it going to be a magnetic volume? Stuff like that. They are volume types. And we also need to give inputs about where the disk will be mounted and whether this volume needs to be encrypted or not. So all these inputs are received from us under the adding storage section. And then the fifth option would be adding tags. Like we discussed some time back, tags are very helpful to identify a machine in an environment where we have 700 or 1000 VMs running. And security groups are the actual firewall that sits in front of EC2 instance, and it protects that EC2 instance from unintended inbound and outbound traffic. Now here is where I can fine tune the access to my EC2 instance based on port numbers and based on IP address from which it can be accessed. And finally, we get to review the whole changes or the whole configurations that we have made to find out whether they are intact with the requirement, and then click on submit. That's going to launch an EC2 instance. But hold on, we're not done yet. When we're about to launch, or before the Amazon console actually launches the EC2 instance, it's going to give us an option to create a key pair. Remember, I said it's key pair. Key pair is two things. One is public and private. The private key is downloaded by the user and is kept with the user, and the public key is used by Amazon to confirm the identity of the user. So just go ahead and download the private key and keep it for yourself. And this private key gets downloaded as an .pem file. It's a format of the file, and it gets downloaded as .pem file. And our next step is to access the EC2 instance. And because the instance that we have launched in this example, let's assume it's a Linux instance, and that's going to require a tool called PuTTY to be able to access it. And this PuTTY tool is really needed when we are trying to access an Linux instance from Windows instance. Most of the time, Windows instance will have PuTTY installed in them, but in some rare cases, they do not come with PuTTY. In those cases, we can go ahead and download PuTTY and PuTTY generator, and we can start using it to access the Linux instance. Now you might ask, well, I understand PuTTY, what's PuTTY generator? Now the file that we have downloaded is in .pem format, but unfortunately PuTTY does not accept .pem format as input. It has to be converted into a different format called PPK. And PuTTY Gen is a tool that helps us to convert the .pem file into PPK file. So the quick way to do it is download generator, open it up, click on conversion, and insert the .pem key that we have downloaded and save the private key. And this, when we save the private key, it gets saved as a .ppk type private key. And when that's done, the next very step is to open PuTTY and try to log in. And the way to log in is to open PuTTY, put that IP address here, and then click on auth. This is where we would input the file that we have created. So click on auth and then click on browse and find the .ppk file that we have converted and stored, browse it and upload it, and then click on open. Now that's going to open up a login screen for us. And the AMIs comes with a default username. Depending on the AMI that we have picked, the username might differ. In our case, we have picked an AMI for which the username is ec2-user, and this is the default, by the way. Let's put the username ec2-user and hit enter, and that's going to open up the Linux instance using CLI. There are a few other things that we can do with the terminal that we'll explain it a little later. Alright, so we have successfully launched an EC2 instance, and give yourself a pat on your back. Launching an instance was just one part of the solution. So let's actually talk about how we can notify our customers. SNS, or Simple Notification Service, is a service or a product in Amazon that helps us to notify customers through email. So navigate to SNS in your account and create a topic. And we're going to use this topic for public notification. So let's make it public and then add subscribers to it. Now these subscribers are the people who you want to be notified about the newsletter. So we already have the email database in there. Add them to the subscribers list, and then they will start getting new newsletters as and when we post them to the topic. And as next step, create a bucket in S3 where you can store content, and in that bucket create an event that triggers a notification to Simple Notification Service. So this is how it will be set up. And notification will be sent to our subscribers anytime we put something in our S3 bucket. So S3 bucket is going to create an event for the notification, and the notification is going to make sure that it's delivered to your end customer because they're already subscribed to the topic as subscribers. And finally, let's connect the S3 with EC2 so the bucket and the AWS instance are in sync. So we put some content in the S3 bucket, our email system notifies our customers, and the customers can go online to a website that's hosted in EC2, and because S3 and EC2 are in sync, the items that we put in S3 will also show up in EC2. See how this is all connected and it's working together. And once this is all connected, our subscribers will regularly be informed anytime we put new content in the S3 bucket, and the same content will be made available in EC2 instance through the website. Let me help you understand about Lambda. One day at office in a growing company, there was discussion going on between two IT personnel. It was about the new role that his colleague Jessica has taken. Benjamin, the guy standing here, wants to know about it. And Jessica's job is new, different, and dynamic and interesting too. She scale and manage servers and operating systems and apply security patches onto them and monitor all of these at the same time to ensure the best quality for application is given to the users. And Benjamin was awestruck with the amount of work Jessica is doing and with the time it would take to complete all of them. But Jessica, being a very dynamic person, very suitable for the job, said it was easy for her to handle all of it and even more. But that easiness on the job did not last longer. As the environment grew more and more, it being a startup company, Jessica was getting drained and was not really happy about all her job as she used to be. Jessica's manual way of scaling an environment did not last long, and she was also finding out that she missed to scale down some of the resources and it's costing her a lot. She needs to pay for the service that she was not at all using. She sort of felt that she was at the end of the road and there was no way out from this manual task. She was very desperate. And that's when Benjamin suggested something, and that brought back the peace and joy Jessica initially had. Benjamin suggested about a service called Lambda that can ease the work that Jessica is doing at the moment. And Lambda, as happy as it looks like, it's a solution that solves the manual, repetitive work and lot more. And Lambda introduced itself as the problem solver and started to explain the following things, the very same thing that we're going to learn about in this series. So in this section, we're going to learn about the features of AWS Lambda, and we're going to talk about what Lambda is, and then we're going to talk about where Lambda is being used in the IT or in the cloud environment as we speak, and then we're going to talk about how Lambda works and some use cases of Lambda, and we're going to be particularly discussing about the use case about automatically backing up the data that's put in the cloud storage. Let's talk about Lambda in detail. Lambda automatically runs our code without requiring us to provision or manage servers. Just write the code and upload it to Lambda, and Lambda will take care of it. That means that we don't require any server to run or to manage, and all you need to do is write the code and upload it to Lambda, and Lambda will take care of it. Which also means that we can stop worrying about provisioning and managing servers. The only thing Lambda expects from you is a code that's working. AWS Lambda also automatically scales our application by running code in response to each trigger. Our code runs in parallel and processes each triggers individually, scaling precisely with the size of the workload. Scaling here is done automatically based on the size of the workload. Lambda can scale the application running the code in response to each and every trigger that it receives. Billing in Lambda is metered on the seconds. We only pay for the amount of time that our code is running, which means that we're not charged for any of the servers. The only payment required is for the amount of time the code is computed. With AWS Lambda, we're charged for every 100 milliseconds. We're actually charged for 100 milliseconds our code executes and the number of times our code is triggered, and we don't pay anything when the code is not running. Let's talk about what is AWS Lambda. Now, Lambda is one of the services that falls under the compute section or the compute domain of services that AWS provides, along with EC2,
EBS, Elastic Load Balancer. Lambda is also a service that comes under the bigger umbrella of compute services in AWS. And Lambda allows us to execute code for any type of application. With AWS Lambda, we can run code for virtually any type of application or backend services. All we need to do is supply our code in one of the languages that AWS Lambda supports. As we speak, the languages that are supported by AWS Lambda are Node.js, Java, C#, Go, and Python. And Lambda can be used to run code in response to certain events from other services. And based on the event, it can run functions, and those functions can be of Node.js, Java, C#, etc. Now let's talk about where is Lambda used. There are a huge number of use cases for Lambda, and there are many ways AWS Lambda is used specifically in the business world. Let's talk about some of them. One use case is AWS Lambda is used to process images when it is uploaded in an S3 bucket. Let's say the object gets uploaded in an S3 bucket in a format that we don't expect it to be, which means the file needs to be formatted. So it gets uploaded in a raw format, and AWS Lambda is triggered anytime a new object is added to the bucket, and the images are processed and converted into thumbnails based on the devices. The other end device that would be reading the data, it could be an PC, it could be an Apple machine, it could be an Android phone, it could be an Apple phone, it could be a tablet, whatnot. So based on the devices, different formats, Lambda can get triggered and convert the video or convert the picture into the different format that it requires. Another use case for Lambda is to analyze the social media data. Let's say we're collecting the hashtag trending data, and the data is received and it's added into the Kinesis stream to feed into the Amazon environment, and Lambda action get triggered and it receives the data, and then the data is stored into the database, which can be used by businesses for later analysis. And some of the companies that have gotten tremendous benefit using Lambda are Thomson Reuters, Benchlinks, Nordstorm, Coca-Cola, Robot are some of the companies to name at the moment that have received tremendous amount of benefit by using Lambda. Let's look at how Lambda works. In other words, let's look at how the complicated function behind the scenes work in a simple and in a seamless way. So here clients send data. Now clients send data to Lambda, and clients could be anyone who's sending request to AWS Lambda. It could be an application or other Amazon web services that's sending data to the Lambda. And Lambda receives the request, and depending on the size of the data or depending on the amount or volume of the data, it runs on the defined number of containers. If it is a single request or if it is less request, it runs on a single container. So the requests are given to the container to handle, and the container which contains the code the user has provided to satisfy the query would run. And if you're sort of new to containers, then let me pause here for a while and explain to you what container is. Now, container image is a lightweight, standalone, executable package of a piece of software that includes everything needs to run it, like the codes, the runtimes, the system tools, the system libraries, and any other settings needed. And it is at the moment available both on Linux and Windows based application, and containerized software will always run the same regardless of the environment it's running on. And containers isolate software from its surrounding. For example, there could be difference between a development and staging environment, so that's sort of isolated, and this helps in reducing the conflict between the teams running different software on the same infrastructure. Alright, now that we know containers needed to understand Lambda, so if there are few requests, it sends to a single container, but as and when the request grows, it actually creates multiple containers, shares the multiple requests to the different containers there. And depending on the volume, depending on the size, depending on the number of sessions, the more number of containers are provisioned so to handle those requests. And when the requests reduce, the number of containers reduce as well, and that helps in saving costs. We're not running any resources and paying for it when we're not using them. And in fact, we're not at all paying for the resources. We're only charged for the amount of time a function is running inside these containers. Now consider a situation where you have to set up a temporary storage and as a system to back up the data as soon as the data is uploaded, which is a near real-time backup. Now, a near real-time manual backups are nearly impossible, and they're not that efficient too. A near real-time manual backups, that's what the business demands, but that's not near real-time backup, that too a manual one, that's not at all efficient. Even if we come up with a solution of manually backing up close to near real time, that's not going to be efficient looking at the amount of data that will be put in and looking at the random times the data will be put into the source bucket. And there is no way we can do a manual backup and keep it as real as possible. But if that's still your requirement, we can use AWS Lambda and set things up so AWS Lambda manually handles the backup. In other words, for an impossible or a difficult situation like that, AWS Lambda comes for the rescue. And this is what we do. Create a two S3 bucket. One would be the source bucket where the data will be uploaded, and the other one is a destination bucket where the data will be backed up from the source bucket. And for these buckets to talk to themselves, it's going to require an IAM role. And then for the automatic copy, it's going to require an Lambda function to copy the files from the source bucket to the destination bucket. And what triggers the Lambda function? The Lambda function is triggered every time there's a change in the metadata for the bucket, and this data is then uploaded into the destination bucket. And after setting all this up, we can literally test it by putting a data in the source bucket that's going to automatically replicate, or that's going to automatically copy the data from the source bucket to the destination bucket. All right, let's see how we can replicate data between two buckets. Well, we have a feature to cross-region replicate in S3. That's a feature that comes along with S3. What if you want to replicate between two different buckets in two different accounts? In those cases, we can use Lambda to replicate the data between the buckets. So you put one data, or you put data in the source bucket, and that data gets replicated to the destination bucket. And let's see how that's done. The procedure here would be to have two buckets to begin with, and then create an IAM role that lets you access to pull data from the source bucket and put data on the destination bucket, and then create Lambda files or Lambda event or triggers to actually look for event in the source bucket, and anytime a new data gets added, Lambda gets triggered, copies the data from the source bucket and moves the data to the destination bucket, and it uses the IAM role and policy for the needed permissions. And in just a couple of clicks, we have set up a temporary backup system that can run seamlessly without any manual intervention, and that can be as near real time as possible. Alright, that's the concept, and let's see how it is done real time through this lab. So to begin with, we need two buckets. So I have here a source bucket and a destination bucket, and the source bucket as of now do not have any data in it, so as the destination bucket. Alright, so that's one down. The second would be to create an IAM role. Alright, so let me create an IAM role, and the role is going to have this policy in it. A policy that's allowing get object on the source bucket, and a policy that's allowing put object on the destination bucket. And here I'm going to use, or I'm going to paste my source and destination buckets ARN. All right, go to services, go to S3, source bucket. All right, click on the source bucket and copy the bucket ARN. So that would be the source bucket ARN. All right, on the destination bucket, copy the destination bucket ARN, and this is going to be my destination bucket ARN. So with this, I'm going to create a policy. All right, go to IAM and create a policy. Now I have already created a policy with the same information. All right, destination bucket ARN, and a policy is available with the name S3 bucket copy Lambda. Attach the policy to the role. Right, go to roles, create a role. Lambda is the service that's going to use it. In here, attach the policy that we have created, right? Give it a name and then create a role. Now I have a role created as well, right? Copy Lambda, and that's having the policy that we have created sometime back. Now create a Lambda function, right? So go to Lambda, create a function, give it a name like S3 bucket copy, right? Choose the role that we want to use, right? That's the role that we want to use. Copy 1, 2, create a function. All right. And in here, we're going to use Node.js code, right? I have a sample code. This can be used as template. In here, replace the source bucket with the name of the source bucket and the destination bucket with the name of the destination bucket. This is a Node.js code that gets run when an event gets triggered. Now, what's an event? Anytime there is a new object placed in the S3 bucket, it creates an event, and the event triggers Lambda, and Lambda checks the source S3 bucket, picks the data, puts it in the destination bucket. All right, paste it here. Paste it here and click on save. All right, now before you click on save, just ensure that you have the appropriate roles defined. That's all you got to do. Click on save. All right, now I already have created a Lambda function, all right, which is the same thing, same code, and the role is attached to it. Now it's running, it's active. Now let's put this to test. Go to S3, pick the source bucket, put some data in it, all right, and in theory, those data should be present in the destination bucket as well. There you go. It's all done by Lambda. I'm going to be touring you with different S3 features and technical details in this section. So what are we going to learn? We're going to learn about what is cloud storage in general, and then the types of storage available in general in the cloud, and how things were before anybody adopted using S3. That's something we're going to learn. And then we're going to immediately dive into what is S3, and then the benefits of using S3 over other storage. And then we're going to do a couple of labs or console walkthroughs about what is object and how to add an object, what is bucket, how to create a bucket, stuff like that. And then we're going to talk about how Amazon S3 generally works. Now, it comes with a lot of features, it comes with a lot of promise. How does this all work? How does Amazon able to keep up with the promise? We're going to talk about that. And then we will talk about some features, add-on features that comes along with Amazon S3. So what is cloud storage in general? Cloud storage is a service that provides web services where we can store our data. And not only that, the data can be easily accessed and the data can be easily backed up, everything over the internet. In short, if you could store your data, if you could access the data, if you could back up your data, everything you do through the internet, then that's a good definition for cloud storage. And additional definitions are, in cloud storage we only pay for what we use. No commitment, no pre-provisioning, is pay as you go type subscription. And the best part is we pay on a monthly basis. We don't rent a hardware for the year, or we don't give commitment for the whole year. It's pay as you go and pay on a monthly basis. And these cloud storages are very reliable, meaning once you put the data in it, it's never going to get lost. And these cloud storages are scalable. Assuming I have a requirement to store 100 times of what my actual data size is, and I want it now, it's available in the cloud. And these storages are secure as well, because we're talking about data virginity. They need to be secure, and Amazon provides tools and technologies through which we can secure our data, and these are generally not found in the on-premises storage system. So let's talk about the different types of storage in general. So S3 is cloud storage in AWS, and then we have Elastic Block Store. Now, Elastic Block Store is actually the SSD hard drives that gets attached to our EC2 instance. It's like the C drive, it's like the D drive, it's like the E drive that gets attached to our instances. Now, EFS is Elastic File System. The underlying technology is kind of the same, but it differs from EBS in a way that EBS can be accessed only by the system that's attached to it, meaning the E volumes and the D volumes we spoke about. They can be accessed only if there is an instance connected to it. But these EFS are actually shared file systems, Elastic File System. Alright, they are shared systems. They can be accessed by multiple systems. They can be accessed from inside the Amazon environment. It can be accessed from on-premises equipment as well. Glacier is actually the archiving solution in the cloud. If you want to dump a data and try to keep them in the low cost as possible, then Glacier is the product we should be using. And then we have Storage Gateway. If I want to safely move my data from my local environment to the cloud environment, and also want to keep a copy of the data locally so users locally can access them, and cloud users or internet users can access the data from the cloud. If that's your requirement, then Storage Gateway is the one we would be choosing. And then we have Snowball. Snowball is really an data import and export system, but it is actually an hardware that gets shipped to our premises where we can copy a data into it and then ship it back to Amazon, and Amazon would copy the data into whatever destination we give them in our account. And if the data is really huge, then I can call for a snowmobile, which is actually a data center on a truck, where Amazon would send me a truck loaded with a data center, as you see, that has compute capacity, lots and lots of storage capacity, and electricity, AC, and a lot more. So they get come parked near our data center, and cables run into our data center. We can copy data into it, send it back to Amazon, and they would copy it to our account in whatever storage that we advise them. So if the data is really huge, then I would be calling Snowmobile. Snowmobile is not available in all the regions. Alright, let's take this example, how things were before S3 was introduced. Two professionals are having a conversation, and one of them is finding it very difficult to sort of manage all the data in the organization. Well, if the data is small, it can be easily managed, but as company grow, and we are living in an era where data is everything. We want data to back up every idea. We want data to back up every proof of concept that we provide. So data is everything. So this era, it's all about collecting data, analyzing them, and saving, not losing logs, saving them, analyzing, stuff like that. So coming back to our discussion here, one person finds it very difficult to store and manage all the data that they have. So some of the data that this person is having problem storing is data that application use to running, and then data that get sent to the customers, and data that the websites require, the data that are because of the email backups, and a lot more other storages that an enterprise can have. And this person is having problem backing up all those data. And even if we think of increasing the local storage capacity, that's going to cost a fortune. And few things that make it sometimes impossible to increase the storage capacity in-house is we will have to go and pay heavy to buy hardware and software to run these storages, and we need to hire a team of experts for maintaining them, the hardware and the software. And anytime if there is a dynamic increase in the storage capacity, the on-premises or in-house hardwares won't be able to scale. And data security is very costly when it comes to building our own storage environment in-house and adding data security on top of it. So the other guy in the conversation was sort of quietly listening everything the manager was saying, and then he slowly introduced him to S3, because he knew that all the problem that this manager was worried about can be solved to S3. In other words, all the scalability, all the data security, all the not being able to provision hardware and software components are all available with S3. So that actually brings us to the discussion about what S3 is. S3 is Simple Storage Service. it actually provides an object storage service. Let me talk to you about object and block storage. Object storage is where you can store things and retrieve. All right, you can't install anything in it, and this object storage can be accessed directly from the internet, whereas block storage is something that needs to be attached to an instance, and we can't directly access it, but we can install software in it. So that's a high level difference between object storage and block storage. And S3 is an object storage. What does that mean? We can store data from the internet, we can retrieve from the internet, but we can't install anything in S3. All right, so S3 is an object-based storage, and it's really built for storing and recovering or retrieving any amount of data or information from anywhere in the internet. Few other things you need to know about S3 is that this S3 is accessible through the web interface. The storage, one type of accessing or one way of accessing S3 is by dragging, dropping content into it, and another way of retrieving data from S3 is go to a browser, click on download. That's going to let you download any content, and the data can be 5 terabytes in size. Now we're talking about one file. You can have hundreds or thousands of files like that. One file can be as big as 5 terabytes in size. And S3 is basically designed for developers where they can push logs into S3 or retrieve logs anytime they want instead of storing locally in the server. They can use S3 as code repositories, where they can save the code and have the applications read the code from there, and a lot more. If they want to safely share the code with another person with a lot of encryption and security added on top of it, that's possible as well. So there are a few things about S3, and on top of all this, S3 provides 11.9 durability and 4.9 availability. Meaning durability is, if I store the data, will it get lost? Amazon is like, no, it's not going to get lost. You're going to have the data because we provide 11.9 durability for the data. And availability is, if you want the data now, will you be able to show it? Amazon is like, yes, we will be able to show it. We have 99.99% availability, and when you request the data, we will be able to show the data to you. Alright, so let's talk about the benefits of S3. S3 is durable. As we saw, it provides 11.9 durability. S3 is low cost. Out of all the storage options in Amazon, S3 is the cheapest, and S3 is very scalable. Like we were saying, there's no required to pre-provision a storage capacity. If you need more, go ahead and use more. If you need even more, go ahead and use even more. And once you're done, some data needs to be removed, just remove the data. So that particular month you will be paying less. So it's very scalable in nature, and it's very available as well. S3 isn't regional service. It's not based on one availability zone. So one availability zone going down within Amazon, the whole availability going down, it's not going to affect your ability to access S3 storage. And S3 is secure. A lot of security features like bucket policy, a lot of security features like encryption, and then MFA authentication are possible with S3 that actually adds a very good security layer on top of the data that we have stored in S3. And not only that, this S3 is very flexible in terms of cost, flexible in terms of where I want to store the data. In terms of cost, there are a lot of pricing tiers within S3. S3 itself is a cheap service. Now within that, we have a lot of pricing tiers depending on the durability. So I can always choose to put data on a different storage tier or storage option in S3. We're going to talk about it as you stick along. And in terms of flexibility in region, I can always choose any of the region available in the console or in the S3 console to put my data to. There is no restrictions on where I can or cannot put the data in the cloud, as long as there are regions available for me to move the data to. And data transferring with S3 is very simple. All I have to do is browse to the bucket, upload the data, and the data gets uploaded. And we can also upload data using CLI. Commands are very similar to Linux. Commands are very similar to what we would use in the run command prompt in Windows, and what we would use in the run command prompt in the PowerShell. Alright, let's talk about a basic building block of S3, which is bucket and objects. Now what's a bucket? What's an object? Object is the actual data, and bucket is the folder where the objects get stored. Let me give you a new definition for object. So object is the actual data plus some information that reference the data, like is it an JPEG file, the name of the file, and at what time it was added to. So they're called metadata. Alright, so object is actually data plus metadata, and bucket is actually a container that receives the data and safely stores in it. And when we add a data in a bucket, Amazon S3 creates an unique version ID and allocates it to the object so we can easily identify it at a later point. Let me show you a quick lab on S3. Alright, I'm in the S3 console. If you're wondering how I reached here, go to services under storage and S3 is right here. And let's create a bucket called Simplilearn. Now the bucket names will have to be unique. So I really doubt if Simplilearn will be available. Let's check it anyway. Alright, it doesn't seem to be available, so let me pick another name, or let's call it simplylearn.samuel.com, and I'm going to put this in Mumbai, or I can choose Oregon. Let me choose Oregon. Yes, let me choose Oregon. And let me create a bucket. Sure enough, a bucket got created. Let me upload an object into the bucket. And you know, these objects can be as big as 5 terabytes. We talked about it, right? All right, let me upload an object. All right, so that's my object. So you get the relation, right? Here's my bucket. All right, here's my bucket, and within that is my object. Now object is the actual file plus what type of file it is, and then the size of the file, the date in which it got added, and the storage class it is in at the moment. So if I have to access it, I can simply access it through the internet. So let's talk about how does this S3 bucket work anyway. Alright, so how does it work? A user creates a bucket. They will specify the region in which the bucket should be deployed. We had an option. We could have chosen to deploy in all the regions Amazon provides S3 service. You know, be it North Virginia, be it Mumbai, be it Tokyo, be it Sydney, be it Oregon. And we chose Oregon to be the destination region where we want to create a bucket and save our data there. And when we upload data into the bucket, we can specify 3 types of storage classes. In our case, we picked the default, which was S3 standard. As we saw on the object data, it was on S3 standard. So that's the basic thing. Later, once the object gets added, we can always add bucket policies. You know, policies define who access it and who should not access it. What can they access? Are we going to allow users only to read or to read write as well? stuff like that. So that's bucket policy. We're defining the life cycle or the lifespan of the data in the S3 bucket. Now, over the time, do you want the data to automatically move to a different storage tier? And at any point, do you want to sort of expire the data, get the data flushed out of your account automatically? Those things can be configured in lifecycle policies. And version control is creating multiple versions. If you're going to use S3 for a code repository, creating multiple versions. Let's say if you want to roll back to whatever you had before a month, how are we going to do it if you kept updating the file and never took a version of it? So version control helps us to keep different versions, and it helps us to roll back to the older version anytime there is a need. So let's talk about the different storage classes in S3. The different storage classes in S3 begins with S3 standard. Now this is the default, and it's very suitable for use cases where you need less or low latency. For example, if you want to access the data of a student's attendance, you would retrieve them very quickly as much as possible. So that's a good use case to store data in S3. Let's understand the different storage classes in Amazon S3. Now let's take a school, for example, and the different data present in a school, and the features of those data, the validity of the data. Alright, so let's take this example, and there are different storage options in S3. Let's take S3 standard, for example, and what would be the actual candidate data that can be stored in S3 standard. Let's talk about that. So S3 standard in general is suitable for use cases where the latency should be very low, and in here the good example or the good candidate file that can be stored in S3 is data that needs to be frequently accessed and that needs to be retrieved quickly. Something like students' attendance report or students' attendance sheet, which we access daily, and then it needs to be retrieved immediately as and when we need it. The other type of storage tier in S3 is infrequent access or infrequent data access. Just like the name says, the use case for that is less frequently accessed data. I mean, the candidate data that should go in infrequent access data is a student's academic record, which we don't need to access on a daily basis. But if there is a requirement, we might want to go and look at it, and that's going to be quick. So it's not a data that we would access on a daily basis, but it's a data that needs to show up on your screen real quick. And the third option is Amazon Glacier. Now, Glacier is really an archival solution in the cloud. So for archives, high performance is not a requirement. So let's talk about some candidate data that can go into archives. Something like students' admission fee, and it's not critical also. Now, anytime if you want to look at the data, you can always wait to retrieve the data. So in other words, put it in the archive, and retrieving from the archival takes time. So students' old record are a good candidate to be put in the archives. The other options are one zone IA storage class, where the data is infrequently accessed and the data is stored in a single availability zone. For example, by default, Amazon stores data in multiple availability zones, and there is a charge for that. Now, it's not an option, but the charge includes storing data in multiple availability zones. But if your data requirement is you want to keep the charges low even further, you can choose a one zone IA storage class where it stores data in one availability zone. And the candidate data that can go in one zone infrequent access is student's report card. And the other option with Amazon S3 is standard reduced redundancy storage. It is suitable for cases where the data is not critical and the data can be reproduced quickly. For example, take a copy of the library book, take a copy of the PDF library book, for example. Now, we would have a source PDF and we would make copies of it, and then we make it available for the readers to read. The other option in S3 is reduced redundancy storage. Here the use case is data that's not critical and data can be reproduced quickly. For example, books in the library are not that critical and we always have a copy of the book we're talking about PDF. So if the customer facing or the student facing book gets deleted, I can always copy the same PDF, put it in the destination folder and make it available for the users to read. That would be a very good use case for reduced redundancy storage. Alright, let's summarize everything that we learned about different storage options in S3. So S3 standard, it's for frequently accessed data. It's the default storage. If you don't mention anything, the data gets stored in S3 standard. It can be used for cloud applications, content distribution, gaming applications, big data analytic, dynamic websites. They are a very good use case for S3 standard frequently accessed data. The other one, on the contrary, is S3 standard infrequently accessed data. Just like the name says, the use case is this is good for data that will be less frequently accessed, and then the use case are it's good for backups, it's good for disaster recovery, and it's good for lifelong storage of data. Glacier, on the other hand, is very suitable for archiving data which is infrequently accessed, and the vault lock feature is the security feature of the Glacier that also provides a long-term data storage in the cloud. This is the lowest storage tier within S3. The other options are one zone infrequent access storage class. Just like the name says, it's infrequently accessed and it is stored in just one availability zone. And use cases are any data that doesn't require any high level of security can be stored here in one zone. The fifth storage tier is reduced redundancy storage. This is good for data that's frequently accessed. It's good for data that is non-critical and that can be reproduced if it gets lost. And reduced redundancy storage, or RRS, is an highly available solution designed for sharing or storing data that can be reproduced quickly. Alright, let's compare and contrast a couple of other features that are available in S3. For example, durability, availability, SSL support, first byte latency, and lifecycle management. So in standard, the durability is 11.9 durability. It's the same for standard IA, one zone IA, Glacier, except for reduced redundancy, the durability is 11.9. And availability of all the storage classes is all the same, except for one zone IA, where the availability zone is 99.5%. All of these products support SSL connection, and the first byte latency of these products are most of them provide access with millisecond latency, except for Glacier. It provides a retrieval time of couple of minutes to a maximum of hours, and all of them can be used for a lifecycle management, moving data from one storage tier to another storage tier. That's possible with all of these storage options. Alright, now that we've understood the different types of storage options available in S3, let's talk about some of the features that are available in S3. Lifecycle management. Now, lifecycle management is a service that helps us to define a set of rules that can be applied to an object or to the bucket itself. Lifecycle is actually moving the data from one storage tier to another storage tier and finally expiring it and completing the life cycle of the object. With lifecycle management, we can manage and store our objects in a very cost-effective way. It has two features basically: transition actions and expiration actions. Let's talk about transition actions. With transition action, we can choose to move the objects or move the data from one storage class to another storage class. With lifecycle management, we can configure S3 to move our data from one storage class to another storage class at a defined time interval or at a defined schedule. Let's talk about transition actions in more detail. Let's say we have our data in S3 at the moment and we haven't used the data for quite some time, and that's how it's going to be for the rest of the time. So that data is a very good candidate to move to the infrequent access because S3 standard is a bit costlier and S3 infrequent access is a bit cheaper than S3 standard. So the kind of usage sort of fits very well for moving that data into infrequent access. So using lifecycle transition or lifecycle management, I can move the data to S3 infrequent access after 30 days. And let's say that the data stayed in infrequent access for 30 more days, and then now I realize that nobody is looking into the data. So I can find an appropriate storage tier for that particular data again, and I can move it to that particular storage tier, which is Glacier. So in this case, after 30 days or in a total of 60 days from the time the data got created, the data can be moved to Glacier. And what does this really help us with? The lifecycle management helps us to automatically migrate our data from one storage cost to another storage cost, and by that it really helps us to save the storage cost. Lifecycle management can also help us with object expiration, meaning deleting the object or flushing it out after a certain amount of time. Let's say that our compliance requirement requires that we keep the data for 7 years, and we have like thousands and thousands of data like that. It would be humanly impossible to check all those or keep track of all the dates and when they need to be deleted, stuff like that. But with lifecycle management, it is very much possible. I can simply create a data and set up lifecycle management for the data to expire after 7 years, and exactly after 7 years the data is going to expire, meaning it's going to be deleted automatically from the account. Alright, let me show you a lab on lifecycle management and let me explain to you how it's actually done. So I'm into the bucket that we have created, and here's our data into the bucket. Assume we have thousands and thousands of data in the bucket, and that requires to be put in a different storage tier over time, and that requires to be expired after 7 years, let's say. So the way I would create a lifecycle management is go to management from inside the bucket and click on lifecycle, and then add a lifecycle rule. Just give it a name like expire. So all the objects that's present in this bucket, meaning the current version of it, set a transition for it. So the transition is, at the moment they are in S3. So here I would like to put them in infrequent access after 30 days. And then after it's been in infrequent access for 30 days, I would like to move it to Glacier. Alright, plus 30 days. So how do you read it? So for the first 30 days, it's going to be in Glacier. So how do we actually read it? So after I put the data in S3, the data is going to get moved to standard IA, and then it's going to stay in standard IA, and after 60 days from the data creation, it's going to get moved to Glacier. So on the 31st day, it's going to move to standard IA. On the 61st day, it's going to move to Glacier. Let's say if I want to sort of delete the data, if I want the data to get deleted automatically after 7 years, being in a Glacier, how do I go about doing it? Let me open up a quick calculator. 365 into 7, that's 2,555 days. Right after that, the data is going to get deleted. Pretty much, I have created a life cycle. So on the 31st day, it's going to get moved to infrequent access, and on the 61st day, Glacier, and after 7 years is over, any data that I put in the bucket, it's going to get deleted. Alright, let's talk about bucket policies. Bucket policies are some permission files that we can attach to a bucket that allows or denies access to the bucket based on what's mentioned in the policy. So bucket policy is really an IAM policy where you can allow and deny permission to an S3 resource. With bucket policy, we can also define security rules that apply to more than one file in a bucket. Now, in this case, we can create an user, or let's say there's already a user called Simplilearn. We can allow or deny that user connection to the S3 bucket or connecting to the S3 bucket using bucket policy. And bucket policies are written in JSON script. And let's see how that's done. Alright, there are tools available for us to help us create bucket policies. What you're looking at is a tool available online that helps us to create a bucket policy. So let's use this tool to create a bucket policy. I'm going to create a deny statement. I'm going to deny all actions to the S3 bucket. And what is the ARN to which we want to attach? The ARN of the resource is actually the name of the bucket, but it really expects us to give that key in a different format. So the ARN is available right here, copy bucket ARN. So this is actually going to deny everybody. Now we wanted to deny a user, just one user. Now look at that. Now we have a policy that has been created that's denying access to the bucket, and it's denying a user called Simplilearn. Pretty much done. So I can use the policy and go over to bucket policies. So once I save it, only the user called Simplilearn won't have access to the bucket, and the rest of them will have access to it. So once I save it, it gets added, and only the user Simplilearn will not have access to the bucket because we're denying them purposefully. The other features of S3 include data protection. We can protect our data in S3 with now one of which is bucket policy. I can also use encryptions to protect my data. I can also use IAM policy to protect my data. So Amazon S3 provides a durable storage. Not only that, it also gives us a protected and scalable infrastructure needed for any of our object storage requirements. So here the data is protected by two means. One is data encryption and the other one is data versioning. Data encryption is encrypting the data so others won't get access, or even if they get access to the file, they won't be able to access the data without the encryption key. And versioning is making multiple copies of the data. So let's talk about them in detail. What's data encryption? Now, data encryption refers to protecting the data while it is being transmitted and protecting the data while it is at rest. Now, data encryption can happen in two ways. One is client encryption, encryption at rest, and server-side encryption, encryption that's in motion. Client-side encryption refers to when client sends the data, they encrypt the data and send it across to Amazon. And server-side encryption is when the data is being transferred, they get encrypted and stay encrypted throughout the transfer. Versioning is another security feature. It helps us so our unintentional edits are not actually corrupting the data. For example, let's say you edited the data and now you realize that the data is incorrect and you want to roll back. Now, how do you roll back? Without versioning, it's not possible. In other words, only with versioning, it's possible. So versioning, it can be utilized to preserve, recovery, and restore any early versions of every object that we stored in our Amazon S3 bucket. Unintentional erases or overwrites of the object can be easily regained if we have versioning enabled. And it's possible only if we have one file with the same key name, and anytime we update the file, it keeps the file name but creates a different version ID. Take this bucket and data for example. Photo.pmg is a file that was initially stored. It attached a version ID to it, and then we edited it. Let's say we added some watermark, we added some graphic to it, and that's now the new version of it. When we store it with the same file name. It accepts the same file name but creates a new version ID and attaches it. Anytime we want rollback, we can always go to the console, look at the old versions, pick the version ID, and roll back to the old version ID. Alright, let's take this example. Now, I'm in a bucket that we've been using for a while, and let me upload an object. Now, before we actually upload an object, this bucket needs to be versioning enabled. So let me version enable this bucket. From this point onwards, this bucket is going to accept versioning. So let me upload an object, photo.jpg. Let me upload it. All right, it successfully got uploaded. Good enough. It's uploaded. Now, let me upload another object with the same file name. Now look at that. It was uploaded at 7:35 a.m. Let me upload another object with the same file name that I have it stored right here. That got uploaded but with the same name. Alright, so that's the other photo. Now what if I want to switch back? The way I would switch back is simply switch back to the older version. Look at that. This is the latest version and this is the old version that I have. I can simply switch back to the old version that was created at such and such time, and I can open it. That's going to open the old file. So in short, it creates different version of the data that I create
as long as it's with the same name. And at any point I can go and roll back to the original data. This is a very good use case if you want to use S3 for storing our codes. Let's talk about other feature like cross-region replication. Now, cross-region replication is a very cool feature if you want to automatically keep a copy of the data in a totally different region for data durability, for any additional data durability, or if you want to serve data to your customers who live in another country or who are accessing your data from another country. If you want to serve the data with low latency, cross-region replication is a very cool feature that you can use and get benefited from. And let's see how that's done. So before we actually do a lab on cross-region replication, let's put together a proper definition for it. Cross-region replication is a feature that provides automatic copying of every object uploaded to our bucket or your bucket, source bucket, and it automatically copies the data to the destination bucket, which is in a different AWS region. As you see here in the picture, I put data only in region 1. It's going to copy the data to region 2. And for us to use cross-region replication, versioning must be turned on. So it creates versions and copies the versions as well. If tomorrow the original region goes down, let's say, the other region will be active and it has the complete data that was present in the original region. Or at any point, if we want to simply cut the region replication and use the other bucket as a standalone bucket, it can be used as well, because it already has all the data that was present in the master or all the data that was present in the original replication bucket. Let's see how that's done. So there are two things needed. One is versioning and another one is role. When we transfer data from one bucket to another bucket, we need proper permissions to do so, and these roles, they give us proper permissions to transfer data from one bucket to another bucket. Let's see how that's done. Right, so here's my bucket, a bucket in US Oregon. Let's create another bucket in Mumbai. Call it .mumbai.com and put it in Mumbai, or create that bucket in Mumbai. There you go. We have one in Oregon, we have one in Mumbai. We're planning to replicate or create replication between these two, right? Create replication between these two buckets. So go to the first bucket, go to management and start a replication. Add a rule. So all content in this bucket is going to get replicated. This is my source bucket. It's quite simple. Select the destination bucket. Now my destination bucket is going to be simplilearn.samuel.mumbai.com. Alright, it says, well, you have versioning enabled in your source bucket, but not on your destination bucket. Do you want to enable it now? Without which we won't be able to proceed further. So let's go ahead and enable versioning through the console that shows up. And then like I said, it's going to require permission to put data onto the other bucket. Now I can create different roles. These are different roles that are used for different other services. I can also choose to create a role that specifically gives permission only to move the data from one bucket to another bucket. Pretty much it's done. So if I go over to my source bucket and if I add some data to it, let's say index.html, assuming I'm adding some files to it, in theory they should move to the other region automatically. There you go. I'm in the Mumbai region and the datas, they got moved to the other region automatically. Let's talk about the other feature called transfer acceleration. Now it's a very handy and a helpful tool or a service to use if we are transferring data which is very long distance from us, meaning from the client to the S3 bucket. Let's say from my local machine, which is in India, if I transfer the data over to Oregon, let's say, it's a long distance. If it is going to go through the internet, it's going to go through high latency connections, and my transfer might get delayed. If it is an 1 gigabit file, it's okay. But if we're talking about anything that's 5 terabyte size, if you're talking about anything that's a 5 terabyte in size, then it's not going to be a pleasant experience. So in those cases, I can use transfer accelerator which in a secure way, but in a fast way,
or a fastest way transfers my data from the laptop or from client to the S3 bucket. And it makes use of a service called CloudFront to transfer or to enable the data acceleration. So the way it would do it is, instead of copying the data directly to the location, instead of copying the data directly to the destination bucket, it copies the data locally into a CloudFront location, which is available very local to whatever place we are in, and from there it copies the data directly to an S3 bucket, not going through the internet. It helps eliminate a lot of latency that could get added when transferring the data. So let's see how that's done. Right here, I'm in the S3 bucket, and under properties I can find transfer accelerator, and if I enable transfer accelerator, so I'm in another bucket. Let me go to properties and let me go to transfer accelerator and enable transfer accelerator. So now if I put data into this bucket, they're going to get copied to the local CloudFront location, and from there they're going to get copied to the S3 bucket from the CloudFront. Now if I need to compare, how the speed is going to be compared to directly putting the data to the internet and using CloudFront, there is a tool available that actually runs for a while and then comes with a report that tells me how much will be the improved speed if I use transfer accelerator, and it shows for all the regions available in Amazon. So from the source to the destination, if you want to put what's the normal and what's the accelerated speed when you transfer the data, those results we will get in the screen. So at the moment this tool is going through its testing, like uploading some file through the internet and uploading some file using CloudFront, and it has come up with the calculation that if I'm uploading file to San Francisco compared to uploading through the internet and through CloudFront, it's 13 times faster. So similar way, it's going to calculate for all the regions available and it's going to give me a result. Let me help you understand series called IAM, a service in AWS for security. Here in this section, we're going to talk about what is security in AWS, and then we're going to slowly or gradually move on to the other topics like types of security available in AWS. Out of all the services, why IAM is the most preferred one, and then we're going to talk about what is IAM in general, how it works, the building blocks or components in IAM, and the features, the attractive features that it provides that makes IAM stand out from the rest of the services available. We're going to talk about that, and then we're going to end today's session with a demo about how IAM gets well interacted with other services in Amazon and help create a secure environment in the cloud. Let's talk about AWS security. Now, cloud security is the highest priority in AWS. And when we host our environment in the cloud, we can be rest assured that we are hosting our environment in a data center or in a network architecture that's really built to meet the requirement of the most security sensitive organization. And this high level of security is available to us on a pay-as-you-go type, meaning there is really no upfront cost that we need to pay. And the cost for using the service is a lot cheaper than what it is in an on-premises environment. So AWS Cloud provides a secure virtual platform where we can deploy our application. Now, compared to the on-premises, with AWS, the security level is very high and the cost involved in using or attaching that type of security to our application is very low compared to on-premises. There's really no upfront cost, and the cost is very lower. Whatever cost that we pay is very lower than what it would be in on-premises, and all this contributes to the secure environment we can get through IAM in AWS Cloud. There are really many types of security services available in AWS. To name a few, or to name the familiar ones, IAM stands first, followed by Key Management System, KMS, and then we have Cognito, that's another service, and Web Access Firewall, WAF, is another security service in AWS. Now let's start our discussion by talking about IAM, and that's what this whole series is about. Now, IAM, or Identity and Access Management, it really enables us to manage access to AWS services and AWS resources in a very secure manner. With IAM, we can create groups. We can actually allow those users or groups to access some service, or we can sort of deny them to access the service, whichever we want. That's all possible through identity and access management. And this feature comes with no additional charge. Now let's talk about how things were before AWS. Before AWS, or before IAM in general, it was not that safe in a corporate to share the password over the phone or through the email. That was the practice that was existed at that time. Now we all can remember the days when we need to switch to a different account, or we had just one admin password commonly stored in a location, or one person would reset it and maintain it, and anytime we need to log in, we call the person, ask for the admin password over the phone, and then we try logging in. Now that was not secure at all back then. Somebody could walk by and sort of eavesdrop, get the password. Now they walk away with the password with them. So they're all possible when we share the password over the phone and through the internet or email. Now with AWS, a lot of options are available that I'm not sharing password over the unsecure medium. Now Slack is a third-party product available with AWS. It's not an AWS product, but Slack is a third-party application that's hosted on AWS. And it's really a communication tool that helps people to share documents. So now we're not sharing the password over the phone, rather through the applications, and no eavesdrop person can really catch the password and try it in their system to access our environment. That's not possible. So you see the difference now. Back then, sharing password was only through phone and email, and you would write it on a paper and you give it to somebody. But now technology is providing provisions enough for us to share the password in a secure way. We're still talking about IAM. IAM is an web service for securely controlling access to the AWS resource. Now it really helps us to authenticate or sort of limit access to a certain set of users accessing the AWS account, or certain set of users accessing a certain set of resources in AWS account. Now you see this picture, we have an IAM administrator who's trying to allocate permissions to different group of people. So we have group 1 on the top and group 2 in the middle and group 3 towards the end. The administrator using IAM, or IAM empowers the administrator, allow access to certain group to certain resources. That's what IAM is all about. Now let's talk about the building blocks, or let's talk about the elements that make and complete IAM. So the elements are categorized into 6 different elements. We have the principal in IAM, the authentication, the request, the actual request coming in, the authorization, allowing, denying access, actions, what are the scope of actions can be taken, and on what resource. Is it EC2? Is it RDS? Is it S3 bucket? So what resource these actions are applied to. So they are the basic elements of an IAM workflow. Let's talk about principal, for example. An action on AWS resource can only be performed by a principal. An individual user, they can be a principal. A role in AWS IAM, it can be a principal as well. In other words, a principal is an entity that can take an action on an AWS resource. A principal can be an user, a principal can be a role, a principal can be an application that's trying to access the AWS environment. Secondly, authentication. Now, authentication is a process of confirming the identity of the principal trying to access the AWS environment. Now, how do we get authenticated, or how does a user get authenticated? By providing credentials or the required keys to validate that this is what he or she is as per what's in the record. So all principal must be authenticated, and we get authenticated using the username and password to log into the console. If it is CLI, or we get authenticated using the access key and the secret access key. The other component that makes up IAM is request. When a principal tries to use the AWS Management Console, what the principal is doing, or what the user is doing, is sending a request to the AWS environment. And the request will have the principal actually wants to perform. Is it a put request, or is it a get request, or is it a delete request, stuff like that. And it's also going to carry information about on which resource the action needs to be done. Is it on EC2 1? Is it on S3 bucket Simplilearn.com? Stuff like that. So it has a specific action that it wants to perform and the resource on which it wants to perform, and also some information about from where the request is originating from. Is it within an AWS environment, or is it with another cloud service provider, or is it with on-premises, stuff like that. So these information will be present in the request. Authorization. Now this IAM uses information from the request context to check for matching policies, and it takes a decision whether to allow or to deny the request. Now here it has a logic. By default, all the resources are denied, and IAM authorizes your request only if every part of the request is allowed by a matching policy. So there is an evaluation logic that says by default all requests are denied, and if there is an explicit allow, then it overrides the default deny. And if you are explicitly denying a service, then all the allow statements gets overridden, and all the other statements gets overwritten, and this explicit deny stands. By default, only the AWS account root user has access to all the resources in that account. So if you're not signed in as a root user, then we must be specifically granted permission through a policy. In other words, we need to be authorized through the policy. Now let's talk about action. Now after authenticating and authorizing the request, AWS approves the action that we are about to take. Now using action, we can view the content, we can create a content or create a bucket or create an EC2 instance. I can edit content, or even I can delete a resource. That's all based on the action that I'm allowed to do. Now that was about actions. Now where is the action performed? The action is performed on the resources. A set of actions can be performed on a resource, and anything that's not mentioned in the action, or anything that's not tagged with the action and the resource, they don't get to complete. For example, let's say if you attempt to delete an IAM role, and you also request to access the EC2 instance for that role, then the request gets denied. Now let's talk about some of the other components of IAM. So the other components of IAM are the basic building block is an user, and then many users together, they form a group, and then policies are the engines that allows or denies a connection. Based on policy, one gets to access or gets no access to a resource. And then roles are another component. Roles are temporary credentials, I would say, that can get assumed to an instance as and when needed. Right, let's talk about this component called user in an IAM. With IAM, we can securely manage access to AWS services, and we can create an IAM user anytime there is a new employee joining our corporate. So it's a one-to-one mapping. One user or one employee get a username directly attached to them. And a username or a user is an account-specific thing. It's very local to that AWS account that we are using. So in detail, an IAM user is an entity that we create in an AWS environment to represent a person or a service that interacts with AWS environment. And this user is going to have some credentials attached to them. And by default, they do not have a password, and they do not have any access key or secret access key attached to them. In fact, literally no credentials of any kind. Now we must create an user, and we must create the type of credential that gets attached to the user. Do they want to access CLI? So based on that, we would be adding credentials to them. A user by default is not authorized to perform any action in AWS. And the advantage of having one-to-one user is that we can assign permissions individually to that user. For example, we might want to assign administrative permissions to few users who can administer our AWS environment, and users are entity within an AWS account. Users don't have to pay separately. They start using the servers, and that get bills under the account they are attached to. So separate users doesn't mean that separate payment for those users. They are just users in our account, and the whole account gets to pay for the resources that they provision. Again, the IAM user does not always represent a person. An IAM user is really just an identity with associated credential and permissions attached to it. It could be an actual person who is a user, and it could be an application also who is a user. Next, we'll talk about groups. Talking about groups or understanding group is very easy. A collection of user forms an IAM group, and we can use IAM group to specify permission for multiple users so that any permission that's applied to the group is also applied to the users who are add to that group. Now there are a few things you might want to know about group. A group can have many users, and a user, they can belong to many groups, but groups can't be nested, meaning group can only have users. A group cannot have a group inside a group. That's not possible. And there's nothing called a default group that sort of automatically includes all users in the AWS account. If you want to have a group, then we will have to create a group. Now let's take this diagram for example. Now this is a diagram of a small company. Now the company owner creates an admin group for users to create and manage other users as the company expands every day. And the admin group creates a developer group and a test group. Each of these groups consists of users who are people, users who are applications that interact with AWS environment. So the different types of users we have are Jim is a user, Brad is a user, and Dev App 1 is a user, and so on. So each users have an individual set of security credential. Like I said, it's 1-to-1, and the 10 users that we see on screen are shared between, or they belong to multiple groups in the account. And managing group is quite easy. We set permission to the group, and that permission gets applied to all the users automatically in the group. And after we applied the policy, if I add another user to the group, the new user will automatically inherit all the policies, all the permissions that's already mentioned in that group. So administrative burden is sort of taken away. Administrative burden about user privilege or user permission management is sort of taken out with IAM. Alright, the next thing we will want to discuss is policy. A policy sets permission and controls the access to AWS resource. And the policies, these permissions and controls, are stored in JSON format. A policy is a very clear document. It defines who has access to a resource and what are all the actions they can perform. So in other words, policy is an entity in AWS that when a policy gets attached to an identity or a resource, it really defines the permission, what they can and cannot do. And AWS, it evaluates these policies when a principal, such as a user, makes an request. And the permission statement in the policy, it really defines whether the user is allowed to access a service or is he denied to access a service. Alright, let's take this example. Now we have a task. The task is to give Paul, who is a developer, access to Amazon S3 environment. And what you're looking at is a snippet of what a policy would look like. So these are some questions we will have to answer, or these are some questions the policy tries to answer, and once it found an answer, then it becomes a complete policy. So who wants access to the service? It's Paul who wants access to the service. And what action do Paul want? Now Paul wants to download, or Paul wants to upload objects in S3. In JSON language, it's otherwise called Paul wants to get information, Paul wants to put information. Otherwise, Paul wants to get object, Paul wants to put object in S3. And which resource does he want? Now, in this case, every bucket. The star symbol represents all buckets in S3. So, which resource? It's all bucket in S3. So, we can start reading already from the data present here. So, who wants access? Paul wants access. What action does he want? He wants to get, he wants to put. And what's the resource that he's trying to access, or you want to give him access? It's all the bucket in AWS. And when does he want? These are additional statement that goes in a policy. So since when does he want that access? He wants access till March 2nd, 2019. So all this who, all this action, all this resource, till the time all this gets allowed. So this is the statement that really defines. Now, does this all refer to an allow statement, or does this all refer to a deny statement? If we had deny here, it's the direct opposite of what we discussed, but we have allow. That means Paul is allowed to get and put access in an S3 bucket, and all the buckets in S3 till March 2nd, 2019, he's allowed to access the resources. So if we put all the information that we have gathered, or all the answers that we have so far, if we put together in a JSON format, this is how it's going to look like. So the effect is allow or deny. Here it's allowing, and the principal is any. Now who can access it? It's any. And action, it's any bucket in S3. Any action in S3, put get request, and the resource is any bucket in S3. So that's how a basic policy would look like, or that's how a basic policy is formed by answering those basic questions. So let's talk about the types of policies. So we have two broad categories, managed policy and inline policy. The managed policy, it's the default policy that we attach to multiple entries, be it users, be it groups, and be it roles in our AWS account. On the other hand, inline policy are the policies that we create and manage them. And these policies are embedded directly into a single user, group, or a role. So if I need to brief it a little bit more, then managed policies are standalone identity-based policies that we can attach to multiple users, groups, and roles in our AWS account. We can use two types of managed policies. In other words, managed policies, they themselves have two categories. One is AWS managed policies, which is created and managed by AWS. And the other one is customer managed policies. Just like the name says, it's managed by the customer. Now we can create and edit an IAM policy in Visual Editor, or simply create a JSON policy document directly and upload it in the console and start using them. So that's managed policy. On the other hand, inline policies are policies that we create and manage and that are embedded directly into a single user, group, or role. Let's talk about this next component called role. Now this role is very similar to everything that we discussed so far. It's a set of permission that defines what actions are allowed and denied by an entity in an AWS console. The role is very similar to an user. I said very similar. I didn't say it's the same as the user, but I said it's very similar to the user. And the difference is that user is hard-coded. User permissions are hard-coded. But the role permissions are accessed by any entity, be it a user or be it an AWS service, and moreover, the role permissions are temporary. On the other hand, user permissions are permanent and the role permissions are temporary. So in detail, a role is very similar to a user in that it's an AWS entity with permission policies that determines what the identity can and cannot do in AWS. Now, instead of it being uniquely associated with one person, a role is intended to be assumable by anyone who needs it. Roles generally do not have a long-term credential, password or access keys associated with it. It does not have long-term credentials. It only has temporary credentials created dynamically and provided to the user as and when the user assumes a role and wants to access any service. Roles can be assumed by users, roles can be assumed by applications, roles can be assumed by services that normally don't have access to AWS resources. For example, you might want to grant a user in your AWS account access to your resource that they do not normally have, or grant users in one AWS account access to resource in another AWS account. Now this is something that we don't have by default, and this is something we may not need all the time. Or you might want to allow a mobile app to use AWS resource, but you do not want to save the key or save the credential or save the passwords in the mobile app. Or sometimes you might want to give access to resources who already have identities defined outside of AWS, like a user who's already an Google or Facebook authenticator. If you want to give them some service, or if you want to let them to access some of the resources in your account, we can use roles for that purpose. Or you also might want to grant access to your account to a third party, a consultant or an auditor, so they can for some time get some temporary access to audit our AWS resources. Remember, they're not permanent users, just temporary users. They want some temporary access to our environment till the audit is over. So for those cases, roles are a very good use case. So let's take this example. Let's see where role sits, and let's see how roles give permission to other services. So here is a scenario where an EC2 instance wants access to an S3 bucket. By default, though both of them were created by the same username or the same admin, they do not have access by default. So by default, they don't have access. And I also do not want to give permanent access, one-on-one hard-coded permanent access. Instead, I would like to create and share access. So that's possible through role. So coming back to the discussion,
The scenario here is that an EC2 instance wants to access data in an S3 bucket. So the first thing is to create a role or a permission. We saw how that's done, right? Using policies. Roles use policies. Policy is the actual working engine for any permission related actions, right? So create a role with an appropriate policy that gives access to S3's bucket, and then launch an EC2 instance with the role attached to it. We said roles are assumed by any entity, right? It could be user, it could be an application, it could be a service, it could be another resource in AWS account. So here it's another resource in AWS account, right? So we create a role and we attach it to an EC2 instance. So now the EC2 instance can assume the role. Now the same role can be attached to another EC2 instance. The same role can be attached to another user. The same role can be attached to another database service. We get the idea, right? Roles can be assumed by anyone. So when the EC2 instance wants to communicate with S3, it contacts the role, and then the role gives this EC2 instance some temporary username and password that expires after 1 hour, let's say. So it's a temporary username and password. Now with that temporary username and password, the EC2 instance can access the S3 bucket and access the file with the credential that it already has. And that credential is a temporary one. And the credential will expire after 1 hour or how much ever time the admin sets it to be. And then the next time when an EC2 instance wants to contact S3, it will have to contact the role, and the role will propose a new access key and secret access key. In other words, a new credential. With that new credential, the second time the EC2 instance will be able to contact the S3 bucket and get the information. So the password is not a permanent or a one-time or a hard-coded password. It keeps rotating. It's a token. It's a secure token that an EC2 instance or any application that uses the role gets to access the resources on the other end. Well, let's talk about the features of IAM. The main feature of IAM is that I can create separate username and password for individual users or resources, and I can delegate access. Now, those days where we had just one username and password for admin and we need to call the other person to get the username and password over the phone, if it gets compromised, the whole account gets compromised, stuff like that. Those issues are gone. I can create separate username and password for all 1,000 users in my account. No more username and password sharing. I can manage access to all those 1,000 accounts in a very simple and an easy way. So IAM provides shared access for all the 1,000 users in my account. It provides shared access to the AWS environment. And the permissions that can be given through IAM are very granular. Now we saw how restrictions can be put on GET requests. We can allow a user to download information and not update an information. So that's possible through the IAM policies that we looked at some time back. And with the use of roles, we're authenticating an EC2 instance instead of the application running on top of it. So if there are like 10 or 20 applications running on top of an EC2 instance, instead of creating a separate username and password for all those 20 instances, I can create a role and assign that role to the EC2 instance, and all the applications running on the EC2 instance get a secure access to the other resources, use the role credential that's provided to that EC2 instance. Now, besides username and password, IAM also supports multi-factor authentication, where we provide our credential, the username and password, plus an OTP from our phone or an randomly generated number that gets displayed in our phone before Amazon console or before Amazon CLI would authenticate and lets us access some of the service in the account. So it's called multi-factor authentication. It's username and password plus something else from what you have. IAM also provides identity federation. If a user is already authenticated with a corporate AD or Facebook or Google, IAM can be made to trust that authentication method and then allow access based on that authentication. Now, without federation, what would happen is the users will have to remember two passwords, one for on-premises and one for cloud. Anytime they work on on-premises, they'll have to use one set of password, and anytime they switch to the cloud, which is going to be very frequent in every day. So anytime they switch to the cloud, they will have to again type in the cloud username and password. Now, with identity federation, we can sort of federate, or we can connect both the authentication systems, both on-premises and IAM. So users can just use one username and password for both on-premises and cloud environments. And all that we saw so far, it's free to use. There is no additional charge for IAM security. There is no additional charge for creating additional users, groups, or policies. It's a free service, comes along with any account. IAM is an PCI DSS compliant product. IAM comes with password policy where we can reset the password remotely or rotate the passwords remotely. And we can set rules like how a user should pick and password. It should not be the one that was used in the past, any of the past 3 times, stuff like that. So you get the idea, right? How the features of IAM help us to build an secure authentication and authorization system in or for our AWS account. All right, it's time to do a quick lab. Let's put all the knowledge that we have earned so far together and apply it and try a lab and solve the problem. So here's a problem statement. We need to create an S3 bucket for a company where users can read or write the data only if they are multi-factor authenticated. So there could be like 20 users in an account, but a user is allowed to read or write a data in an S3 bucket only if the user is multi-factor authenticated. This is a very good use case if we have sensitive data in an S3 bucket and you only want privileged or MFA authenticated users to do changes to those buckets. And for those privileged users, you would enable multi-factor authentication. So let's see how that's done. Before that, let me talk to you a bit more about multi-factor authentication. Now, multi-factor authentication is that additional level of security process. It's provided by AWS. Here, the user's identity is confirmed only after the user proposes or the user passes 2 levels of verification. Now, one being the username and password and another being an OTP that gets generated. In this case, it's the mobile phone. It could also be an RSA token key that generates the one-time password. That's possible as well. But in this case, it's the mobile phone. Now, that's going to be very similar to how we log in to our Gmail account sometimes. When we log into a Gmail account and if you have the proper setting enabled, it's going to send an one-time password to the mobile phone, and only after we put that information, it's going to let us log in. Let's see how all this is done in an AWS account. So the first thing is to log in to the AWS account, create a user, and attach the user to the virtual MFA device. Now we're going to use Google Authenticator here, and we're going to attach the user to Google Authenticator and make the user use the Google Authenticator one-time password every time he logs in to the account. Now this is in addition to the username and password that he or she already has, right? So the first thing is to log into the account, connect or sync the virtual appliance with the AWS username and password. Now when we sync, there will be an one-time password that gets shown in the phone. Type in the password in the AWS console, and then the phone and the username comes to sync. And from that point onwards, the user, anytime they log in, they will have to propose their username and password, which is the first step of security. And then once they typed in the username and password, type in the MFA code that gets generated on the phone. That would be the second step of security or the last step of security. Once that is done, the account is going to let them log in and access the AWS resources. Alright, so in order to test IAM, MFA, S3 together, this is what we're going to do. So we're going to create a bucket and we're going to have 2 users, and we're going to allow or deny access to the S3 bucket to those 2 users based on whether they are MFA authenticated or not. And on purpose, we're going to assign MFA to one user and no MFA to the other user. Like you might have guessed by now, the user with MFA will have access to the bucket, and the user with no MFA attached will not have access to the bucket. Both of them are going to have full S3 services, but MFA, like I said, is one layer above the other permissions. MFA stands at all time. So irrespective of whether the underlying policy says but they have full access to the S3 bucket, they're not going to, because MFA stands on top of it. Let's see how that's done. To begin with, firstly, we need a bucket. So let's create a bucket. So I'm in my AWS console. So let me go to S3. And in here, create a bucket. Call that bucket as Simplilearn MFA bucket. and let me put it in North Virginia and create. Alright, so that's done. Now I'm going to put a separate folder in here. I'm going to create another folder in here, and the name of the folder is tax documents. Now this is where I'm planning to keep my tax files, and I only want my privileged users to be able to upload and download information from the tax document. So on the bucket side, it's partially done, or on the S3 side, it's partially done. So let's go back to IAM, and here we're going to create two users, one a junior employee and another one an senior employee. The senior employee is the one who's going to have MFA access and more access to the S3 bucket, and the junior employee is the one who's not going to have access to that particular bucket. So let's get started. Let's create an user under IAM. Click on users, and let's create a user. Call this user junior right. So he's a junior user, and for the password, set a password. The user does not need to create a new password at sign in because it's a test environment, and the user who creates the username and the user are the same person. So let's keep it simple. Username, password, management console access, and this user is going to have full S3 bucket access. All right, this is really the policy. We should be familiar with this JSON document by now. It says effect is allowed, and what action? Any action in S3, and what resource? Anybody who's attached to it. Review and create a user. So this user is having S3 full access. Now let's create another user, call them as senior employee. All right, attach a policy to the user. From the surface level, both of them have the same permissions. Both of them have S3 full access. All right, so both of them have S3 full access, as we see. There's one thing different we're going to do to this senior employee. Now we're going to attach MFA to this employee. So the way we would do it is under the summary section of that particular user, click on security credential, and see here is a place we can attach an MFA to this user. So let's attach MFA to this user. For MFA, I can use both virtual MFA or hardware MFA. This being a lab environment, we're going to use virtual MFA. Now, that is an application. There are a lot of applications available, but there is one application that I'm using at the moment called Google Authenticator. So once we have installed the application, and once it is running, so I can go to virtual MFA device, and once it is running, I can scan the code using the Google Authenticator in my mobile phone. Once you turn on the application, and once you do scan the barcode that is showing right here, now that's going to give us codes that we can use. And we will have to put in those codes here twice. We'll have to wait for some time, and it would generate a second set of key that we can put. So my first set of key is 402351. Right, I'll have to wait for some time, and then it would throw me a second set of key. It's like validating twice right here. So let me put in my second set of key. So this user is now MFA authenticated user. So anytime this user logs in, it's going to ask for MFA. Anytime this user proposes something, it's going to attach the MFA key along with it. Alright, so we're done with the IAM. What have we done with IAM? We have created two users. Both of them have S3 full access, but one of them have MFA access and the other one does not have MFA access. And based on whether the user is having MFA or not, we're identifying privileged users by this MFA. Alright, so based on whether the user has MFA or not, we're going to allow deny access in the S3 bucket. So we already have a bucket, we already have a folder, and this is a very privileged folder path. Here I would like to restrict access based on whether the user is having MFA or not. So let me create a bucket policy here. Now here's a policy that I have written. The policy says that, under tax document folder, give access only if the user is MFA authenticated, right? If the user is not MFA authenticated, simply deny the access to that user. So as you might guess right now, the user 1 will not have access, or the junior employee will not have access because it's a privilege, and junior employee might tend to delete them unknowingly, and only privileged users get access to the tax document because it's confidential, because it's privileged, because if it gets deleted we won't be able to get it back for those reasons, right? So apply the bucket policy. Now try logging in as the different users and see how the permissions are applied on both the users. Alright, so let's make a note of the IAM URL. And then the 2 usernames and password. Let's log in. So let me log in as the privileged user. Sure enough, I'm being asked for an MFA code. Let me put my MFA code. So let's directly navigate to the S3 bucket. Right, here's my privileged path. Let me try uploading some content. Claim forms. Sure enough, I'm able to upload content into it. Will I be able to delete? Yes, I'm able to delete as well. Now let's see what's the situation for the other user. So let's log in as the other user. Navigate to the S3 bucket. If you noticed, when logging in, it did not ask for an MFA code because the user is not set up for MFA. So navigate to the folder which we want to test. Now try adding some files. As you see, it's failing to add content to this bucket. It shows error because the bucket policy is requiring MFA and this user is not MFA, and we did that in IAM or under IAM. But still, as you see, they will be able to view the content in the bucket. They can do all that. We have specifically restricted access to upload and download content from the bucket, and that's exactly this user is now denied with.
In this section, we're going to learn about why we need a solution called CloudFormation, or why we need a product called CloudFormation. And we're going to talk in detail about what is CloudFormation, and then how CloudFormation works and the concepts involved in CloudFormation, like templates and stacks. There are some concepts involved in CloudFormation. We're going to talk about that. And how do we maintain access control over CloudFormation? We're going to talk about that as well in this video. And then we're going to go through a demo or a lab where we create an LAMP stack environment from a template through CloudFormation. And then we're going to talk about some use cases, one of which include being able to create an redeployable template using CloudFormation. That's a very good use case. We're going to talk about that in this video. So let's talk about why CloudFormation. So when the number of products and services grow more, and managing them and maintaining them becomes an tedious work. And CloudFormation, it sort of eases that environment. Now, CloudFormation is really an infrastructure as a code, and it sort of solves all the problem that we discussed some time back. And with CloudFormation, we can actually create a perfect clone of the server configuration at any point in time. And we can also manage the configuration changes With CloudFormation, we can manage the configuration changes across the environment. And not only that, we can easily embed in the ad hoc changes to our existing environment. So one might ask, why use CloudFormation? Let's look at the current problem that we have. Creating and managing multiple AWS resources in the portal is a big task, especially when you need to replace some services. It becomes a bigger task. Now, CloudFormation eases that work. Let me explain it in detail. Now, at the moment, without the CloudFormation, or environments that don't use CloudFormation have this problem. That is, a lot of time is being spent on building the infrastructure, and less focus and less time at the moment is being given on developing that application that runs on that environment. That's because majority of the time is consumed by building the environment. And if we need to redeploy the same environment again and again, the same happens in a cycle. Again, in a new environment, we start from the scratch, build the environment, and then put application on top of it. Now, that can be avoided using CloudFormation. Now, without CloudFormation, it still is a problem, because the resource or the bandwidth that is needed for the application development is not provided, because that's taken by developing the infrastructure. And to solve that problem, we can use CloudFormation. Now, that leads to a discussion about what is CloudFormation. So let's try understanding what CloudFormation is. CloudFormation is a service that provides users a simple way to create and manage collection of AWS resources by provisioning and updating them in a very orderly and in a predictable way. If I need to expand explanation of CloudFormation, CloudFormation is a service that really helps us to model and set up our Amazon Web Services or resources, so we can spend less time on managing the resources and show more focus on the application that runs on top of it. We can simply create a template for an EC2 instance or for an RDS instance and upload it in the CloudFormation portal, and CloudFormation will provision and configure those resources based on the template that we define. We really don't have to sort out the complexities in dependency between those applications. Once the template is vetted and validated, CloudFormation takes the responsibility of handling the dependencies between the application in an orderly and a predictable way. It creates those services and makes it available for us once the template is fully run. So in short, the CloudFormation, it allows us to create and model our infrastructure and applications without we having to perform the manual action. For example, the well-known company called Expedia is able to easily manage and run its entire front and back-end resources they run on AWS in CloudFront. What does that mean? They are spending less time on managing the infrastructure and more time on the core business and the application that runs on top of it. And we're still talking about what CloudFormation is. With CloudFormation, it enables us to manage our complete infrastructure or AWS resource in a text file. Now, we're going to see that in a moment. It's either a JSON or an YAML file, and that file is called as the template to begin with. The resources the template provision is called the stack. All right, so the abstract of the code is called the template, and the resource that it provisions is called the stack. And this stack can be, it's going to run resources, obviously, and those resources can be updated as well. It's not like once you create a stack, it's done. If you need a change, you need to go create another resource. That's not needed. This stack is an updatable stack. Let's say if I'm including 2 more servers, if I'm sort of extending my environment, it's branching out to another application. Now I'm including another functionality in my environment. All those can be embedded in the update and can be updated. So like I said, the stack is an updatable one. Now let's talk about what the template can do, or some features and functionality of the template. Now, using a template, we can almost include all the application and resources that a user might require. Let's say, after the EC2 instance is provisioned, running an application on top of it, and you want to templatize that and include that in the template, that's possible as well. And these templates are portable ones, meaning I can use the template in one region and I can use the same template in another region, and that's going to build a very similar environment in another region. I can also share that with the customer, and when they run it, it's going to run an environment from the portable template in their account, in their environment. Of course, all the security is taken care. I'm just saying that if we need to build a resource, if we need to build an architecture, if we need to build an environment which looks very similar to the other environment, that is possible. And these templates are reusable by the use of some sections in the template, like the parameter section, the mapping section, the condition section within the template is what makes the templates reusable. And we will talk about parameters, mapping, and conditions down the line. We're still talking about AWS, how AWS CloudFormation works, and we're going to talk about how a template becomes an infrastructure. Right? So to begin with, one requires a template, and the template would be in JSON or YAML format. So one would develop a template based on the requirement, based on number of EC2 instances, based on whether they want a load balancer, based on whether they want a Windows server, based on whether they want an database server in that environment, and then based on the applications that will be running on top of it that can be templatized in the code itself. So one creates a code, and then the code is saved locally, or they can be put in an S3 bucket from which the CloudFormation will call the template and provision the resource. Right. So we use CloudFormation to create a stack or create the resource defined in the template. And CloudFormation analyzes the template first, validates the template, and then it identifies the dependencies between them, and then it starts provisioning the resource one after the other. For example, if you need 5 servers in a new VPC, obviously it's going to create the VPC first and servers second, and stack. All right, let's understand the two major components in CloudFormation. By now you might have guessed it. The two major components are the template and the stack. Together they aid or they complement CloudFormation, and that's how the resources are provisioned, that's how the resources are managed, and that eases the job of the administrator who's managing the environment. So let's talk about template first. A template in CloudFormation is an text file or a formatted text file in JSON or YAML language, and that the code or the template or the text file that actually describes how your infrastructure looks like or will look like once provisioned. And for us to create the template, or for us to modify an existing template, we can use a tool available called CloudFormation Designer from the console, or any text editing tool that's available. But I would recommend the CloudFormation Designer though, that has rich graphics in it. And these templates are built off, or they consist of 9 main objects. The first of which is the format version, and this really identifies the capabilities of the template based on the version number. And then the second object in a template would be description, and this helps us to include any arbitrary comments about the template. For what reason are we building this template? What's the purpose of it? Stuff like that. And then we have the object called metadata in a template, and that includes details about the template, details of the resources in the template. And then we have the optional parameters section. This really helps us to customize our template. Now, parameters enable us to input custom values to our template each time we create or update and stack. And the mapping object, it helps us to match a key to a corresponding set of named values. For example, if you want to set a value based on region, then we get to create a mapping that uses region name as the key, and then the value that we want to specify for each specific regions. And then we have conditions object. This is again an optional object. With this, we can include statements that define when a resource is created or when a property is defined. For example, we can compare whether a value is equal to another value, and based on the result of that condition, we can conditionally create additional resources. And then the object called transform. It's an optional object as well, And this transforms section specifies one or more transforms that we can use in our CloudFormation template. For example, AWS CloudFormation transforms helps simplify template authoring by condensing the expression of the AWS infrastructure as a code or the CloudFormation template, and it enables reuse of template components. For example, we can condense multiple line resources, declaring it into a single line in our template. Now we will talk about all these examples in the upcoming slides. And then we have the required section called resource that declares the AWS resource that you want to include in the stack. For example, if you want to include an EC2 instance, if you want to include an S3 bucket, we would be using the resource object in our stack. And then we have object called output. This output object, it's an optional object in the template, and it helps us to sort of declare the outputs that we can import into other stacks, or we can actually show it on the CloudFormation console. For example, if you want the output of the name of the S3 bucket that got created in response to a CloudFormation template, now we can have that outputted into an output section in the CloudFormation console itself. So it's sort of easy for us to identify the resources that the template provisioned. So with all of those objects put together, this is how a full-blown CloudFormation template with all the objects included is going to look like. Now this includes optional and mandatory objects. Let's talk about those objects in detail in the upcoming section. Alright, let's now discuss each and every object of this template structure. And let's begin our discussion with the format version. The format version, it really defines the capabilities of the template. The latest version, format version as of now, is the one that was updated on 2010. Now the value of the template format version, it has to be an string. And if we really don't specify the format version, CloudFormation automatically assumes the latest version. Talking about descriptions are really any comments that help ourselves that we want to embed in the template itself. That can be a description. And this description in a template, it has to be an string. The length of the string can be between 0 to 124 bytes in length. The metadata are really used in the template to provide any additional information using the JSON and YAML objects. And metadata holds some implementation details of a specific resource. And parameters are really a way to customize the template. Each time we create or update our stack, these parameters are the ones that helps us to give some custom value to the template during runtime. In the example shown below, the parameter named instance type parameter, it lets us to specify the EC2 instance type for the stacks to use when creating or updating the stack. By default, as we see, it's picking T2 micro, and this is the value that will get picked if we don't provision another value to it. And mapping really enables us to map a key to a corresponding named value that we specify in a conditional parameter. And also we can retrieve the map or retrieve the values in the map using the function findInMapInStrict function. Let's take this example. Let's say based on a region, if we want to set values in a template, we can create a mapping that uses a key and holds the value that you want to specify for each region. And the object conditions can be used when we want to reuse the templates by creating resources in a totally different context. For example, in a template during stack creation, all the conditions that we mention in the template are evaluated, and any resources that are associated and that come up to be true are created, and any condition that fails or invalid are kind of ignored automatically, and the check moves forward to the next condition. And conditional is an optional object, and it includes statements that define when a resource is created or when a property is actually defined. For example, you can you can compare whether a value is equal to another value, and based on the result of that condition, we can conditionally create resources. If you have multiple conditions, then they are generally separated with commas. Sometimes conditions are very helpful when we want to create templates and we want to reuse those templates which was created for one environment to another environment. For example, if you want to use a template that was created in a test environment in a dev environment, conditions would be helpful.
For example, in a production environment, we might want to include instances with certain capabilities, and in a test environment, we might want to include instances with some reduced capability in them for saving money. And condition helps us to create resources based on the environment it will be used in. We can also use intrinsic functions to define conditions like equals. We can also use OR conditions. We can use NOT functions, intrinsic functions in a condition. And when put together, the syntax is going to look like the one that you see on the screen. Now, the optional object called transform, it specifies one or more transforms that the CloudFormation uses to process our template. Now, these transform sections are built on a simple declarative language of AWS CloudFormation with a powerful macro system that helps us to reuse the templates or the template components. And they really help us to condense or simplify our codes by enabling reuse of the template components. For example, condense a multiple line resource declaration into a single line in our template. The resource section, it really declares the AWS resource that you want to include in the stack, such as EC2 instance, such as S3 bucket. And some of the resource fields are the logical ID, the resource type, and the properties. Let's talk about them in brief. The logical ID is unique within the template, and the logical ID name, it actually references the resource in other parts of the template. In this case, it's my bucket. For example, if we want to map an Elastic block store volume, or if we want to map an name of the bucket in another place in the template, then we would use the logical ID. And again, in this case, it is my bucket. A logical name has the physical ID with which we actually assign the resource. For example, in this case, my S3 bucket was named as my bucket to begin with. And the resource type in the template, it identifies that the type of the resource is an S3 bucket. And the properties are the additional optional information that we can specify to our resource. For example, if it is an EC2 instance, let's say we would like to know which AMI it used, then property section really defines the AMI that was used, or AMI as the property of the instance. So this section describes the output value that needs to be imported to other stacks, or the output value that needs to be shown in the console for the user to easily navigate to the resource that are being created. For example, for a S3 bucket name, we can declare an output, and once the bucket is created, we can actually declare the output and import the name of the bucket in a different place in the console, so it's easy to view instead of the user getting confused and going to S3 and searching for the bucket name. This can be made available in the CloudFormation console itself. And the output fields, it can include some of these followings, like the logical ID. It's actually the identifier of the current output, and it's very unique within the template. And it can also include a description. Description is really a string type that describes the output value, and it can also include value, and value is the property that was returned by the AWS CloudFormation describe stacks command. Alright, let's talk about the template resource attribute. In this section, we're going to talk about attributes that you can add to a resource to control additional behavior and relationships. So let's talk. There are many resource attributes available, out of which we have if we need to name them, we have a creation policy, and then we have deletion policy. It depends on metadata attribute, update policy attribute. Let's talk about each of them separately. When we associate the create policy attribute with the resource, it actually delays the resource configuration actions before proceeding with the stack creation. The attribute stack creation is delayed till the time the CloudFormation receives some number of success signals back. This is a very good use case when we do AutoScaling. And this creation policy can be used only with a limited number of services like AutoScaling and EC2 instances. Some of the use cases would be if you want to install a software application on an EC2 instance, you might want the applications to be running before it proceeds further. So in this case, we would use the creation policy attribute to the instance and then send the success signal after the applications are installed and configured. Then CloudFormation goes to the next step. here in the syntax that we're looking at. The autoscaling creation policy and the minimum successful instance percentage, it's actually a number of signals that it will have to reply back before it can move forward. Using deletion policy, it preserves backing up of resources when the stack is getting deleted. And by default, if you don't have a delete policy, the data gets deleted just like that. But if we use an deletion policy, we would be able to preserve the data by taking a snapshot of it, or just letting the resource and moving on with deleting the other resources in the stack. And we specify the delete policy attribute for each resource specifically that we want to control. And if there are no deletion policy mentioned for a particular resource, the CloudFormation simply deletes the resources as that's its default behavior. And if you want to keep the resource when the stack is deleted, we mention retain in the delete policy, and that simply retains the resource from getting deleted. So in this example, we're actually retaining an DynamoDB table. Rest of the resources in the stack will get deleted. And using the depends on attribute, we actually create an order in which the resource gets deleted. For example, if I map one resource to another resource and say that this resource depends on the other resource gets created first, then followed by this instance or this resource. So with the depends on attribute, we can specify that the creation of specific resource is actually followed by another. When we add the depends on attribute to a resource, the resource is created only after the creation of the resource specified by the depends on attribute. Let's take this example. In this example, we're saying that the resource X depends on Y. We've said that X depends on Y. So in this case, when CloudFormation is executing, it's going to deploy Y first because it has some resources that depends on it. So it's going to create Y first, and then it's going to create the resource called X. On the same context, let's say in the template, we say that an EC2 is going to depend on S3, and when the CloudFormation is executing, it's going to create an S3 bucket first and then the EC2 instance. That's probably because the codes needed for the EC2 instance are stored in the S3 bucket. And what we're looking at is the syntax of how the depends on template resource attribute will look like. This is how it actually will look like when we put it in the CloudFormation. The instance depends on the bucket.
The other template resource attribute is metadata. Metadatas are the one that really helps us to associate our resources with the structured data. And by including this attribute in our template, or by including this attribute to a resource, we can specify the data in JSON or in YAML language. For example, in this section of the template, we're creating a VPC, and the metadata explains, or metadata defines, that the VPC is part of the region US East 1. And the update policy template resource attribute in CloudFormation, we can manage and replace the updates of the instance in an autoscaling group. For example, you're looking at this sample where it says that the update policy, will it replace the instance in an autoscaling group or not? So depending on what the value is for the will replace section, whether it's true or false, depending on that, the update policy will replace the instance or will replace the autoscaling group itself when it's doing a rolling deployment. Now that we've discussed about templates, let's talk about AWS stacks as well. Now we know that AWS stacks are the actual resources that gets generated or that gets created because we ran a template, right? So stack is a collection of AWS resource that we can manage in a single unit. In other words, we can create a stack, update a stack, or delete a stack, and that would actually create, update, delete the collection of resources within the stack. And all the resources in the stack are really defined by the CloudFormation template. And a stack, for instance, can include all the resources required to run a web application, such as a web server, a database server, and some networking rules that come along with it. All that gets embedded in a stack. And let's say if we want to delete all the resources that were created by template, that is in a a separate stack, we can simply delete the stack, and that would sort of delete all the resources that is in the stack. So it sort of helps us to manage all the resources in a single unit or as a single unit. So to summarize, stack is a collection of AWS resource and it can be managed as a single unit. And the CloudFormations template defines a stack in which the resource can be created, deleted, or updated in a very predictable way. And a stack can have all the resources like web server, database server, VPC, the network and the security configurations in a VPC, all that is required to run a web or a database application. Now, stack could be nested as well. With CloudFormation, we can actually nest a stack with another stack, and that's going to create a hierarchy of the stacks. For example, this is a very good picture that explains how the stacks are nested in a hierarchical way. Let's say stack P is the root stack, and that could be a parent stack for the stack called R and the stack called Q. And the same way, the stack called R is a parent stack for the stack S, and the stack S is the parent stack for T and Q. You get that, right? So stacks can always be nested. It's possible. CloudFormation allows us to create a Microsoft Windows stack based on Amazon EC2 Windows AMIs and provide us with the ability to install software and use remote desktop to access our stack and update the configuration of our stack. And these stacks can be run on Windows Server instances. There are a number of pre-configured templates available, and it's directly available to use from the AWS website itself. To name a few, we have templates available for SharePoint running on an Windows Server 2008 R2. We also have templates that create a single server installation of Active Directory running on a Windows Server. And in fact, we have templates available for Elastic Beanstalk and some sample applications that runs from an Windows Server 2008 R2. Let's talk about stack sets. Stack sets actually has taken the stack level implementation to the next level. Using the AWS CloudFormation template, we can define a stack set that lets us to create stack in AWS account across the globe by using just a single template. And after we create the stack, or after the stack set is defined, creating, updating, or deleting the stack in the target account and the regions can also be specified by us. So the stack set, it really extends the functionality of the stacks by allowing us to create, update, and delete stack across multiple accounts, regions in just a single operation. And using an administrator account, we can define and manage an AWS CloudFormation template and use the template as the basis for provisioning stacks into some selected target accounts across a specified region. Let's talk about CloudFormation access control. With IAM, I can specify the list of users or list of privileged users who would have access to the CloudFormation template, who can create, update, and delete stacks. So that's how IAM helps me with having or putting a layer of control over the CloudFormation service. And we can also use service roles. Service roles are the one that allows AWS CloudFormation to make a call to a resource in a stack on the user's behalf. And I can also have stack policies, and these stack policies are applied to the users who already have access to the CloudFormation service. And these policies are the ones that help the users who attempt to update the stack. All right, let's do a quick lab on creating a LAMP stack on an EC2 instance with a local MySQL database for storage. Now, we can do the other way as well. I can pick an EC2 instance and install the servers one top of the other. That can be done as well, but that's going to take a lot of time. Now, we're talking about automating it. We're talking about, provisioning an infrastructure using a code, and CloudFormation helps us to do that. So this is what we're going to do. We're going to create, or we have a CloudFormation template already, and we're going to use that template to provision a web instance, and that is going to have, look at that, that's going to have MySQL installed in it, that's going to have PHP, that's going to have HTTPD service installed in it and running. And it's also going to have a PHP website running from it. So that's going to receive information from the website, and that's going to store that information in the database that's very local to it. This is the template that defines that environment. All right, this is a very simple provisioning. So let's provision this environment. Let's create a stack. We're going to give a stack name and a database password. Right, and which region is it? This is in California, is it? All right. Now let me do one thing. Let me switch to the Mumbai region, or let me switch to North Virginia region. North Virginia, and from here, actually, let me switch to Mumbai region. Right, just to be sure, it's the same template that we're provisioning. Right, that's the same template that we are provisioning. Right, let's give this name. So it can be great. This could be Simplilearn Lambda stack, and what could be the DB password and DB root password, and what could be the DB user. I'm going to keep the rest as defaults, and I'm going to launch. Alright, so there's an issue with the password. Password should only have alpha numeric characters. Get that. So let's go back and create a new password. Right, it also needs to have 8 characters. So what can be our password? Look at that. The template is actually creating the resources. And here in the screen, we can see the template that we used to deploy the environment. If you remember, we discussed about instant types in parameters, right? The default instance type is T2 small, but these are also allowed to run. Alright, parameter section is the one that was used to receive information from us, like the DB name, the DB password, the DB root password, DB user instance type, key name, and the SSH locations. Alright, now this resource section is showing us the resource that it actually created. Right, looks like it's rolling back. Why would that be? Give me a moment. Alright, this is one live example. Anytime it could not provision, or if there is an interruption that it could not proceed, it would simply roll back and delete all the resources that it had provisioned, and that's what it did. Now let me fix this. Alright, as a fix, I have switched the region because I had some issue with the VPC. That's going to take time for me to analyze and fix it. So here we're going to understand about CloudFormation. So I thought I'll run the CloudFormation from another VPC that I know is working fine. That's in North Virginia. Alright, let's provision a LAMP server which is running out of Linux, which has Apache installed in it, which has PHP and MySQL already installed in it. So one server going to act as web and DB server. Right, so I'm going to create a stack, and from here I'm going to pick a sample stack. If we look at it in the designer, it's going to provision one LAMP server and a security group attached to it. There you go. Right, so let's go ahead and create a stack. All right, parameters are used to receive input from us. What could be the DB password and the DB user, and let's select the key name. Right, I'm going to keep the rest as defaults, and I'm going to create a stack. Alright, so our stack that we ran from the template, at the moment it's getting created, it's in progress. From here I can watch the events as to what is getting created at the moment. Like I said, a lot of these would have already sorted out their dependencies, which one needs to get created first, which one needs to get created second. All that is sorted out by CloudFormation itself. And parameters are the values that we have inputted, and resource tab is a section where we can find what resources are being provisioned at the moment. So to begin with, it created a security group. At the moment it's creating an instance, and output, it's empty as of now. We're going to come back and see it. Now output is where we can get outputs of a finished job. Let's say here I wanted an URL of the server that got created. So instead of me going to a couple of other places within the console and find the output of the URL or the output of the resource that was created, I can simply get it from here. Well, this needs to be defined in the templates first. Once we define it in the template, it's going to be made available like here, right? So I can open it up, and so there you go. So it already has a database locally installed, and it's connected to it. If I launch an application on top of it, that will get connected to the database, which is very local, and my single server with web and database in it is ready for production. Now, while we're talking about a LAMP server, a single LAMP server, let's talk about creating an environment like this, which has Elastic Load Balancer, a VPC, a server running in an auto-scaling group, and putting some restrictions that nobody will be able to access the EC2 instance directly, but they should be able to access the EC2 instance or the data only through the Elastic Load Balancer. This is a bit complicated than the environment that we've already created. Let's see how this is done. Alright, in this lab, we're going to create Elastic Load Balanced auto-scaling group, which is going to create a load balancer and an auto-scaling group, and that auto-scaling group receives traffic only from the load balancer. So here's the template, and here's the architecture that we're going to provision. Let me call it right, and the key pair it's going to use is Simplilearn key pair. Now this is where the problem was. Now we were selecting few subnets. So now if I provision it, now this is going to take its short time to provision the resources. So through parameters, we can see the values that we have inputted, and the events look good. No rollback, no deletes, and the resource section shows the resource that it is creating. So previously it created a target group, now it's creating the application load balancer itself. Alright, so it created a load balancer, and then it created a security group. It created a launch configuration. At the moment it's creating a web server group. And the events look good with all green and yellow. Green ones are completed, yellow ones are in progress. We don't have any red delete or rollback errors, so it looks good. Alright, it took a while, and the resources have been created. Some of them show that they are in progress, but the status of the stack is complete. All resources have been created, and we do have an output to access the URL. There you go. And remember, there was another feature of the CloudFormation that was it should restrict access, direct access to EC2 instance. Let's see if that has been done. If I try to access using the load balancer, it lets me access. But if I try to access it using the EC2 instance IP or the DNS name, my connection won't go through because it's blocked through the security group, but direct access through the load balancer is allowed, and that's what we wanted to achieve through that template. Here we're going to talk about Amazon ECS, a service that's used to manage Docker containers. So without any further ado, let's get started. In this session, we would like to talk about some basics about AWS, and then we're going to immediately dive into why Amazon ECS and what is Amazon ECS in general. And then it uses a service called Docker, so we're going to understand what Docker is. And there are competitive services available for ECS. I mean, ECS is not the own and only service to manage Docker containers. But why ECS? Advantage of ECS. We will talk about that. And the architecture of ECS. So how it functions, what are the components present in it, and what are the functions that it does. I mean, each and every component, what are all the functions that it does. All those things will be discussed in the architecture of Amazon ECS. And how it works, how it all connects together. That's something we will discuss. And what are the companies that are using ECS? What were the challenge and how ECS helped to fix the challenge? That's something we will discuss. And finally, we have a wonderful lab that talks about how to deploy Docker containers on an Amazon ECS. So let's talk about what is AWS. Amazon Web Service, in short called as AWS, is an web service in the cloud that provides a variety of services such as compute power, database storage, content delivery, and a lot of other resources, so you can scale your business and grow, not focus more on your IT needs and the rest of the IT demands. Rather, you can focus on your business and let Amazon scale your IT, or let Amazon take care of your IT. So what is that you can do with AWS? With AWS, we can create, deploy any application in the cloud. So it's not just deploying, you can also create your application in the cloud. It has all the tools and services required, the tools and services that you would have installed in your laptop or you would have installed in your on-premises desktop machine for your development environment. The same thing can be installed and used from the cloud. So you can use cloud for creating, and not only that, you can use the same cloud for deploying and making your application available for your end user. The end user could be internal users, the end user could be in the internet, the end user could be kind of spread all around the world. It doesn't matter. So it can be used to create and deploy your applications in the cloud. And like you might have guessed, now it provides service over the internet. That's how your users worldwide would be able to use the service that you create and deploy, right? So it provides service over the internet. So that's for the end customer. And how will you access those services? That's again through the internet. It's like the extension of your data center in the internet. So it provides all the services in the internet. It provides compute service through the internet. So in other words, you access them through the internet. It provides database service through the internet, over the internet. In other words, you can securely access your database through the internet, and a lot more. And the best part is this is pay as you go, or pay only for what you use. There is no long-term or beforehand commitment here. Most of the services does not have any commitment. So there is no long-term and beforehand commitment. You only pay exactly for what you use. There's no overage, there's no overpaying, right? There's no buying in advance, right? You only pay for what you use. Let's talk about what ECS is. So before ECS, before containers, right? ECS is a service that manages Docker containers, right? It's not a product or it's not a feature all by itself. It's a service that's dependent on Docker container. So before Docker containers, all the applications were running on VM or on a host or on a physical machine, right? And that's memory bound, that's latency bound. The server might have issues, on and on, right? So let's say this is Alice and she's trying to access her application, which is running somewhere in her on-premises, and the application isn't working. What could be the reason? Some of the reasons could be memory full, the server is currently down at the moment, we don't have another physical server to launch the application, A lot of other reasons. So a lot of reasons why the application wouldn't be working in on-premises. Some of them are memory full issue and server down issue, very less high availability, or in fact single point of failure and no high availability, if I need to tell it correctly. With ECS, the services can kind of breathe free, right? The services can run seamlessly. Now how is that possible? Now, those things we will discuss in the upcoming sessions. So because of containers and ECS managing containers, the applications can run in a high available mode. They can run in a high available mode, meaning if something goes wrong, right, there's another container that gets spun up, and your application runs in that particular container. Very less chances of your application going down. That's what I mean. This is not possible with a physical host. This is very less possible with a VM, or at least it's going to take some time for another VM to get spun up. So why ECS, or what is ECS? Amazon ECS maintains the availability of the application and allows every user to scale containers when necessary. So it not only meets the availability of the application, meaning one container running your application or one container hosting your application should be running all the time. So to meet that high availability, availability is making sure your service is running 24/7. So container makes sure that your services run 24/7. Not only that. Suddenly, if there is an increase in demand, how do you meet that demand? Right? Let's say you have like 1,000 users. Suddenly, the next week there are like 2,000 users. Right. So how do you meet that demand? Container makes it very easy for you to meet that demand. In case of VM, or in case of physical host, you literally will have to go buy another physical host, or add more RAM, add more memory, add more CPU power to it, right? Or kind of club 2-3 hosts together, clustering. You would be doing a lot of other things to meet that high availability and also to meet that demand. But in case of ECS, it automatically scales the number of containers. It automatically scales the number of containers needed, and it meets your demand for that particular hour. So what is Amazon ECS? The full form of ECS is Elastic Container Service, right? So it's basically a container management service which can quickly launch and exit and manage Docker containers on a cluster. So what's the function of ECS? It helps us to quickly launch and quickly exit and manage Docker containers. So it's kind of a management service for the Docker containers you will be running in Amazon or running in the AWS environment. So in addition to that, it helps to schedule the placement of container across your cluster. So it's like this. You have two physical hosts, joined together as a cluster. And ECS helps us to place your containers. Now, where should your container be placed? Should it be placed in host 1? Should it be placed in host 2? So that logic is defined in ECS. We can define it. You can also let ECS take control and define that logic. Most cases you will be defining it. So schedule the placement of containers across your cluster. Let's say two containers want to interact heavily. You really don't want to place them in two different hosts, right? You would want to place them in one single host so they can interact with each other. So that logic is defined by us. And these container services, you can launch containers using AWS Management Console, and also you can launch containers using SDK kits available from Amazon. You can launch through a Java program. You can launch container using an .NET program. You can launch container using an Node.js program, as in when the situation demands. So there are multiple ways you can launch containers through Management Console and also programmatically. And ECS also helps to migrate application to the cloud without changing the code. So anytime you think of migration, the first thing that comes to your mind is that how will that environment be? Based on that, I'll have to alter my code. What's the IP? What is the storage that's being used? What are the different parameters I'll have to include? The environment parameters of the new environment. With containers, now that worry is already taken away, because we can create an pretty exact environment the one that you had on premises, the same environment gets created in the cloud. So no worries about changing the application parameter, no worries about changing the code in the application. Right? You can be like, if it ran in my laptop, a container that I was running in my laptop, it's definitely going to run in the cloud as well, because I'm going to use the same container in the laptop and also in the cloud. In fact, you're going to ship it. You're going to move the container from your laptop to Amazon ECS and make it run there. So it's like the very same image, the very same container that was running in your laptop will be running in the cloud or production environment. So what is Docker? We know that ECS helps to quickly launch, exit, and manage Docker containers. What is Docker? Let's answer that question. What is Docker? Now, Docker is a tool that helps to automate the development of an application as a lightweight container so that the application can work efficiently in different environments. This is pretty much what we discussed right before the slide. I can build an application in my laptop or in on-premises in a container environment, Docker container environment, and anytime I want to migrate, right, I don't have to kind of rewrite the code and then rerun the code in that new environment. I can simply create an image, a Docker image, and move that image to that production or the new cloud environment and simply launch it there. Right, so no compiling again, no relaunching the application. Simply pack all your code in a Docker container image and ship it to the new environment and launch the container there. That's all. So Docker container is a lightweight package of software that contains all the dependencies. So because, when packing, you'll be packing all the dependencies. You'll be packing the code. You'll be packing the framework. You'll be packing the libraries that are required to run the application. So in the new environment, you can be pretty sure, you can be guaranteed that it's going to run because it's the very same code, it's the very same framework, it's the very same libraries that you have shipped, right? There's nothing new in that new environment. It's the very same thing that's going to run in that container. So you can be rest assured that they are going to run in that new environment. And these Docker containers are highly scalable and they are very efficient. Suddenly you wanted like 20 more Docker containers to run the application. Think of adding 20 more hosts, 20 more VMs, right? How much time would it take? And compared to that time, the amount of time that Docker containers would require to kind of scale to that amount, like 20 more containers, it's very less, or it's minimal or negligible. So it's an highly scalable and it's a very efficient service. You can suddenly scale number of Docker containers to meet any additional demand. Very short boot up time because it takes it's not going to load the whole operating system. And these Docker containers, they use the Linux kernel and features of the kernel like C groups and namespaces to kind of segregate the processors so they can run independently any environment, and it takes very less time to boot up. And the data that are stored in the containers are kind of reusable. So you can have an external data volume and I can map it to the container, and whatever the space that's occupied by the container and the data that the container puts in that volume, they are kind of reusable. You can simply remap it to another application. You can kind of remap it to the next successive container. You can kind of remap it to the next version of the container, next version of the application you'll be launching, and you don't have to go through building the data again from the scratch. Whatever data the container was using previously or the previous container was using, that data is available for the next container as well. So the volumes that the containers uses are very reusable volumes. And like I said, it's isolated application, so it kind of isolates by its nature. It kind of, by the way it's designed, by the way it is created, it isolates one container from another container, meaning anytime you run applications on different containers, you can be rest assured that they are very much isolated. Though they are running on the same host, though they are running on the same laptop, let's say, though they are running on the same physical machine, let's say, running 10 containers, 10 different applications, you can be sure that they are well disconnected or well isolated applications. Now let's talk about the advantages of ECS. The advantage of ECS is improved security. its security is inbuilt in ECS. With ECS, we have something called as a container registry. That's where all your images are stored, and those images are accessed only through HTTPS. Not only that, those images are actually encrypted, and access to those images are allowed and denied through identity and access management policies, IAM. And in other words, let's say two containers running on the same instance. Now, one container can have access to S3 and the others, or the rest of the others, are denied access to S3. So that kind of granular security can be achieved through containers when we mix and match the other security products available in Amazon, like IAM, encryption, accessing it using HTTPS. These containers are very cost efficient. Like I've already said, these are lightweight processes. Right? We can schedule multiple containers on the same node, and this actually allows us to achieve high density on an EC2 instance. Imagine an EC2 instance that's very less utilized. That's not possible with a container, because you can actually dense or crowd an EC2 instance with more container in it, so to best use those resources. In EC2, straightforward, you can just launch one application. But when we use containers, you can launch like 10 different applications on the same EC2 server. That means 10 different applications can actually feed on those resources available and can benefit the application. And ECS not only deploys the container, it also maintains the state of the containers, and it makes sure that the minimum set of containers are always running based on the requirement. That's another cost efficient way of using it, right? And anytime an application fails, and that has a direct impact on the revenue of the company, and ECS makes sure that you're not losing any revenue because your application has failed. And ECS is a pretty extensible services. It's like this: in many organizations, there are majority of unplanned work because of environment variation. A lot of firefighting happens when we kind of deploy the code from one, or kind of move the code or redeploy the code in a new environment. A lot of firefighting happens there. Right. This Docker containers are pretty extensible. Like we discussed already, environment is not a concern for containers, because it's going to kind of shut itself inside a Docker container, and anywhere the Docker container can run, the application will run exactly the way it performed in the past. So environment is not a concern for the Docker containers. In addition to that, ECS is easily scalable. We have discussed this already. And it has improved compatibility. We have discussed this already. Let's talk about the architecture of ECS. Like you know now, the architecture of ECS is the ECS cluster itself. That's group of servers running the ECS service, and it integrates with Docker, right? So we have a Docker registry. Docker registry is a repository where we store all the Docker images or the container images. So it's like three components. ECS is of three components. One is the ECS cluster itself. Right? When I say ECS itself, I'm referring to ECS cluster of servers that will run the containers. And then the repository where the images will be stored, right? The repository where the images will be stored, and the image itself. So container image is the template of instructions which is used to create a container, right? So it's like, what's the OS? What is the version of node that should be running? And any additional software do we need? So those questions gets answered here. So it's the template of instructions which is used to create the containers. And then the registry is the service where the Docker images are stored and shared. So many people can store there, and many people can access, or if there's another group that wants to access, they can access the image from there, or one person can store the image and rest of the team can access, and the rest of the team can store image, and this one person can pick the image from there and kind of ship it to the customer or ship it to the production environment. All that's possible in this container registry. And Amazon's version of the container registry is ECR. And there's a third party. Docker itself has a container registry, that's Docker Hub. ECS itself, which is the group of servers that runs those containers. So these two, the container image and the container registry, they kind of handle Docker in an image format, just an image format. And in ECS is where the container gets live, and then it becomes an compute resource and starts to handle requests, starts to serve the page and starts to do the batch job, whatever your plan is with that container. So the cluster of servers, ECS, integrates well with the familiar services like VPC. VPC is known for securing. VPC is known for isolating the whole environment from rest of the customers, or isolating the whole environment or the whole infrastructure from the rest of the clients in your account, or from the rest of the applications in your account, on and on. So VPC is a service that provides or gives you the network isolation. ECS integrates well with VPC. And this VPC enables us to launch AWS resources such as Amazon EC2 instance in a virtual private network that we specify. This is basically what we just discussed. Now let's take a closer look at the ECS. How does ECS work? Let's find answer for this question. How does ECS work? ECS has got a couple of components within itself. So these ECS servers can run across availability zone. As you can see, there are two availability zones here. They can actually run across availability zones. And ECS has got two modes, Fargate mode and the EC2 mode. Right here we're seeing Fargate mode, and then here we're seeing nothing. That means it's an EC2 mode. And then it has got different network interfaces attached to it, because they need to be running in an isolated fashion, right? So anytime you want network isolation, you need separate IP, and if you want separate IP, you need separate network interface card, and that's what you have, Elastic Network Interface Card, separate Elastic Network Interface Card for all those tasks and services. And this runs within an VPC. Let's talk about the Fargate service. Tasks are launched using the Fargate service. So we will discuss about tasks. What is Fargate? Now, Fargate is a compute engine in ECS that allows users to launch containers without having to monitor the cluster. ECS is a service that manages the containers for you, right? Otherwise, managing containers will be a full-time job. So ECS manages it for you, and you get to manage ECS. That's the basic service. But if you want Amazon to manage ECS and the containers for you, we can go for Fargate. So Fargate is a compute engine in ECS that allows users to launch containers without having to monitor the ECS cluster. And the tasks that we discussed, the tasks has two components. You see task right here. So they have two components. We have ECS container instance, and then the container agent. So like you might have guessed right now, ECS container instance is actually an EC2 instance, right, capable of running containers. Not all EC2 instances can run containers. So these are like specific EC2 instances that can run containers. They are ECS container instances. And then we have container agent, which is the agent that actually binds those clusters together, and it does a lot of other housekeeping work, right? Kind of connects clusters, makes sure that the version needed is present. So it's all part of that agent, or it's all job of that agent. Container instances is part of Amazon EC2 instance, which run Amazon ECS container agent. Pretty straightforward definition. And then a container agent is responsible for communication between ECS and the instance, and it also provides the status of the running containers. Kind of monitors the container, monitors the state of the container, make sure that the container is up and running, and if there's anything wrong, it kind of reports it to the appropriate service to fix the container, on and on. Right? So container agent, when we don't manage container agent, it runs by itself, and you really don't have to do anything to make the container agent better. It's already better. You really won't be configuring anything in the agent. And then Elastic Network Interface Card is a virtual interface network that can be connected to an instance in VPC. So in other words, Elastic Network Interface is how the container interacts with another container, and that's how the container interacts with the EC2 host, and that's how the container interacts with the internet, external world. And a cluster is a set of ECS container instances It's not something that's very difficult to understand. It's simply a group of EC2 instances that runs that ECS agent. And this cluster handles the process of scheduling, monitoring, and scaling the request. We know that ECS can scale, the containers can scale. How does it scale? That's all monitored and managed by this ECS cluster. Let's talk about the companies that are using Amazon ECS. There are a variety of companies that use ECS clusters. To name a few, Okta uses ECS cluster, and Okta is a product that uses identity information to grant people access to applications on multiple devices at any given point of time. They make sure that they have a very strong security protection. So Okta uses Amazon ECS to run their Okta application and serve their customers. And Abima is a TV channel, and they chose to use microservices and Docker containers. They already had microservices and Docker containers, and when they thought about a service that they can use in AWS, ECS was the only service that they can immediately adapt to. And because in Abima TV the engineers have already been using Docker and Docker containers, it was kind of easy for them to adapt themselves to ECS and start using it, along with the benefits that ECS provides. Previously they had to do a lot of work, but now ECS does it for them. Right. Similarly, Remain and Ubisoft, GoPro are some of the famous companies that use Amazon ECS and get benefited from its scalability, get benefited from its cost, gets benefited from its Amazon managed services, get benefited from the portability that ECS and the migration option that ECS provides. Let's talk about how to deploy a Docker container on Amazon ECS. The way to deploy a Docker container on ECS is, first we need to have an AWS account and then set up and run our first ECS cluster. So in our lab we're going to use the launch wizard to run an ECS cluster and run containers in them. And then task definition. Task definition tells the size of the container, the number of the container. And when we talk about size, it tells how much of CPU do you need, how much of memory do you need. And talking about numbers, it requires how many numbers of container you're going to launch. Is it 5, is it 10, or is it just one running all the time? Now those kind of information goes in the task definition file. And then we can do some advanced configuration on ECS, like load balancers and what port number you want to allow and you don't want to allow, who gets access, who shouldn't get access, and what's the IP that you want to allow and deny requests from, on and on. And this is where we would also mention the name of the container, so to differentiate one container from the other, and the name of the service. Is it a backup job? Is it a web application? Is it a data container? Is it going to take care of your data backend? And the desired number of tasks that you want to be running all the time. Those details go in when we try to configure the ECS service, right? And then you configure your cluster. You put in all the security in the configure your cluster step or configure cluster stage. And finally, we will have an instance and bunch of containers running in that instance. All right, let's do a demo. So here I have logged in to my Amazon portal, and let me switch to the appropriate region. I'm going to pick North Virginia. North Virginia, look for ECS. And it tells ECS is a service that helps to run and manage Docker containers. Well and good. Click on it. I'm in North Virginia. Just want to make sure that I'm in the right region. And go to clusters. And here we can create cluster. This is our Fargate, and this is our EC2 type launching for Linux and Windows environment. But I'm going to launch through this walkthrough portal. Right? This gives a lot of information here. So the different steps involved here is creating a container definition, which is what we're going to do right now, and then a task definition, and then service, and finally the cluster. It's a 4-step process. So in container definition, we define the image, the base image we are going to use. Now here I'm going to launch an HTTPD or a simple HTTP web page, right? So a simple HTTPD 2.4 image is fair enough for me. And it's not a heavy application, so 0.5 gigabit of memory is enough. And again, it's not a heavy application, so 0.25 virtual CPU is enough in our case, right? You can edit it based on the requirement. You can always edit it. And because I'm using HTTPD, the port mapping is already port 80. That's how the container is going to receive the request. And there's no health check as of now. When we want to design critical and complicated environments, we can include health check, right? And this is the CPU that we have chosen. We can edit it. And I'm going to use some bash commands to create an HTML page, right? This page says that, Amazon ECS sample app, right? And then it says Amazon ECS sample app. Your application is running on a container in Amazon ECS. So that's the page, the HTML page that I'm going to create, right? Index.html. So I'm going to create and put it in an appropriate location so those pages can be served from the container, right? If you replace this with any of your own content, then it's going to be your own content. ECS comes with some basic logs, and these are the places where they get stored. That's not the focus as of now, right? So I was just saying that you can edit it and customize it to your needs. We're not going to do any customization now. We're just getting familiar with ECS now. And the task definition, name of the task definition is first run task definition, and then we are running it in a VPC. And then this is an Fargate mode, meaning the servers are completely handled by Amazon, and the task memory is 0.5 gigabit, and the task CPU is 0.25 virtual CPU. Name of the service: is it a batch job? Is it an a front end? Is it a back end? Or is it a simple copy job? What's the service? Name of the service goes here. Again, this you can edit it. And here's our security group. As of now, I'm allowing port 80 to the whole world. If I want to restrict to a certain IP, I can do that. The default option for load balancing is no load balancer, but I can also choose to have a load balancer and use port 80 to map that port 80 to the container port 80, right? I can do that. The default is no load balancer. All right, let's do one thing. Let's use load balancer. Let's use load balancer, and port 80 receives information on port 80 HTTP. What's going to be the cluster name? We're in the last step. What is the cluster name? Cluster name can be Simplilearn ECS demo. Next, we're done, and we can create. So it's launching a cluster, as you can see, and it's picking the task definition file that we've created, and it's using that to launch an service. And then these are the log groups that we discussed, and it's creating a VPC. Remember, ECS clubs well with the VPC. It's creating a VPC, and it's creating two subnets here for high availability. It's creating that security group, port 80, allowed to the whole world, and then it's putting it behind an load balancer. It generally would take like 5 to 10 minutes, so we just need to be patient and let it complete its creation. And once this is complete, we can simply access these servers using the load balancer URL. And when this is running, let me actually take you to the other products or the other services that are integrated with ECS. It's getting created. Our service is getting created as of now. ECR repository. This is where all our images are stored. Now, as of now, I'm not pulling my image from ECR. I'm pulling it directly from the internet, Docker Hub. But all custom images, they are stored in this repository. So you can create a repository, call it app1, create a repository. So here's my repository. So any image that I create locally, or any Docker image that I create locally, I can actually push those images using these commands right here, and they get stored here. And I can make my ECS connect with ECR and pull images from here. So they would be my custom images. And as of now, because I'm using a default image, it's directly pulling it from the internet. Let's go to EC2 and look for a load balancer, because we wanted to access the application from behind a load balancer, right? So here is a load balancer created for us, and anytime I put the URL, so a cluster is now created. You see there's one service running. All right, let's click on that cluster. Here is the name of our application, and here is the tasks, the different containers that we are running. And if you click on it, we have an IP, right? IP of that container. Right? And it says it's running, it was created at such and such time and started at such and such time. And this is the task definition file that this container uses, meaning the template, the details, all the version details, they all come from here, and it belongs to the cluster called Simplilearn ECS demo, right? And you can also get some logs, container logs from here. So let's go back. And there are no ECS instances here because remember, this is Fargate. You're not managing any ECS instance, right? So that's why you're not seeing any ECS instance here. So let's go back to tasks and go back to the same page where we found the IP. Pick that IP, put it in the browser, and you have this sample HTML page running from an container. So let me go back to load balancer, EC2, and then under EC2 I'll be able to find a load balancer, find that load balancer, pick that DNS name, put it in the browser, and now it's accessible through the load balancer URL. Right now this URL can be mapped to other services like DNS. This URL can be embedded in any of your application if you want to make that application connect with this container. Now using IP is not all that advisable because these containers can die and then a new container gets created, and when a new container gets created it gets a new IP, right? So hardcoding IP is hardcoding dynamic IPs are not advisable. So you would be using load balancer and putting that URL in that application that you want to make it interact with this container instance. It was a wonderful experience in walking you through this ECS topic, and in here we learned about what AWS is and why we're using ECS and what is ECS in general, what is Docker in specific, and we also learned about the advantages of ECS, the architecture, the different components of ECS, and how ECS works when they're all connected together. And we also looked at the companies that use ECS and their use cases, and finally a lab, how we can launch ECS Fargate through the portal. In this section we are going to talk about basics of AWS, and then we're going to immediately dive into why we need Amazon Route 53, and then we're going to expand and talk about the details of Amazon Route 53, the benefits it provides over its competitors, and the different types of routing policy it has, and some of Amazon Route 53's key features. And we're going to talk about how to access Route 53, the different ways, the different methods you can access Route 53, and finally we're going to end with a wonderful demo in Route 53. So let's talk about what is AWS. Amazon Web Services, or AWS in short, is a cloud provider that offers a variety of services such as a variety of IT services or infrastructure services such as compute power, database, content delivery, and other resources that helps us to scale and grow our business. And AWS is hot, AWS is picking up, AWS is being adapted by a lot of customers. That's because AWS is easy to use even for a beginner. And talking about safety, the AWS infrastructure is designed to keep the data safe irrespective of the size of the data. Be it small data, be it very minimal data, be it all the data that you have in terabytes and in petabytes, Amazon can keep it safe in their environment. And the wonderful thing and the most important reason why a lot of customers move into the cloud is that the pay-as-you-go pricing. There is no long-term commitment and it's very cost effective. What this means is that you're not paying for a resource that you're not using. In on-premises, you do pay for resources you're not using a lot. Meaning you go and buy a server, you do the estimate for the next 5 years, and only after like 3 or 4 years you'll be hitting the peak capacity, but still you would be buying that capacity before 4 years. Right, and then you will gradually be, utilizing it from, 40%, 60%, 70, 80, and then 100. So what you have done is that even though you're not using the full capacity, you still have bought it and are paying for it from day one. But in the cloud, it's not like that. You only pay for the resources that you use. Anytime you want more, you scale up the resource and you pay for the scaled up resource. And anytime you want less, you scale down the resource and you pay less for that scaled down resource. Let's talk about why Amazon Route 53. Let's take this scenario where Rachel is trying to open her web browser and the URL that she hit isn't working. A lot of reasons behind why the URL isn't working. It could be the server utilization that went high. It could be the memory usage that went high. A lot of reasons. And she starts to think, is there an efficient way to scale resources according to the user requirements? Or is there an efficient way to kind of mask all those failures and kind of divert the traffic to the appropriate active resource or active service that's running our application? You always want to hide the failures, right? In IT, kind of mask the failure and direct the customer to another healthy service that's running, right? None of your customers would want to see a server not available, or none of your customers would want to see your service not working. Not impressive to them. And this is Tom. Tom is an IT guy and he comes up with an idea and he's answering Rachel, yes, we can scale resources efficiently using Amazon Route 53. In a sense, he's saying that yes, we can mask the failure and we can keep the services up and running, meaning we can provide more high availability to our customers with the use of Route 53. And then he goes on and explains Amazon Route 53 is a DNS service that gives developers an efficient way to connect users to internet applications without any downtime. Now, downtime is the key. Amazon Route 53 helps us to avoid any downtime that customers would experience. You still will have downtime in your server, in your application, but your customers will not be made aware of it. And then Rachel is kind of interested and she's like, yeah, that sounds interesting. I want to learn more about it. And Tom goes on and explains the important concepts of Amazon Route 53. That's everything that I'm going to explain it to you as well. All right, so what is Amazon Route 53? Amazon Route 53 is a highly scalable DNS or domain name system web service. This service, this Amazon Route 53, it functions three main things, or it has three main functions. So the first thing is, if a website needs a name, Route 53 registers the name for the website domain. Let's say you want to buy google.com. You want to buy the domain name. Let's say you want to buy that domain name. You buy that through Route 53. Secondly, Route 53 is the service that actually connects your server, which is running your application or which is serving your web page. So that's the service that actually, Route 53 is the service that connects the user to your server when they hit google.com in the browser or whatever domain name that you have purchased. So you bought a domain name and the user types in your domain name.com, and then Route 53 is a service that helps the user to connect their browser to the application that's running in an EC2 instance or any other server that you are using to serve that content. Now, not only that, Route 53 checks health of the resource by sending automated requests over the internet to a resource. So that's how it identifies if there is any resource that has failed. When I say resource, I'm referring to any infrastructure failure, any application level failure. So it kind of keeps checking. So it understands it first before the customer notices it, and then it does the magic, kind of shifts the connection from one server to the other server. We call it routing. We will talk about that as we progress. So the benefits of using Route 53. It's highly scalable, meaning suddenly, let's say the number of requests, the number of people trying to access your website through that domain name that you have bought, let's say it has increased. Route 53 is highly scalable, right? It can handle even millions and millions of requests because it's highly scalable and it's managed by Amazon. The same thing, it's reliable, it's highly scalable, it can handle large queries without the users, without you interacting, without the user who bought it interact with it. You don't have to scale up. When you're expecting more requests, it automatically scales. And it is very reliable in a sense that it's very consistent. It has the ability to route the users to the appropriate application through the logic that it has. It's very easy to use. When we do the lab, you're going to see that. It's very easy to use. You buy the domain name and then you simply map it to the application. You simply map it to the server by putting in the IP, or if you can simply map it to another load balancer by putting in the load balancer URL. You can simply map it to another S3 bucket by simply putting the S3 bucket name or the S3 bucket URL. It's pretty straightforward, easy to set up. And it's very cost effective in a way that we only pay for the service that we have used. So no wastage of money here. So the billing is set up in such a way that you are paying only for the amount of requests that you have received, right? The amount of traffic, the amount of requests that you have received, and a couple of other things. The number of hosted zones that you have created, right? And a couple of other things. It's very cost effective in such a way that you only pay for the service that you are using. And it's secure in a way that access to Route 53 is integrated with the Identity and Access Management, IAM. So you only have authorized users gain access to Route 53. The trainee who just joined yesterday won't get access. And the contractor or the consultant, the third-party consultant you have given access, or who is using your environment, you can block access to that particular person because he's not the admin or he's not a privileged user in your account. So only privileged users and admin gain access to Route 53 through IAM. Now let's talk about the routing policies. So when you create a record in Route 53, record is nothing but an entry. So when you do that, you choose a routing policy. Right? Routing policy is nothing but it determines how Route 53 responds to your queries, how the DNS queries are being responded. Right? That's a record, or that's a routing policy. So the first one is a simple routing policy. So we use simple routing policy for a single resource. In other words, simple routing allows to configure DNS with no special Route 53 routing. It's kind of one-to-one. You use a single resource that performs a given function to your domain. For example, if you want to simply map an URL to a web server, that's pretty straightforward, simple routing. So it routes traffic to a single resource, example, web server to a website. And with simple routing, multiple records with the same name cannot be created, but multiple values can be created in the same record. The second type of routing policy is failover routing. So we would be using failover routing when we want to configure active, passive failover. If something failed, right, you want to fail over to the next resource, which was previously the backup resource, now the active resource, or which was previously the backup server, now it's an active server. So you would be failing over to that particular resource or that particular IP. If you want to do that, we use failover routing. So failover routing routes traffic to a resource when the resource is healthy, or to a different resource when the previous resource is unhealthy. In other words, anytime a resource goes unhealthy, it does all that's needed to shift the traffic from the primary resource to the secondary resource. In other words, from the unhealthy resource to the healthy resource. And this records can route traffic to anything from an Amazon S3 bucket, or you can also configure a complex tree of records. Now, when we configure the records, it will be more clear to you. So as of now, just understand that Route 53 can route, or this routing policy, the failover routing policy, can route traffic to Amazon S3 bucket or to a website that has complex tree of records. Geolocation routing policy. Now, geolocation routing, just like the name says, it takes that routing decision based on the geographic location of the user. Right? In other words, when you want to route traffic based on the location of the user, that's your primary criteria for sending that request to the appropriate server, we would be using geolocation routing. So it localizes the content and presents a part or the entire website in the language of the user. For example, a user from US, you would want to direct them to an English website, and a user from German, if you want to send them to the German website, and a user from France, you want to send those requests, or you want to show content specific to a customer who lives in France, a French website. So this is, if that's your condition, this is the routing policy we would be using. And the geographic locations are specified by either continent or by country or by state in the United States. So only in the United States you can actually split it to state level, and for the rest of the countries you can do it on a country level. On a high level you can also do it on a continent level. The next type of routing policy would be geo-proximity routing. Geo-proximity routing policy, when we want to route traffic based on the location of our resource and optimally shift traffic from resources in one location to resource in another location, we would be using geo-proximity routing. So geo-proximity routing routes traffic to the resources based on the geographic location of the user and the resources they want to access. And it also has an option to route more traffic or less to a given resource by specifying a value known as a bias. Kind of weight, but we also have weighted routing that's different. So we've chosen different name, bias. You can send more traffic to a particular resource by having a bias on that particular routing condition. And a bias expands or shrinks the size of the geographic region from which traffic is routed to a resource. And then we have latency based routing. Just like the name says, we use latency based routing if we have resources in multiple AWS regions, and if we want to route traffic to the region that provides the best latency at any given point of time. So let's say if one single website needs to be installed and hosted on multiple AWS regions, then latency routing policy is what is being used. It improves the performance of the users by serving the request from the AWS region that provides the lowest latency. So at any given point, if performance is your criteria, and at any given point of time, irrespective of what happens in Amazon infrastructure, irrespective of what happens in the internet, if you want to route your users to the best performing website, best performing region, then we would be using latency based routing. And for using latency based routing, we should create latency records for the resources in multiple AWS regions. And then the other type of a routing policy is multi-value routing policy, where we can make Route 53 to respond to DNS queries with up to 8 healthy records selected at random. So you're not kind of loading one particular server. We can define 8 records, and on a random basis, Route 53 will respond to queries from these 8 records. So it's not one server that gets all the requests, but 8 servers gets the request in a random fashion. So it's multi-value routing policy, and what we get by this is that we are distributing the traffic to many servers instead of just one server. So multi-value routing configures Route 53 to return multiple values in response to a single or multiple DNS queries. It also checks the health of odd resources and returns the multiple values only for the healthy resources. Let's say out of the 8 servers we have defined, one server is not doing healthy. It will not respond to the query with the details of the unhealthy server, right? So now it's going to treat it as only 7 servers in the list because one server is unhealthy. And it has the ability to return multiple health checkable IP addresses to improve availability and load balancing. The other type of routing policy is weighted routing policy, and in here we use to route traffic, or this is used to route traffic to multiple resources in a proportion that we specify. So this is an weighted routing, and weighted routing routes multiple resources to a single domain name or a subdomain and control the traffic that's routed to each resources. So this is very useful when you are doing load balancing and testing new versions of the software. So when you have a new version of the software, you really don't want to send 100% of the traffic to it. So you want to get customers' feedback about the new software that you have launched, new version or new application that you have launched. So you would kind of send only 20% of the traffic to that application, get customer feedback, and if all is good, then we would move the rest of the traffic to that new application. So any software launches, application launches will be using weighted routing. Now let's talk about the key benefits or key features of Route 53. Some of the key features of Route 53 are traffic flow. It routes end users to the endpoint that should provide the best user experience. That's what we discussed in the routing policies, right? It uses a routing policy, a latency-based routing policy, and geo-based routing policy, and then failover routing policy. So it kind of improves the user experience. And the other key feature of Route 53 is we can buy domain names using Route 53 console. We can buy it from here and use it in Route 53. Previously it was not the case, but now we can buy it directly from Amazon through Route 53, and we can assign it to any resources that we want. So anybody browsing that URL, the connection will be directed to the server in AWS that runs our website. Health checks. It monitors health and performance of the application. So it comes with an health check attached to it. Health check are useful to make sure that the unhealthy resources are retired, right? The unhealthy resources are taken away, or your customers are not kind of hitting the unhealthy resources and they see an service down page or something like that. We can have weighted round robin load balancing. That's helpful in spreading traffic between several services or servers via a round robin algorithm. So no one server is fully hit, or no one server kind of fully absorbs all the traffic. You can split and shift the traffic to different servers based on the weight that you would be configuring. And also weighted routing also helps with soft launch of your new application or the new version of your website. There are different ways we can access Amazon Route 53. So you can access Amazon Route 53 through AWS console. You can also access Amazon Route 53 using AWS SDKs, and we can configure it using the APIs. And we can also do it through the command line interface. That's Linux type, Linux flavor, AWS command line interface. We can also do that using Windows command line, Windows PowerShell flavored command line interface as well. Now let's look at some of the companies that are using Route 53. So some of the famous companies that use Route 53 are Medium. Medium is an online publishing platform, and it's more like a social journalism. It's kind of having hybrid collection of professionals, people, and publications, or exclusive blogs or publishers on Medium. It's kind of an blog website, and that uses Route 53 for the DNS service. Reddit is an social news aggregation or web content rating and discussion website that uses Route 53. So these are some websites that are accessed throughout the world, and they are using Route 53, and it's highly scalable. Suddenly if there is a new news, right, their website will be accessed a lot, and they need to keep their service up and running all the time, more availability. Otherwise customers will end up in a broken page, and the number of customers who will be using the website will come down. So it's very critical. Now these companies are very critical, they're being highly available, their site being highly available, and the internet is very critical and crucial for them, and they rely and use Route 53 to meet that particular demand. And Airbnb is another company, Instacart, Coursera is another company, Stripe is another company that uses Route 53 as their DNS provider for their DNS service. They use Route 53 so their customers get best performance. They use Route 53 so their website is highly available. They use Route 53 to kind of shift the traffic between the resources, so their resources are properly used with all the weighted routing. The resources are properly used. Now let's quickly look at a demo. I'm in my AWS console and I'm in Route 53. So let me click on Route 53. So in this lab, we're actually going to simulate buying a domain name, and then we're going to create an S3 static website, and we're going to map that website to this DNS name, right? So the procedure is the same for mapping load balancer, the procedure is the same. For mapping CloudFront, the procedure is the same for mapping EC2 instances as well. We're picking S3 for simplicity, right? But our focus is actually on Route 53. So let's go in here and we'll see if we can, right? We'll buy a domain name here. So let's first check the availability of a domain name called Simplilearn-demo-Route 53. Let's check its availability. It is available for $12. So let me add it to cart and then come back here. And then once you continue, it'll ask for personal information. Once you give the personal information, you finally check out and then it gets added to your shopping list. Once you pay for it, Amazon takes like 24 to 48 hours to make that DNS name available. So the next stage would be contact details, and then the third stage would be verify and purchase. So once we have bought the domain name, it will become available in our DNS portal. And I do have a domain name which I bought some time back, and it's now available for me to use. So I can go to hosted zone and simply start creating. I can go to hosted zone, and then here it's going to list all the domain names for me. Right, click on the domain name and then click on the record set, and here I can actually map Elastic Load Balancer, S3 website, VPC endpoint, API gateway, and CloudFront, Elastic Beanstalk domain names. Right, all that gets mapped through this portal. Quite simple, like 4 or 5 step button clicks, and then it'll be done. So I have an domain name bought, and then I'm going to go to S3, and I'll show you what I've done in S3. So I've created a bucket name called as DNS name. Let me clear the content in them. So I've created a bucket, and then permissions, I've turned off public access blocking, and then I've created a bucket policy. So this bucket is now publicly accessible. And then I went on to properties and created the static website hosting. Right? And I've pointed that this is the file, that's my index file that I'm going to put, or name of the file that's going to be my index file that I'm going to put in this S3 bucket. So I've put the index file.html, saved it, and we're going to create a file now. We're going to create an index file. So this is a sample code. It says Amazon Route 53 getting started, routing internet traffic to S3 bucket for your website, and then a couple of other information. So I've saved it as an index.html file in my desktop. So let me upload that from my desktop into this bucket. So that's index.html, and it's in capital I. So let me go to properties and go to static website hosting and make sure that I spell it properly. Right, it's case sensitive, and then save it. So now this means that my website should be running through this URL, and it does. It's running through the static website URL. We're halfway through. So now let me go back to Route 53. Go back to Route 53, go back to hosted zones, go into the domain name, and then create a record set. And it's going to be an alias record. And I see my S3 static website endpoint there. Right, so click on it and create. It has now created an record that's pointing my domain name to the S3 endpoint that I have created. And my static website is running from it. So let me test it. Right, so let me go to the browser, put the domain name in there, and sure enough, the domain name, when my browser queried for the domain name, Route 53 returned a response saying this domain name is actually mapped to the S3 bucket, static website hosting enabled S3 bucket, and this is the URL for that static website hosting. And then my browser was able to connect to that S3 bucket and download the details and show it in my browser. Right, so it's that simple and pretty straightforward.
Let me help you understand AWS Elastic Beanstalk. So what's in it for you? We'll be discussing about what is AWS, why we require AWS Elastic Beanstalk, what is AWS Elastic Beanstalk, the advantages, disadvantages, the components of Beanstalk, along with that, the architecture and the companies that are primarily using the AWS Beanstalk. So let's get started and first understand what is AWS. AWS stands for Amazon Web Services. It's a cloud provider and that offers a variety of services such as compute power, database storage, content delivery, and many other resources. So we know that AWS is the largest cloud provider in the market, and so many services are available in the AWS where you can apply the business logics and create the solutions using the cloud platforms. Now, why AWS Elastic Beanstalk? Now what happened earlier and that whenever the developer used to create the software or the modules related to the softwares, it has to be joined together to create a big application. Now one developer creates a module that has to be shared with another developer, and if the developers are geographically separated, then it has to be shared over a medium, probably an internet. So that is going to take some time. It would be a difficult process, and in return it makes the application or a software development a lengthier process, the building of the software development a lengthier process. So there were challenges which the developers were facing earlier, and to overcome that we have the Beanstalk as a service available in the AWS. So why AWS Elastic Beanstalk is required? AWS Elastic Beanstalk has made the life of the developers quite easy in terms of that they can share the applications across different devices at a shorter time duration. Now let's understand what is AWS Elastic Beanstalk. AWS Elastic Beanstalk is a service which is used to deploy and scale web applications by developers. Not only web application, any application that is being developed by the developers. This is a symbol representation of the AWS Elastic Beanstalk. Now, along with that, the AWS Elastic Beanstalk supports the programming language, the runtime environments that are Java, .NET, PHP, Node.js, Python, RubyGo, and Docker. And in case if you're looking for any other programming language or a runtime environment, then you can make a request with AWS to arrange that for you. Now, what are the advantages associated with the Elastic Beanstalk? First advantage is that it's a highly scalable service. Now, when we talk about a scalability, it means that whenever we require the resources in demand, we can scale up the resources or we can scale down the resources. So that is kind of a flexibility we get in terms of changing the type of resources whenever we need it. And in that case, the Elastic Beanstalk is a highly scalable service. Now that is something which is very difficult to achieve in case of an on-prem environments, because you have to plan for the infrastructure, and in case if you're short of the resources within that infrastructure, then you have to procure it again. The second advantage associated with the Beanstalk is that it's a fast and simple to begin. Now when we say it's fast and simple, that means that you just have to focus on the development of an application, building an application, and then you can just deploy the application directly using the Beanstalk. What the Beanstalk is going to do, that every networking aspect is being taken care by the Beanstalk. It deploys your application in the backend on the servers, and then you can directly access your application using the URL or through the IP address. The third advantage is that it offers the quick deployment. That is what we discussed in the fast and simple to begin as well. So why it offers a quick deployment? You don't have to bother about the networking concepts. You just have to focus on the application development, and then you can just upload your application, deploy that, and then you are good to go. The other advantage is that it supports multi-tenant architecture. When we talk about tenants or multi-tenants, that means we can have a virtual environments for separate organizations or the divisions within the organizations that will be virtually isolated. So likewise, you can have virtually isolated environments created on the Beanstalk, and they can be separated, used as a separate entities or a separate divisions within the organization. And we know that it's a flexible service. Since it's a scalable, then it is a flexible also. Now coming to the simplifies operations as an advantage. Now once the application is deployed using the Beanstalk, then it becomes very easy to maintain and support that application using the Beanstalk services itself. And the last advantage that we can have from the Beanstalk is that it's a cost efficient service. The cost efficient, as we know that many of the AWS services are cost effective. The cost optimization can be better managed using the AWS Beanstalk as compared to if you are developing or if you are deploying any kind of an application or a solution on the on-prem servers. Now there are some components that are associated with the AWS Beanstalk, and it has to be created in the form of a sequence manner. So AWS Elastic Beanstalk consists of few important components which are required while developing an application. Now what are these components? These are 4 components. One is application, the second is application version, the third is environment, and the fourth one is the environment tier. And we have to progress while deploying our applications or the softwares using the same sequence. Now let's understand what are the different components of the Beanstalk are. The application. It refers to a unique label which is used as a deployable code for a web application. So generally you deploy your web application or you create your application, and that is something which is basically used as a unique label. Then the second component is application versions. So it resembles a folder which stores a collection of components such as environments, versions, and environment configurations. So all these components are being stored using the application version. The third most important component is the environment. In the environment, only the current versions of the applications runs. Now remember that Elastic Beanstalk supports multiple versions as well. And using the environment, you can only run the current version of the application. If you wanted to have another version of an application to be running, then you have to create another environment for that. Then comes the environment tier. And in the environment tier, it designates the type of application that the environment runs on. Now generally there are two types of environment tier. One is the web and the other one is the worker node, and that's something which we'll be discussing later as well. Now let's understand how does Elastic Beanstalk in AWS works. So first we have to create an application, and this is a task that would be done by the developers. And for that you can actually select any runtime environment or a programming language like Java, Docker, Ruby, Go, Perl, or Python as well. And once you select that environment, you can develop your application using that runtime environments. Now after that, once the application is created, then you have to upload the version of an application on the AWS. And after that, once the version is uploaded, and then you have to launch your environment. So just have to click on the buttons, that's it, nothing more you have to do. Once the environment is launched, then you can actually view that environment using a web URL or using the IP address. Now what happens in that case is when you launch an environment, in the backend, the Elastic Beanstalk automatically runs an EC2 instance. And using a metadata, the Beanstalk deploys your application within that EC2 instance. That is something which you can look into the EC2 dashboard as well. So you don't have to take care of the security groups, you don't have to take care of the IP addressing, and even you don't have to log in into the instance and deploy your application. It would be done automatically by the Beanstalk. It's just that you just have to monitor the environment, and the statistics will be available there itself in the Beanstalk dashboard. Otherwise you can view those statistics in the CloudWatch logs as well. Now in case if you wanted to update any kind of a version, then you just upload a new version and then just deploy that and then monitor your environment. So these are the essentials to create a local applications for any platform, whether it's a Node.js, Python, etc. These are the things that you have to actually take care, and this is the sequence you have to follow while creating an environment. So you can say that it's a 4 steps creation of or deployment of your application. That's it. Now after users upload their versions, the configuration is automatically deployed with a load balancer. Yes, and with a load balancer, that means you can access the applications using the load balancer DNS also. And apart from load balancer, if you wanted to put any other feature that includes the auto-scaling, for example, if you wanted to create your EC2 instances where the application will be deployed within the virtual private cloud or in a particular subnet within the VPC, all those features that are available, and you can select them using the Beanstalk itself. You don't have to move out to the VPC, you don't have to actually go to the EC2 dashboard and select all those separately. Everything would be available within the Beanstalk dashboard. So that's what it says in the presentation, that after creating an application, the deploy service can be specifically accessed using the URL. So once the environment is created, there will be a URL defined. Now you can put a URL name also. That is something which you wanted to put for your application. You can define that. You can check for the availability of that URL, and then you have to use that URL to access your application over the browser. Now once it is done, then in the monitor environment, it says the environment is monitored, provided capacity provisioning, load balancing, auto scaling, and monitor features. All those features are available there itself in the Beanstalk. Now let's understand the architecture of AWS Elastic Beanstalk. Now there are 2 types of environments that you have to select. You can select, one is the web server environment and the other one is the worker environment. So based on the client requirement, Beanstalk gives you 2 different types of environment that you have to select. Generally, the web server environment is the front end facing. That means the client should be accessing this environment directly using a URL. So mostly web applications are deployed using that environment. The worker environment is the backend applications or the micro apps, which are basically required to support the running of the web applications. Now it depends on the client requirement what kind of an environment you wanted to select. Now in the web server environment, it only handles the HTTP request from the clients. So that's why we use the web server environment mostly for the web applications or any application which works on the HTTPS requests. So it's not only the HTTP, you can use the HTTPS as well. The worker environment, it processes background tasks and minimizes the consumption of resources. So again, it is just like a kind of a microservice or an application services that are running in the backend to support the web server environment. Now, coming to the understanding of the AWS Beanstalk. So this is how the architecture of the AWS Beanstalk is designed, and you can refer to that image also. Now, in the web server environment, let's say if we select a web server environment, and it says that if the application receives client requests, the Amazon Route 53 sends these requests to the Elastic Load Balancer. Now, obviously, we discussed here that the web server environment is primarily an environment which receives the HTTP requests. It's a kind of a client-facing environment. Now, if the application receives a client request from the Amazon Route 53, this Route 53 is a service which is primarily used for DNS mapping. It's a global service, and you can route the traffic from the Route 53, matching your domains towards the load balancer. And from the load balancer, you can point that traffic to the web server environment. Obviously, the web server environment is nothing. It's just the EC2 instances that would be running in the backend. Now, here in the diagram, you can see that there are two web server environments, and they are created in the AutoScaling group. That means there is some kind of scaling options that are defined as well. And these instances are created in an availability zone, or they can be created in a different availability zone also for the redundancy as well. And these web application servers are further connected to your databases, which primarily will be in a different security groups. Probably it can be an RDS database also. So all these functionalities, all these features are basically available on the Elastic Beanstalk dashboard itself. Now, what happens in that case is if the application receives client requests, Amazon Route 53 send these requests to the load balancer. Later, the load balancer shares those requests among the EC2 instances. How does that happen? It happens using a predefined algorithm. The equal distribution of a load is distributed to both the EC2 instances or n number of EC2 instances running in the availability zone. Now, in the availability zones, every EC2 instance would have its own security group. They can have a common security group also. They can have their own security group as well. Now, after the security group, the load balancer is then connected to the Amazon EC2 instance, which are part of the AutoScaling group. So that's something which we have discussed already. Now, this AutoScaling group would be defined from the Beanstalk itself, and there will be some scaling options that will be created. It could be a possibility that it might be the minimum number of instances that would be running as of now, and based on the threshold defined, it may increase the number of EC2 instances, and the load balancer will keep on distributing the load to as many instances that will be created inside the availability zones. Obviously, there will be an internal health check that the load balancer will be first doing before distributing the real-time traffic to these instances created by the Beanstalk. Now, what does AutoScaling group does? It automatically starts the additional EC2 instance to accommodate increasing load on your application. That's something which we know that. And also it monitors and scales instances based on the workload as well. So depends on what kind of a scaling threshold you have defined in the AutoScaling groups. And when the load of an application decreases, the EC2 instance will also be decreased. So whenever we talk about the AutoScaling, generally it comes in our mind is that we scale up the resources. That means it increases the EC2 instances. In the AutoScaling, you might have the scale down option also, scale down policy also created, in which if the load minimizes, it can terminate the additional EC2 instances as well. So that is something which will be automatically managed. All these features can be achievable using the Elastic Beanstalk, and with this feature accommodated, it gives you the better cost optimization in terms of managing your resources. Now it says that Elastic Beanstalk has a default security group, and the security group acts as a firewall for the instances. Now here in this diagram, it says about the security group AutoScaling also. You might create it in a default VPC also. You might create it in your custom VPC also, where you can have the additional level of security is also created. You can have the NACLs, NACLs also defined here before the security groups. So that would give you the additional filtering option or the firewall option. Now it says that with these groups, with these security groups, it allows establishing security groups to the database server as well. So every database would also have its own security group, and the connection can be created between the web servers environment that is created by the Beanstalk to the database security groups as well. Now let's discuss about the worker environment. Now, understanding the worker environment, what happens is that the web server environment is the client facing. The client sends a request for an access to the web server. And in this diagram, the web server further sends it to the SQS, which is a simple queue service. And the queue service sends it to the worker environment, and then whatever the worker environment is created for doing some kind of a processing or some kind of an application that is running in the backend, that environment initiates and then send back the results to this SQS and vice versa. So let's understand the architecture of a AWS Elastic Beanstalk with the worker environment. So when a worker environment here is launched, AWS Elastic Beanstalk installs a server on every EC2 instance. So that is in the case of a web server environment also. And later the server passes the request to the simple queue service. Now this service is an asynchronous service. Instead of a simple queue service, you can have other services also. It is not necessary that you need to have the SQS also. This is an example that we are discussing about. And the SQS shares those messages via a post request to the HTTP path over the worker environment. And there are many case studies also with respect to this kind of an environment that is being created, that is being done on many customers. And you can search for these kind of a case studies available on the internet. Now the worker environment executes the task given by the SQS with the HTTP response after the operation is completed. Now here what happens is a quick recap. The client requests for an access of an application to a web server using an HTTP request. The web server passes that request to the queue service. The queue service shares the message with the worker. Probably a worker might be the manual worker, and generally it's an automated worker. So it would be shared via the worker environment only. And the worker sends back the response with the HTTP response back to the queue. That response can be viewed directly from the queue service by the client using the web server. So this is one of the examples. Likewise, as I said, that there can be many other examples also where you can have the worker environments defined. Now, what are the companies that are using the Elastic Beanstalk? These are few of the companies that are primarily using. One is Zillow, Jelly Button Games, then you have League of Women Voters, eBury. These are some of the few listed companies, and obviously you search on the AWS site and you'll find many more organizations that are using the Elastic Beanstalk primarily for deploying their applications. Now the next thing is to go with the practicals, that how actually we use the Elastic Beanstalk. So let's look into the demo using the AWS Elastic Beanstalk. Now first you have to log in into the AWS console, and I'm sure that you might be having the accounts created, or you can use the IAM credentials as well. And then you have to select the region also. Now I am in the North Virginia region. Likewise, you can select any of the regions that are listed here. Now click on the services and you have to search for the Elastic Beanstalk. You can find the Elastic Beanstalk under the compute section. So here itself, you'll find the Elastic Beanstalk as a service. Now open this service and there it will give you an option to create an environment. You have to specifically select an environment, probably a worker environment or a web service environment. So let's wait for the service to open. So we have the dashboard now available with us. This is how the Elastic Beanstalk looks, and this is the symbol representation of a beanstalk. Now what you have to do is we have to click on Get Started, and that will load, and you have to create a web app. So instead of creating a web app, what we'll do, we'll create a new application. So just click on Create a New Application, put an application name. Let's say we put something like XYZ. You can put any description to your application. Let's say it's a demo app, and click on Create. Now it says you have to select an environment. Now the environment, the application name XYZ is created. You just have to select an environment. So click on Create One now, and it is going to ask you that what kind of an environment tier you wanted to select. So as we discussed that there are two types of environments. One is the web server and the one is the worker environment. Let's look into it, what is defined by the AWS. AWS says that it has two types of environment tiers to support different types of web applications. Web servers are standard applications that listen for and then process HTTP requests, typically over port number 80. Workers are specialized applications that have a background processing task that listens for message on an Amazon SQS queue. Workers application posts those messages to your application by using the HTTP response. So that's what we saw in the case of the Beanstalk slides also. Now the usability of a worker environment can be anything. Now we'll do a demo for creating a web server environment. So just click on Select, and we have the environment name created. Now we can define our own domain. It ends with the region.elasticbeanstalk.com. Let's say I look for a domain which is XYZ only. That's the environment name. Now I'll check for the availability whether that domain name is available with us or not. And it says we don't have that domain name. So probably I'll try to make it with some other name, and let's look for the availability. XYZ ABC, and it says yes, it is available. Now, once I deploy my application, I would be able to access the application using this complete DNS. So you can put a description. It's a demo app that we are creating, and then you have to define a platform as well. Now, these are the platforms that are supported by the AWS. Let's say I wanted to run a Node.js environment. So I'll just click on the Node.js platform. The application codes is something which is basically developed by the developers, and you can upload the application right now, or you can do that later as well once the environment is ready. Now, either you can select to create an environment if you wanted to go with all the default settings. Otherwise, if you wanted to customize it more, you can click on configure more options. So let's click on configure more options. And here you would be able to define various different features like the type of an instance. For example, what kind of an EC2 instance or a server that should be running so that the Beanstalk can deploy your applications over it. If you wanted to modify, just click on a modify button, and here you can modify your instances with respect to the storage as well. Now, apart from that, if you wanted to do some modification in the case of monitoring, in the case of databases, in the case of security, or in the case of a capacity, let's look into the capacity. So here you can actually do the modification. So in the capacity, you can select the instance type also. By default, it is t2.micro, but in case if your application requires a larger type of an instance, then you can actually go for the instance type as well. Similarly, you can define your AMI IDs also, because obviously for the application to run, you would require the operating system also. So you can select that particular AMI ID for your operating system as well. Let's cancel that. Likewise, you have many other features that you can actually define here from the dashboard, and you don't have to go to the EC2 dashboard to do the modifications. Now let's go and create an environment. Let's assume that we are going with the default configuration. So this is going to create our environment. The environment is being created, and you can get the environment and the logs defined in the dashboard itself. So you'll see that the Beanstalk environment is being initiated, the environment is being started, and in case if there would be any errors or if it is deployed correctly, you'll get all the logs here itself. Now the environments are basically color coded. So there are different color codings that are defined. If you get the environment in a green color, that means everything is good to go. So here you can see that it has created an Elastic IP. It has checked the health of the environment. Now it has created the security groups, and that would be an auto security groups created by the Beanstalk. And the environment creation has been started. You can see that Elastic Beanstalk as Amazon S3 storage bucket for your environment data as well. This is the URL through which you will be accessing the environment, but right now we cannot do that since the environment is being created. Let's click on the application name, and here you can see that it is in a gray color. That means right now the build is being done. It is being created. Once it will be successfully created, it should change to the green color, and then we will be able to access our environment using the URL. Now, if I move to the EC2 instances and see in the EC2 dashboard, if I see whether the instance is being created by the Beanstalk or not. So let's see, and let's see what are the differences in terms of creating an instance manually and getting it created from the Beanstalk. So click on the EC2. Let's go to the old EC2 experience. That's what we are familiar with. And let's see what's there in the dashboard. So here you can see one running instance. Let's open that. And the XYZ environment, which was created from the Beanstalk, is being initiated. The instance is being initiated. And that is something which is being done by the Beanstalk itself. We have not gone to the dashboard and created it manually. Now, in the security groups, if you see that, here the AWS Beanstalk security groups are defined. It has the Elastic IPs also defined. So everything is being created by the Beanstalk itself. Right. Now let's go back to the Beanstalk and let's look into the status of our environment, whether the color coding has been changed from gray to green or not. And here you can see the environment is successfully created, and we have that environment colored in green. We'll access the environment, and it says it's a web server environment. Its platform is Node.js running on 64-bit Amazon Linux AMI, and it's a sample application. Health status is okay. Now the other thing is that if you do not want to use the web console, the management console, to access the Beanstalk, then the Beanstalk offers you the Elastic Beanstalk CLI as well. So you can install the command line interface. And then you have the command references, CLI command references that you can actually play with and get your applications deployed using the Beanstalk itself. So this is one of the sample CLI commands that you can actually look into. Now let's look into the environment. Let's click on the environment and we'll be represented with the URL. It says health is okay. These are the logs that you have to follow in case if there are any issues. The platform is Node.js. That is what we selected. Now the next thing is you just have to upload and deploy your applications. So just click on upload and deploy. Select the version label or the name. Select file, and wherever your application is hosted at, just select that, upload it and deploy your application. You'll see that like your environment is created, similarly your application will be deployed automatically on the instance, and from this URL you will be able to view the output. It is as simple as just like you have to follow these 4 steps. Now let's see whether the Node.js environment is running on our instance before deploying an application. So we'll just click on this URL. Since the Beanstalk has already opened up the security groups or HTTP port 80 for all, we can actually view that output directly from the URL. So we have the Node.js running, that's visible here, and after that you just have to upload and deploy your application, and then from that URL you can get the output. Now this URL you can map it with the Route 53 service. So using the Route 53 DNS services, the domain names can be pointed to the Elastic Beanstalk URL, and from there it can be pointed to the applications that are running on the EC2 instance. Whether you wanted to point it to the URL directly using the Beanstalk, you can do that. Otherwise, as we saw in the slides, you can use the Route 53, point it to the load balancer, and then point it to the instances directly also once it is created by the Beanstalk. So that was the demo, guys, with respect to the Beanstalk and how we can actually run the environments. Apart from that, the operational tasks like system operations, you can manage all these things from the environment dashboard itself. So you have the configurations, you have the logs, you can actually check the health status of your environment, you can do the monitoring, and you can actually get the alarms and the events here. So let's say if I wanted to see the logs, I can request for the logs here itself, and I'll be represented with the full log report, and I can now download that log file and I can view the logs. So we have this bundle logs in the zip file. All right, so if you want to see some kind of logs with respect to Elastic Beanstalk activity, it's in the form of a notepad, and here you can see what all configurations the Beanstalk has done on your environment, on your instance. Similarly, you can go for the health, monitoring, alarms, events, and all those things.
In this lesson, you'll learn all about virtual private clouds and understand their concept. You'll know the difference between public, private, and elastic IP addresses. You'll learn about what a public and private subnet is. And you'll understand what an internet gateway is and how it's used. You'll learn what route tables are and when they are used. You'll understand what a NAT gateway is. We'll take a look at security groups and their importance. And we'll take a look at network ACLs and how they're used in Amazon VPC. We'll also review the Amazon VPC best practices and also the costs associated with running a VPC in the Amazon cloud. Welcome to the Amazon Virtual Private Cloud and Subnet section. In this section, we're going to have an overview of what Amazon VPC is and how you use it. And we're also going to have a demonstration of how to create your own custom virtual private cloud. We're going to look at IP addresses and the use of elastic IP addresses in AWS. And finally, we'll take a look at subnets, and there'll be a demonstration about how to create your own subnets in an Amazon VPC. And here are some of the terms that are used in VPCs. There's subnets, route tables, elastic IP addresses, internet gateways, NAT gateways, network ACLs, and security groups. And in the next sections, we're going to take a look at each of these and build our own custom VPC that we'll use throughout this course. Amazon defines a VPC as a virtual private cloud that enables you to launch AWS resources into a virtual network that you've defined. This virtual network closely resembles a traditional network that you'd operate in your own data center, but with the benefits of using the scalable infrastructure of AWS. A VPC is your own virtual network in the Amazon cloud, which is used as the network layer for your EC2 resources. And this is a diagram of the default VPC. Now there's a lot going on here, so don't worry about that. What we're going to do is break down each of the individual items in this default VPC over the coming lesson. But what you need to know is that a VPC is a critical part of the exam, and you need to know all the concepts and how it differs from your own networks. Throughout this lesson, we're going to create our own VPC from scratch, which you'll need to replicate at the end of this so you can do well in the exam. Each VPC that you create is logically isolated from other virtual networks in the AWS cloud. It's fully customizable. You can select the IP address range, create subnets, configure route tables, set up network gateways, define security settings using security groups, and network access control lists. So each Amazon account comes with a default VPC that's pre-configured for you to start using straight away, so you can launch your EC2 instances without having to think about anything we mentioned in the opening section. A VPC can span multiple availability zones in a region. And here's a very basic diagram of a VPC. It isn't this simple in reality. And as we saw in the first section, here's the default Amazon VPC, which looks kind of complicated. But what we need to know at this stage is that the CIDR block for the default VPC is always a 16 subnet mask. So in this example, it's 172.31.0.0/16. What that means is this VPC will provide up to 65,536 private IP addresses. So in the coming sections, we'll take a look at all of these different items that you can see on this default VPC. But why wouldn't you just use the default VPC? Well, the default VPC is great for launching new instances when you're testing AWS. But creating a custom VPC allows you to make things more secure, and you can customize your virtual network as you can define your own IP address range. You can create your own subnets that are both private and public, and you can tighten down your security settings. By default, instances that you launch into a VPC can't communicate with your own network. So you can connect your VPCs to your existing data center using something called hardware VPN access, so that you can effectively extend your data center into the cloud and create a hybrid environment. Now to do this, you need a virtual private gateway, and this is the VPN concentrator on the Amazon side of the VPN connection. Then on your side, in your data center, you need a customer gateway, which is either a physical device or a software application that sits on your side of the VPN connection. So when you create a VPN connection, a VPN tunnel comes up when traffic is generated from your side of the connection. VPC peering is an important concept to understand. A peering connection can be made between your own VPCs or with a VPC in another AWS account, as long as it's in the same region. So what that means is, if you have instances in VPC A, they wouldn't be able to communicate with instances in VPC B or C unless you set up a peering connection. Peering is a one-to-one relationship. A VPC can have multiple peering connections to other VPCs, but, and this is important, transitive peering is not supported. In other words, VPC A can connect to B and C in this diagram, but C wouldn't be able to communicate with B unless they were directly peered. Also, VPCs with overlapping CIDRs cannot be peered. So in this diagram you can see they all have different IP ranges, which is fine, but if they had the same IP ranges, they wouldn't be able to be peered. And finally for this section, if you delete the default VPC, you have to contact AWS support to get it back again. So be careful with it and only delete it if you have good reason to do so and know what you're doing. This is a demonstration of how to create a custom VPC. So here we are, back at the Amazon Web Services Management Console. And this time we're going to go down to the bottom left where the networking section is. I'm going to click on VPC. And the VPC dashboard will load up. Now there's a couple of ways you can create a custom VPC. There's something called the VPC wizard, which will build VPCs on your behalf from a selection of different configurations. For example, a VPC with a single public subnet, or a VPC with public and private subnets. Now this is great because you click a button, type in a few details, and it does the work for you. However, you're not going to learn much or pass the exam if this is how you do it. So we'll cancel that and we'll go to your VPCs and we'll click on Create a VPC. And we're presented with the Create a VPC window. So let's give our VPC a name. I'm going to call it Simplilearn_VPC. And this is the kind of naming convention I'll be using throughout this course. Next, we need to give it the CIDR block, or the classless interdomain routing block. So we're going to give it a very simple one, 10.0.0.0, and then we need to give it the subnet mask. So you're not allowed to go larger than 15. So if I try to put 15 in, it says no, not going to happen. For a reference, subnet mask of 15 would give you around 131,000 IP addresses. And subnet 16 will give you 65,536, which is probably more than enough for what we're going to do. Next, you get to choose the tenancy. There's two options, default and dedicated. If you select dedicated, then your EC2 instances will reside on hardware that's dedicated to you. So your performance is going to be great, but your cost is going to be significantly higher. So I'm going to stick with default. And we just click on Yes, Create. It'll take a couple of seconds. And then in our VPC dashboard, we can see our Simplilearn VPC has been created. Now, if we go down to the bottom here to see the information about our new VPC, we can see it has a route table associated with it, which is our default route table. So there it is. And we can see that it's only allowing local traffic at the moment. We go back to the VPC again. We can see it's been given a default network ACL. And we'll click on that and have a look. And you can see this is very similar to what we looked at in the lesson. So it's allowing all traffic from all sources, inbound and outbound. Now if we go to the subnet section, and just widen the VPC area here, you can see there's no subnets associated with the VPC we've just created. So that means we won't be able to launch any instances into our VPC. And to prove it, I'll just show you. We'll go to the EC2 section. So this is a glimpse into your future. This is what we'll be looking at in the next lesson. And we'll just quickly try and launch an instance. We'll select any instance, it doesn't matter. Any size, not important. So here, the network section, if I try and select Simplilearn VPC, it's saying no subnets found, this is not going to work. So we basically need to create some subnets in our VPC. And that is what we're going to look at in the next lesson. Now, private IP addresses are IP addresses that are not reachable over the internet, and they're used for communication between instances in the same network. When you launch a new instance, it's given a private IP address and an internal DNS hostname that resolves to the private IP address of the instance. But if you want to connect to this from the internet, it's not going to work. So then you'd need a public IP address, which is reachable from the internet. You can use public IP addresses for communication between your instances and the internet. Each instance that receives a public IP address is also given an external DNS hostname. Public IP addresses are associated with your instances from the Amazon pool of public IP addresses. When you stop or terminate your instance, the public IP address is released and a new one is associated when the instance starts. So if you want your instance to retain its public IP address, you need to use something called an elastic IP address. An elastic IP address is a static or persistent public IP address that's allocated to your account and can be associated to and from your instances as required. An elastic IP address remains in your account until you choose to release it. There is a charge associated with an Elastic IP address if it's in your account but not actually allocated to an instance. This is a demonstration of how to create an Elastic IP address. So we're back at the Amazon Web Services Management Console. We're going to head back down to the Networking VPC section and we'll get to the VPC dashboard. On the left hand side we'll click on Elastic IPs. Now you'll see a list of any Elastic IPs that you have associated in your account, and remember, any Elastic IP address that you're using that isn't allocated to something you'll be charged for. So I have one available and that is allocated to an instance currently. So we want to allocate a new address, and it reminds you that there's a charge if you're not using it. I'm saying yes, allocate, and it takes a couple of seconds, and there's our new Elastic IP address. Now we'll be using this IP address to associate with the NAT gateway when we build that. AWS defines a subnet as a range of IP addresses in your VPC. You can launch AWS resources into a subnet that you select. You can use a public subnet for resources that must be connected to the internet, and a private subnet for resources that won't be connected to the internet. The net mask for the default subnet in your VPC is always 20, which provides up to 4,096 addresses per subnet, and a few of them are reserved for AWS use. A VPC can span multiple availability zones, but a subnet is always mapped to a single availability zone. This is important to know. So here's our basic diagram, which we're now going to start adding to. So we can see the virtual private cloud, and you can see the availability zones, and now inside each availability zone we've created a subnet. Now you won't be able to launch any instances unless there are subnets in your VPC. So it's good to spread them across availability zones for redundancy and failover purposes. There's two different types of subnet, public and private. You use a public subnet for resources that must be connected to the internet, for example web servers. A public subnet is made public because the main route table sends the subnet's traffic that is destined for the internet to the internet gateway, and we'll touch on internet gateways next. Private subnets are for resources that don't need an internet connection or that you want to protect from the internet, for example database instances. So in this demonstration we're going to create some subnets, a public and a private subnet, and we're going to put them in our custom VPC in different availability zones. So we'll head to Networking and VPC, wait for the VPC dashboard to load up. We'll click on Subnets. We'll go to Create Subnet. And I'm going to give the subnet a name. So it's good to give them meaningful names. So I'm going to call this first one for the public subnet 10.0.1.0, and I'm going to put this one in the US East 1B availability zone, and I'm going to call it Simplilearn public. So it's quite a long name, I understand, but at least it makes it clear for what's going on in this example. So we need to choose a VPC. So we obviously want to put it in our Simplilearn VPC. And I said I wanted to put it in US East 1B. I'm using the North Virginia region, by the way. So we click on that. Then we need to give it the CIDR block. Now, as I mentioned earlier, when I typed in the name, that's the range I want to use. And then we need to give it the subnet mask. And we're going to go with 24, which should give us 251 addresses in this range, which obviously is going to be more than enough. If I try and put a different value in that's unacceptable to Amazon, it's going to say, it's going to give me an error and tell me not to do that. Let's go back to 24 and click. I'm going to cut and paste this, by the way, just because I need to type something very similar for the next one. Click Create. And it takes a few seconds. Okay, so there's our new subnet, and I just widen this. You can see, so that's the IP range, that's the availability zone, it's for Simplilearn, and it's public. So now we want to create the private. So I'm going to put the name in. I'm going to give the private the IP address block of that. I'm going to put this one in US East 1C, and it's going to be the private subnet. Obviously I want it to be in the same VPC. Availability zone of US East 1C, and we're going to give it 10.0.2.0/24, and we'll click yes, create. And again, it takes a few seconds. Okay, so let me sort by name. So there we are, we can see now we've got our private subnet and our public subnet. In fact, let me just type in Simplilearn, there we are. So now you can see them both there. And you can see they're both in the same VPC, Simplilearn VPC. Now if we go down to the bottom, you can see the route table associated with these VPCs. And you can see that they can communicate with each other internally, but there's no internet access. So that's what we need to do next. In the next lesson, you're going to learn about internet gateways and how we can make these subnets have internet access. Welcome to the networking section. In this section, we're going to take a look at internet gateways, route tables, and NAT devices. And we'll have a demonstration on how to create each of these AWS VPC items. So to allow your VPC the ability to connect to the internet, you need to attach an internet gateway. And you can only attach one internet gateway per VPC. So attaching an internet gateway is the first stage in permitting internet access to instances in your VPC. Now here's our diagram again, and now we've added the internet gateway, which is providing the connection to the internet to your VPC. But before you can configure internet correctly, there's a couple more steps. For an EC2 instance to be internet connected, you have to adhere to the following rules. Firstly, you have to attach an internet gateway to your VPC, which we just discussed. Then you need to ensure that your instances have public IP addresses or elastic IP addresses, so they're able to connect to the internet. Then you need to ensure that your subnet's route table points to the internet gateway, and you need to ensure that your network access control and security group rules allow relevant traffic to flow to and from your instance. So you need to allow the rules to let in the traffic you want, for example HTTP traffic. After the demonstration for this section, we're going to look at how route tables, access control lists, and security groups are used. In this demonstration, we're going to create an internet gateway and attach it to our custom VPC. So let's go to Networking VPC, bring up the VPC dashboard, and on the left hand side we click on Internet Gateways. So here's a couple of internet gateways I have already, but I need to create a new one. So create Internet Gateway. I'll give it a name, which is going to be Simplilearn Internet Gateway, IGW. And I'm going to click Create. So this is an internet gateway which will connect a VPC to the internet, because at the moment our custom VPC has no internet access. So there, it's created. Simplilearn IGW. But its state is detached because it's not attached to anything. So let me try and attach it to a VPC. And it gives me an option of all the VPCs that have no internet gateway attached to them currently. So I only have one, which is Simplilearn VPC. Yes, attach. Now you can see our VPC has internet attached, and you can see that down here. So let's click on that, and it will take us to our VPC. But before any instances in our VPC can access the internet, we need to ensure that our subnet route table points to the internet gateway. And we don't want to change the main route table, we want to create a custom route table. And that's what you're going to learn about next. A route table determines where network traffic is directed. It does this by defining a set of rules. Every subnet has to be associated with a route table, and a subnet can only be associated with one route table. However, multiple subnets can be associated with the same route table. Every VPC has a default route table, and it's good practice to leave this in its original state and create a new route table to customize the network traffic routes associated with your VPC. So here's our example, and we've added two route tables, the main route table and the custom route table. The new route table, or the custom route table, will tell the internet gateway to direct internet traffic to the public subnet. But the private subnet is still associated to the default route table, the main route table, which does not allow internet traffic to it. All traffic inside the private subnet is just remaining local. In this demonstration, we're going to create a custom route table, associate it with our internet gateway, and associate our public subnet with it. So let's go to Networking and VPC. The dashboard will load, and we're going to go to Route Tables. Now our VPC only has its main route table at the moment, the default one it was given at the time it was created. So we want to create a new route table, and we want to give it a name. So we're going to call it Simplilearn. I'm going to call it Route Table, RTB for short. And then we get to pick which VPC we want to put it in. So obviously we want to use Simplilearn VPC. So we click Create. It'll take a couple of seconds, and here you are. Here's our new route table. So what we need to do now is change its route so that it points to the internet gateway. So if we go down here to routes, at a minute you can see it's just like our main route table. It just has local access. So we want to click on Edit, and we want to add another route. So the destination is the internet, which is all the zeros, and our target, and we click on this, it gives us the option of our internet gateway, which we want to do. So now we have internet access to this to this route table. And we click on Save. Save was successful. So now we can see that as well as local access, we have internet access. Now at the moment, if we click on subnet associations, you do not have any subnet associations. So basically both our subnets, the public and private subnets, are associated with the main route table, which doesn't have internet access. So we want to change this. So we'll click on Edit, and we want our public subnet to be associated with this route table. So click on Save. So it's just saving that. So now we can see that our public subnet is associated with this route table, and this route table is associated with the internet gateway. So now anything we launch into the public subnet will have internet access. But what if we wanted our instances in the private subnet to have internet access? Well, there's a way of doing that with a NAT device, and that's what we're going to look at in the next lecture. You can use a NAT device to enable instances in a private subnet to connect to the internet or other AWS services, but prevent the internet from initiating connections with the instances in the private subnet. So we talked earlier about public and private subnets to protect your assets from being directly connected to the internet. For example, your web server would sit in the public subnet and your database in the private subnet, which has no internet connectivity. However, your private subnet database instance might still need internet access or the ability to connect to other AWS resources. If so, you can use a Network Address Translation device, or a NAT device, to do this. A NAT device forwards traffic from your private subnet to the internet or other AWS services, and then sends the response back to the instances. When traffic goes to the internet, the source IP address of your instance is replaced with the NAT device address, and when the internet traffic comes back again, the NAT device translates the address to your instance's private IP address. So here's our diagram, which is getting ever more complicated, and if you look in the public subnet, you can see we've now added a NAT device, and you have to put NAT devices in the public subnet so that they get internet connectivity. AWS provides two kinds of NAT devices, a NAT gateway and a NAT instance. AWS recommends a NAT gateway as it's a managed service that provides better availability and bandwidth than NAT instances. Each NAT gateway is created in a specific availability zone and is implemented with redundancy in that zone. A NAT instance is launched from a NAT AMI, an Amazon Machine Image, and runs as an instance in your VPC, so it's something else you have to look after, whereas a NAT gateway, being a fully managed service, means once it's installed, you can pretty much forget about it. A NAT gateway must be launched into a public subnet because it needs internet connectivity. It also needs an elastic IP address, which you can select at the time of launch. Once created, you need to update the route table associated with your private subnet to point internet-bound traffic to the NAT gateway. This way, the instances in your private subnets can communicate with the internet. So if you remember back to the diagram when we had the custom route table, which was pointed to the internet gateway, now we're pointing our main route table to the NAT gateway, so that the private subnet also gets internet access, but in a more secure manner. Welcome to the Create a NAT Gateway demonstration, where we're going to create a NAT gateway so that the instances in our private subnet can get internet access. So we'll start by going to Networking and VPC. And the first thing we're going to do is take a look at our subnets, and you'll see why shortly. So here are our Simplilearn subnets. So this is the private subnet that we want to give internet access, but if you remember from the section, NAT gateways need to be placed in public subnets. So I'm just going to copy the name of this subnet ID for the public subnet, and you'll see why in a moment. So then we go to NAT gateways on the left hand side, and we want to create a new NAT gateway. So we have to put a subnet in there. So we want to choose our public subnet. Now, as you can see, it truncates a lot of the subnet names on this option, so it's a bit confusing. So we know that we want to put it in our Simplilearn VPC in the public subnet, but you can see it's truncated. So it's actually this one at the bottom, but what I'm going to do is just paste in the subnet ID, which I copied earlier, so there's no confusion. Then we need to give it an elastic IP address. Now, if you remember from the earlier demonstration, we created one, so let's select that. But if you hadn't allocated one, you could click on the Create New EIP button. So we'll do that. Okay, so it's telling me my NAT gateway has been created. And in order to use your NAT gateway, ensure that you edit your route table to include a route with a target of, and then our NAT gateway ID. So it's given us the option to click on our edit route tables. So we'll go straight there. Now here's our route tables. Now, here's the custom route table that we created earlier, and this is the default, the main route table, which was created when we created our VPC. So we should probably give this a name so that we know what it is. So let me just call this Simplilearn RTB main. So now we know that's our main route table. So if you take a look at the main route table and the subnet associations, you can see that our private subnet is associated with this table. So what we need to do is put a route in here that points to the NAT gateway. So if we click on routes and edit, and we want to add another route, and we want to say that all traffic can either go to the Simplilearn Internet Gateway, which we don't want to do. We want to point it to our NAT instance, which is this NAT ID here. And we click Save. So now any instances launched in our private subnet will be able to get internet access via our NAT gateway. Welcome to the Using Security Groups and Network ACL section. In this section, we're going to take a look at security groups and network ACLs, and we're going to have a demonstration on how you create both of these items in the Amazon Web Services console. A security group acts as a virtual firewall that controls the traffic for one or more instances. You add rules to each security group that allow traffic to or from its associated instances. Basically, a security group controls the inbound and outbound traffic for one or more EC2 instances. Security groups can be found on both the EC2 and VPC dashboards in the AWS Web Management Console. We're going to cover them here in this section, and you'll see them crop up again in the EC2 lesson. And here is our diagram, and you can see we've now added security groups to it. And you can see that EC2 instances are sitting inside the security groups, and the security groups will control what traffic flows in and out. So let's take a look at some examples, and we'll start with a security group for a web server. Now obviously a web server needs HTTP and HTTPS traffic as a minimum to be able to access it. So here is an example of the security group table, and you can see we're allowing HTTP and HTTPS, the ports that are associated with those two, and the sources, and we're allowing it from the internet. We're basically allowing all traffic to those ports. And that means any other traffic that comes in on different ports would be unable to reach the security group and the instances inside it. Let's take a look at an example for a database server security group. Now imagine you have a SQL Server database, then you would need to open up the SQL Server port so that people can access it, which is port 1433 by default. So we've added that to the table and we've allowed the source to come from the internet. Now because it's a Windows machine, you might want RDP access so you can log on and do some administration. So we've also added RDP access to the security group. Now you could leave it open to the internet, but that would mean anyone could try and hack their way into your box. So in this example, we've added a source IP address of 10.0.0.0.0. So only IP ranges from that address can RDP to the instance. Now there's a few rules associated with security groups. By default, security groups allow all outbound traffic. So if you want to tighten that down, you can do so in a similar way to you can define the inbound traffic. Security group rules are always permissive. You can't create rules that deny access, so you're allowing access rather than denying it. Security groups are stateful, so if you send a request from your instance, the response traffic for that request is allowed to flow in regardless of the inbound security group rules. And you can modify the rules of a security group at any time, and the rules are applied immediately. Welcome to the Create Security Group demonstration, where we're going to create two security groups, one to host DB servers and one to host web servers. Now if you remember from the best practices section, it said it was always a good idea to tier your applications into security groups, and that's exactly what we're going to do. So if we go to networking and VPC to bring up the VPC dashboard, on the left hand side under security we click on security groups. Now you can also get to security groups from the EC2 dashboard as well. So here's a list of my existing security groups, but we want to create a new security group, and we're going to call it Simplilearn Web Server SG Security Group, and we'll give the group name as the same, and our description is going to be Simplilearn Web Servers Security Groups. Okay, and then we need to select our VPC. Now it defaults to the default VPC, but obviously we want to put it in our Simplilearn VPC. So we click Yes, Create. Takes a couple of seconds, and there it is. There's our new security group. Now if we go down to the rules, the inbound rules, you can see there are none. So by default, a new security group has no inbound rules. But what about outbound rules? If you remember from the lesson, a new security group by default allows all traffic to be outbound. And there you are. All traffic has destination of everywhere. So all traffic is allowed. But we want to add some rules. So let's click on inbound rules. Click on edit. Now this is going to be a web server. So if we click on the drop down, we need to give it HTTP. So you can either choose custom TCP rule and type in your own port ranges, or you can just use the ones they have for you. So HTTP, this pre-populates the port range. And then here you can add the source. Now if I click on it, it's giving me the option of saying allow access from different security groups. So you could create a security group and say I only accept traffic from a different security group, which is a nice way of securing things down. You could also put in here just your IP address so that only you could do HTTP requests to the instance. But because it's a web server, we want people to be able to see our website, otherwise it's not going to be much use. So we're going to say all traffic, so all source traffic can access our instance on port HTTP 80. I want to add another rule because we also want to do HTTPS, which is hiding from me. There we are. And again, we want to do the same. And also, because this is going to be a Linux instance, we want to be able to connect to the Linux instance to do some work and configuration. So we need to give it SSH access. And again, it would be good practice to tie it down to your specific IP or an IP range. But we're just going to do all for now. And then we click on save. And there we are. There we have our ranges. So now we want to create our security group for our DB servers. So let's click create security group. And then we'll go through it and give it a similar name. Simplilearn DB servers SG. And the description is going to be Simplilearn DB servers security group. And our VPC is obviously going to be Simplilearn VPC. So let's click yes, create. We'll wait a few seconds. And here's our new security group. As you can see, it has no inbound rules by default, and outbound rules allow all traffic. So this is going to be a SQL Server database server. And so we need to allow SQL Server traffic into the instance. So we need to give it Microsoft SQL port access. Now the default port for Microsoft SQL Server is 1433. Now in reality, I'd probably change the port the SQL Server was running on to make it more secure, but we'll go with this for now. And then the source. So we could choose the IP ranges again, but what we want to do is place the DB server in the private subnet and allow the traffic to come from the web server. So the web server will accept traffic, and the web server will then go to the database to get the information it needs to display on its on the website. Or if people are entering information into the website, we want the information to be stored in our DB server. So basically, we want to say that the DB servers can only accept SQL Server traffic from the web server security group. So we can select the Simplilearn web server security group as the source traffic for Microsoft SQL Server data. So we'll select that. Now our SQL Server is obviously going to be a Windows instance, so from time to time we might need to log in and configure it. So we want to give RDP access. Now again, you would probably put a specific IP range in there. We're just going to do all traffic for now. Then we click save. And there we are. So now we have two security groups, DB servers and web servers. A network ACL is a network access control list, and it's an optional layer of security for your VPC that acts as a firewall for controlling traffic in and out of one or more of your subnets. You might set up network ACLs with rules similar to your security groups in order to add an additional layer of security to your VPC. Here is our network diagram, and we've added network ACLs to the mix. Now you can see they sit somewhere between the root tables and the subnets. This diagram makes it a little bit clearer, and you can see that a network ACL sits in between a root table and a subnet. And also you can see an example of the default network ACL, which is configured to allow all traffic to flow in and out of the subnets to which it's associated. Each network ACL includes a rule, whose rule number is an asterisk. This rule ensures that if a packet doesn't match any of the other numbered rules, it's denied. You can't modify or remove this rule. So if you take a look at this table, you can see on the inbound, some traffic would come in and it would look for the first rule, which is 100. And that's saying I'm allowing all traffic from all sources. So that's fine, the traffic comes in. If that rule 100 wasn't there, it would go to the asterisk rule. And the asterisk rule is saying traffic from all sources is denied. Let's take a look at the network ACL rules. Each subnet in your VPC must be associated with an ACL. If you don't assign it to a custom ACL, it will automatically be associated to your default ACL. A subnet can only be associated with one ACL. However, an ACL can be associated with multiple subnets. An ACL contains a list of numbered rules which are evaluated in order, starting with the lowest. As soon as a rule matches traffic, it's applied regardless of any higher numbered rules that may contradict it. AWS recommends incrementing your rules by a factor of 100, so there's plenty of room to implement new rules at a later date. Unlike security groups, ACLs are stateless. Responses to allowed inbound traffic are subject to the rules for outbound traffic. Welcome to the network ACL demonstration, where we're just going to have an overview of ACLs where they are in the dashboard. Now, you don't need to know a huge amount about them for the exam, you just need to know how they work and where they are. So let's go to networking and VPC, and when the dashboard loads, on the left hand side under security there's network ACLs. So let's click on that. Now you can see some ACLs that are in my AWS account. So we want the one that's associated with our Simplilearn VPC. So if we extend this VPC column, that's our network ACL there, Simplilearn VPC. Now let's give it a name because it's not very clear to see otherwise. Also, I'm kind of an obsessive tagger, so let's call it Simplilearn ACL and click on the tick. So there we are. So now it's much easier to see. So we click on inbound rules. So this is exactly what we showed you in the lesson. The rule is 100, so that's the first rule that's going to get evaluated, and it's saying allow all traffic from all sources. And the outbound rules are the same. So if you wanted to tighten down the new rule, you could click edit, we would give it a new rule number, say which would be 200. So you should always increment them in 100. So that means if you had 99 more rules you needed to put in place, you'd have space to put them in between these two. And then you could do whatever you wanted. You could say, you know, we are allowing HTTP access from all traffic, and we're allowing, or you could say, actually, you know what, we're going to deny it. So this is the way of blacklisting traffic into your VPC. Now I'm not going to save that because we don't need it, but this is where network ACLs sit, and this is where you would make any changes. It's also worth having a look at the subnet associations with your ACL. So we have two subnets in our Simplilearn VPC, so we would expect to see both of them associated with this network ACL because it's the default. And there they are. There's both our public and our private subnets are associated. And you can also see up here on the dashboard, it says default. So this is telling us this is our default ACL. If you did want to create a new network ACL, you would click create network ACL. You'd give it a name, just say new ACL, and then you would associate it with your VPC. So we would say Simplilearn VPC. Takes a few seconds, and there we are. There we have our new one. Now you can see this one says default no, because it obviously isn't the default ACL for our Simplilearn VPC, and it has no subnets associated with it. So let's just delete that because we don't need it. But there you are. There's a very brief overview of network ACLs. Welcome to the Amazon VPC Best Practices and Costs, where we're going to take a look at the best practices and the costs associated with the Amazon Virtual Private Cloud. Always use public and private subnets. You should use private subnets to secure resources that don't need to be available to the internet, such as database services. To provide secure internet access to the instances that reside in your private subnets, you should provide a NAT device. When using NAT devices, you should use a NAT gateway over NAT instances because they're a managed service and require less administration effort. You should choose your CIDR blocks carefully. Amazon VPC can contain from 16 to 65,536 IP addresses, so you should choose your CIDR block according to how many instances you think you'll need. You should also create separate Amazon VPCs for development, staging, test and production, or create one Amazon VPC with separate subnets, with a subnet each for production, development, staging and test. You should understand the Amazon VPC limits. There are various limitations on the VPC components. For example, you're allowed 5 VPCs per region, 200 subnets per VPC, 200 route tables per VPC, 500 security groups per VPC, 50 in- and outbound rules per VPC. However, some of these rules can be increased by raising a ticket with AWS support. You should use security groups and network ACLs to secure the traffic coming in and out of your VPC. Amazon advises to use security groups for whitelisting traffic and network ACLs for blacklisting traffic. Amazon recommends tiering your security groups. You should create different security groups for different tiers of your infrastructure architecture inside VPC. If you have web tiers and DB tiers, you should create different security groups for each of them. Creating tier-wise security groups will increase the infrastructure security inside the Amazon VPC. So if you launch all your web servers in the web server security group, that means they'll automatically all have HTTP and HTTPS open. Conversely, the database security group will have SQL Server ports already open. You should also standardize your security group naming conventions. Following a security group naming convention allows Amazon VPC operation and management for large-scale deployments to become much easier. Always span your Amazon VPC across multiple subnets in multiple availability zones inside a region. This helps in architecting high availability inside your VPC. If you choose to create a hardware VPN connection to your VPC using Virtual Private Gateway, you are charged for each VPN connection hour that your VPN connection is provisioned and available. Each partial VPN connection hour consumed is billed as a full hour. You'll also incur standard AWS data transfer charges for all data transferred via the VPN connection. If you choose to create a NAT gateway in your VPC, you are charged for each NAT gateway hour that your NAT gateway is provisioned and available. Data processing charges apply for each gigabyte processed through the NAT gateway. Each partial NAT gateway hour consumed is billed as a full hour. This is the practice assignment for designing a custom VPC, where you'll create a custom VPC using the concepts learnt in this lesson. Using the concepts learnt in this lesson, recreate the custom VPC as shown in the demonstrations. The VPC name should be Simplilearn VPC. The CIDR block should be 10.0.0.0/16. There should be 2 subnets, one public with a range of 10.0.1.0 and one private with a range of 10.0.2.0, and they should be placed in separate availability zones. There should be one internet gateway and one NAT gateway, and also one custom route table for the public subnet. Also create 2 security groups, Simplilearn Web Server Security Group and Simplilearn DB Server Security Group.
So let's review the key takeaways from this lesson.
Amazon Virtual Private Cloud, or VPC, enables you to launch AWS resources into a virtual network that you've defined. This virtual network closely resembles a traditional network that you'd operate in your own data center. but with the benefits of using scalable infrastructure of AWS. There are three types of IP address in AWS. A private IP address. This is an IP address that's not reachable over the internet, and it's used for communication between instances in the same network. A public IP address is reachable from the internet, which you can use for communication between your instances and the internet. And there's an elastic IP address. This is a static, public, persistent IP address that persists after an instance restarts, whereas a public IP address is reassociated after each restart. Amazon defines a subnet as a range of IP addresses in your VPC. You can launch AWS resources into a subnet that you select, and a subnet is always mapped to a single availability zone. Use a public subnet for resources that must be connected to the internet, and a private subnet for resources that won't be connected to the internet. To allow your VPC the ability to connect to the internet, you need to attach an internet gateway to it, and you can only attach one internet gateway per VPC. A route table determines where network traffic is directed. It does this by defining a set of rules. Every subnet has to be associated with a route table, and a subnet can only have an association with one route table. However, multiple subnets can be associated to the same route table. And you can use a NAT device to enable instances in a private subnet to connect to the internet or other AWS services. But a NAT device will prevent the internet from initiating connections with instances inside your private subnet. A security group acts as a virtual firewall that controls the traffic for one or more instances. You add rules to each security group that allow traffic to or from its associated instances. A Network Access Control List, or Network ACL, is an optional layer of security for your VPC that acts as a firewall for controlling traffic in and out of one or more of your subnets.
Let's look into what we have in our session. So what's in it for you? We would be covering what is AWS, why do we need AWS Sagemaker, what is AWS Sagemaker services, what are the benefits of using the AWS Sagemaker, machine learning with AWS Sagemaker, how to train a model with AWS Sagemaker, how to validate a model with AWS, and the companies that are using AWS Sagemaker. Along with that, we will be covering up one live demo on the AWS platform. Now let's understand what is AWS. So what is AWS? It's an Amazon Web Services. It's the largest or most widely used public cloud platform offered by Amazon. It provides services over the internet. AWS services can be used to build, monitor, and deploy any type of application in the cloud. AWS also uses the subscription pricing model. That means you only pay for whatever the services you use for. Now, why do we need AWS SageMaker? Let's look into it. So let's consider an example of one of the company, that is ProQuest. Now, before AWS SageMaker, the ProQuest is a global information content and technology company that provides valuable content such as ebooks, newspapers, etc. to the users. Before AWS SageMaker, the ProQuest requirement was to have a better user experience, maximum relevant search results. Now, after AWS SageMaker, they were able to achieve those results. So they achieved more appealing video user experience. They achieved more relevant search results for the users. Now, what do we mean by AWS SageMaker? Why this service is primarily used? So Amazon SageMaker is a cloud machine learning platform that helps users in building, training, tuning, and deploying machine learning models in a production-ready hosted environment. So it's kind of a machine learning service which is already hosted on the AWS platform. Now, what are the benefits of using AWS SageMaker? The key benefits of using AWS SageMaker are: it reduces machine learning data cost, so you can do the cost optimization while running this particular service on the AWS. All ML components are stored in a particular place in a dashboard, so they can be managed together. Highly scalable, so it can be scalable you can scale this particular service on the fly. It trains the models quite faster, maintains the uptime, so you can be assured that your workloads will be running all the time. It will be available all the time. High data security. So security becomes a major concern on the cloud platforms, and it ensures that you have the high data security. Along with that, you can do a data transfer to different AWS services like S3 bucket and all with the simple data transfer techniques. Now, machine learning with AWS SageMaker, let's look into it. So machine learning with AWS SageMaker is a 3-step function. So one is to build, second is to test and tune the model, and third is to deploy the model. Now with the build, it provides more than 15 widely used ML algorithms for training purpose. Now to build a model, you can collect and prepare training data, or you can select from the Amazon S3 bucket also. Choose and optimize the required algorithm. So some of the algorithms that you can select are k-means, linear regressions, logistic regression. SageMaker helps developers to customize ML instances with the Jupyter Notebook interface. In the test and tune, you have to set up and manage the environment for training. So you would need some sample data to train the model. So train and tune a model with the Amazon SageMaker. SageMaker implements hyperparameter tuning by adding a suitable combination of algorithm parameters. Also, it divides the training data and stores that in the Amazon S3. S3 is a simple storage service which is primarily used for storing the objects and the data. Hence, it is used for storing and recovering data over the internet. And below you can see that AWS SageMaker uses Amazon S3 to store data as it's safe and secure. Also, it divides the training data and stores in Amazon S3, where the training algorithm code is stored in the ECR. ECR stands for Elastic Container Registry, which is primarily used for containers and Dockers. ECR helps users to save, monitor, and deploy Docker and the containers. Later, SageMaker sets up a cluster for the input data, trains it, and stores it in the Amazon S3 itself. So this is done by the SageMaker itself. After that, you need to deploy it. So suppose you want to predict limited data at a time, you use Amazon SageMaker hosting services for that. Okay. But if you want to get prediction for an entire data set, prefer using Amazon SageMaker batch transform. Now the last step, that is to deploy the model. So once tuning is done, models can be deployed to SageMaker endpoints, and in the endpoint, real-time prediction is performed. So you would have some data which you would reserve and validate your model whether it is working correctly or not. Now evaluate your model and determine whether you have achieved your business goals. Now the other aspect is how we can train a model with AWS SageMaker. So this is basically a flow diagram which shows you how to train a model with the AWS SageMaker, and here we have used a couple of services of an AWS to get that done. So model training in AWS SageMaker is done on machine learning compute instances, and here we can see there are two machine learning compute instances used as helper code and the training code. Along with that, we are using two S3 buckets and the ECR for the container registry. Now let's look into what are the ways to train the model as per the slides. So below are the following requirements to train a model. So here in the diagram you can see these are the following requirements to train a model. The URL of an Amazon S3 bucket where the training data is stored, that is mentioned. The compute resources on machine learning compute instances. So these are all your machine learning compute instances. Then the URL of an Amazon S3 bucket where the output will be stored, and the path of AWS Elastic Container Registry where the code data is saved. The inference code image lies in the Elastic Container Registry. Now what are these called? These are called as the training jobs. Now when a user trains a model in Amazon SageMaker, he/she creates a training job. So we need to first create a training job, and then the input data is fetched from the specified Amazon S3 bucket. Once the training job is built, Amazon SageMaker launches the ML compute instances. So these compute instances will be launched once the training job is built. Then it trains the model with the training code and the data set, and it shows the output and model artifacts in the AWS S3 bucket. So this is done automatically. Now here the helper code performs a task when the training code fails. The interference code, which is in the Elastic Container Registry, consists of multiple linear sequence containers that process the request for inference on data. The EC2 container registry is a container registry that helps users to save, monitor, and deploy container images, whereas container images are the ready applications. Once the data is trained, the output is stored in the specified Amazon S3 bucket. So here you can see the output will be stored here. To prevent your algorithm being deleted, save the data in Amazon SageMaker critical system, which can process your ML compute instances. Now, how to validate a model? Let's look into it. So you can evaluate your model using offline or using the historical data. So first thing is that you can do the offline testing to validate a model. You can do an online testing with the live data. So if you have a live data coming or real-time streams coming, you can validate a model from there as well. You can validate using a holdout set, and also you can validate using the k-fold validation. Now use historical data to send requests to the model through the Jupyter Notebook in Amazon SageMaker for the evaluation. Online testing with live data deploys multiple models into the endpoints of Amazon SageMaker and directs live traffic to the model for validation. Validating using a holdout set is part of the data is set aside, which is called holdout set. So the part of the data is left, which is basically called as the holdout set. This data is not used for the model training. So later, when the model is trained with the remaining input data and generalize the data based on what is learned initially. So whatever the data which is left out will be used for validating a model, because we have not used that data while training a model. The k-fold validation is the input data is split into two parts. One part is called k, which is the validation data for testing the model, and the other part is k-1, which is used as a training data. Now, based on the input data, the machine learning model evaluates the final output. Now, the companies that are using AWS SageMaker, one is the ADP. So you must be knowing about ADP, Zalando, Dow Jones, which is the stock market, ProQuest, and the Intuit. Now let's look into the demo that how we can actually run the AWS SageMaker. So we'll use the R algorithm and then package the algorithm as a container for building, training, and deploying a model. We are going to use the Jupyter Notebook for that, for model building, for model training, for model deployment, and the code for the demo is in the below link. So you can see here that from this link you can get the code for the demo. Let's try to do a demo on the AWS. Now I would be using a link which is provided by Amazon to build, train, and deploy the machine learning model on the SageMaker, as you can see on my screen. And in this tutorial, you would have some steps where you can put those steps and the code, Python codes, into your AWS SageMaker Jupyter Lab. So in this tutorial, you will learn how to use Amazon SageMaker to build, train, and deploy a machine learning model. And for that, we will use the popular XGBoost ML algorithm for this exercise. So first of all, what you need to do is you have to go to the AWS console, and there you have to create a notebook instance. So in this tutorial, you will be creating a notebook instance. You will prepare the data, train the model to learn from the data, deploy the model, evaluate your ML model's performance, and once all those activities are done, then we'll see how we can actually remove all the resources in order to prevent the extra costing. Now the first step is we have to enter to the Amazon SageMaker console. So here you can see I'm already logged in into the SageMaker console. You can click on the services, search for the SageMaker here, and here you get the Amazon SageMaker service. Now the next step is that we have to create a notebook instance. So we will select the notebook instance from the SageMaker service, and then after the notebook instance is selected, we'll put a name to our instance and we'll create a new IAM role for that. So let's wait for the SageMaker Studio to open. So here you can see the studio is open, and you just have to click on the notebook instances, and here you have to create a notebook instance. So here you can see a couple of notebook instances have already been created. One of them is in service. So this is the notebook instance that we are going to use for creating the demo model. I'll show you how you can create a notebook instance. You just have to click on create notebook instance button and put your notebook instance name So you can put something like demo-sagemaker 987, or we can put it as model. We'll go with notebook instance type as default, which is mlt2.media. And in the permission and encryptions under the IAM role, we'll click on create a new IAM role. Now, why we are creating a new IAM role? So that we can allow the SageMaker to access any S3 bucket that has been created on our account. Just click on create a role, and here you would see that the new IAM role will be created with the set of permissions. Then rest of the things we'll keep it as default, and then you just have to click on create a notebook instance. The notebook instance creation takes some time, so you just have to wait for a couple of minutes to get that in service. We already have one of the notebook instance that has been created, so we will be using that to create a demo. Now going back to the steps, so these are the steps that we have already performed. Now once the notebook instance is created, then we have to prepare the data. So in this step, we will be using the SageMaker notebook instance to pre-process the data that would require to train the machine learning model. And for that, we would be opening up the Jupyter notebook, and then we have to select an environment, a kernel environment in the Jupyter notebook that would be conda_python 3. So let's follow these steps. Go back to the SageMaker, click on the notebook instances, select the running notebook instance, and here you would select the Open Jupyter Lab. Now here you would see that the SageMaker would try to open up the Jupyter notepad, and we would be performing all our inputs into that Jupyter notebook and executing the results there itself. So just wait for the notebook to open. Now here you can see the Jupyter Lab notebook has been opened. So I would be selecting one of the notebook that has been created. So this one. So likewise, you can create your own notebook also. How you can do that? First of all, let me select the kernel environment. So I would be selecting conda_python 3 and just click on select. So how you can create your own notebook? Just have to click on file, click on new, and here you can select the notebook. Just name your notebook, select the environment conda_python 3 to run this demo. So I have my notebook open. So in the tabs, I would be putting up the Python codes, and I would be executing those codes to get the output directly. So the next step is to prepare the data, train the ML model, and deploy it. We will need to import some libraries and define a few environment variables in the Jupyter notebook environment. So I would be copying this code, which you can see that would try to import NumPy, pandas. These are all required to run the Python syntax. So just copy this code and paste it into your notebook. Right? So once you do that, execute your code, and here you can see that you get the output, which is that it has imported all the necessary libraries that have been defined in the code. Now the next step is we would create an S3 bucket into the S3 service, and for that you have to copy this Python code, just that you have to edit it. So you have to specify this bucket name that you want to get created. So here I would provide the bucket name, which should be unique, should not overlap. So something like SageMaker -demo is the name that I have selected for the bucket, and now you have to execute that code. It says that the S3 bucket has been created successfully with the name SageMaker -demo 9876. So this is something which you can verify. So you can go to the S3 service, and there you can verify whether the bucket has been created or not. Now the next task is that we need to download the data to the AWS SageMaker instance and load it into the data frame. And for that, we have to follow this URL. So from this URL, which is build, train, deploy machine learning model would have a data in the form of bank_clean.csv, and this will be deployed onto our SageMaker instance. We'll copy this code and paste it here and execute the code. So it says that it has successfully downloaded bank_clean.csv, which has the data inside it, and that has been loaded into the SageMaker data frame successfully. Now we have a data to build and train our machine learning model. So what we are going to do, we are going to shuffle the data and we are going to split it, one into the training data set and the other one into test data set. So for the training data set, we are going to use 70% of the customers that are listed in the CSV file, and 30% of the customers in the CSV file data, we will be using it as a test data to train the model. So we will copy the following code into a new code cell, and then we are going to run that code cell. So I'll just copy it for training the data so that we can segregate the data model, 70% for building the model and 30% for testing the data. So click on run the execution, and here you can see that we got the output successfully. Now we have to train the model from that data. So how we are going to train that model? And for that we'll use SageMaker pre-built XGBoost model, which is an algorithm. So you will need to reformat the header and first column of the training data and load the data from the S3 bucket. So what I'll do is I'll copy this syntax and paste it in the node cell. So it has the train data, it would train the model. Click on run execution. Now it is changing the S3 input class, which will be renamed to training input, because now we are training the model with the training data. So we just have to wait for some time till it gets executed completely. Now the next thing is that we need to set up the Amazon SageMaker session to create an instance of the XGBoost model. So here we are going to create this SageMaker session. We are going to create an instance of the XGBoost model, which is an estimator. So just copy that code and paste it here. Execute it. And here you can see that it will start. It has basically changed the parameter image name to the image_URI in the SageMaker Python SDK v2. Now we'll follow the next step, that is, with the data loaded in the XGBoost estimator, we'll set up train the model using gradient optimization. And we'll copy the following code, and that would actually start the training of the model. So copy this code, and this would actually start training the model using our input data that we have reserved, 70% of that data that we have reserved for training the model. So just copy that, again initiate the execution, and it will start the training job. Now we'll deploy the model, and for that I would copy the deploy code, put that in the cell, and execute it. So it says parameter image will be renamed to image URI and using already existing model. So XGBoost was deployed already. If you have not done that, if you're doing it the first time, so it will initiate another XGBoost instance. So where you can find your XGBoost endpoints created, you just have to scroll down, and here under the inference, click on the endpoints, and you should find the XGBoost endpoints defined here. So here you can see that today I have created one XGBoost endpoint, and that is now in process of creating. So just refresh it. So it is still created. It is going to take some time to get that in service. Now our endpoint is in service state, so now we can use it. So going forward with the next steps, we'll try to predict whether the customer in the test data enroll for the bank product or not. For that, we are going to copy this code, put that in the Jupyter cell function and execute it. So here it gives you the output that it has actually evaluated, and the same output we got in the screenshot of the demo as well. Now we are going to evaluate the model performance. So what we are going to do, we are going to get the prediction done. So based on the prediction, we can conclude that you predicted a customer that will enroll for a certificate of deposit accurately for 90% of the customers in the test data, with a precision of 65% for enrolled and 90% which haven't enrolled for it. So for that, we are going to copy this code and execute it here in the cell. So if it is predicted correctly, that means our model is working absolutely fine. So here you can say the overall classification rate is 89.5%, and there is the accurate prediction that has been made by the model. And that's what the output we can see here in the screenshot of a model. So that means our model is absolutely working fine. It has been built, deployed and trained correctly. Now the next thing is that once you are done with that, you terminate your resources, and for that you just have to copy this code and put that in the cell function, so that the additional resources and the endpoints and the buckets that have been created by the Jupyter Notepad should be terminated, so that you would not be incurred with the extra costing. So just execute it, and here you would see that it would try to terminate all the additional resources that we have created from the Jupyter Notebook. Let's look into what we have in the CloudFront. So what's in it for you? We would be covering up the concept of what is AWS, what was earlier before AWS CloudFront, after AWS CloudFront, what were the services that were introduced, how it benefited. What do we mean by AWS CloudFront, benefits of the using AWS CloudFront, and how AWS CloudFront actually is known as a content delivery service, the name of the companies that are using AWS CloudFront, and we would be covering up one live demo. Now, AWS is the Amazon Web Services. It's a cloud service provider that basically offers a multiple services, variety of services, such as compute power, database storage, networking, and other resources, so that you can create your solutions on the cloud and help the business grow. Now, with AWS, you only pay for whatever the services you use. So for example, if you are using a service for a couple of hours, then you pay for only that many hours that you have used that service. Before AWS CloudFront, so there is an example that we are going to talk, and that is you must be aware of an application called Spotify. So when you used to access Spotify, and when you click on it, it kept on loading, and at the end you used to get the error, and the error was that the connection failed. And why you received that error? Because of a latency issue, probably a network error, right? So how you can solve these kind of a latency issues, and that is also going to, these kind of an issues are also going to impact the performance of an application. So with the introduction of AWS CloudFront, this problem of loading the application got resolved. So after AWS CloudFront, with the help of AWS CloudFront, Spotify gives the facility of updating new features, access to million songs that you can access instantly. So with the use of AWS CloudFront, the latency issues were solved, and successfully you can basically access your application. Now, what we mean by AWS CloudFront? So AWS CloudFront is a globally distributed network that is offered by AWS, Amazon Web Services, which securely delivers content to the end users across any geography with a higher transfer speed and an improved or a low latency. Now, what are the benefits of AWS CloudFront? There are multiple benefits. One is the cost effective. So it helps you to do the cost optimization when you use the CloudFront. It is time saving, so it is implemented easily, and also a lot of issues with respect to accessing the application with respect to latency and all can be resolved. Content privacy, so the content is placed to the end users and also to the CloudFront servers in a secured manner, in a secured way. It is highly programmable and you can make the changes, amend the changes on the fly, and you can target any location, any geography across the globe. Along with that, it helps you to get the content deliver quickly. Now, how AWS CloudFront delivers the content? Let's look into the architecture. So this is a flow, and the flow is with respect to how the user is going to get a content from the CloudFront. Now, the client first access a website by typing a URL on the browser, and in the step 1, it tries to access the application. Then the client requests, when the website is open, the client requests for an object to download, such as, for example, a particular file. Now, at that time, the DNS routes user request to download that file to AWS CloudFront. The AWS CloudFront connects to the nearest edge locations. Edge locations are basically the servers where it caches the files, documents, and the web codes. AWS CloudFront connects to its nearest edge location in order to serve the user the request. At edge location, AWS CloudFront looks for its requested cache file. Once the file is found, let's say if the file is available in the cache of an edge location, AWS CloudFront then sends the file to the user. Otherwise, if the file is not found in the cache memory of an edge location, AWS CloudFront compares the requirement with the specification and share it with a respected server. That means a web server or a server where the file is actually available. The web server, responds to the edge location by sending the file back to the CloudFront edge location. And then as soon as the AWS CloudFront receives the file, it shares with the client, also adds the file to the cache of an edge location for a future reference. This is how the flow of a CloudFront is. Now, the name of the companies that are using the AWS CloudFront. So one of them is Geo7 app, which is a very popular app. So it uses Amazon CloudFront to deliver 15 petabytes of audio and video to its subscribers globally, which is a huge data. Sky News, it uses the service in order to unify the content for faster distribution to subscribers. The Discovery Communications also uses the CloudFront. It uses the service for delivering API, static asset, and also the dynamic content. And then the TV1 EU, Streaming Europe, is basically also uses the CloudFront service that helps in improving latency and performance that results in fastest delivery of content. Now let's look into the demo how to use CloudFront to serve private S3 bucket as a website. Now I'm going to run a CloudFront distribution demo on the AWS console, and we'll basically try to deliver the content from a private S3 bucket and then map that with the domain name using the Route 53 service. So what we need for this demo, we would need a domain URL, we would need a Route 53 service, we would need CloudFront, we have to create a CloudFront distribution, and that will be linked with our S3 bucket, the private S3 bucket, right? And in the S3 bucket, we would have one HTML file, the index.html file. So let's move into AWS console. So right now I have opened up the CloudFront distribution, and here you can see that couple of distributions have already been created. So what I'm going to do, I'm going to create a distribution. Now there are two types of delivery method for your content. One is the web distribution and the other one is RTMP. RTMP stands for real-time audio or video distribution. It's basically used for distribution of a media content or a media file which are available in the S3 bucket. Here we are going to select a web distribution because primarily we will be using files which uses protocols HTTP or the HTTPS. So you have to click on Get Started, and in the origin domain name you have to specify the bucket where your code is available. So I have a bucket already created. Here you can see. And what you need to do is you have to create a bucket with the URL name or the domain name which you would be mapping with the Route 53 service. So this is a bucket that has already been created. Let me show you in a new tab. So here you have to go to the storage. Under the storage, you have to select the S3 bucket. Let's open the link in the new tab and let's look into how we can create the S3 buckets. Now here are a couple of buckets already created. I have created one bucket with the domain name that I'm going to use and map it with the Route 53 service. So that is basically mapped to a region which is in Ohio. And if you open up this bucket, here you will find an HTML web page. The index.html has been already added, right? So similarly, you have to create a bucket with a domain and an index.html page needs to be uploaded there. Now again, we'll go to the CloudFront. We'll try to create a distribution. Just have to click on create distribution. Select a web delivery method. Select an origin domain, which is sunshinelearning.in. And origin path, you don't have to specify. Origin ID is this one. So basically, when you define an origin domain name, automatically the origin ID appears. You can customize this origin ID as per your requirement also. So rest of the things, primarily we keep it as a default settings only until and unless if we require some customized settings to be done. So let's say if you have to change the cache behavior settings, you can do that. Otherwise, we'll keep it as default. Now in the distribution setting, you can either select use all edge locations for the best performance. So what does AWS basically do here? It uses all the edge locations which are associated with AWS across the globe. Otherwise, you can specify based on the regions also, right? Apart from that, if you want to enable firewalls or the access control list, you can specify here. And then what you need to do is in the default root object, here you have to specify your index.html page, which is in the S3 bucket. The distribution state has to be enabled, and if you want to use IP version 6 as well, you need to enable it. Click on create distribution. Now you can see here a distribution has been created. It's in progress and it is enabled. And it takes around 15 to 20 minutes to get that distribution completed. The reason is that the web codes, the web pages will be distributed across all the edge locations across the globe. So hence it takes time to get that done, right? Well, let's move on to Route 53 service and let's create the hosted zones. So we'll type Route 53 here, scalable DNS and domain name registration. And what we are going to do here is we are going to map our URL, the domains pointed to the name servers that will be provided by the Route 53. So we have to create a hosted zone. Let's wait for it. So now the Route 53 dashboard is open and you can see one hosted zone is already created. So just click on the hosted zone. And in order to point the traffic from the external domains towards the AWS, you have to first point the domains traffic to the hosted zone in the Route 53. So I'll click on create hosted zone, but before that I will first delete the existing one. And then I'll create another record, another hosted zone, right? Put your domain name. Let's say I put as sunshinelearning.in, and it is acting as a public hosted zone. Rest of the things will be default. Click on create hosted zone. Now it gives you 4 name servers, and these 4 name servers has to be updated in the domain. So you have to update these name servers in a platform from where you have purchased the domain, right? So this is half of the work done. Then what you need to do is you have to go and create records. Now in the records, you can select a routing policy. So right now what we are targeting basically that the traffic from the domain should be pointed directly towards the CloudFront distribution. Hence, we are going with a simple routing right now. Click on next. Here you have to specify the record sets. So we are going to create the records. Just click on default simple record. Put here as World Wide Web. And you have to select an endpoint. So endpoint we are selecting for the CloudFront distribution. So we have to specify alias for the CloudFront distribution. Now here we are going to put the CloudFront distribution URL, and then we are going to define the simple record set. So what we need is we need a CloudFront distribution URL, which you can find it from the CloudFront service itself, and you can find the domain name here itself. You just have to copy that and then paste it here in the distribution, and then just click on define simple records. Again, click on create records, and here you can see the record set has been updated. Now this domain is basically pointed towards these name servers, which are further pointed towards the CloudFront distribution. Right now, the only thing which is left is that within the domain, from wherever you have purchased the domain, you should update these 4 name servers, and then you can see the live traffic coming on this domain will have an output from the CloudFront distribution. Let's begin with our tutorial, and let's look into what we have in AWS AutoScaling. So I would be covering up why we require AWS AutoScaling, what is AWS AutoScaling, what are the benefits of using the scaling service, how this AutoScaling works, the different scaling plans we have, what is the difference between the snapshot and the AMI, what is a load balancer, and how many types of load balancers we have, and along with that I would be covering up a real live demo on the AWS. Let's begin with why we require AWS AutoScaling. Now before AWS Cloud Scaling, there was a question in the mind of enterprises that they were spending a lot of money on the purchase of the infrastructure. If they have to set up some kind of a solution, so they have to purchase an infrastructure, and a one-time cost was required. So that was a burden for them in terms of procuring a server, hardware, software, and then having a team of experts to manage all those infrastructure. So they used to think that no longer they require these resources if there was a cost-efficient solution for their project. That was the project manager used to think. Now, after the AWS Cloud Scaling that was introduced, automatically the AutoScaling maintains the application performance based on the user requirements at the lowest possible price. So what does the AutoScaling does is that whenever there is a scalability required, it manages it automatically. And hence the cost optimization became possible. Now, what is AWS AutoScaling? Let's look into deep. So AWS AutoScaling is a service that helps users to monitor their applications and the servers and automatically adjust the capacity of their infrastructure to maintain the steadiness. So they can increase the capacity, they can even decrease the capacity also for the cost optimization. And also predictable performance at the lowest possible cost. Now, what are the benefits of AutoScaling? It gave the better fault tolerance applications. You can get the servers created and you can have a clone copy of the servers so that you don't have to deploy the applications again and again. Better cost management because the scalability is decided by the AWS automatically based on some threshold parameters. It was a reliable service, and whenever the scaling is created or initiated, you can get the notifications onto your mail IDs or to your cell phones. Scalability, as I mentioned, is always there in the AutoScaling. It can scale up, it can scale down as well. And it has the flexibility in terms of whenever you want to schedule it, if you want to stop it, if you want to keep the size of the servers at a fixed number, you can always make the changes on the fly. And the better availability. Now, With the use of the autoscaling, we come around with the terminology called snapshot and the AMI. Let's look into the difference between the snapshots and the AMI. Snapshots versus AMI. So in a company, there was one of the employee that was facing an issue with launching the virtual machines. So he asked his colleague a question. Is it possible to launch multiple virtual machines with a minimum amount of time? Because it takes a lot of time in terms of creating the virtual machines. The other colleague said that yes, it is possible to launch multiple EC2 instances, and that can be done at a lesser time and with the same configuration. And this can be done either you use a snapshot or the AMI on the AWS. Then the colleague said that what are the differences between the snapshot and AMI? Let's look into the difference now. The snapshots basically kind of a backup of a single EBS volume, which is just like a virtual hard drive that is attached to the EC2 instance. Whereas the AMI, it is basically used as a backup of an EC2 instance only. The snapshots opts for this when the instance contains multiple static EBS volumes. When you opt for the snapshot, whenever the instance contains multiple static EBS volumes. AMI, this is widely used to replace the failed EC2 instance. In the snapshots, here you pay only for the storage of the modified data, whereas with the AMI, you pay only for the storage that you use. The snapshots are non-bootable images on EBS volume, whereas AMI are bootable images on the EC2 instance. However, creating an AMI image will also create the EBS snapshots. Now, how does AWS AutoScaling work? Let's look into it. So for the AWS AutoScaling to work, you have to configure single unified scaling policy per application resource. And this scaling policy, with that you can explore the applications also. And then select the service you want to scale. Also, for the optimization, select do you want to optimize the cost or do you want to optimize the performance. And then keep track of scaling by monitoring or getting the notifications. Now, what are the different scaling plans we have? So, in the autoscaling, a scaling plan basically helps a user to configure a set of instructions for scaling based on the particular software requirement. The scaling strategy basically guides the service of AWS AutoScaling on how to optimize resources in a particular application. So, it's basically kind of the parameters that you set it up so that how the resource optimization can be achieved in the autoscaling. With the scaling strategies, users can create their own strategy based on their required metrics and thresholds, and this can be changed on the fly as well. What are the two types of scaling policies we have? So there are basically dynamic scaling and the predictive scaling. Now, what is dynamic scaling? It basically guides the service of AWS AutoScaling on how to optimize the resources. And it is helpful in optimizing resources for availability and particular price. Now, with scaling strategies, users can create their plan based on the required metrics and thresholds. So a metric can be like, let's say, a network in, network out, or it can be a CPU utilization, memory utilization likewise. Now, in the predictive scaling, its objective is to predict future workload based on daily and weekly trends and regular forecast future network traffic. So it is kind of a forecast that happens based on the previous past experiences. It uses a machine learning technique for analyzing that network traffic, and this scaling is like how weather forecast works, right? It provides schedule scaling actions to ensure the resource capacity is available for application requirement. Now, with the auto scaling, you would need the load balancers also, because if there are multiple instances that are created, then you would need a load balancer to distribute the load to those instances. So let's understand what do we mean by a load balancer. A load balancer basically acts as a reverse proxy, and it is responsible for distributing the network or the application traffic across multiple servers. With the help of a load balancer, you can achieve a reliability, you can achieve a fault tolerance of an application. That is basically, it increases the fault tolerance and the reliability. So for example, when there is a high network traffic that is coming to your application, and if that much traffic comes to your application to the instances, your instances may crash. So how you can avoid that situation? So You need to manage the network traffic that is coming to your instances, and that can be done with the load balancer. So thanks to the AWS load balancers, which helps in distributing network traffic across backend servers in a way that it increases performance of an application. Here in the image, you can see the traffic coming from different resources landing onto the EC2 instance, and the load balancer is actually distributing that traffic to all the 3 instances, hence managing the network traffic quite properly. Now, what are the types of load balancers we have? There are 3 types of load balancers on the AWS. One is the classic load balancer, second is the application load balancer, and the third one is the network load balancer. Let's look into what we have in the classic load balancer. So the classic load balancer is the most basic form of load balancing, and we call it as a primitive load balancer also, and it is widely used for the EC2 instances. It is based on the IP address and the TCP port, and it routes network traffic between end users as well as in between the backend servers. And it does not support host-based routing, and it results in low efficiency of resources. Let's look into what we have in the application load balancer. This is one of the advanced forms of load balancing. It performs a task on the application level in the OSI model. It is used when there are HTTP and HTTPS traffic routing is required, and also it supports the host-based and path-based routing and performs well with the microservices or the backend applications. The network load balancer performs the task at layer 4 of the connection level in the OSI model. The prime role of the network load balancer is to route the TCP traffic, and it can manage a massive amount of traffic and is also suitable to manage the low latencies. Let's look into the demo and see how practically we can create the autoscaling. Hi guys, let's look into the demo for how we can create an autoscaling on the AWS console. So right now I'm logged into the AWS console and I am in the Mumbai region. What you need to do is you have to go to the compute section, and under that click on the EC2 service. Let's wait for the EC2 service to come. Now just scroll down, and under the load balancing there is an option called autoscaling. So there first you have to create a launch configuration, and then after that you have to create the autoscaling groups. So click on launch configuration, and then you have to click on create launch configurations. So click on create launch configuration. Now this launch configuration is basically the set of parameters that you define while launching an autoscaling, so that this uniformity is maintained with all the instances. So that includes, let's say if you select a Windows OS or a Linux OS, that particular type of an operating system will be implemented in all the instances that will be part of an autoscaling. So there are certain set of parameters that we have to specify during the launch configuration, so that we can have a uniformity in terms of launching the servers. So here I would select an Amazon Linux AMI, and then I would select the type of a server, which will be t2.micro. Click on configure details, put the name to the launch configuration. Let's say we put it as a demo, and the rest of the things we'll keep it default. Click on add storage. Since it's a Linux AMI, we can go with the 8 GB storage. That should be fine. Click on configure security group. Let's create a new security group which has the SSH port open, and that is open for anywhere, which is basically source IPv4 and IPv6 IPs. Any IP will be able to access that. Click on review. Just review your launch configuration. If you want to make changes, you can do that. Otherwise, click on create a launch configuration. You would need the key pair, and this key pair will be a unique key pair which will be used with all the instances that are part of the autoscaling group. So we can select an existing key pair if you have that. Otherwise, you can create a new key pair. So I have an existing key pair. I'll go with that, acknowledge it, and click on create launch configuration. Now we have successfully launched the configuration of an autoscaling. The next thing is to create an autoscaling group. So click on create an autoscaling group using this launch configuration. Put a group name. Let's say we put something like test, and the group size to start with, it says 1 instance, so that means at least a single instance will always be running, and it will be initiated and running 24/7. till the autoscaling is available. You can increase the size of the minimum base instances also. Let's say you can change it to 2 also. So you would get at least 2 servers running all the time. So we'll go with the one instance. The network would be the VPC default, and in the VPC particular region, we can select the availability zones. So let's say if I select availability zone 1A and then availability zone 1B. So how the instances will be launched? So one instance will be launched in 1A, the other one in the 1B, the third one in the 1A, fourth one in the 1B. Likewise, it will be equally spread among the availability zones. Next part is to configure the scaling policies. So click on it. If you want to keep this group at its initial size, let's say if you want to go with only a single instance or 2 instances and you don't want the scaling to progress, you can put it, keep this group at its initial size. So this is basically a way to halt the scaling. But we'll use the scaling policies to adjust the capacity of this group. So click on it. And we would scale between, let's say, minimum 1 instance that we have, and we'll scale it between 1 to 4 instances. And on what basis these instances will be scaled up or scaled down would be defined in the scale group size. So the scaling policies you can implement based on a scale group size or using the simple scaling policies using the steps. So in the scale group size, you have certain metrics. You can use average CPU utilization. You can define a metric related to average network in, average network out, or the load balancer request counts per target. And if you create the simple scaling policies using steps, then you need to create the alarms, and there you can get some more metrics that you can add up as a parameter for the auto scaling. Let's go with the scaling group size. Let's go with the metric type as average CPU utilization, and the target value here you have to specify what would be the threshold that when the instance CPU utilization is crossed, then a new instance should be initiated. So you can put a reasonable threshold for that. Let's say we put something like 85%, and whenever the instance CPU utilization is crossed 85% threshold, you will see that there will be a new instance created. Let's go to the next configure notifications, and here you can add notifications. So let's say if there is a new instance that is initiated and you want to basically be notified, so you can get notifications over your email IDs, or you can get it on the cell phones. So for that, for adding the notification, you would need the SNS service that is called as a simple notification service, and you have to create a topic there. You have to subscribe for the topic using your email ID, and then you should get the notifications. Click on configure tags. The tags are not mandatory. You can basically put a tag. Let's say if you want to identify the instance for the purpose it was created. Otherwise, you can leave it blank also. Click on review and review your scaling policies, notification, tags, as well as the scaling group details. Click on create auto scaling group, and here you go. Your scaling has been launched. Click on close, and you should get at least a single instance initiated automatically by the auto scaling. So let's wait for the details to appear. So here you can see our launch configuration name, demo, auto scaling group name, test, minimum instance we want 1, the maximum instances we want 4. We have selected 2 availability zones, AP South 1A, AP South 1B, and the instance 1 has been initiated. And if you want to verify where exactly this instance has been initiated, just click on the instances here, and here you will see that a single instance has been initiated, that is in service, and that has been initiated in AP South 1B. Now once the threshold of this instance crosses 85%, that is what we have defined in the scaling policies, then you should see that another instance will be initiated. So likewise, this is basically I have created steps to initiate a scaling policy, that means to increase the number of servers whenever the threshold crosses. Likewise, here itself you can add another policy to scale down the resources in case if the CPU utilization goes to a normal value. So let's begin with Amazon Redshift, and let's see what we have for today's session. So what's in it for you today? We'll see what is AWS, why we require Amazon Redshift, what do we mean by Amazon Redshift, the advantages of Amazon Redshift, the architecture of Amazon Redshift, some of the additional concepts associated with the Redshift, and the companies that are using the Amazon Redshift. And finally, we'll cover up one demo which will show you the practical example that how you can actually use the Redshift service. Now, what is AWS? As we know that AWS stands for Amazon Web Service. It's one of the largest cloud providers in the market, and it's basically a secure cloud service platform provided from the Amazon. Also, on the AWS, you can create and deploy the applications using the AWS service. Along with that, you can access the services provided by the AWS over the public network, that is, over the internet. They are accessible. Plus, you pay only whatever the service you use for. Now, let's understand why we require Amazon Redshift. So earlier, before Amazon Redshift, what used to happen that the people used to, or the developers used to fetch the data from the data warehouse. So data warehouse is basically a terminology which is basically represents the collection of the data. So a repository where the data is stored is generally called as a data warehouse. Now, fetching data from the data warehouse was a complicated task because might be a possibility that the developer is located at a different geography and the data warehouse is at a different location, and probably there is not that much network connectivity or some networking challenges, internet connectivity challenges, security challenges might be, and a lot of maintenance was required to manage the data warehouses. So what were the cons of the traditional data warehouse services? It was time consuming to download or get the data from the data warehouse. Maintenance cost was high, and there was the possibility of loss of information in between the downloading of the data, and the data rigidity was an issue. Now, how these problems could overcome, and this was basically solved with the introduction of Amazon Redshift over the cloud platform. Now, we say that Amazon Redshift has solved traditional data warehouse problems that the developers were facing, but how? What is Amazon Redshift actually is? So what is Amazon Redshift? It is one of the services over the AWS, Amazon Web Services, which is called as a data warehouse service. So Amazon Redshift is a cloud-based service or a data warehouse service that is primarily used for collecting and storing the large chunk of data. So it also helps you to get or extract the data, analyze the data using some of the BI tools. So business intelligence tools you can use and get the data from the Redshift and process that. And hence it simplifies the process of handling the large scale data sets. So this is the symbol for the Amazon Redshift over the AWS. Now let's discuss about one of the use case. So DNA is basically a telecommunication company, and they were facing an issue with managing their website and also the Amazon S3 data, which led down to slow process of their applications. Now, how could they overcome this problem? Let's see that. So they overcome this issue by using the Amazon Redshift, and all the company noticed that there was a 52% increase in the application performance. Now, did you know that Amazon Redshift is basically cost less to operate than any other cloud data warehouse service available on the cloud computing platforms? And also the performance of an Amazon Redshift is the fastest data warehouse, we can say that is available as of now. So in both cases, one is that it saves the cost as compared to the traditional data warehouses, and also the performance of this Redshift service or a data warehouse service, the fastest available on the cloud platforms. And more than 15,000 customers presently they are using the Amazon Redshift service. Now let's understand some of the advantages of Amazon Redshift. First of all, as we saw that it is one of the fastest available data warehouse service, so it has the high performance. Second is, it is a low cost service. So you can have a large scale of data warehouse or the databases combined in a data warehouse at a very low cost. So whatever you use, you pay for that only. Scalability. Now, in case if you wanted to increase the nodes of the databases in your Redshift, you can actually increase that based on your requirement, and that is on the fly. So you don't have to wait for the procurement of any kind of a hardware or the infrastructure. It is whenever you require, you can scale up or scale down the resources. So the scalability is again one of the advantage of the Amazon Redshift. Availability, since it's available across multiple availability zones, so it makes this service as a highly available service. Security. So whenever you access Redshift, you create a clusters in the Redshift, and the clusters are created you can define a specific virtual private cloud for your cluster, and you can create your own security groups and attach it to your cluster. So you can design the security parameters based on your requirement, and you can get your data warehouse or the data items in a secured place. Flexibility, and you can remove the clusters, you can create another clusters. If you are deleting a cluster, you can take a snapshot of it and you can move those snapshots to different regions. So that much flexibility is available on the AWS for the service. And the other advantage is that it is basically a very simple way to do a database migration. So if you're planning that you wanted to migrate your databases from the traditional data center over the cloud on the Redshift, it is basically very simple to do a database migration. You can have some of the inbuilt tools available on the AWS, you can connect them with your traditional data center and get that data migrated directly to the Redshift. Now let's understand the architecture of the Amazon Redshift. So architecture of an Amazon Redshift is basically it combines of a cluster, and that we call it as a data warehouse cluster. In this picture, you can see that this is a data warehouse cluster and this is a representation of a Amazon Redshift. So it has some of the compute nodes which does the data processing, and a leader node which gives the instructions to these compute nodes. And also the leader node basically manages the client applications that require the data from the Redshift. So let's understand about the components of the Redshift. The client application of Amazon Redshift basically interact with the leader node using JDBC or the ODBC. Now what is JDBC? It's a Java database connectivity, and the ODBC stands for Open Database Connectivity. The Amazon Redshift service using a JDBC connector can monitor the connections from the other client applications. So the leader node can actually have a check on the client applications using the JDBC connections. Whereas the ODBC allows a leader node to have a direct interaction or to have a live interaction with the Amazon Redshift. So ODBC allows a user to interact with live data of Amazon Redshift. So it has a direct connectivity, direct access of the applications, as well as the leader node can get the information from the compute nodes. Now, what are these compute nodes? These are basically kind of a databases which does the processing. So Amazon Redshift has a set of computing resources which we call it as a nodes, and the nodes, when they are combined together, they are called it as a clusters. Now a cluster, a set of computing resources which are called as nodes, and this gathers into a group which we call it as a data warehouse cluster. So you can have a compute node starting from 1 to n number of nodes, and that's why we call that the Redshift is a scalable service, because we can scale up the compute nodes whenever we require. Now the data warehouse cluster, or each cluster, has one or more databases in the form of a nodes. Now what is a leader node? This node basically manages the interaction between the client application and the compute node. So it acts as a bridge between the client application and the compute nodes. Also, it analyzes and develops designs in order to carry out any kind of a database operations. So leader node basically sends out the instructions to the compute nodes, basically perform or execute that instruction and give that output to the leader node. So that is what we are going to see in the next slide, that the leader node runs the program and assign the code to individual compute nodes, and the compute nodes execute the program and share the result back to the leader node for the final aggregation, and then it is delivered to the client application for analytics or whatever the client application is created for. So compute nodes are basically categorized into slices, and each node slice is allotted with specific memory space, or you can say a storage space, where the data is processed. These node slices works in parallel in order to finish their work, and hence when we talk about a Redshift as a faster processing capability as compared to other data warehouses or traditional data warehouses, this is because that these node slices work in a parallel operation that makes it more faster. Now, the additional concept associated with Amazon Redshift is there are two additional concepts associated with the Redshift. One is called as the column storage and the other one is called as the compression. Let's see what is the column storage. As the name suggests, column storage is basically kind of a data storage in the form of a column, so that whenever we run a query, it becomes easier to pull out the data from the columns. So column storage is an essential factor in optimizing query performance and resulting in quicker output. So one of the examples are mentioned here. So below example show how database tables store record into disk block by row. So here you can see that if we wanted to pull out some kind of an information based on the city, address, age, we can basically create a filter, and from there we can put out the details that we require, and that is going to fetch out the details based on the column storage. So that makes data more structured, more streamlined, and it becomes very easier to run a query and get that output. Now the compression is basically to save the column storage. We can use a compression as an attribute. So compression is a column level operation which decreases the storage requirement, and hence it improves the query performance. And this is one of the syntax for the column compression. Now the companies that are using Amazon Redshift, one is LYA, the other one is Equinox, the third one is the Pfizer, which is one of the famous pharmaceuticals company. McDonald's, one of the burger chains across the globe, and Philips, it's an electronic company. So these are one of the biggest companies that are basically relying and they are putting their data on the Redshift data warehouse service. Now in another video, we'll see the demo for using the Amazon Redshift. Let's look into the Amazon Redshift demo. So these are the steps that we need to follow for creating the Amazon Redshift cluster. And in this demo, what we'll be doing is that we'll be creating an IAM role for the Redshift so that the Redshift can call the services, and specifically we'll be using the S3 service. So the role that we'll be creating, we'll be giving the permission to Redshift to have an access of an S3 in the read-only format. So in the step one, what we require, we'll check the prerequisites, and what you need to have is the AWS credentials. If you don't have that, you need to create your own credentials, and you can use your credit and the debit card. And then in the step two, we'll proceed with the IAM role for the Amazon Redshift. Once the role is created, we'll launch a sample Amazon Redshift cluster mentioned in the step 3, and then we'll assign a VPC security groups to our cluster. Now you can create it in the default VPC also, you can create a default security groups also, otherwise you can customize the security groups based on your requirement. Now to connect to the sample cluster, you need to run the queries, and you can connect to your cluster and run queries on the AWS Management Console query editor, which you will find it in the Redshift only. Or if you use the query editor, you don't have to download and set up a SQL client application separately. And in the step 6, what you can do is you can copy the data from the S3 and upload that in the Redshift, because the Redshift would have an access, a read-only access for the S3, as that will be created in the IAM role. So let's see how we can actually use the Redshift on the AWS. So I am already logged in into my account. I am in North Virginia region. I'll search for Redshift service, and here I find Amazon Redshift. So just click on it. Let's wait for the Redshift to come. Now this is a Redshift dashboard, and from here itself you have to run the cluster. So to launch a cluster, you just have to click on this launch cluster, and once the cluster is created, and if you wanted to run queries, you can open query editor, or you can basically create queries and access the data from the Redshift. So that's what it was mentioned in the steps also, that you don't require a separate SQL client application to get the queries run on the data warehouse. Now, before creating a cluster, we need to create the role. So what we'll do is we'll click on the services and we'll move to IAM role section. So IAM role I can find here under the security, identity and compliance. So just click on the identity access management and then click on create roles. So let's wait for IAM page to open. So here in the IAM dashboard, you just have to click on the roles. I already have the role created. So what I'll do is I'll delete this role and I'll create it separately. So just click on a create role, and under the AWS services, you have to select for the Redshift, because now the Redshift will be calling the other services, and that's why we are creating the role. Now, which other services that the Redshift will be having an access of? S3. Why? Because we'll be putting up the data on the S3, and that is something which needs to be uploaded on the Redshift. So we'll just search for the Redshift service, and we can find it here. So just click on it, and then click on Redshift customizable in the use case. Now click on next permissions, and here in the permissions, give the access to this role, assign the permissions to this role in the form of an S3 read-only access. So you can search here for the S3 also. Let's wait for the policies to come in. Here it is. Let's type S3. And here we can find Amazon S3 read-only access. So just click on it and assign the permissions to this role. Tags, you can leave them blank. Click on next review. Put a name to your role. Let's put my Redshift role and click on a create role. Now you can see that your role has been created. Now the next step is that we'll move to Redshift service and we'll create one cluster. So click on the services click on Amazon Redshift. You can find that in the history section since we browsed it just now. And from here, we are going to create a sample cluster. Now, to launch a cluster, you just have to click on launch this cluster. Whatever the uncompressed data size you want in the form of a gigabyte, terabyte, or petabyte, you can select that. And let's say if you select in the form of GB, how much GB memory you want, you can define it here itself. This also gives you the information about the costing. On demand is basically pay as you use. So they are going to charge you $0.5 per hour for using the 2 node slices. So let's click on launch this cluster, and this will be a DC2.large kind of an instance that will be given to you. It would be in the form of a solid state drive, SSDs, which is one of the fastest way of storing the information. And the nodes 2 are mentioned by default. That means there will be 2 node slices that will be created in a cluster. You can increase them also. Let's say if I put 3 node slices, so it is going to give us 3 into 0.16 TB per node storage. Now here you have to define the master username password for your Redshift cluster, and you have to follow the password instructions. So I would put a password to this cluster, and if it accepts, that means it does not give you any kind of a warning. Otherwise it is going to tell you about you have to use the ASCII characters and all. And here you have to assign this cluster the role that we created recently. So in the available IAM roles, you just have to click on my Redshift role, and then you have to launch the cluster. If you wanted to change something in with respect to the default settings, let's say if you wanted to change the VPC from default VPC to your custom VPC, and you wanted to change the default security groups to your own security groups, so you can switch to advanced settings and do that modification. Now let's launch the cluster, and here you can see the Redshift cluster is being created. Now if you wanted to run queries on this Redshift cluster, so you don't require a separate SQL client, you just have to follow the simple steps to run a query editor, and the query editor you will find it on the dashboard. So let's click on the cluster, and here you would see that the Redshift cluster would be created with the 3 nodes in the US East 1B availability zone. So we have created the Redshift cluster in the Ohio region, and now what we'll do is we'll see how we can create the tables inside the Redshift, and we'll see how we can use the copy command so that we can directly move the data uploaded on the S3 bucket to the Redshift database tables. And then we'll query the results of a table as well. So how we can do that? First of all, after creating the Redshift cluster, we have to install SQL Workbench /J. This is not a MySQL, which is managed by Oracle, and you can find this on the Google. You can download it from there. And then you have to connect this client with the Redshift database. How you can do? Click on File, click on Connect Window, and after connecting a window, you have to paste the URL, which is a JDBC driver. This driver link, you can find it onto the AWS console. So if you open up a Redshift cluster, there you would find the JDBC driver link. Let's wait for it. So this is our cluster created. Let's open it, and here you can find this JDBC URL. And also make sure that in the security groups of a Redshift, you have the port 5439 open for the traffic, incoming traffic. You also need to have the Amazon Redshift driver, and this is the link where you can download the driver and specify the path. Once you are done with that, you provide the username and the password that you created while creating the Redshift cluster. Click on OK. So this connects with the database, and now the database connection is almost completed. Now what we will be doing in the SQL Workbench, we'll be first creating the sales table, and then in the sales table, we'll be adding up the entries copied from the S3 bucket, and then move it to the Redshift database. And after that, we'll query the results in the sales table. Now, whatever the values you are creating in the table, the same values needs to be in the data file. And I have taken up this sample data file from this link, which is docs.aws.amazon.com, Redshift, sample database creation. And here you can find a download file, ticketdb.zip file. This folder has basically multiple data files, sample data files, which you can actually use it to practice uploading the data on the Redshift cluster. So I have extracted one of the files from this folder, and then I have uploaded that file in the S3 bucket. Now we'll move into the S3 bucket. Let's look for the file that has been uploaded on the S3 bucket. So this is the bucket sample, and sales underscore tab.text is the file that I have uploaded. This has the entries, data entries that will be uploaded using a copy command onto the Redshift cluster. Now, after putting up the command for creating up the table, then we'll use a copy command. And copy command, we have to define the table name. The table name is sales, and we have to define the path from where the data would be copied over to the sales table in the Redshift. Now, path is the S3 bucket, and this is the Redshift bucket sample, and it has to look for the data inside the sales underscore tab.text file. Also, we have to define the role ARN that was created previously. And once it is done, then the third step is to query the results inside the sales table to check whether our data has been uploaded correctly on the table or not. Now what we'll do is we'll execute all these three syntax. It gives us the error because we have to connect it again to the database. Let's wait for it. Execute it. It again gives us the error. Let's look into the name of the bucket. It's Redshift bucket sample. So we have two T's mentioned here. Right. Let's connect with the database again and now execute it. So table sales created, and we got the error. The specified bucket does not exist. Redshift bucket sample. Let's view the bucket name. Redshift bucket sample. Let's copy that. Put it here, connect to the window, connect back to the database, right, and now execute it. So table sales created, the data in the table has been copied from the S3 bucket to sales underscore tab.text to the Redshift, and then the query of the results. The results from the table has been queried.
In this section, you'll learn what elastic load balancing is. Elastic load balancing automatically distributes incoming application traffic across multiple Amazon EC2 instances. It enables you to achieve increased levels of fault tolerance for your applications by seamlessly providing the required amount of load balancing capacity needed to distribute the application traffic. You can distribute incoming traffic across your EC2 instances in a single availability zone or multiple availability zones. Elastic load balancing automatically scales its request handling capacity in response to incoming traffic. Elastic load balancing can also detect the health of your Amazon EC2 instances. When it detects an unhealthy instance, it will spread the load across the remaining instances and no longer route traffic to the unhealthy instance. When you're using VPC, you can create and manage security groups associated with elastic load balancing to provide additional networking and security options. You can also create a load balancer without a public IP address, so it serves as an internal, i.e. non-internet facing, load balancer. Elastic load balancing also supports the ability to stick user sessions to specific EC2 instances using cookies. And if you remember from lesson 2 when we talked about session affinity, this is a version of that. In this demonstration, we're going to create a load balancer for our Simplilearn web servers. So to do that, we'll go to the Compute EC2 section. And I want to show you that before we can configure load balancing, there's a couple of things we need to do. So if we go to Load Balancers on the left-hand side, and then click on Create Load Balancer. So we want to create the load balancer inside Simplilearn VPC. Now I want to show you this warning that comes up. It says please select at least 2 subnets in different availability zones to provide high availability for your load balancer. And you could think, well, that's great, we have 2 subnets. We have a public subnet and a private subnet, and they're both in different availability zones. So if we add them both, we get another warning. It says this is an internet-facing elastic load balancer, but there is no internet gateway attached to the subnet you've just selected. So obviously our private gateway, private subnet, only has a NAT gateway to provide its internet access, so it's not a public internet-facing subnet. So what that means is we need to create a new public subnet in a different availability zone for our load balancer. So we already have this one, public, in US East 1B. We're going to create a public subnet in US East 1C as well. So to do that, let's go back
to the networking VPC section, and this is going to be a quick review of the VPC lesson. So we'll go to subnets, we'll sort by VPC. So here are our two existing subnets. So we'll create a new subnet, and we're going to call it, let me just paste what I copied, we're going to call it 10.0.3.0 US East 1C Simplilearn Pub, and we're going to put it in our Simplilearn VPC, and we want to put it in the US East 1C availability zone, so it's different to our existing public subnet, and we're going to put it in that CIDR block. So let's click create. So there we are. Now we have 3 subnets in our Simplilearn VPC, 2 of them are public. Now, if you remember, when you create a new subnet, it will get attached to your default route table by default. So that's no good because our default route table doesn't have internet access. So we need to go to route tables. We click on our main default route table and have a look at subnet associations. We can see that our new subnet is in here. So we need to move it into our custom route table, so it will be the same as our existing public subnet. So if we click on edit, we just tick the box next to our new public subnet and click save. So now our new public subnet is in this route table, so it has internet access. So now we're good to go. So let's go back to the EC2 section, and we want to launch a new web server into this new public subnet. So we'll go to, well, we'll launch it from our AMI because we've already configured our web servers as an AMI. So we'll click launch. We'll choose T2 Nano. We'll configure our instance details. So we're going to place it in the Simplilearn VPC. We're going to place it in our new public subnet in the US East 1C availability zone. We're going to enable a public IP. We're going to give it the administrator IAM role, and we're going to protect against accidental termination. The storage is fine. We're going to tag this one as Simplilearn Web Server 3. We'll configure the security group, so we'll put it in an existing group, which will be the web servers group, and we'll launch it using our existing Simplilearn key pair, which I have possession of. Okay, so that's launching. So we can see our Simplilearn web servers. So there we are, we've got 3 of them. We've got 1, 2 which are already up and running, and number 3 which is coming online. So now we're ready to create our load balancing. So let's go to load balancers again and create load balancer. We want to put it in our VPC and we'll give it a name. So this is the kind of internal name. We can tag it differently later on because you can't put any underscores or hyphens in this section. So we'll call it Simplilearn LB, Simplilearn VPC. If we wanted to create an internal load balancer, so it was balancing traffic that was just internal to our AWS VPC, we could tick this box. Here's the listener configuration. So what we can do here is we're saying that any HTTP traffic that comes in on port 80 to the load balancer is being pushed to port HTTP 80 on our instances. So what we could do is you could change this. You could have a different port for the load balancer and it maps it to your web servers. You could protect your web servers, but we're just going to leave it as it is. Now we want to add the subnets, so we're going to add both of our public subnets, and that warning's now gone, so now we're good. We have 2 subnets in 2 availability zones. Next we assign security groups. So we could just use our existing web server security group because that has HTTP port 80 open. It also has HTTPS open and SSH. So it's probably good practice to create a new security group just for our load balancer. So we'll call it Simplilearn Load Balancer SG. And we're simply going to have HTTP port 80 open from anywhere and nothing else. And we should probably just give it a quick description so we know what it is. Security group for load balancing. Okay, so let's click Next, Configure Security Settings. And it's just telling us that our load balance security isn't using a secure listener because we're not using HTTPS or SSL, which is fine for this demonstration. Next, we configure the health check. So this is the check that the load balancer is going to perform to see if our instances are healthy. So it's using HTTP port 80, and it's going to look for existence of a file. So we're going to tell it to look for our healthcheck.html file. And if that doesn't exist, then the instance isn't healthy. Now we can configure some more details. So the response timeout is 5 seconds. We'll leave that. The interval between checks, the default value is 30. So let's bring that down because we want things to happen quicker. So that's 10 seconds. Unhealthy threshold is set to 2. So if it has 2 checks where it doesn't find the file, it's going to determine that the instance is unhealthy. And the healthy threshold is 10. We're also going to bring that down. We'll bring that down to 3. So after 3 consecutive healthy checks, it will say the instance is healthy. Okay, so now we can add our EC2 instances. So we'll add our 3 web servers. We've enabled cross-zone load balancing, so it can push traffic across both availability zones. And the connection draining setting we'll just leave as default. That's when it detects an unhealthy instance, that's how long before it will start redirecting traffic elsewhere. So next we'll click on Add Tags, so we can give this a more meaningful name. Simplilearn _ load balancer, and review and create. Okay, so we can review everything we did. We should be okay, so let's click create, and our load balancer is now being created. So let's have a look. So here it is. If we click on instances, you can see the instances, and it's saying they're all out of service at the moment. So that's because it's just configuring itself, and it will take a while to come up. So I'm going to pause the demonstration and we'll come back when everything's up and running. Okay, so the load balancer has configured, and you can see that 2 of our 3 web servers are in service, but our 3rd web server is out of service. So why do you think this is? Well, I'll tell you why. It's because our new web server, Simplilearn Web Server 3, has just come up and we haven't done anything to it other than just launch the AMI. So let's go and check out what's going on the instance. So I've opened sessions to our 3 web servers here, and this is the new one, and it's because the Apache service isn't started by default. So we need to start the Apache service. Okay, so we get that weird error, but it tells me it's okay. So if we now go back to the load balancer and we wait a few seconds, we should see the Simplilearn web server number 3 come online. There you are, so now we're online. So it was as simple as just starting the service. So that shows how load balancing works.
Today, I'm joined by 2 giants of the cloud computing industry. They'll be going head to head with each other to decide who amongst them is better. It's going to be one hell of a fight. Now, let's meet our candidates. On my left, we have AWS, who's voiced by Apeksha.
Hi guys.
And on my right, we have Microsoft Azure, who's voiced by Anjali.
Hey there.
So today, we'll be deciding who's better on the basis of their origin and the features they provide, their performance in the present day, and comparing them on the basis of pricing, market share and options, free tier, and instance configuration. Now, let's listen to their opening statements. Let's start with AWS.
Launched in 2006, AWS is one of the most commonly used cloud computing platforms across the world. Companies like Adobe, Netflix, Airbnb, HTC, Pinterest, and Spotify have put their faith in AWS for their proper functioning. It also dominates the cloud computing domain with almost 40% of the entire market share. So far, nobody's even gotten close to beating that number. AWS also provides a wide range of services that covers a great number of domains. Domains like compute, networking, storage, migration, and so much more.
Now, let's see what Azure has to say about that.
Azure was launched in 2010 and is trusted by almost 80% of all Fortune 500 companies. The best of the best companies in the world choose to work only with Azure. Azure also provides its services to more regions than any other cloud service provider in the world. Azure covers 42 regions already, and 12 more are being planned to be made. Azure also provides more than 100 services spanning a variety of domains.
Now that the opening statements are done, let's have a look at the current market status of each of our competitors. This is the performance round. Here we have the stats for the market share of AWS, Azure, and other cloud service providers. This is for the early 2018 period. Amazon Web Services takes up a whopping 40% of the market share, closely followed by Azure at 30% and other cloud services adding 30%.
This 40% indicates most organizations' clear interest in using AWS. We are number one because of our years of experience and trust we've created among our users.
Sure, you're the market leader, but we are not very far behind. Let me remind you, more than 80% of the Fortune 500 companies trust Azure with their cloud computing needs. So it's only a matter of time before Azure takes the lead.
The rest of the 30% that is in AWS or Azure accounts to the other cloud service providers like Google Cloud Platform, Rackspace, IBM SoftLayer, and so on. Now for our next round, the comparison round. First, we'll be comparing pricing. We'll be looking at the cost of a very basic instance, which is a virtual machine of 2 virtual CPUs and 8 GBs of RAM. For AWS, this will cost you approximately $0.0928 per hour. And for the same instance in Azure, it'll cost you approximately $0.096 per hour. Next up, let's compare market share and options.
As I mentioned before, AWS is the undisputed market leader when it comes to the cloud computing domain, taking up 40% of the market share. By 2020, AWS is also expected to produce twice its current revenue, which comes close to $44 billion. Not to mention, AWS is constantly expanding its already strong roster of more than 100 services to fulfill the shifting business requirements of organizations.
All that is great, really, good for you. But the research company Gartner has released a magic quadrant that you have to see. You see, the competition is now neck to neck between Azure and AWS. It's only a matter of time before Azure can increase from its 30% market share and surpass AWS. This becomes more likely considering how all companies are migrating from AWS to Azure to help satisfy their business needs. Azure is not far behind AWS when this comes to services as well. Azure's service offerings are constantly updated and improved on to help users satisfy their cloud computing requirements.
Now, let's compare AWS and Azure's free offerings.
AWS provides a significant number of its services for free, helping users get hands-on experience with the platform, products, and services. The free tier services fall under 2 categories: services that will remain free forever and the others that are valid only for 1 year. The always free category offers more than 20 services, for example Amazon SNS, SQS, CloudWatch, etc. And the valid for a year category offers approximately 20 services, for example Amazon S3, EC2, Elastic Cache, etc. Both types of services have limits on their usage, for example storage, number of requests, compute time, etc. But users are only charged for using services that fall under the valid for a year category after a year of their usage.
Azure provides a free tier as well. It also provides services that belong to the categories of free for a year and always free. There are about 25 plus always free services provided by Azure. These include App Service, Functions, Container Service, Active Directory, and lots more. And as of the valid for a year, there are 8 services offered. There's Linux or Windows virtual machines, blob storage, SQL database, and few more. Azure also provides the users with credits of $200 to access all their services for 30 days. Now this is a unique feature that Azure provides, where its users can use their credits to utilize any service of a choice for the entire month.
Now let's compare instance configuration. The largest instance that AWS offers is that of a whopping 256 GBs of RAM and 16 virtual CPUs. The largest that Azure offers isn't very far behind either, 224 GBs of RAM and 16 virtual CPUs. And now for the final round. Now each of our contestants will be shown facts and they have to give explanations for these facts. We call it the rapid fire round. First, we have features in which AWS is good and Azure is better.
AWS does not cut down on the features it offers its users. However, it requires slightly more management on the user's part.
Azure goes slightly deeper with the services that fall under certain categories like Platform as a Service and Infrastructure as a Service.
Next, we have hybrid cloud, where AWS is good and Azure is better.
Okay, although AWS did not emphasize on hybrid cloud earlier, they are focusing more on technology now.
Azure has always emphasized on hybrid cloud and has features supporting it since the days of its inception.
For developers, AWS is better and Azure is good.
Of course it's better, because AWS supports integration with third-party applications.
Well, Azure provides access to data centers that provide a scalable architecture.
For pricing, both AWS and Azure are at the same level.
It's good for AWS because it provides a competitive and constantly decreasing pricing model.
And in the case of Azure, it provides offers that are constantly experimented upon to provide its users with the best experience.
And that's it. Our contestants have finished giving their statements. Now, let's see who won. Surprisingly, nobody. Each cloud computing platform has its own pros and cons. Choosing the right one is based entirely on your organization's requirements. We're going to talk about the best cloud computing platform available, Amazon Web Services.
Rahul, I think you said something wrong here. The best cloud computing platform is obviously Google Cloud Platform.
No, it isn't. AWS has more than 100 services that span a variety of domains.
Alright, but Google Cloud Platform has cheaper instances. What do you have to say about that?
Well, I guess there's only one place we can actually discuss this. A boxing ring.
So guys, I'm Apeksha and I will be Google Cloud Platform.
And I'm Rahul, I'll be AWS.
So welcome to Fight Night.
This is AWS versus GCP. The winner will be chosen on the basis of their origin and the features they provide, their performance in the present day, and comparing them on the basis of pricing, market share and options, the things they give you for free, and instance configuration. Now first let's talk about AWS. AWS was launched in 2004 and is a cloud service platform that helps businesses grow and scale by providing them services in a number of different domains. These domains include compute, database, storage, migration, networking, and so on. A very important aspect about AWS is its years of experience. Now, AWS has been in the market a lot longer than any other cloud service platform, which means they know how businesses work and how they can contribute to the business growing. Also, AWS has over $5.1 billion of revenue in the last quarter. This is a clear indication of how much faith and trust people have in AWS. They occupy more than 40% of the market, which is a significant chunk of the cloud computing market. They have at least 100 services that are available at the moment, which means just about every issue that you have can be solved with an AWS service.
Now that was great, but now can we talk about GCP? I hope you know that GCP was launched very recently in 2011 and it is already helping businesses significantly with a suite of intelligent, secure and flexible cloud computing services. It lets you build, deploy and scale applications, websites, services on the same infrastructure as Google. The intuitive user experience that GCP provides with dashboards, wizards is way better in all the aspects. GCP has just stepped in the market and it is already offering a modest number of services. And the number is rapidly increasing. And the cost for a CPU instance or regional storage that GCP provides is a whole lot cheaper. And you also get a multi-regional cloud storage. Now what do you have to say on that?
I'm so glad you asked. Let's look at present day. In fact, let's look at the cloud market share of the fourth quarter of 2017. This will tell you once and for all that AWS is the leader when it comes to cloud computing. Amazon Web Services contributes 47% of the market share. Others like Rackspace or Verizon Cloud contribute 36%, Microsoft Azure contributes 10%, the Google Cloud Platform contributes 4%, and IBM Software contributes 3%. 47% of the market share is contributed by AWS. Do you need me to convince you any more?
Wait. All that is fine, but we only started a few years back and have already grown so much in such a less span of time. Haven't you heard the latest news? Our revenue is already $1 billion per quarter. Wait for a few more years and the world shall see.
And AWS makes $5.3 billion per quarter. It's going to take a good long time before you can even get close to us.
Yes, we'll see.
Now, let's compare a few things. For starters, let's compare pricing. For AWS, a compute instance of 2 CPUs and 8 GB RAM costs approximately $68 US. Now, a compute instance is a virtual machine in which you can specify what operating system, RAM, or storage you want to have. For cloud storage, it costs 2.3 cents per GB per month with AWS.
You really want to do that? Because GCP wins this hands down. Let's take the same compute instance of 2 CPUs with 8 GB RAM. It will cost approximately $50 per month with GCP. And as per my calculations, that's a 25% annual cost reduction when compared to AWS. Talking about cloud storage costs, it is only 2 cents per GB per month with GCP. What else do you want me to say?
Let's talk about market share and options. Now, AWS is the current market leader when it comes to cloud computing. Now, as you remember, we contribute at least 47% of the entire market share. AWS also has at least 100 services available at the moment, which is a clear indication of how well AWS understands businesses and helps them grow.
Yeah, that's true, but you should also know that GCP is steadily growing. We have over 60 services that are up and running, as you can see here, and a lot more to come. It's only a matter of time when we will have as many services as you do. Many companies have already started adopting GCP as their cloud service provider.
Now, let's talk about things you get for free. With AWS, you get access to almost all the services for an entire year with usage limits. Now, these limits include an hourly or by-the-minute basis. For example, with Amazon EC2, you get 750 hours per month. You also have limits on the number of requests to services. For example, with AWS Lambda, requests per month. Now, after these limits are crossed, you get charged standard rates.
With GCP, you get access to all cloud platform products like Firebase, the Google Maps API, and so on. You also get $300 in credit to spend over a 12-month period on all the cloud platform products. And interestingly, after the free trial ends, you won't be charged unless you manually upgrade to a paid account. Now, there is also the always free version for which you will need an upgraded billing account. Here, you get to use a small instance for free and 5 GB of cloud storage. Any usage above this always free usage limits will be automatically billed at standard rates.
Now let's talk about how you can configure instances. With AWS, the largest instance that's offered is of 128 CPUs and 4 TBs of RAM. Now, other than the on-demand method like I mentioned before, you can also use spot instances. Now, these are for situations where your application is more fault tolerant and can handle an interruption. Now, you pay for the spot price, which is effective at a particular hour. Now, these spot prices do fluctuate but are adjusted over a period of time.
The largest instance offered with Google Cloud is 160 CPUs and 3.75 TBs RAM. Like spot instances of AWS, Google Cloud offers short-lived compute instances suitable for batch jobs and fault-tolerant workloads. They are called as preemptible instances. So these instances are available at 80% off on-demand price. Hence, they reduce your compute engine costs significantly. And unlike AWS, these come at a fixed price. Google Cloud Platform is a lot more flexible when it comes to instance configuration. You simply choose your CPU and RAM combination. Of course, you can even create your own instance types this way. Before we wrap it up, let's compare on some other things as well. Telemetry. It's a process of automatically collecting periodic measurements from remote devices. For example, GPS. GCP is obviously better because they have superior telemetry tools which help in analyzing services and providing more opportunities for improvement.
When it comes to application support, AWS is obviously better since they have years of experience under their belt. AWS provides the best support that can be given to the customers.
Containers are better with GCP. A container is a virtual process running in user space. As Kubernetes was originally developed by Google, GCP has full native support for the tool. Other cloud services are just fine-tuning a way to provide Kubernetes as a service. Also, the containers help with abstracting applications running. The applications can be deployed easily regardless of their environment.
When it comes to geographies, AWS is better since they have a head start of a few years. AWS in this span of time has been able to cover a larger market share and geographical locations. Now, it's time for the big decision. So, who's it going to be?
Yeah, who is it going to be? GCP or AWS?
I think I'm going to go for choosing the right cloud computing platform is a decision that's made on the basis of the user or the organization's requirement. On that note, I believe it's time for us to wrap this video up.
We hope you guys enjoyed this video and learned something new.
That AWS is better, right?
No, that choosing a platform entirely depends on you and your organization's requirement.
AWS, Azure and GCP are three of the world's largest cloud service providers. But how are they different from each other? Let's find out. Hey guys, I'm Rahul and I'll be representing Amazon Web Services.
I'm Chinmayi and I'll be representing Microsoft Azure.
And I'm Shruti and I'll be representing Google Cloud Platform.
Talking about market share, Amazon Web Services leads with around 32% of the worldwide public cloud share.
Azure owns up to 16% of the worldwide market share.
And GCP owns around 9% of the world's market share.
Let's talk about each of these service providers in detail. AWS provides services that enable users to create and deploy applications over the cloud. These services are accessible via the internet. AWS, being the oldest of the lot, was launched in the year 2006.
Azure, launched in 2010, is a computing platform that offers a wide range of services to build, manage, and deploy applications on the network using tools and frameworks.
Launched in the year 2008, GCP offers application development and integration services for its end users. In addition to cloud management, it also offers services for big data, machine learning, and IoT.
Now let's talk about availability zones. These are isolated locations within data center regions from which public cloud services originate and operate. Talking about AWS, they have 69 availability zones within 22 geographical regions. This includes regions in the United States, South America, Europe, and Asia Pacific. They are also predicted to have 12 more additions in the future.
Azure, available in 140 countries, has over 54 regions worldwide grouped into 6 geographies. These geographical locations have more than 100 data centers.
GCP is available in 200 plus countries across the world. As of today, GCP is present in 61 zones and 20 regions, with Osaka and Zurich being the newly added regions.
Now let's talk about pricing. These services follow the pay-as-you-go approach. You pay only for the individual services you need for as long as you use them without requiring long-term contracts or complex licensing. Now on screen, you can see the pricing for each of these cloud service providers with respect to various instances like general purpose, compute optimized, memory optimized, and GPU. Now let's talk about the compute services offered. First off, we have virtual servers. For AWS, we have EC2. It is a web service which eliminates the need to invest in hardware so that you can develop and deploy applications in a faster manner. It provides virtual machines in which you can run your applications.
Azure's virtual machines is one of the several types of computing resources that Azure offers. Azure gives the user the flexibility to deploy and manage a virtual environment inside a virtual network.
GCP's VM service enables users to build, deploy, and manage virtual machines to run workloads on the cloud.
Now let's talk about the pricing of each of these services. AWS EC2 is free to try. It is packaged as part of AWS's free tier that lasts for 12 months and provides 750 hours per month of both Linux and Windows virtual machines.
Azure Virtual Machine Service is a part of the free tier that offers this service for about 750 hours per month for a year. The user gets access to Windows and Linux virtual machines.
GCP's VM service is a part of a free tier that includes micro-instance per month for up to 12 months.
Now let's talk about Platform as a Service or PaaS services. For AWS, Elastic Beanstalk is an easy-to-use service for deploying and scaling web applications and services developed with Java, .NET, Node.js, Python, and much more. It is used for maintaining capacity, provisioning, load balancing, auto-scaling, and application health monitoring.
The PaaS backbone utilizes virtualization techniques where the virtual machine is independent of the actual hardware that hosts it. Hence, the user can write application code without worrying about the underlying hardware.
Google App Engine is a cloud computing platform as a service which is used by developers for hosting and building apps in Google data centers. The App Engine requires the apps to be written in Java or Python and store data in Google Bigtable and use the Google query language for this.
Next, let's talk about virtual private server services. AWS provides Lightsail. It provides everything you need to build an application or a website along with the cost-effective monthly plan and minimum number of configurations.
In simple words, VM Image is a more comprehensive image for Microsoft Azure virtual machines. It helps the user create many identical virtual machines in a matter of minutes.
Unfortunately, GCP does not offer any similar service.
Next up, we have serverless computing services. AWS has Lambda. It is a serverless compute service that lets you run your code without facilitating and managing servers. You only pay for the compute time you use. It is used to execute backend code and scales automatically when required.
Azure Functions is a serverless compute service that lets you run event-triggered code without having to explicitly provision or manage infrastructure. This allows the users to build applications using serverless simple functions with the programming language of their choice.
GCP Cloud Functions make it easy for developers to run and scale code in the cloud and build event-driven serverless applications. It is highly available and fault-tolerant.
Now let's talk about storage services offered by each of these service providers. First off, we have object storage. AWS provides S3. It is an object storage that provides industry standard scalability, data availability, and performance. It is extremely durable and can be used for storing as well as recovering information or data from anywhere over the internet.
Blob storage is an Azure feature that lets developers store unstructured data in Microsoft's cloud platform. Along with storage, it also offers scalability. It stores the data in the form of tiers depending on how often data is being accessed.
Google Cloud Storage is an online storage web service for storing and accessing data on Google Cloud Platform infrastructure. Unlike the Google Drive, Google Cloud Storage is more suitable for enterprises. It also stores objects that are organized into buckets.
Amazon provides EBS or Elastic Block Store. It provides high-performance block storage and is used along with EC2 instances for workloads that are transaction or throughput intensive.
Azure Managed Disk is a virtual hard disk. You can think of it like a physical disk in an on-premises server but virtualized. These managed disks allow the users to create up to 10,000 VM disks in a single subscription.
Persistent storage is a data storage device that retains data after power to the device is shut off. Google Persistent Disk is durable and high-performance block storage for GCP. Persistent Disk provides storage which can be attached to instances running in either Google Compute Engine or Kubernetes Engine.
Next up, we have disaster recovery services. AWS provides a cloud-based recovery service that ensures that your IT infrastructure and data are recovered while minimizing the amount of downtime that could be experienced.
Site recovery helps ensure business continuity by keeping business apps and workloads running during outages. It allows recovery by orchestrating and automating the replication process of Azure virtual machines between regions.
Unfortunately, GCP has no disaster recovery service.
Next, let's talk about database services. First off, for AWS, we have RDS or Relational Database Service. It is a web service that's cost-effective and automates administration tasks. Basically, it simplifies the setup, operation, and scaling of a relational database.
Microsoft Azure SQL Database is a software as a service platform that includes built-in intelligence that learns app patterns and adapts to maximize performance, reliability, and data protection. It also eases the migration of SQL Server databases without changing the user's applications.
Cloud SQL is a fully managed database service which is easy to set up, maintain, and administer relational PostgreSQL, MySQL, and SQL Server databases in the cloud. Hosted on GCP, Cloud SQL provides a database infrastructure for applications running anywhere.
Next, we have NoSQL database services. AWS provides DynamoDB, which is a managed, durable database that provides security, backup and restore, and in-memory caching for applications. It is well known for its low latency and scalable performance.
Azure Cosmos DB is Microsoft's globally distributed multi-model database service. It natively supports NoSQL created for low latency and scalable applications.
GCP Cloud Data Store is a NoSQL database service offered by Google on the GCP. It handles replication and scales automatically to your application's load. With Cloud Data Store's interface, data can easily be accessed by any deployment target.
Now let's talk about the key cloud tools for each of these service providers. For AWS, in networking and content delivery, we have AWS Route 53 and AWS CloudFront. For management, we have AWS CloudWatch and AWS CloudFormation. For development, we have AWS CodeStart and AWS CodeBuild. For security, we have IAM and Key Management Service.
For Microsoft Azure, networking and content delivery, we have Content Delivery Network and ExpressRoute. For management tools, we have Azure Advisor and Network Watcher. For development tools, for management, we have Azure Advisor and Network Watcher. For development, we have Visual Studio IDE and Azure Blob Studio. For security, we have Azure Security Center and Azure Active Directory.
For GCP, we have the following tools. For networking and content delivery, we have Cloud CDN and Cloud DNS. For management, we have Stackdriver and GCP monitoring. For development, we have Cloud Build and Cloud SDK. And finally, for security, we have Google Cloud IAM and Google and Cloud Security Scanner.
Now let's talk about the companies using these cloud providers. For AWS, we have Netflix, Unilever, Kellogg's, NASA, Nokia, and Adobe.
Pixar, Samsung, eBay, Fujitsu, EMC, and BMW, among others, use Microsoft Azure.
So as seen on your screens, the companies that use GCP are Spotify, HSBC, Snapchat, Twitter, PayPal, and 20th Century Fox.
Let's talk about the advantages of each of these services. Amazon provides enterprise-friendly services. You can leverage Amazon's 15 years of experience delivering large-scale global infrastructure, and it still continues to hone and innovate its infrastructure management skills and capabilities. Secondly, it provides instant access to resources. AWS is designed to allow application providers, ISVs, and vendors to quickly and securely host your applications, whether an existing application or a new SaaS-based application. Speed and agility. AWS provides you access to its services within minutes. All you need to select is what you require and you can proceed. You can access each of these applications anytime you need them. And finally, it's secure and reliable. Amazon enables you to innovate and scale your application in a secure environment. It secures and hardens your infrastructure. More importantly, it provides security at a cheaper cost than on-premise environments.
Now talking about some of the advantages of Azure. Microsoft Azure offers better development operations. It also provides strong security profile. Azure has a strong focus on security, following the standard security model of detect, assess, diagnose, stabilize, and close. Azure also provides a cost-effective solution. The cloud environment allows businesses to launch both customer applications and internal apps in the cloud, which saves on IT infrastructure costs. Hence, it's OpEx friendly.
Let's now look at the advantages of GCP. Google bills in minute-level increments, so you only pay for the compute time you use. They also provide discounted prices for long-running workloads. For example, you use the VM for a month and get a discount. GCP also provides live migration of virtual machines. Live migration is the process of moving a running VM from one physical server to another without disrupting its availability to the users. This is a very important differentiator for Google Cloud compared to other cloud providers. GCP provides automatic scalability. This allows a site's container scale to as many CPUs as needed. Google Cloud Storage is designed for 99.9% durability. It creates server backup and stores them in a user-configured location.
Let's talk about the disadvantages of each of these services. For AWS, there's a limitation of the EC2 service. AWS provides limitations on resources that vary from region to region. There may be a limit to the number of instances that can be created. However, you can request for these limits to be increased. Secondly, they have a technical support fee. AWS charges you for immediate support, and you can opt for any of these packages. Developer, which costs $29 per month, Business, which costs more than $100, and Enterprise, that costs more than $15,000. It has certain network connectivity issues. It also has general issues when you move to the cloud, like downtime, limited control, backup protection, and so on. However, most of these are temporary issues and can be handled over time.
Talking about some of the disadvantages of Microsoft Azure. Codebase is different when working offline and it requires modification when working on the cloud. PaaS ecosystem is not as efficient as IaaS. Azure Management Console is frustrating to work with. It is slow to respond and update and requires far too many clicks to achieve simple tasks. Azure Backup is intended for backing up and restoring data located on your on-premises servers to the cloud. That's a great feature, but it's not really useful for doing bare metal restores of servers in a remote data center.
Let's now look into the disadvantages of GCP. So when it comes to cloud providers, the support fee is very minimal, but in the case of GCP, it is quite costly. It is around $150 per month for the most basic service. Similar to AWS S3, GCP has a complex pricing schema. Also, it is not very budget friendly when it comes to downloading data from Google Cloud Storage.
Kubernetes specific to AWS Cloud Platform. So what's a part of this tutorial and demo? What's in store for you? At our offset, I would like to cover the basics of orchestration tools. As most of you would know, Kubernetes is one of the most popular orchestration tools in recent times, specifically for applications which are cloud native and deployed on some or the other types of containers. But what are these orchestration tools? Why would one need to use orchestration tools? What are the facilities or features provided by these orchestration tools? That's the first thing that I'm going to cover. After that, I will pick two orchestration tools specific to container management, Docker Swarm versus Kubernetes. I'm going to compare them with regard to the features that they provide, the use cases that they cover, what facilities that they provide, and when to use what. After that, I will get into a little bit details of the Kubernetes architecture, what exactly is required for setting up a Kubernetes cluster, what runs in a control plane or a master node, what runs as a part of the worker node. After that, I will end the tutorial by running you through a demo by setting up a 3-node Kubernetes cluster on AWS platform. I will use something called as KOPS, which is one of the admin tools for setting up production grade Kubernetes cluster. So I will use this to set up a 3-node cluster on AWS. Alright, now that we set the context right, let me get started. So what are orchestration tools? The application development and the lifecycle management from the time the application is developed, connecting the source code to your continuous integration, to testing them all along your development process, and eventually moving it down to production, managing your production servers, the dependencies that your software has, the requirement that it has in terms of the hardware, the features of fault tolerance, self-healing capabilities, auto-scaling, all this has complicated over the last few years. As a part of DevOps, one thing that everyone is interested in is managing all this application dependency or lifecycle management using some or the other kind of a tool. So that's where these orchestration tools have become very, very popular. So what kind of features that they provide is you'll have to just let them know what are the kinds of tool sets that is required, what are the fault tolerance mechanisms that it has to be adopted to, what kind of a self-healing capabilities that the application will have to need, and if at all there is any auto-scaling features that is required. If at all you can bake in all these specific parameters into your tool, your orchestration tool becomes a one-stop shop for all your deployment and configuration management needs. That's where these orchestration tools have become a very, very popular and relevant, specifically these days when people are more and more interested in adopting DevOps practices. Alright, so having said that about orchestration tools, let's concentrate on two of these orchestration tools specifically for container management: Docker, Swarm, and Kubernetes. Many of the applications that are written for these kind of containers are called or kind of fall into a category of cloud native, where the application need not know much about the underlying infrastructure or the platform where these applications are running. So these two, along with Apache Mesos, there are many other container management systems, but I'm going to pick Docker, Swarm, and Kubernetes for comparing the features that is provided by these two frameworks. For the sake of comparison, I picked up Docker, Swarm, and Kubernetes just because of the reason that both of them operate in the space of container management. They do something very, very similar to containers. That's the similarity that exists between these two orchestration tools. However, there's a big difference that exists when it comes to the types of containers that both of them cater to, and also the capacity of workloads they can be used for. Docker Swarm is a cluster management solution that is provided by Docker Container. Docker is one of the very, very popular containers of recent times, and in case you have your applications that is totally powered by only Docker containers, if you have a need where you want to run a cluster of servers which are running only Docker containers, Docker Swarm should be your choice for your orchestration tool. Kubernetes, on the other hand, can cater to any other types of containers other than Docker, and including Docker as well. So in case you have your applications which have got Docker in them, which have got RKT in them, which they have got LX in them, or any other type of container, Kubernetes should be your choice of orchestration tool. A Docker Swarm can manage up to 40, 50, or 60 max nodes. So in case your application is totally written in Docker containers and the load or the expected cluster size is about 50-60 nodes, Docker Swarm should be your choice of orchestration tool. On the other hand, Kubernetes is something that was open sourced by Google, and the scale of operations that Kubernetes can cater to is Google scale. So if in case your applications are more than 1,000 nodes, that is where Kubernetes comes into play. That's the big difference that exists between Docker Swarm and Kubernetes. Putting those differences aside, let me compare Docker Swarm and Kubernetes based upon other features which are similar in nature. The first and important feature that Kubernetes provides is something called as auto-scaling. If at all the load on your cluster is too high and your application is experiencing more load, so Kubernetes can add new nodes to your cluster. Of course, you'll have to configure Kubernetes in order to have those capabilities where it can spin up new VMs or new nodes. If at all you do that configuration correctly, Kubernetes has got the capacity, or it has got the feature where it can bring up a new node and add it to the cluster on the fly based upon the load that exists at that moment. On similar lines, if at all the load is not too high, it can identify a few of those nodes which have got less number of replicas or less number of application containers running on it. It can move them to some other node and also scale down by deleting few nodes from your cluster. So that is the powerfulness of auto-scaling which is provided by Kubernetes, and this unfortunately does not exist in Docker swarm. The other feature of load balancing, specifically application load balancing. So Docker Swarm gives you an application level auto load balancing. However, Kubernetes gives you the flexibility of manually configuring any other type of load balancer of your choice for application load balancing. Installation. As I mentioned earlier, Docker Swarm is a loose cluster of containers which are running on nodes. It is very easy to spin up a new node and then connect them to a swarm. And this can be done in a very loosely coupled way, where you can create swarms of your choice. Nodes are allowed to connect to swarms and quit or leave the swarms on the fly. So in and all, the installation is pretty easy and fast. Kubernetes, on the other hand, the configuration of Kubernetes, the way to spin up a big cluster specifying the size of the node, how many master nodes, how many config planes that you want, how many nodes that you want. It's a pretty tough thing to bring up a Kubernetes. Scalability. Kubernetes strength is very strong. They are very tightly coupled, and even they have the capability where on the cluster size, things or the nodes can be increased on the fly based upon the requirement. On a Docker Swarm, the cluster strength is weak as compared to Kubernetes. Worker nodes can be added to a swarm. Worker nodes can be asked to leave a swarm or can be taken out of a swarm based upon the requirement. So this is kind of a loosely coupled architecture for Docker Swarm, while Kubernetes, the cluster is very tightly coupled. Since Docker Swarm runs only Docker containers, containers find it very easy to share data and a lot of other things with each other because they all have the same signature. They are all from the same family. So it's very easy for them to share not just volumes, but a lot of other things. However, for Kubernetes, since it manages containers of different types, if your application has to share some data across different containers, there's a little bit of a complexity in how you would want your containers to share data. Also, when it comes to Kubernetes, Kubernetes groups containers in something called as pods, while a pod can have either one container, that's the preferred choice, or multiple containers. And the idea of pod is like each pod can run in any other node. It's not guaranteed that you would want to have 2 or 3 pods to be running on the same node. That makes data sharing a little bit of a different thing compared to Docker Swarm. GUI. So there's not a good enough UI tool in Docker Swarm, at least the CE edition of it, which will allow you to get to know what is running on your containers, what is the size of the containers, what is the volume of the containers, and all that stuff. There are some free and open source tools like Portainer, which gives you a good visibility into your running Docker containers. However, there's nothing at a swarm level that is provided by Docker. Kubernetes gives you an out-of-the-box dashboard, which is easy to configure and set up. You can also club it with some metrics services, and you can also get information about the size of the cluster that is running, what is the load on the nodes, and stuff like that. All this across your cluster in a very beautiful dashboard perspective. So that way, this is a little bit of a good UI for Kubernetes, while for Docker Swarm, there isn't anything that is provided out of the box. Let me spend some time in explaining a little bit about the Kubernetes architecture, what comprises of the Kubernetes cluster, what resides in a master or a control plane, and what resides in a worker node. This is a very high level depiction of a Kubernetes cluster. So this is the master node, which has got something called as a cluster store, a controller, a scheduler component, and an API server. And these are the bunch of nodes that are connected or administered by the master node. The master node can be 1, 3, 5, typically an odd number. This is as per the typical cluster management thing, where you would need the master nodes to be in odd numbers so that whenever there's any contention in terms of what needs to be deployed where or where to give the job to whom and stuff like that, all the masters would cast their vote and they would decide on the outcome. So that's the master node, and there are a bunch of nodes which can be connected and administered by the master node. kubectl, or the command from using which anybody can assign some workloads to the cluster, can also be run either on the same node or on a separate node. So kubectl is the command line tool that we will be installing and using in order to fire up our commands to our cluster. So if at all I have to put up a job on our cluster, if I have to give out any specific commands to my cluster, all this is done using kubectl. There's a bunch of REST APIs which is used by kubectl, and kubectl will talk to the API server and fire up the commands specific to my cluster. what runs in the master node? Master node, without saying, it's the most important component of any of the cluster. If at all you're running cluster with only one master node, if your master node goes down, there's no other way that you can, or any user can talk to the different nodes in the cluster. So master node is the most vital component responsible for the complete Kubernetes cluster. There's always one node that should be running as a master node. That's the bare minimal requirement for your cluster. So what are the other components in the master node? The most important one is called etcd. So this is nothing but a data store, a value of key value pair, which is stored, which contains all information about your cluster. So all the configuration details, which node is up, which worker node is down, all this information is stored in the cluster store. So all the managers would access this cluster store before they go ahead and decide any other work item or anything else that has to be done specific to your cluster. What's in the controller? As the name says, controller is something, it's like a daemon server that is running in a continuous loop. All the time it is responsible for controlling the set of replicas, the kind of workloads that is running based upon the configuration that the user has set in. So if at all, if you are aware of something called as replication controllers, endpoint controllers, namespace controllers, all these controllers are managed by the controller component. If any user asked for some 3 replicas of a particular pod or a service to be running, and if at all any of the nodes goes down or the pod goes down for whatever reason, the controller is the one who wakes up and assigns this particular job or the pod to some other available node by looking up for the details using in the cluster store. That's the importance of the control manager or the controller. The scheduler assigns the tasks based upon whoever is asked for any job to be scheduled based upon a time frame or based upon some criteria. It also tracks the working load as to what exactly is the load, who is running what in the cluster, and places the workload on whoever is the available resource at that time. Alright, API server. This is one other important component in our Kubernetes cluster, where how would the end user deploy or give out any sort of a workload onto your cluster? All the requests come to the API server. So this is an entry point for all your requests that come into your cluster. Anybody wants to deploy something, anybody wants to scale up a controller, anybody wants to bring down few services, anybody wants to put in a service, all this will have to come in as a part of a REST API endpoint. And API server is the entry point. In case you don't want somebody to access your cluster, in case you want only specific people or specific users to be running some specific workloads, you can set all those role-based access control for this API server. So this is the entry point for anyone who wants to submit any job to your cluster. So that's a quick overview about the master node. What are the important components of a master node? Now let's go over to what runs in a worker or a slave node. As I mentioned earlier, slave nodes are something where the job that is submitted to your cluster is eventually run as a pod, as a service, as a container. So in Kubernetes world, there is something called as a pod. A pod is nothing but a combination of a container. It is a wrapper around your running containers. So slave nodes or the worker nodes typically run these pods. So that is where the whole workload typically gets run. But there are a bunch of other components in the node which also manages what runs in the pod, who has to have access to the pod, what is the state of the pod, is it in a running state, is it going down for some reason, and all that stuff. So let's quickly go over those components that is there in the slave node. The most important component, in my opinion, that should be on the node should be the container runtime. As I mentioned earlier, Kubernetes can run any different types of containers, not just Docker. So in case you want to have a node which wants to have Docker running on it, RKT running on it, LKC running on it, or any other container environment that is running on it, you have to ensure that the specific container runtime environment is available on that specific node, so that whenever a job is submitted, a description of what needs to be run as a part of the pod, what should be the image with which it should be powered, and what kind of a container to spin up. So that's what, when the job is finally assigned to this particular node, it would definitely need a container runtime to be up and running. So that exists only if at all the container runtime is installed and running on your Kubernetes worker node. Okay, now that we know what our Kubernetes node can run, how would somebody assign a job to our node? That is using something called as a kubelet. As the name says, kubelet is a small subset which talks to the kube API server. So any node which has to run any kind of a pod, all these instructions are passed around by the kube API server to the kubelet, and kubelet is capable of processing whatever job that is assigned to it and ensuring that so many pods and so many services are spun up based upon the requirement. The last component that exists in the worker node is the kube proxy or Kubernetes proxy. This plays a very, very important role, acting as a load balancer and a network proxy. So what typically happens is whenever the pods are running in nodes, the pods can be typically running in any node. There is no affinity towards any node on which these pods are running, because pods or containers are something called as ephemeral. They can run anywhere. So how would somebody reach out to these applications that is running in some pod which is running in one container now and running in probably another container, another node altogether tomorrow? So that is where your Kubernetes proxy comes into picture, and this component will ensure that any container that is spun up or any pod that is spun up, it keeps track of all these pods and kind of connects the endpoints or acts like a DNS server, so that it knows when somebody is trying to reach out to this particular service, which is the pod on which the service is typically running. So that plays a very, very important role by acting as a load balancer and a network proxy. Now that at a very high level we know what are all the components that make up of our Kubernetes cluster, let's go ahead and create a small cluster. We'll spin up this cluster on AWS platform. Finally, we get to the demo section of my tutorial. Now that you guys are aware as to what is Kubernetes, what is the use of Kubernetes, you also know at a very, very high level what are the components of a cluster. What is a master node or a control plane? What are the components of a master node and what should be existing in a worker node? You're probably thinking that it's maybe pretty hard to kind of set this up. So let me demystify that by running you with a quick demo of how to set up a simple 3-node Kubernetes cluster using a tool called kops. And I will be doing this whole setup on my AWS Cloud. Okay, so what is kops? Kops is nothing but a simple tool. This is an admin tool that allows you to bring up production grade Kubernetes environments. As I said, setting up a Kubernetes cluster on a bare metal is a little challenging. So that is why I would use something called as a kops, and I will use this on my cluster which I will spin up on my AWS instance. So I have an AWS account, and what I will do first is I will first spin up an EC2 server. I will power this with one of the Linux AMIs, and I will install kops on it. Now this will be my starting point from where I'm going to trigger running up a big cluster. In our case, I'll try to keep it a little small. I don't want too many nodes in my cluster. I'm going to have one master node and 2 worker nodes. This whole operation would be done programmatically by installing this kops admin tool. So as you may know, AWS, it's a little hard for me to programmatically run other components or rather bring up servers. It's not pretty simple. So what I would do is I will create an IAM role which will attach to my EC2 server, so that my EC2 server gets powered with all the required role, so that it can go ahead and spin up cluster based upon my configuration that I'm going to specify. Alright, so once I have my cluster set up, I will also install kubectl, which you would probably know by now is nothing but a command line utility using which I can kind of connect to my cluster, give out some jobs, put some pods and stuff like that. So I will use kubectl. I will also have a pair of SSH keys so that from this machine, I would be able to successfully get onto the master node and submit jobs on my behalf. So let me begin by first logging into my AWS account. All the steps that I will be following to bring up my AWS cluster, Kubernetes cluster, will be documented, and I'll be sharing you this document in a GitHub repository, so that in case anybody wants to try, you'll be more than happy to find all the required instructions in one place. Okay, now the first thing that I would need is to launch an AWS EC2 instance. Now this is an instance where I'm going to install kops and I will use it as a base server from where I'm going to fire some commands which will bring up my Kubernetes cluster. So let me log into my AWS account and let me stick to one particular region and let me bring up one EC2 instance. Alright, so let me launch my instance. Let me choose, doesn't matter either ways, but in case you want to try it on your free tier, I would recommend choose free tier only and choose an AMI of your choice. Let me choose this instance. I will make it T2 micro. That is good for me. Configuration, instance details. All right. I don't want to change anything here. That looks good. Maybe I will change this 30 gig. That's good for me. Let me add a tag to my instance. I will name this as my kops server. Alright, I would need a bunch of ports to be opened up. So what I will do is I will create a new security group called Open to the World. I would not recommend that you do this since I don't want to. It will take a long time for me to specifically pick and choose the ports that has to be open for running my cluster. I don't want to do that. I will open up all the HTTP and HTTPS ports so that it's quicker. So I will say all TCP. I would say from anywhere, just to be on the safer side. I also open HTTP and HTTPS, and I will make this anywhere and anywhere. This is good for me. I will say review and launch. Alright, so I chose a T2 micro instance. Just for the sake of easiness, I've opened up all the ports, and the instance details are, you've seen what is that I've chosen. Alright, now important part is like I would need a key pair. I need to create a new key pair. I will call this as Simplilearn keys. I will download this key pair and then I will launch the instance. It will take some time for my EC2 instance to come up. In the meanwhile, what I'll do is I will convert. I have this PEM file, which is the pair of keys, the SSH keys with which I need to log into my EC2 instance. So I'll need to convert this because I'm trying to connect from a Windows box. I would need to convert this into a PPK file. So I have puttigen. I'm going to load my set of keys here and convert that key into a PPK key. All right, open. All right, I would say save. Hang on, save private key. Yes, I would say Simplilearn or Simplilearn private key. I will save this here. Done that. That's all. So this is my public key, which is the PEM file, and this is my PPK or my private key. Now using the private key, I will log into my EC2 instance. Okay, now my EC2 instance is up and running. It is running in this Ohio region, and this is the IP address of my public IP address of my machine. So let me connect to it. So I use MOBA Xterm, which is nothing but an SSH emulator. You can use PuTTY or any of these sessions which allow you to do an SSH. This is my IP address of my machine, and since I've spun up an Amazon AMI, this is the default user. I would need to specify the private keys for my session, and this is the private key for my session. Say OK. I am in my Amazon EC2 instance. So let me look at what are the other things that I need to do. Alright, so as I said, I just brought up my EC2 instance, but I would need my EC2 instance to run few things on my behalf so that it can spin up other EC2 instances. It can also talk to an S3 bucket where I'm going to store the instance state of my Kubernetes cluster. Also some sort of an auto-scaling group because I want to spin up more and more instances. I also want to have a private hosted zone using my Route 53. So I would need my EC2 instance to have all these sort of permissions for my server. So what I would do is I will go and create a permission, a role in the EC2, or rather in the AWS IAM role, and I will attach this IAM role to my EC2 instance. Alright, so let me go to my IAM, which is nothing but the identity and access management. I will create a role called as possibly kops role. I will create a role. This role will be used by my EC2. So I'm going to click on EC2. I will say next permissions. They would need a lot of permissions, specific permissions to be very honest. And the permissions are all listed out here. S3, EC2 and all this stuff. Just to keep it pretty simple, what I would do is I will create a role with the administrative access. Alright, so I don't want any tags. I will review. I'll create a role name. I will say kops role for EC2. Alright, so I'm going to create a role which has got administrative access role. So I'm going to create a role So this would ensure that my EC2 instance from which I'm going to run my cluster would have all the prerequisite permissions so that it can go and spin up instances, talk to S3 buckets and all that stuff. All right, now let us have our running instance get powered by this role. So I will connect this role to my running instance. All right, so this is my EC2 instance that is running. I will say action, attach, replace IAM roles. So there is no role as of now. I would want my COPS role for EC2. This is the role that I created. So I want this new role to be assigned to my EC2. All right, great. Now my EC2 instance, which is my COPS server, has got all the required permissions so that he can create a cluster on my behalf. Great. Now before this, let me do a sudo yum update -y so that any of the, because this is a newly provisioned VM, I just want to ensure that all my system libraries are all updated so that when I do install COP and kubectl and all those things, none of them will fail because of some dependency or package issues. So I'm just running a sudo update -y so that all the libraries are updated. Okay, looks like it is done. So let me go ahead and install COPS. COPS is a pretty simple installation. It is available in a particular location. I have to just copy this and ensure that I do a curl and I install this particular stuff. All right, so it is fetching the COPS tool. It's installing for me. Once it is copied down, let me change the mode so that I can execute it, and then also let me move it to my user local bin so that it is available for me in my path. Okay, that's pretty much the COPS installation. Let me also do one other thing. Let me install something called as kubectl. So this is what would be, a tool using which I'm going to be firing my commands to my Kubernetes cluster once it comes up. Right, this is a pretty smaller executable. So kubectl. All right, so I have kubectl as well as COPS installed on my EC2 server now. Okay, now what I'll do next is I'm going to create an S3 bucket in AWS so that the Kubernetes cluster state is persisted in this bucket. So let me create a simple bucket with this name, S3 bucket with this name. So let me go to S3 and let me create a simple bucket with this name. I will just say create a bucket. Okay, so the Simplilearn.Kubernetes is the bucket that I created. So this bucket will store all information about my cluster. Let me now go and create a DNS entry or a DNS zone or a AWS Route 53 hosted zone for my cluster. So this is required so that I can give a cluster name for my Kubernetes cluster that I'm coming up. So I will create a private hosted zone and possibly I will call this as Simplilearn.in. So this will be my name of my private hosted zone. In case you already have any other public hosted zones in your name, you can always put a Route 53 hosted zone specific for your domain name. Since I don't have anyone, I'm just going to create a simple private hosted zone. So let me head down to Route 53, click on any of these and you'll get these hosted zones out here. So I'm going to create a hosted zone here. I'm going to create a hosted zone. Click on create hosted zone. This would be Simplilearn.in. I want to create a public. No, I don't want a public. I want a private hosted zone, and I'm going to associate my VPC ID for this hosted zone. Since I'm going to try out all my exercises in the Ohio region, I will associate the VPC of the Ohio region for this. Alright, so this is the one that is specific to the Ohio region. So I will say this one, I'll say create a hosted zone. Great. Now let me come back to my EC2 box. My EC2 is all powered with whatever it needs in order to go ahead with the installation of my cluster. Only a few things that I need to take care of is that, now that I put a name for my cluster, I also have an S3 bucket that I've configured for my cluster. I will have to ensure that I need to put in these two configurations as a part of my cluster building activity. So I will open my bash rc file and I'm going to export these two variables. If at all you remember well, these two variables are nothing but the cluster name, which is nothing but the the private hosted zone that I created, and the S3 bucket where I'm going to create, or rather I'm going to store my cluster state. So let me copy these two and open up my bash rc file. Alright, so I will just add these two and copy these and export them out as my variable. I'm going to save this here. Now let me ensure that this gets picked up. Alright, I've got these two that I've configured, and I've also ensured that these environment variables are set. Now let me create a pair of SSH keys. This is to ensure that I can log into the box that I'm going to be provisioning as a part of my cluster. SSH-keygen. I don't want to give any parameters. Let it go to the home directory with the default name and without any passphrase. Alright, so I created a bunch of my key pair. Now I'm all set to go ahead and run my kops. Now kops will ensure that this will take some time for the cluster to come up, but this is exactly how I would define my kops command. I already have it copied here. So kops create cluster. The state of the cluster will be stored in this particular variable, which is what I have exported out. The number of node count is 2. Node count is the worker node count. If at all I don't specify, there's a configuration for specifying the master or the control plane as well. If I don't specify that, the default one is 1. So I'm going to create one primary or the master node and two worker nodes. Size of my master, node size of the worker nodes, what are the zones where I want this to be created, and where do I store the cluster information. And okay, I've already added this master count. This is actually not required, but this is the command that I'm going to fire off so that I bring up my cluster. Alright, that went off very fast, but this actually did not create a cluster. It is just the definition of a cluster, and that's why this came out very fast. Now that everything looks good with whatever configuration that I specified, now let me go ahead and create the cluster by saying kops update cluster -a. Yes. Now this will take some time, a good 5 to 10 minutes for it to, because this will actually start provisioning the servers. And as I mentioned earlier, based upon my configuration, I'm going to come up with one master server and two nodes or the worker nodes. Alright, so this is the command for me to validate the cluster. And I'm going to try it out first. I'm pretty sure that it will fail because all my servers are not up yet. It is taking some time. The validation, everything failed. But let me try to look at my EC2 instances and see how many servers do I have running as of now. If you see, I had only one server that I had started, which was my COP server, and automatically the other three instances, one is called nodes.simply.in, these two are the nodes, and this is the master node. So these three got automatically provisioned by the kops command that I ran. Alright, so this may take a while for it to get validated, a good 5 to 10 minutes. So what I'll do is I'll pause the video now and I'll come back once the cluster is up and running. It's been a good 8 to 9 minutes since I started my cluster. So let me validate now. Okay, seems good. So there's a master node, minimum 1, max 1, some nodes which are nothing but the slave nodes or the worker nodes. There are two of them, T2 micro, subnet. So my clusters seem to be up and running, and my cluster name is Simplilearn.in. So what I would want to do is now let me just log into the master and see if I can run some pods. So let me get back to my installation steps here. The validation cluster is done. So let me log into since my cluster name is Simplilearn.in, this is the way to log into my box. So let me get into my box. So if you see here, this is the host name of the machine that I'm currently in. If you see this is nothing but this COP server. This is a server. Now from here, I'm trying to get into the master box. Alright, so if you see, the IP address has changed. I was in a different box. I'm in a different box now. If I see host name, you'll find a different host name. So this is 153, which is nothing but the master node. Yep, it's 153. This is the particular host. So I'm getting into this machine now. So I started the cluster from my COP server here. It ran and brought up 3 nodes. So I'm actually getting into my master node and see if I can run some pods on it. Alright, so let me try kubectl get cluster info. Try kubectl get nodes. Alright, so there are 3 nodes here, master node and one master node and 2 worker nodes. So let me see if I have some pods here. kubectl get pods. So there's no pod as of now. So what I'll try to do is let me just spin up a very simple pod just to check if my connections everything is correct or not correct. I have a simple Node.js application that I've built and I've got a container for that. This is already pushed to the Docker Hub registry. It is called Simplilearn Docker Hub, and the image name that I have here is called my node app. and I will use this image to power one of my pods that I will run. So this is the way in which I'm going to launch my pod. Let me show you these commands. kubectl run, the name for my deployment that I'm going to run, -- image, and this is the image that is going to be powering my container. So this is Simplilearn Docker Hub / my node app -- replicas equal to I want 2 replicas to be running, and the port that I want to expose this particular pod is on 8080. So let me run this. As soon as this is run, it creates something called as a deployment. Alright, now let me just say I'm not really interested in the deployment. I'm interested in checking if at all the pods are up and running. So I will say kubectl get pod. Alright, so that was pretty fast. So I have 2 pods that are running here. These are 2 replicas because I asked for 2 replicas. These pods are running, so I can run kubectl describe pod pickup. Alright, I can pick up any of the pod name and see what is the pod, what is the information does it contain, from what is the image that is pulling, what is the image name, ID. This is actually running my pod, which is actually spinning up a container. Great. So far so good. So in Kubernetes, the pods are ephemeral, so they can be there at any time, cannot be at any time. If I need to expose my pod outside, I will have to create a service for my pod. So what I'll do is I'll create a very simple service by exposing this particular deployment. Before that, let me check kubectl get deployment. So there's a deployment that is created. The deployment name is Simplilearn app. So I will expose my deployment Simplilearn app as I'll just expose this. Let me see. Alright, I'm not specifying what type and all. I don't want to get into the complications of what are the different types of exposing this service and all that stuff. So if I don't specify anything, it gives me something called a cluster IP. So this is where my pod is actually exposed. So let me just check if at all this pod is up and running. I'll just try a simple curl command. Curl http : this is my cluster IP, and the port is 8080. If at all I hit this, it's actually hitting my application and giving me whatever. I put a simple sys.out kind of a thing where I'm just printing the container ID of whatever pod is serving being served out of. So I'm actually hitting my container and I'm getting this output from the container. So everything looks good. My container is up and running. So let me just go and clean it up. I will say kubectl delete deployment Simplilearn app. This should get rid of all the pods that I created. kubectl get pod. Alright, these pods are interminating things. Let me just check kubectl get services. There's one service. I don't want this service. Let me delete that. kubectl delete service. I want this. Alright, that sounds good. So let me come back to my host, my COP server from where I'm running. So I managed to successfully verify this pod, see if everything is up and running. So what I'll do is I'll just go ahead and complete this demo by going and getting rid of my cluster. So cops delete cluster -es. Alright, so this will ensure that it will clean up my complete cluster that I created. So I had 3 or 4 running instances. If you see that, all the 3 are shutting down because the COP server, which had COPS installed on it, is now got a mandate to go ahead and shut down and clean up the whole instances and all those things that I've created as a part of my deployment.
In this video, you will get to know some interesting facts about AWS, get a brief overview about the course, and understand how the certification can help your career. Amazon Web Services provides a highly reliable, scalable, low-cost infrastructure platform in the cloud that powers hundreds of thousands of businesses in 190 countries around the world. The worldwide cloud computing market grew 28% in revenues in 2015, which is $110 billion, and the public cloud revenue is expected to grow to $167 billion by 2020. In a recent survey conducted by cloud management company RightScale to assess the challenges regarding cloud computing, 32% of the respondents cited lack of resources or expertise as the #1 challenge, against 29% citing security as the biggest challenge. The AWS certification holder takes home an average salary of $125,871, which is an increase from $114,935 last year. AWS Developer Associate is the perfect certification that proves your technical expertise in identifying appropriate AWS architecture and in designing, developing, and deploying optimum AWS cloud solutions. You'll enhance your existing knowledge of AWS so you can identify and deploy secure procedures for optimal cloud deployment and maintenance. You will learn how to develop and maintain applications written for S3, DynamoDB, SQS, SNS, SWS, AWS Elastic Beanstalk, and AWS CloudFormation. You will be able to identify and implement cloud security best practices. With the certification, you will be an asset to any organization, helping it to leverage the benefits of best practices around advanced cloud-based solutions and identify and implement the appropriate architecture for development, testing, and staging environments. Simplilearn's AWS Developer Associate Level course will help you understand the key concepts required to prepare for the certification exam. Before diving into the course details, let us get a glimpse of all the interesting ways you get to learn about AWS. Delve into the various AWS services. Work with AWS Management Console. Learn the CLI commands. Validate your knowledge. The practice assignments and the 3 live projects are included for you to gain hands-on experience with AWS Management Console and the CLI to become a domain expert in building, deploying, and managing systems in AWS. This course comprises 24 hours of instructor-led training, 15 hours of e-learning, and 3 hours of demonstrations to understand technical details associated with data management, networking, security, and more. You will also be provided with 3 question sets, totaling 180 questions to validate the depth of your knowledge. What are the prerequisites for this course? You should have attended AWS Essentials course or should have equivalent experience. You should have knowledge developing applications with API interfaces. You should have a basic understanding of relational and non-relational databases. And be familiar with messaging and queuing services.
In this video, you will get to know some of the interesting facts about AWS, get a brief overview about the course, and know how the certification can help your career. Amazon Web Services provides a highly reliable, scalable, low-cost infrastructure platform in the cloud that powers hundreds of thousands of businesses in 190 countries around the world. The worldwide cloud computing market grew 28% to $110 billion in revenues in 2015. In the first quarter of 2016, Amazon Web Services, or AWS, revenue was up by 58%. The certification holder takes home an average salary of $125,871, up from $114,935 last year. According to Forbes, there are over 18 million jobs in the field of cloud computing globally. AWS SysOps Administrator Associate is the perfect certification to prove your technical expertise in deploying, managing, and operating scalable, highly available, and fault-tolerant systems on AWS platform. You'll enhance your existing knowledge of AWS so you can select the appropriate products and tools to leverage AWS in the most efficient and cost-effective way. You'll learn how to implement and control the flow of data to and from AWS, and also be able to estimate AWS usage costs and identify operational cost control mechanisms. With the certification, you will be an asset to any organization, helping it to leverage the benefits of best practices around advanced cloud-based solutions and migrate on-premises applications to AWS. Simplilearn's AWS SysOps Administrator Associate Level course will help you understand the key concepts required to prepare for the certification exam. Before diving into the course details, let us get a glimpse of all the interesting ways you get to learn about AWS. Delve into the various AWS services. Work with AWS Management Console. Learn the CLI commands. Validate your knowledge. The practice assignments and the 3 live projects are included especially for you to gain hands-on experience with AWS Management Console and the CLI, to become a domain expert in building, Deploying and Managing Systems in AWS. This course comprises 24 hours of instructor-led training, 15 hours of e-learning, and 3 hours of demonstrations to understand technical details associated with data management, networking, security, and more. You will also be provided with 3 question sets, totaling 180 questions to validate the depth of your knowledge. Learning path. This certification also serves as a prerequisite for the AWS DevOps Engineer Professional Exam. Whether you are looking to future-proof your career or enhance your know-how about the leading cloud provider in the global market, becoming an AWS SysOps Administrator Associate will put you well on your way to achieving your career goals. You should ideally be an IT professional with experience in both traditional IT infrastructure and the AWS platform. You should have experience in everyday operations of a system administrator, which include deployment of the IT systems, backups, OS management, and have some experience with the AWS platform.
In today's era, many organizations run their software environments in the Amazon Web Services, AWS. And a lot of other companies are also migrating to AWS every day. Considering that if you're looking for an AWS job or planning to move to an AWS position in your current company, earning an AWS certification can be a brilliant investment. AWS, Amazon Web Service, is one of the leading platforms in cloud computing. Amazon Web Services was founded in the year 2006 and apparently it holds a market share of 31.7%. AWS provides approximately 175 fully featured services. It consists of significant benefits like compute, storage, databases, networking, analytics, robotics, machine learning, and artificial intelligence. In case you're wondering where do you begin, which AWS certification is the right choice for you, AWS provides 12 individual certifications spread across 4 different levels. Identifying where to start and which AWS certificate is the best choice for your job profile can be a little confusing at first. But once you find out what's the right choice, the path usually becomes pretty clear. As I already said, AWS provides 12 certifications: AWS Certified Cloud Practitioner, AWS Certified Developer Associate, AWS Certified SysOps Administrator Associate, AWS Certified Solutions Architect Associate, SaaCO2, AWS Certified DevOps Engineer Professional, AWS Certified Solutions Architect Professional, AWS Certified Advanced Networking Specialty, AWS Certified Security Specialty, AWS Certified Machine Learning Specialty, AWS Certified Database Specialty DBS C01, AWS Certified Data Analytics Specialty DAS C01, AWS Certified Alexa Skill Builder Specialty. You can get a complete understanding of all learning paths to prepare for the certifications on the Simplilearn AWS certifications page. Now, let us have a closer look at each certification. Let's start with the AWS Certified Solutions Architect. It is an associate exam designed for individuals who are willing to gain knowledge in designing applications. The associate certification focuses on the core AWS services like Identity and Access Management, Virtual Private Cloud, S3, and EC2. With this certification, a candidate will be able to design and deploy a cost-effective application on the AWS platform, move an existing on-premises application on the AWS platform, submit and retrieve data from the AWS platform, identify and define best practices for the implementation of AWS architecture, estimate AWS costs and identify cost control mechanisms. The fee for completing this certification is $150 and the average salary an AWS professionals earn after completing this certification is $130,883. Now, let's move ahead and know the eligibility criteria for this certification. Next, you should be able to identify and define requirements for an AWS-based application. AWS requires at least 1 year of deploying distributed systems at scale. Knowledge of at least one programming language is required. Proficiency in hybrid system deployment using AWS components is necessary. Provide best AWS service for architecture requirements. Next comes AWS Certified Solutions Architect for Professional. It was designed for experts who are willing to enhance their knowledge in designing distributed systems and applications on the AWS platform. With this certification, a candidate will be able to learn the process of designing and deploying a reliable and cost-effective application on the AWS platform. He will be able to provide appropriate AWS services to develop and deploy an application based on client requirements. Migrating an existing multi-tier and complex application on the AWS platform. He can design and deploy enterprise-level operations on AWS platform. Estimating AWS costs and identify the cost control mechanisms will become easier. The fee for completing this certification is $300 and the average salary an AWS professionals earn after completing this certification is $148,456. Now, let's look at the prerequisites for completing this certification. First is minimum 3 years of hands-on experience in designing and deployment of AWS Cloud architecture. Earlier, this AWS certification required completion of the AWS Certified Solutions Architect Associate certification exam. But since last year, this criterion is not required. However, if an individual doesn't have any experience in AWS, we recommend you to prepare for Solutions Architect Associate certification first. Next, the capability of identifying and assessing cloud requirements for designing an AWS application is required. Now, let's discuss AWS Certified Developer Certificate for Associate level. It was designed for beginners to enhance their skill in creating and maintaining AWS applications. With this certification, a candidate will be able to learn the development process of reliable and cost-effective cloud solution using AWS, choosing an appropriate AWS service for the application, gain knowledge of creating IAM credentials, IAM roles, etc. in the AWS services, developing code that optimizes the performance of AWS services used by your application. The fee for completing this certification is $150 and the average salary an AWS professional earn after completing the certification is $130,272. You should have a basic knowledge of AWS services, their uses, and best practices for the AWS architecture. To earn the salary as mentioned earlier, you must have at least 1 year of hands-on experience in the design and maintenance of AWS cloud applications. Knowledge of popular programming language is required. Experience with the development and maintenance of applications built for Amazon S3, DynamoDB, SQS, SNS, SWS, Elastic Beanstalk, and CloudFormation is important. You should be proficient in the design, development, and deployment of cloud-based applications using the AWS platform. Moving further, let's discuss AWS Certified DevOps Engineer Certification for Professionals. This certification is designed for enhancing knowledge in provisioning, management, security, and operations of AWS solutions. With this certification, a candidate will be able to understand, implement, and automate the security controls and compliance validations. implementation and management of methodologies on AWS and continuous delivery systems. Determine and deploy metrics. Also will be able to monitor and log systems on AWS. Implementation of highly available and robust systems on AWS platform. Automate the operational process with designing, management, and maintenance tools. The fee for completing this certification is $300 and the average salary an AWS professional earn after completing this certification is $1,37,724. The eligibility criteria required to complete this certification are minimum 2 years of practical knowledge in operating, provisioning, and managing applications in an AWS environment. Achievement of AWS Certified Developer Associate or AWS Certified SysOps Administrator Associate certification. Knowledge of other development methodologies and processes such as Agile. Experience in testing and automation via programming and scripting languages. Hands-on experience in code development for at least one high-level programming language. Next comes AWS Certified SysOps Administrator certification for the associate level. This certification is suitable for IT professionals interested in deploying, scaling, migrating, and managing AWS systems. This AWS exam tests your ability to deploy, manage, and operate fault-tolerant systems on AWS. Migration of an existing application on AWS. Recognizing and selecting the appropriate AWS service based on compute, data, or security requirements. Identifying and estimating the AWS usage costs and cost control mechanisms. The fee for completing this certification is $150 and the average salary an AWS professionals earn after completing the certification is $1,30,610. The eligibility criteria required to complete the certification are at least 1 year of hands-on experience in operating AWS-based applications, understanding of provisioning, operating, and maintaining AWS-based systems, identifying the challenges and implementing AWS best practices over the complete life cycle of a project, ability to identify and define a solution for AWS-based applications. Moving forward, let's discuss AWS Certified Big Data. This certification validates skills of technical expertise in designing and managing AWS solutions that can help organizations extract valuable insights from their data. This exam will teach you how to perform implementation of core AWS Big Data services with best architectural practices, simple techniques to design and maintain big data services, leverage tools to automate data analysis.
If getting your learning started is half the battle, what if you could do that for free? Visit Skill Up by Simplilearn. Click on the link in the description to know more.
The fee for completing this certification is $300 and the average salary an AWS professionals earn after completing the certification is $1,30,610. The eligibility criteria required to complete the certification are: first, you must have an AWS account to follow along with hands-on activities. Next, AWS recommends associate level certification before attempting the AWS Big Data exam. It is an advanced and challenging exam. A minimum of 5 years of hands-on experience in data analytics. Experience in designing and developing a scalable and cost-effective architecture to process data. Defining and architecting AWS Big Data services and their existence in the data lifecycle of collection, ingestion, storage, processing, and visualization. Finally, the last criterion is you should have a basic understanding of AWS services and a fair understanding of big data and Hadoop concepts. Next comes the AWS Certified Security Certification. This certification is intended for cloud security professionals. It allows experts to improve their knowledge on how to secure the AWS platform. With this certification, a candidate will gain understanding of AWS security services, implementation of AWS mechanisms, secure internet protocols and data encryption methods, implementation of AWS data protection and specialized data classifications, ability to make trade-off decisions about cost and security based on the requirement, understanding of security operations and risk. The fee for completing this certification is $300, and the average salary an AWS professionals earn after completing the certification is $103,195. The eligibility criteria required to complete the certification are achievement in any one AWS Associate Certification or Cloud Practitioner Certificate, more than 2 years of hands-on experience in securing AWS workloads, at least 5 years of IT security experience in designing and implementing security solutions. Next comes the AWS Certified Advanced Networking Certification. This certification validates the skills of IT professionals in designing and implementing AWS as part of a hybrid IT network architecture. The objective of this certification is to help an individual to develop and deploy cloud-based solutions using AWS, design and maintain network architecture for all AWS services, implementing core AWS services according to basic architecture best practices, leverage tools to automate AWS networking tasks. The fee for completing the certification is $300, and the average salary an AWS professionals earn after completing the certificate is $113,065. The eligibility criteria required to complete the certification are basic knowledge of AWS networking technologies and concepts, minimum experience of 5 years in data analytics, accomplishing at least one AWS certification, which is Solution Architect for Associate Level, SysOps Administrator, Associate Level, AWS Certified Developer, Associate Level, or Cloud Practitioner Certification. Speaking of Cloud Practitioner Certification, it was intended for individuals who have basic knowledge in cloud computing and would like to enhance their technical skills. This exam tests will teach you the fundamental security aspects of the AWS platform along with the shared security model, knowledge of AWS services and the common use cases, ability to explain AWS Cloud and its global infrastructure, capability to define principles of AWS Cloud architecture, ability to define pricing models, billing, and account management. The fee for completing the certification is $100, and the average salary an AWS professionals earn after completing the certification is $90,512. The eligibility criteria required to complete the certification are basic knowledge of IT solutions and services and their uses in the AWS platform, more than 6 months of experience in any role of AWS Cloud. Moving further, let's understand what AWS Certified Alexa Skill Builder Certification is. This certification is designed for professionals who are currently in the role of Alexa Skill Builder. It validates an individual's ability to build, test, and publish Amazon Alexa skills. This certification will help you gain basic knowledge such as how to design the architecture and user experience, elaborates on the best practices of AWS and Alexa security. It helps in understanding the process of developing, testing, and troubleshooting, helps in understanding the skill publishing process, and along with the Alexa Developer Console. It consists of skill operations and life cycles. The fee for completing the certification is $300. The recommended knowledge and experience required to have before attempting the certification are more than 6 months of practical knowledge on building Alexa skills using the Alexa Skills Kit, advanced programming knowledge. Next comes machine learning. This certification will help you learn how to implement a suitable machine learning algorithm for your business by unlocking new insights. This certification will help you gain basic knowledge such as choosing an appropriate ML algorithm for a given business problem, finding out appropriate AWS service to implement ML solutions, designing and applying scalable, cost-efficient, and secure ML solutions. The fee for completing this certification is $300. The recommended knowledge and experience required to have before attempting this certification are understanding of basic ML algorithms, experience in implementing hyperparameter optimization, familiar with machine learning and deep learning frameworks, knowledge of ML model training best practices, knowledge of ML deployment and operational best practices. Finally, we will be discussing the AWS Database Certification. This certification helps an individual to learn the process of planning, designing, and monitoring AWS database solutions. It validates an individual's ability to differentiate the essential features of AWS database services, analyze client requirements to create and suggest suitable database solutions using AWS services. The fee for completing this certification is $300. The eligibility criteria required to complete the certification are at least 5 years of experience with basic database technologies, minimum 2 years of hands-on experience on AWS services, knowledge of AWS cloud-based relational and NoSQL databases. A lot of people might be wondering about the validity of the certification. The certification is valid for only 2 years. An individual has to take up the exam every 2 years. The reason behind the logic of recertification is Amazon keeps frequently adding new features and services to their website. In that case, staying up to date is essential. AWS recertification consists of either taking a step ahead, that is advancing to the next level of your certification, which is from associate level to the professional level, or taking a recertification test at a reduced cost.
Let's see the steps to create an AWS account. The first step is to open the AWS web page. Then, click Create a Free Account to display the sign-in or Create an AWS Account page. In this page, click I am a new user. Enter your email ID or mobile number in the email or mobile number box, and then click Sign in using Secure Server. The AWS servers verify if an account already exists with the entered email ID. If yes, it displays an error message, else displays the login credentials page. In the Login Credentials page, enter the name. Re-enter the previously entered email ID and the password for your account. Then, click Create Account to display the contact information page. This page gives you the option to create a company account or a personal AWS account. For this demonstration, we will create personal AWS account. Then enter your full name and address in the displayed fields. Next, enter the CAPTCHA characters from the displayed security image. An important step is to open the AWS agreement and read it thoroughly. Then select the AWS Customer Agreement checkbox. Selecting the checkbox indicates that you have read the AWS agreement and you agree to it. Then, click Create Account and continue to display Payment Information page. In this page, enter the credit card details, and then click Verify Card and continue to display the Identity Verification page. Before displaying the Identity Verification page, the AWS servers verify the entered credit or debit card details by performing a reversible transaction of a small amount. This page displays your entered mobile number and is used to verify and confirm your identity. As you click Call Me Now, the AWS system calls you on the displayed number and your computer screen displays a 4-digit verification PIN. Enter the displayed 4-digit PIN in your phone using the keypad. Once the verification is successful, the page displays a message, Identity Verification Complete. Simply click Continue to select your support plan to display the support plan page. This page displays and explains about the 3 support plans: Basic, Developer, and Business. For this demonstration, we will select the free or basic plan, and then click Continue to display the welcome page of the AWS services. Congratulations! You have successfully created an AWS account.
Let's talk about databases in AWS. There are a host of options to store your data by using multiple database services in AWS. So, quickly speaking, you have RDS, the relational database service that supports many engines. Then there's an offering from AWS that is known as Aurora. It is a fully managed MySQL-compatible relational database service. Then you have a NoSQL service offered from AWS that is a fully managed service as well. It is called DynamoDB. We are going to take a look at that. Then you have Redshift. That is a petabyte-level data warehousing service. Again, it is a fully managed service. Then you have Elasticache. That supports in-memory cache. 2 very popular engines such as Memcached and Redis. Then you have a very cool service called Database Migration Service that basically allows you to migrate your database from Oracle to Aurora. You can use the service and then there is no downtime at all when you use this service. So let's take a look at RDS, DynamoDB, Elasticache, and Redshift. So once you're in AWS console, you can see that this is the RDS, and it is a management service, which essentially means that batch upgrade, operating systems installation are all taken care of by AWS. Then what we are responsible for is when we store our data, we have to provide permissions to set up the firewall settings and to allow access for everything. Then, of course, we are responsible for setting up the databases, but the engine is provided by AWS. Then if I click on this thing, let's say, for example, I want to fire my SQL instance, and if I click on this thing, I'll just show you how the high availability as well as the backup is taken care of by AWS. So I'll select my server, my hardware that's based on my workload, and then I can do something called multi-AZ deployment. When I do this, it basically asks if you want to have a master save configuration, a high availability configuration, and when I do that, then yes, I do get copies of my database in the multiple availability zones within the region. And these are synchronized, replicated copies. So in the event of failure, I will automatically be switched on to the other availability zone that has the same copy of my database. So let's quickly add the DB identifier and the username and password. So I'll just call it MySQL for the sake of simplicity. Let me just copy and paste all these. Okay, it doesn't like that. Okay, so it doesn't like my SQL database. And let us copy it all over. And then let's go to the next step. Now, when we go to advanced settings, I'll show you that they have something called backup. And then this backup is automatically provisioned by AWS. And you can see here that there is a maintenance window as well. If I want, I can give a window, then this is where you should take my backup, and the same thing for the maintenance. Now, these are all the things that are taken care of by AWS. And in a traditional environment, we have to do all these things ourselves. So this is the beauty of using AWS, that we don't have to worry about the patches. We don't have to worry about the backup. We don't have to worry about the high availability. It's just configured, and all we have to do is set some security rules, some firewall rules, and some accessibility rules for the users. Coming back to the NoSQL offering of AWS. So this is Amazon DynamoDB. Again, it is a very fast and flexible NoSQL database. So for all of your IoT platforms, for your mobile, for your gaming, this is the AWS service that you are going to use because it is a schemaless database, essentially, where you can have a keypad value and you don't have to worry about whether I'm going to store one value or do I have to store values in all columns as well. It deals in something called read capacity unit and write capacity unit for your read requirement and for your write requirement. And that's how it works. You don't have to worry about the provisioning of resources. It scales automatically. Redshift is a petabyte scale data warehousing solution. And again, it is a managed service, so you don't have to worry about, the OS level or the patches. The same thing goes with Elasticache as well. It supports the very popular Memcache and Redis engines. And it is a fully managed service, so you don't have to worry about management or scaling of all of the memory in these engines. Now, let's look at storage services that AWS offers. Now, storage makes up a very big part of the services that AWS offers in the cloud. They are heavily used by multiple organizations, individuals, consumers around the world. So let's go and look at a few things. So EBS is essentially your block storage, your hard drives. They are low latency. And all of your web servers and your database servers, your analytics engines, they all use EBS, Elastic Block Storage. Let's say you have a requirement to have shared file storage. That is where you are going to use Elastic File Storage. And again, it provides high fault tolerance with consistent latencies, and you pay only for what you use, so you do not have to pre-provision it. Just in the case of EBS, you need to pre-provision it. Then you have S3, a simple storage service and one of the most popular services of AWS, launched way back in 2006. It is secure, it has 11.9's durability, and it scales past tens of trillions of objects, and it has many, many use cases. Most importantly, for storage, backup, and recovery. Tiered archiver. We're going to look at a demo of that thing, and it also acts like a data link for big data analytics. Now, if we have something called cold data that we want to keep for our audit records or some archival records, AWS has something called Glacier that is very, very economical archival service. The rates start as low as like 4 cents a gigabyte, which is very, very cheap. You also have something called Storage Gateway, where you apply this virtual device to your data center, and then you can store all data through this storage gateway in the cloud. This is one of the very popular services in the hybrid environment, where you want to keep some data in the cloud and some data in your data center. There are a host of data transfer services which help you move your data to cloud, and it can go from a small amount of data that you can transfer over the internet to exabytes of data that you can transfer through truck to AWS storage services. So you have something called Data Connect, where you connect directly to AWS Regional Data Transfer. You bypass the internet, and then your network is connected. Then you have something called Snowball, which is like a box where you migrate petabytes of data in batches to the cloud. Then you have something called Snowmobile, where you migrate exabytes of data in batches to the cloud. And they will simply send a truck to your data center, you plug it in, the truck will roll into AWS data center, and then they will put data anywhere you want. So let's also take a look at Kinesis Firehose as well. So you have these Kinesis streams, and you have ingestion process, streaming data, your IoT data, your mobile data, your Twitter feed, the clickstream data. These are the things you can use Kinesis to store and process all of that data. This is where you would come in AWS services, AWS console to request Snowball. These are all the things that AWS gives you to transfer your data. Again, your data is secure, it's encrypted, it's addressed in transit, and you can access it anywhere using the internet. Let's look at S3 in AWS Management Console. S3 is a place which is used for data leaks, for any sort of data that you would want to upload in cloud. I can very easily go and I can create a bucket, so let's create a bucket. Bucket is where you are going to store your data. All right, so I have created Albert Simplilearn Lab Bucket, and if I click on it, I can do so many things over here. I can upload any data that I want over here. I can send the permissions of who all can access this data by default. In AWS, it's a shared responsibility model. So I can upload the data and I can choose who can access this data in S3. There are so many things that I can do with this bucket. That is my folder in the cloud, S3. That is Simple Storage Service. I can enable versioning, so I can keep all the versions of my objects over here. I can set up logging. I can set up a static website hosting. We will have a demo for this static website hosting as well, but we don't have to worry about this killing the load balancing, etc. It just scales automatically. I did mention that it's a great tool for disaster recovery, and what you can do is you can set up your backups, your snapshots in S3. You can put all your data in S3. You can simply enable the cross-region replication. So what happens is that, let's say you are in US East 1 or Northern Virginia region, and you want to set the cross-region replication to Oregon or maybe somewhere in Europe. You can just come over here and you can enable the cross-region replications. So what happens is AWS will automatically replicate your data from one region to another of your choice. You decide where you want your data to be replicated. AWS will not do so on its own. There are so many types of things that you can do. You can tag everything. You can give permissions to all your people. There are so many types of permissions that you can give. There is an access control list. You can set up a bucket policy. It's also tightly integrated with identity and access management, so you can very easily command who is able to access your bucket. Apart from that, there are some really interesting things. There is something called lifecycle. Now, this is a tiered storage. So normally, whenever you get data, typically that data is going to be very hot. So you would define the data or classify the data as a hot data, warm data, or cold, depending on how frequently it is accessed. Then you would normally have a tiered storage. So S3 has 4 classes. That's standard storage, and infrequent access storage, reduced redundancy storage, where you would put normally reproducible data, and archival storage, that is Glacier. So what you normally do whenever you get some data, you would keep it in a standard, and you would know over a period of time you would want to move that into an infrequent storage, like over here. So I will say that move this data into infrequent storage, which offers the same security, same durability, but it's a lot cheaper. Okay, and then after that, I can also add a data that I want to move into archive, which is Glacier, after some time. So we can add it to Glacier after 60 days, and if I just click on Next, this is where I will see it. And then I can also delete that object after whatever the amount of time that I would want, and I click on it. You see here that I have set up a transition rule that says that for the current version of the object, anything that I add to this S3 bucket, I want to transition all those objects automatically to standard infrequent access class. And then I will be charged lesser than what I've been charged now. And then I also want to transition to Amazon Glacier. That is my archival service after 60 days. I do not want to delete them ever. So these are the things that you can do with the S3. You also have a lot of analytics tools, which allow you to see who is accessing your data, what data you have, who is adding a lot of data, and these are all available to you at a very economical rate. All these services are tightly integrated with each other, so you can plug them in with an EC2 instance or IM, and you can get all the information at your fingertips. So let's talk about static website hosting on S3. And this is one of the very, very powerful features of S3, where we can actually host a website. And it's static and some part dynamic as well. So you do not need a web server to host your website. I have this bucket over here, AWS Agile.n. I click on it, and you can see that I have a couple of HTML pages, error.html and index.html, and then my code. My HTML, CSS files, my image, my video files are inside the folder. So I come over here, I click on the properties, and you can see that the bucket hosting is enabled. So if I click on it, all I need is 2 documents, then whatever I want inside my website. If I simply click on this thing, this is what I get. Now, these are the things that I have inside my website, my folder, and the beauty of it is that you do not need any web servers. You do not need any load balancer. You don't need any firewalls. You can simply give this URL, and then you can map it to your DNS, the domain name service, and then anybody will type your website name or your blog name, and then they are going to land on this page. And it's scalable, it is load balanced, and you can scale it to any number of people. You can have millions of hits coming in, and this is one of the very, very, very popular services of S3.
According to NIST, cloud computing is a model for enabling ubiquitous, convenient, on-demand network access to a shared pool of configurable computing resources. For example, networks, servers, storage, applications, and services that can be rapidly provisioned and released with minimal management effort or service provider interaction. Let us understand this definition by focusing on a few key words. Ubiquitous means irrespective of any type of web-enabled device or any type of network, such as Ethernet, PPP, FOC, etc. We can access the services subscribed from the service provider. Cloud computing takes the technology, services, and applications that are similar to those on the internet and turns them into a self-service utility. The latest version of NIST definition states that cloud computing networks must use virtualization and multi-tenancy. It also states that the customer must be able to provision his or her resources with minimal management effort and service providers interaction. This means customer can access the resource subscribed from anywhere and anytime. In the next slide, we will discuss essential characteristics of cloud computing. NIST states that there are 5 essential characteristics which are achieved by the service providers so that they can call their service as cloud service. The 5 essential characteristics are on-demand self-service, rapid elasticity, measured service, resource pooling, and broad network access. Let's understand each characteristic one by one in the coming slides. The next slide will introduce us to the concept of on-demand self-service. On-demand self-service means that a client can provision computer resources without the need for interaction with the cloud service provider personnel. The customer gets the complete privilege to select the resources and decide its quantity based on their business process, without any formal consultation with the service provider. The customer can access their dedicated portal anytime and from anywhere. However, he needs to comply with the limitation of regulatory concern to perform changes in configuration of the current setup. The customer can upgrade or downgrade services anytime. Also, the upgrade or downgrade of resources is committed in.
Let's talk about the economics of cloud. How much does it cost to be on cloud? What happens if I move some of my resources from my data center to cloud? How long is it going to take? And if I have to pay monthly, what will my monthly bill be? How do I know that? AWS gives you a lot of tools to manage your cost before you hop onto AWS Cloud or after you have made the move to cloud. Then, once you have been on cloud for a while, and we'll take a look at all of these things, so at the very beginning, at a very basic level, it is the pay-as-you-go model. It is not a CAPEX model, that is capital expenditure model. It is an OPEX model. So you pay only for what you use. You do not have to pay a fee or anything, and you can get a volume discount as well. So if you are a large organization and you have multiple teams and multiple accounts for AWS, you can have a billing option where you will have one person, one account that is going to pay the bill for all of the accounts in the organization. And the benefit you get from doing this is a volume discount. There are 3 tools that we are going to look at now. One is known as the AWS Cost Calculator. And what the AWS Cost Calculator does for you is it tells you how much you'll be charged for each service for all the resources that you are going to use. It will calculate and tell you your monthly bill. So, in this scenario, we are looking at a very simple implementation where we have a dev environment, a QA environment, and a broad environment. In dev and QA, we have one server each that we are choosing as G2.medium. And in broad, we have 2 servers. We know that broad is going to run for a very long time, so we are using the billing option of a 1-year partial payment, and then we get a lot of discounts. If we know that this workload is going to be required for up to 3 years, then we can select this option, and we'll get up to a 75% discount now. This is only for servers. Down below, we have used EBS volumes, which are just hard drives, and then I also selected 3 volumes, one each for dev, QA, and production. And then I also added how much snapshot data I'm going to have every month. If you see on the top of here that I get the monthly bill now, this is something only for EC2. I could use the same thing for my database as well, so I will have some databases as well, and I can add all the databases I need. Apart from this, if I scroll down here, there are so many services on your left that you can see that if you want to use all these services, and it will just let me know what the monthly charge is for all of these things. So this is something you can do before you hop on to AWS. There are servers I have at my disposal in my data center, and then I'm going to transfer my workload, my application, all my data to the cloud. How much am I going to pay? And this is a tool that is used day in and day out by pre-salespersons, by solutions architects, by executives who want to know beforehand how much they're going to pay. On the same line, we have something called TCO Calculator. That is the Total Cost of Ownership Calculator. Now here, we can also add the manual labor that we have, the personnel that we have, the power that we have, and it goes into more granular details of the resources that we have. It just gives you a total cost of ownership, and this is why these two things are very, very beautiful things. If you want to know beforehand what will happen if you move some of your workload to cloud, and you get a very, very, very good idea of the cost that you are going to spend in cloud on a monthly basis. Coming back to AWS Console. Within the console, there's a tool called AWS Trusted Advisor that essentially checks your implementations. So once you are on the cloud, once you have added all the sources on the cloud from your databases, your servers, your storage, your cache, everything, then the AWS Trusted Advisor checks all that you have done, and then it gives you recommendations on 4 different things. Among those 4 things are the cost optimization, which will tell you that if you are using these workloads for production, you might want to convert them into a reserve pricing option. So there are on-demand pricing options, there is a reserve pricing option, and then there's a spot pricing option. Reserve is the one that you use if you know you are going to run this workload for a period of 1 year, 2 years, or 3 years. Then you can buy that capacity in advance from AWS. And you don't have to necessarily pay all the money up front. You can do a partial payment for 1 year, and you still get up to 40% of the discount, which is really beautiful. Apart from your cost, AWS Trusted Advisor also gives you recommendation on performance, on security, and fault tolerance. So, if you know some of your firewall routes are not as stringent as they should be, it is going to scream at you, please don't do this. If you can see here, I have some of my security groups that have instance-level firewalls, or they have unrestricted access, so I have kept it open for the entire world, and I really shouldn't be doing that. So, these are the things that AWS provides for cost optimization and for cost management in cloud. So, even before you are into the cloud, or when you have been in the cloud for a while, you can use these tools to optimize your costs on a regular basis.
Let's look into what we have in the
AWS interview questions, which we find are important. And our hope is that you would use this material in your interview preparation and be able to crack that cloud interview and step into your dream cloud job. So as you progress in watching, you're going to see that these questions are practical scenario-based questions that tests the depth of the knowledge of a person in a particular AWS product or in a particular AWS architecture. So why wait? Let's move on. All right, so in an interview, you would find yourself with a question that might ask you, define and explain the 3 basic types of cloud services and the AWS products that are built based on them. See, here, it's a very straightforward question. Just explain 3 basic types of cloud service. And when we talk about basic type of cloud service, it's compute, obviously, that's a very basic service. Storage, obviously, because you need to store your data somewhere. And networking, that actually connects a couple of other services to your application. These basic will not include monitoring. These basic will not include analytics because they are considered as optional. They are considered as advanced services. You could choose a non-cloud service or a product for monitoring and for analytics. So they're not considered as basic. So when we talk about basics, they are compute, storage, and networking. And the second part of the question says, explain some of the AWS products that are built based on them. Of course, compute EC2 is a major one. That's That's the major share of the compute resource. And then we have platform as a service, which is Elastic Beanstalk, and then function as a service, which is Lambda. AutoScaling and Lightsail are also part of compute services. So the compute domain, it really helps us to run any application, and the compute service helps us in managing the scaling and deployment of an application. Again, Lambda is a compute service, so the compute service also helps in running event-initiated stateless applications. The next one was storage. A lot of emphasis is on storage these days, because if there's one thing that grows in a network on a daily basis, that's storage. Every new day we have new data to store, process, manage. So storage is again a basic and an important cloud service, and the products that are built based on the storage services are S3, object storage, Glacier for archiving, EBS, Elastic Block Storage as a drive attachment for the EC2 instances, and EFS file share for the EC2 instances. So the storage domain helps in the following aspects. It holds all the information that the application uses, so it's the application data. And we can also archive old data using storage, which would be Glacier, and any object files and any requirement for block storage can be met through Elastic Block Store and S3, which is again an object storage. Talking about networks, it's just not important to answer the question with the name of the services and the name of the product. It'll also be good if you could go in depth and explain how they can be used, right? So that actually proves you to be a person knowledgeable enough in that particular service or product. So talking about networking domain, VPC, networking, can't imagine networking without VPC in a cloud environment, especially in AWS cloud environment. And then we have Route 53 for domain resolution or for DNS. And then we have CloudFront, which is an edge caching service that helps customers to read their application with low latency. So networking domain helps with some of the following use cases. It controls and manages the connectivity of the AWS services within our account. And we can also pick an IP address range. If you're a network engineer, or if you are somebody who works in networks or are planning to work in network, you will soon realize the importance of choosing your own IP address for easy remembering. So having an option to have your own IP address in the cloud, own range of IP address in the cloud, it really helps, really helps in cloud networking. The other question that get asked would be the difference between the availability zone and the region. Actually, the question generally gets asked so to test how well you can actually differentiate and also correlate the availability zone and the region relationship, right? So a region is a separate geographic area like the US West 1, which represents North California, or the AP South, which represents Mumbai. So regions are a separate geographic area. On the contrary, availability zone resides inside the region. You shouldn't stop there, you should go further and explain about availability zones. And availability zones are isolated from each other, and some of the services will replicate themselves within the availability zone. So availability zone does replication within them, but regions, they don't generally do replication between them. The other question you could be asked is, what is autoscaling? What do we achieve by autoscaling? So in short, autoscaling, it helps us to automatically provision and launch new instances whenever there is an demand. It not only helps us meeting the increasing demand, it also helps in reducing the resource usage when there is low demand. So autoscaling also allows us to decrease the resources or resource capacity as per the need of that particular hour. Now, this helps business in not worrying about putting more effort in managing or continuously monitoring the server to see if they have the needed resource or not, because autoscaling is going to handle it for us. So business does not need to worry about it. And autoscaling is one big reason why people would want to go and pick a cloud service, especially an AWS service. the ability to increase and shrink based on the need of that arc. That's how powerful is AutoScaling. The other question you could get asked is, what's geo-targeting in CloudFront? Now we know that CloudFront is caching, and it caches content globally in the Amazon caching service global wide. The whole point is to provide users worldwide access to the data from a very nearest server possible. That's the whole point in using or going for CloudFront. Then what do you mean by geo-targeting? Geo-targeting is showing customer and specific content. Based on language, we can customize the content. Based on what's popular in that place, we can actually customize the content. The URL is the same, but we could actually change the content a little bit, not the whole content, otherwise it would be dynamic, but we can change the content a little bit, a specific file or a picture or a particular link in a website, and show customized content to users who will be in different parts of the globe. So how does it happen? CloudFront will detect the country where the viewers are located, and it will forward the country code to the origin server. And once the origin server gets the specialized or a specific country code, it will change the content and it will send to the caching server, and it gets cached there forever. And the user gets to view a content which is personalized for them for the country they are in. The other question you could get asked is the steps involved in using CloudFormation or creating a CloudFormation or backing up an environment with a CloudFormation template. We all know that if there is a template, we can simply run it and it provisions the environment, but there is a lot more going into it. So the first step in moving towards infrastructure as a code is to create the CloudFormation template, which as of now supports JSON and YAML file format. So first create the CloudFormation template and then save the code in an S3 bucket. S3 bucket serves as the repository for our code, and then from the CloudFormation call the file in the S3 bucket and create a stack. And now CloudFormation uses the file, reads the file, understands services that are being called, understands the order, understands how they are connected with each other. CloudFormation is actually an intelligent service. It understands the relation. Based on the code, it would understand the relationship between the different services, and it would set an order for itself and then would provision the services one after the other. Let's say a service has a dependency, and the dependent service, the other service which this service, let's say service A and B, service B is dependent on service A, let's say. CloudFormation is an intelligent service. It would provision the resource A first and then would provision resource B. What happens if we inverse the order? If we inverse the order, resource B first gets provision, and because it does not have dependency, chances that the CloudFormation's default behavior is that if something is not provisioned properly, if something is not healthy, it would roll back. Chances that the environment provisioning will roll back. So to avoid that, CloudFormation first provisions all the services that has or that's dependent on, that's depended by another service. So it provisions those services first and then provisions the services that has dependencies. And if you're being hired for a DevOps or if the interviewer wanted to test your skill on systems side, this definitely would be a question in his list. How do you upgrade or downgrade a system with near zero downtime? Now everybody's moving towards zero downtime or near zero downtime. All of them want their application to be highly available. So the question would be, how do you actually upgrade or downgrade a system with near zero downtime? Now we all know that I can upgrade an EC2 instance to a better EC2 instance by changing the instance type, stopping and starting. But stopping and starting is going to cause a downtime, right? So you should be answering, or you should be thinking in those terms, because that's a wrong answer. Specifically, the interviewer wants to know, how do you upgrade a system with zero downtime? So upgrading system with zero downtime, it includes launching another system parallelly with the bigger EC2 instance type with a bigger capacity, and install all that's needed. If you're going to use an AMI of the old machine, well and good. You don't have to go through installing all the updates and installing all the application. From the AMI, once you've launched it in a bigger instance, locally test the application to see if it is working. Don't put it on production yet. Test the application to see if it is working. And if the application works, we can actually swap. If your server is behind Route 53, let's say, all that you could do is go to Route 53, update the information with the new IP address of the new server, and that's going to send traffic to the new server now. So the cutover is handled. Or if you're using static IP, you can actually remove the static IP from the old machine and assign it to the new machine. That's one way of doing it. Or if you are using Elastic NIC card, you can actually remove the NIC card from the old machine and attach the NIC card to the new machine. So that way we would get near zero downtime. If you're hired for an architect level, you should be worrying about cost as well, along with the technology. And this question would test how well you manage cost. So what are the tools and techniques we can use in AWS to identify and know that we are paying the correct amount for the resources that we are using? Or how do you get a visibility of your AWS resources running? One way is to check the billing. There's a place where you can check the top services that were utilized. It could be free and it could be paid service as well. Top services that can be utilized. It's actually in the dashboard of the cost management console. So that table here shows the top 5 most used services. So looking at it, you can get it. All right, so I'm using a lot of storage. I'm using a lot of EC2. Why is storage high? You can go ahead and try to justify that, and you will find if you are storing things that shouldn't be storing, and then clean it up. Why is compute capacity so high? Why is data transfer so high? So if you start thinking in those levels, you'll be able to dig in and clean up unnecessary and be able to save your bill. And there are cost explorer services available which will help you to view your usage pattern or view your spending for the past 13 months or so, and it will also forecast for the next 3 months. Now, how much will you be using if your pattern is like this? So that will actually help and will give you a visibility on how much you have spent, how much you will be spending if the trend continues. Budgets are another excellent way to control cost. You can actually set a budget. All right, this is how much I am willing to spend for this application, for this team, or for this month, for this particular resource. So you can actually put a budget mark, and anytime it exceeds, anytime it's nearing, you would get an alarm saying that, well, we're about to reach the allocated budget amount, stuff like that. That way you can go back and know, and you know that how much the bill is going to be for that month, or you can take steps to control bill amount for that particular month. So AWS budget is another very good tool that you could use. Cost allocation tags helps in identifying which team or which resource has spent more in that particular month. Instead of looking at the bill as one list with no specifications into it and looking at it as an expenditure list, you can actually break it down and tag the expenditure to the teams with cost allocation tags. The dev team has spent so much. The production team has spent so much. The training team has spent more than the dev and the production team. Why is that? Now, you'll be able to think in those levels only if you have cost allocation tags. Now, cost allocation tags are nothing but the tags that you would put when you create a resource. So for production services, you would put as a production tag, you would create a production tag and you would associate that resources to it. And at a later point, when you actually pull up your bill, that's going to show a detailed list of this is the owner, this is the group, and this is how much they have used in the last month. And you can move forward with your investigation and encourage or stop users using more services with the cost allocation tags. The other famous question is, are there any other tools or is there any other way of accessing AWS resource other than the console? Console is GUI, right? So in other words, other than GUI, how would you use the AWS resource and how familiar are you with those tools and technologies? The other tools that are available that we can leverage and access the AWS resource are, of course, PuTTY. You can configure PuTTY to access the AWS resources, like log into an EC2 instance. An EC2 instance does not always have to be logged in through the console. You could use PuTTY to log into an EC2 instance, and like the jump box, like the proxy machine, and like the gateway machine, and from there you can actually access the rest of the resources. So this is an alternative to the console. And of course, we have the AWS CLI. In any of the Linux machines or Windows machines, we can install, so that's point 2, 3 and 4. We can install AWS CLI for Linux, Windows, also for Mac. So we can install them, and from there, from your local machine, we can access, run AWS commands and access, provision, monitor the AWS resources. The other ones are, we can access the AWS resource programmatically using AWS SDK and Eclipse. So these are a bunch of options we have to use the AWS resource other than the console. If you're interviewed in a company or by a company that focuses more on security and want to use AWS native services for their security, then you would come across this question. What services can be used to create a centralized logging solution? The basic services we could use are CloudWatch logs, store them in S3, and then use Elasticsearch to visualize them, and use Kinesis to move the data from S3 to Elasticsearch. Right? So log management, it actually helps organizations to track the relationship between operational and security changes and the events that got triggered based on those logs. Instead of logging into an instance, or instead of logging into the environment and checking the resources physically, I can come to a fair conclusion by just looking at the logs. Every time there's a change, the system would scream and it gets tracked in the CloudWatch, and then CloudWatch pushes it to S3. Kinesis pushes the data from S3 to Elasticsearch, and I can do a time-based filter, and I would get a fair understanding of what was going on in the environment for the past 1 hour or whatever the time window that I wanted to look at. So it helps in getting a good understanding of the infrastructure as a whole. All the logs are getting saved in one place, so all the infrastructure logs are getting saved in one place, so it's easy for me to look at it in an infrastructure perspective. So we know the services that can be used, and here are some of the services and how they actually connect to each other. It could be logs that belongs to one account. It could be logs that belongs to multiple accounts. It doesn't matter. Those three services are going to work fairly good, and they're going to inject, or they're going to suck logs from the other accounts, put it in one place and help us to monitor. So as you see, you have CloudWatch here that actually tracks the metrics. You can also use CloudTrail if you want to log API calls as well, push them in an S3 bucket. So there are different types of log. Flow logs are getting captured in an instance. Application logs are getting captured from the same VPC, from a different VPC, from the same account, from a different account. And all of them are analyzed using Elasticsearch using the Kibana client. So step 1 is to deploy the ECS cluster. Step 2 is to restrict access to the ECS cluster because it's valid data. You don't want anybody to put their hands and access their data. So restrict access to the ECS dashboard. And we could use Lambda also to push the data from CloudWatch to the Elasticsearch domain. And then Kibana is actually the graphical tool that helps us to visualize the logs. Instead of looking at log as just statements or in a bunch of characters, a bunch of files, Kibana helps us to analyze the logs in a graphical or a chart or a bar diagram format. Again, in an interview, if the interviewer is more concerned about testing your knowledge on AWS security products, especially on the logging, monitoring, event management, or incident management, then you could have a question like this. What are the native AWS security logging capabilities? Now, most of the services have their own logging in them, have their own logging, like S3. S3 has its own login, and CloudFront has its own logging. DS has its own logging. VPC has its own logging. In addition, there are account level logins like CloudTrail and AWS config services. So there are a variety of logging options available in the AWS, like CloudTrail. config, CloudFront, Redshift logging, RDS logging, VPC flow logs, S3 object logging, S3 access logging, stuff like that. So we're going to look at two servers in specific. CloudTrail. Now this CloudTrail, the very first product in that picture we just saw, the CloudTrail provides an very high level history of the API calls for all the account. And with that, we can actually perform a very good security analysis of our account. And these logs are actually delivered to, you can configure it, they can be delivered to S3 for long time archivals. And based on a particular event, it can also send an email notification to us saying, hey, just got this error, thought I'll let you know, stuff like that. The other one is config service. Now config service helps us to understand the configuration changes that happened in our environment, and we can also set up notifications based on the configuration changes. So it records the cumulative changes that are made in a short period of time. So if you want to go through the lifetime of a particular resource, what are the things that happened? What are the things it went through? They can be looked at using AWS config. All right. The other question you could get asked is if your role includes taking care of cloud security as well. Then the other question you could get asked is the native services that Amazon provides to mitigate DDoS, which is denial of service. Now, not all companies would go with Amazon native services, but there are some companies which want to stick with Amazon native services just to save them from the headache of managing the other softwares or bringing in another tool, a third-party tool, into managing DDoS. They simply want to stick with Amazon proprietary Amazon native services, and a lot of companies are using Amazon service to prevent DDoS, denial of service. Now, denial of service is, if you already know what denial of service is, well and good. If you do not know, then let's know it now. Denial of service is a user trying to or maliciously making attempt to access a website or an application. The user would actually create multiple sessions and he would occupy all the sessions, and he would not let legitimate users access the service. So he's in turn denying the service for the user. A quick picture review of what denial of service is. Now look at it. These users, instead of making one connection, they are making multiple connections, and there are cheap software programs available that would actually trigger connections from different computers in the internet with different MAC addresses, so everything kind of looks legitimate for the server, and it would accept those connections and it would keep the sessions open. The actual users won't be able to use them, so that's denying the service for the actual users, denial of service. All right, and distributed denial of service is generating attacks from multiple places, from a distributed environment. So that's distributed denial of service. So the tools, the native tools that helps us to prevent the denial of service attacks in AWS is Cloud Shield and Web Access Firewall, AWS WAF. Now they are the major ones. They are designed to mitigate a denial of service. If your website is often bothered by denial of service, then we should be using AWS Shield or AWS WAF. And there are a couple of other tools that also does. When I say that also does, denial of service is not their primary job, but you could use them for denial of service. Route 53's purpose is to provide DNS. CloudFront is to provide caching. Elastic Load Balancer, ELB's work is to provide load balancing. VPC is to create an secure virtual private environment. But they also support mitigating denial of service, but not to the extent you would get in AWS Shield and AWS WAF. So AWS Shield and WAF are the primary ones, but the rest can also be used to mitigate distributed denial of service. The other tricky question is this actually will test your familiarity with the region and the services available in the region. So when you're trying to provision a service in a particular region, you're not seeing the service in that region. How do we go about fixing it, or how do we go about using the service in the cloud? It's a tricky question. And if you have not gone through such situation, you can totally blow it away. You really need to have a good understanding on regions, the services available in those regions, and what if a particular service is not available, how to go about doing it. The answer is not all services are available in all regions. anytime Amazon announces a new service, they don't immediately publish them on all regions. They start small, and as in when the traffic increases, as in when it becomes more likable to the customers, they actually move the service to different regions. So as you see in this picture, within America, North Virginia has more services compared to Ohio or compared to North California. So within North America itself, North Virginia is the preferred one. So similarly, there are preferred regions within Europe, Middle East, and Africa, and preferred regions within Asia Pacific. So anytime you don't see a service in a particular region, chances that the service is not available in that region yet, we got to check the documentation and find the nearest region that offers that service and start using the service from that region. Now you might think, well, if I'm looking for a service in Asia, let's say in Mumbai, and if it is not available, why not simply switch to North Virginia and start using it? You could, but that's going to add more latency to your application. So that's why we need to check for application, which is check for region, which is very near to the place where you want to serve your customers, and find nearest region instead of always going back to North Virginia and deploying your application in North Virginia. Again, there's a link in aws.com that you can go and look for services available in different region, and that's exactly what you're seeing here. And if your service is not available in a particular region, switch to the other region that provides your service, the nearest other region that provides that service, and start using service from there. With the coming up of cloud, a lot of companies have turned down their monitoring team. Instead, they want to go with the monitorings that cloud provides. Nobody wants to, or at least many people don't want to go through the hassle of, at least new startups and new companies that are thinking of having a monitoring environment. Now, they don't want to go with traditional NOC monitoring. Instead, they would like to leverage AWS monitorings available, because it monitors a lot of stuff, not just the availability, but it monitors a lot of stuff like failures, errors. It also triggers emails, stuff like that. So how do you actually set up a monitor to how do you set up a monitor to monitor the website metrics in real time in AWS? The simple way, anytime you have a question about monitoring, CloudWatch should strike your mind, because CloudWatch is meant for monitoring, is meant for collecting metrics, is meant for providing graphical representation of what's going on in a particular network at a particular point of time. So CloudWatch helps us to monitor applications, and using CloudWatch we can monitor the state changes. Not only the state changes, the auto-scaling life cycle events. Anytime there are more services added, there is a reduction in the number of servers because of less usage, and very informative messages can be received through CloudWatch. CloudWatch can now support scheduled events. If you want to schedule anything, CloudWatch has an event that would schedule an action, right? Schedule a trigger, time-based, not incident-based. Anything happening and then you get an action happening, that's incident-based. On the other hand, you can simply schedule few things on time-based. So that's possible with CloudWatch. So this CloudWatch integrates very well with a lot of other services like notifications for notifying the user or for notifying the administrator about it. And it can integrate well with Lambda. So to trigger an action, anytime you're designing an auto-healing environment, this CloudWatch can actually monitor and send an email if we are integrating it with SNS, Simple Notification Service. Or this CloudWatch can monitor, and based on what's happening, it can trigger an event in Lambda, and that would in turn run a function till the environment comes back to normal. So CloudWatch integrates well with a lot of other AWS services. Alright, so CloudWatch has 3 statuses: green when everything is going good, yellow when the service is degraded, and red when the service is not available. Green is good, so we don't have to do anything about it. But anytime there's an yellow, the picture that we're looking at, it's actually calling a Lambda function to debug the application and to fix it. And anytime there's a red alert, it immediately notifies the owner of the application about, well, the service is down, and here is the report that I have. Here is the metrics that I've collected about the service, stuff like that. If the job role requires you to manage the servers as well, There are certain job roles which are on the system side. There are certain job roles which is development plus system side. Now you're responsible for the application and the server as well. So if that's the case, you might be tested with some basic questions like the different types of virtualization in AWS and what are the difference between them. All right, the three major types of virtualization are HVM, which is hardware virtual machine. The other one is PV, para virtualization. And the third one is PV on HVM, para virtualization on hardware virtual module. All right, the difference between them, or actually describing them, is actually the difference between them. HVM, it's actually a fully virtualized hardware. The whole hardware is virtualized and all virtual machines act separate from each other. And these VMs are booted by executing master boot record in the root block. And when we talk about para virtualization, Paragrub is actually the special boot loader which boots the PV AMIs. And when we talk about PV on HVM, it's actually the marriage between HVM and PV. And this para virtualization on HVM, in other words, PV on HVM, it actually helps operating system take advantage in storage and the network input output available through the host. Another good question is, name some of the services that are not region specific. Now, you've been taught that all services are within a region and some services are within an availability zone. For example, EC2 is within an availability zone, EBS is within an availability zone, S3 is region specific, DynamoDB is region specific, stuff like that. VPC is both availability and region specific, meaning subnets are availability zone specific and VPC is region specific, stuff like that. So you might have thought, you might have learned in that combination. But there could be some tricky questions that tests you how well you have understood the region, non-region, and availability, non-availability services. I should say there are services that are not region specific. That would be IAM. So we can't have IAM for every availability zone and for every region, which means users will have to use one username and password for one region, and anytime they switch to another region they will have to use another username and password. That's more work, and that's not a good design as well. Authentication has to be global. So IAM is a global service, and which means it's not region specific. On the other hand, Route 53 is again a regional specific, so we can't have Route 53 for every region. Route 53 is not a region specific service. It's a global service, and it's one application. Users access from everywhere or from every part of the world, so we can't have one URL or one DNS name for each region if your application is a global application. And then Web Application Firewall works well with CloudFront. Then CloudFront is a region-based service. So the Web Application Firewall, it's not a region-specific service. It's a global service. And CloudFront is again a global service. Though you can cache content on a continent and country basis, it's still considered a global service. Right? It's not bound to any region. So when you activate CloudFront, you're activating it away from region or availability zone. So when you're activating a Web Application Firewall, because it's not a region specific service, you're activating it away from availability zone and regions. So a quick recap: IAM users, groups, roles, and accounts, they are global services. They can be used globally. Route 53 services are offered at edge locations and they are global as well. Web Application Firewall, a service that protects our web application from common web exploits. They are global service as well. CloudFront is Global Content Delivery Network, CDN, and they are offered at edge locations, which are a global service. In other words, non-region specific service or beyond region service. All right, this is another good question as well. In the project that you are being interviewed, if they really want to secure their environment using NAT, or if they are already securing their environment using NAT by any of these two methods like NAT gateway or NAT instances, you can expect this question: what are the difference between a NAT gateway and NAT instances? Now, they both serve the same thing, right? So they're not two different services trying to achieve two different things. They both serve the same thing, but still they do have differences in them. All right. On a high level, they both achieve providing NATing for the service behind it, but the difference comes when we talk about the availability of it. NAT Gateway is a managed service by Amazon, whereas NAT Instance is managed by us. Now I'm talking about the third point, maintenance here. NAT Gateway is managed by Amazon. NAT Instance is managed by us, and availability of NAT Gateway is very high, and availability of NAT Instance is less compared to the NAT Gateway because it's managed by us. It's on an EC2 instance which could actually fail, and if it fails, we'll have to relaunch it. But if it is NAT Gateway, if something happens to that service, Amazon would take care of reprovisioning it. And talking about bandwidth, it can burst up to 75 gigabits. Traffic through the NAT gateway can burst up to 75 gigabits. But for NAT instance, it actually depends on the server that we launch. And if we are launching a T2 micro, it barely gets any bandwidth. So there's a difference there. And the performance, because it's highly available because of the bigger pipe, 75 gigabits, the performance of the NAT gateway is very high, but the performance of the NAT instance is going to be average. Again, it depends on the size of the NAT instance that we pick. And billing. Billing for NAT gateway is the number of gateways that we provision and the duration for which we use the NAT gateway. But billing for NAT instance is number of instance and the type of instance that we use. Of course, number of instance, duration, and the type of instance that we use. Security in NAT gateway cannot be assigned, meaning it already comes with full packed security. But in NAT instance, security is a bit customizable. I can go and change the security because it's a server managed by me or managed by us. I can always change the security. Well, allow this, don't allow this, stuff like that. Size and load of the NAT gateway is uniform, but the size and the load of the NAT instance changes as per a NAT gateway is a fixed product, but NAT instance can be small instance, can be a big instance, so the size and the load through it varies. Right. The other question you could get asked is, what are the difference between stopping and terminating an EC2 instance? Now you will be able to answer only if you have worked on environments where you have your instance stopped and where you have your instance terminated. If you have only used lab and are attending the interview, chances are that your way is lost when answering this question. It might look like both are the same. Well, stopping and terminating, both are the same. But there is a difference in it. So when you stop an instance, it actually performs a normal shutdown on the instance and it simply moves the instance to the stopped state. But when you actually terminate the instance is moved to the stop state. The EBS volumes that are attached to it are deleted and removed, and we'll never be able to recover them again. So that's a big difference between stopping and terminating an instance. If you're thinking of using the instance again along with the data in it, you should only be thinking of stopping the instance, but you should be terminating the instance only if you want to get rid of that instance forever. If you are being interviewed for an architect level position or a junior architect level position or even an cloud consultant level position, or even in an engineering position, this is a very common question that get asked. What are the different types of EC2 instances based on their cost or based on how we pay them, right? They're all compute capacity. For example, the different types are on-demand instances, spot instances, and reserved instances. It kind of looks the same. They all provide the compute capacity. They all provide the same type of hardwares for us. But if you're looking at cost saving or optimizing cost in our environment, we got to be very careful about which one are we picking. Now we might think that, well, I'll go with on-demand instance because I pay on a per hour basis, which is cheap. I can use them anytime I want, and anytime I don't want, I can simply get rid of it by terminating it. You're right, but if the requirement is to use the service for 1 year, the requirement is to use the service for 3 years, then you'll be wasting a lot of money buying on-demand instances. You'll be wasting a lot of money paying on an hourly basis. Instead, we should be going for reserved instance where we can reserve the capacity for the complete 1 year or complete 3 years and save huge amount in buying reserved instances. Alright, so on-demand is cheap to start with if you're only planning to use it for a short while, but if you're planning to run it for a long while, then we should be going for reserved instance. That is what is cost efficient. So spot instance is cheaper than on-demand instance. And there are different use cases for spot instance as well. So let's look at one after the other. The on-demand instance. The on-demand instance is purchased at a fixed rate per hour. This is very short-term and irregular workloads. And for testing, for development, on-demand instance is a very good use case. We should be using on-demand for production. Spot instance. Spot instance allows users to purchase EC2 at a reduced price, and anytime we have more instances, we can always go and sell it in spot instances. I'm referring to anytime we have more reserved instances, we can always sell them in spot instance catalog. And the way we buy spot instance is we actually put a budget. This is how much I'm willing to pay. All right, would you be able to give service within this cost? So anytime the price comes down and meets the cost that we have put in, we'll be assigned an instance, and anytime the price shoots up, the instance will be taken away from us. But in case of on-demand instances, we have bought that instance for that particular hour and it stays with us. But with spot instances, it varies based on the price. If you meet the price, you get the instance. If you don't meet the price, it goes away to somebody else. And the spot instance availability is actually based on supply and demand in the market. There's no guarantee that you will get spot instance at all time. All right, so that's a caveat there you should be familiar with. That's a caveat there you should be aware when you are proposing somebody that we can go for spot instance and save money. It's not always going to be available. If you want your spot instance to be available to you, then we need to carefully watch the history of the price of the spot instance. Now, how much was it last month and how much is it this month? So how can I quote, or how much can I quote, stuff like that. So you got to look at those history before you propose somebody that, well, we're going to save money using spot instance. On the other hand, reserved instance provide cost savings for the company. We can opt for reserved instances for 1 year or 3 years. There are actually 3 types of reserved instances: light, medium, and heavy reserved instances. They are based on the amount that we would be paying. And cost benefit also depends with reserved instance. The cost benefit also depends based on, are we doing all upfront or no upfront or partial payment, then split the rest as monthly payments. So there are many purchase options available. But overall, if you're looking at using an application for the next 1 year and 3 years, you should not be going for on-demand instance. You should be going for reserved instance, and that's what gives you the cost benefit. And in an AWS interview, sometimes you might be asked, how you interact with the AWS environment. Are you using CLI? Are you using console? And depending on your answer, whether console or CLI, the panelists put a score. Okay, this person is CLI specific, this person is console specific, or this person has used AWS environment through the SDK, stuff like that. So this question tests whether you are a CLI person or a console person. And the question goes like this: how do you set up SSH agent forwarding so that you do not have to copy the key every time you log in? If you have used PuTTY, anytime if you want to log into an EC2 instance, you will have to put the IP and the port number. Along with that, you will have to map, or we will have to map the key in the PuTTY, and this has to be done every time. That's what we would have done in our lab environments, right? But in production environment, using the same key or mapping the same key again and again every time, it's actually a hassle. It's considered as a blocker. So you might want to cache it. You might want to permanently add it in your PuTTY session so you can immediately log in and start using it. So here, in the place where you would actually map the private key, there's a quick button that actually fixes or that actually binds your SSH to your PuTTY instance. So we can enable SSH agent forwarding that will actually bind our key to the SSH, and next time when we try to log in, we don't have to always go through mapping the key and trying to log in. Alright, this question, what are Solaris and AX operating systems? Are they available with AWS? That question generally gets asked to test how familiar are you with the AMIs available? How familiar are you with EC2? How familiar are you with the EC2 hardwares available? That basically tests that. Now the first question or the first thought that comes to your mind is, well, everything is available with AWS. I've seen Windows, I've seen Ubuntu, I've seen Red Hat, I've seen Amazon AMIs, and if I don't see my operating system there, I can always go to Marketplace and try them If I don't find a marketplace, I can always go to community and try them. So there are a lot of AMIs available, there are a lot of operating systems available. I will be able to find Solaris and AX, but that's not the case. Solaris and AX are not available with AWS. That's because Solaris uses a different, Solaris does not support the architecture, does not support public cloud currently. The same goes for AX as well. They run on Power CPU and not on Intel, and as of now, Amazon does not provide power machines. This should not be confused with HPC, which is high performance computing. Should not be confused with that. Now, these are different hardwares, different CPU itself that the cloud providers do not provide yet. Another question you could get asked in organizations that would want to automate their infrastructure using Amazon native services would be, how do you actually recover an EC2 instance or auto recover an EC2 instance when it fails? Well, we know that EC2 instances are considered as immutable, meaning irreparable. We don't spend time fixing bugs in an OS, stuff like that. Once an EC2 instance crashes, like it goes on a OS panic, or there are various reasons why it would fail. So we don't have to really worry about fixing it. We can always relaunch that instance and that would fix it. But what if it happens at 2 o'clock in the night? What if it happens during a weekend when nobody's in office looking or monitoring those instances? So you would want to automate that, not only on a weekend or during midnights, but it's general practice good to automate it. So you could face this question: how do you actually automate an EC2 instance once it fails? And the answer to that question is using CloudWatch, we can recover the instance. So as you see, there is an alarm threshold set in CloudWatch, and once the threshold is met, meaning if there is an error, if there is a failure, if the EC2 instance is not responding for a certain while, we can set an alarm. And once the alarm is met, let's say the CPU utilization stayed high for 5 minutes, right? It's not taking any new connections, or the instance is not pinging for 5 minutes, or in this case, it's 2 minutes. It's not pinging, so it's not going to respond connection. So in those cases, you would want to automatically recover that EC2 instance by rebooting the instance. All right, now look at this, the take this action section under the action. So there we have a bunch of options like recover this instance, meaning reboot the instance. So that's how we would recover. The other two options are beyond the scope of the question, but still you can go ahead and apply, just like I'm going to do it. So the other option is stop the instance. That's very useful when you want to stop instances that are having low utilizations. Nobody's using the system as of now. You don't want them to be running and wasting the cloud expenditure. So you can actually set an alarm that stops the EC2 instance that's having low utilization. So somebody was working in an instance and they left it without, or they forgot to shut down that instance, and it gets, they will only use it again the next day morning. So in between there could be like 12 hours that the system is running idle, nobody's using it, and you're paying for it. So you can identify such instances and actually stop them when the CPU utilization is low, meaning nobody is using it. The other one is to terminate. Let's say you want to give system to somebody temporarily and you don't want them to hand the system back to you. All right? This is actually an idea. In other words, this is actually the scenario. So you hand over a system to somebody, and when they're done, they're done. We can actually terminate the system. So you could instruct the other person to terminate the system when they're done, and they could forget and the instance could be running forever. Or you can monitor the system after the specified time is over and you can terminate the system. Or best part, you can automate the system termination. So you assign a system to somebody and then turn on this CloudWatch action to terminate the instance when the CPU is low for like 2 hours, meaning they've already left, or CPU is low for 30 minutes, meaning they've already left, stuff like that. So that's possible. And if you're getting hired for an system side architect, or even on the SysOps side, you could face this question: what are the common and different types of AMI designs? There are a lot of AMI designs. The question is the common ones and the difference between them. So the common ones are the full back AMIs, and the other one is just enough OS AMI, JEOS AMI, and the other one is hybrid type AMIs. So let's look at the difference between them. The full backed AMI just like the name says, it's fully baked. It's ready to use AMI. This is the simplest AMI to deploy. It can be a bit expensive. It can be a bit cumbersome because you'll have to do a lot of work beforehand. You could use the AMI. So a lot of planning, a lot of thought process will go into it. And the AMI is ready to use, right? You hand over the AMI to somebody and it's ready to use. Or if you want to reuse the AMI, it's already ready for you to use. So that's full baked AMI. The other one is just enough operating system AMI, just like the name says. It has, as you can also see in the diagram or in the picture, it covers a part of the OS. All bootstraps are already packed properly, and the security monitoring, logging, and the other stuff are configured at the time of deployment or at the time you would be using it. So not much thought process will go in here. The only focus is on choosing the operating system and what goes, the operating system specific agents or bootstraps that goes into the operating system. That's all we worry about. The advantage of this is it's flexible, meaning you can choose to install additional softwares at the time of deploying, but that's going to require an additional expertise on the person who will be using the AMI. So that's another overhead there. But the advantage is that it's kind of flexible. I can change the configurations during the time of deployment. The other one is a hybrid AMI. Now the hybrid AMI actually falls in between the fully baked AMI and just enough operating system options. So these AMIs have some features of the baked type and some features of the just enough OS type. So as you see, the security monitoring, logging are packed in that AMI. And the runtime environments are installed during the time of a deployment. So this is where the strict company policies would go into the AMI. Company policies like you got to log this, you got to monitor this. These are the ports that generally gets open in all the systems, stuff like that. So they strictly go into the AMI and sits in an AMI format. And during deployment, you have the flexibility of choosing the different runtime and the application that sits in an EC2 instance. Another very famous question you would face in an interview is, how can you recover login to an EC2 instance to which you lost the key? Well, we know that if the key is lost, we can't recover it. There are some organizations that integrate their EC2 instances with an AD. That's different. Right, so you can go and reset the password in the AD and you will be able to log in with the new password. But here the specific tricky question is, you are using a key to log in, and how do you recover if you have lost the key? Generally, companies would have made a backup of the key so we can pick from the backup. But here the specific question is, we have lost the key, literally no backups on the key at all. So how can we log in? And we know that we can't log into the instance without the key present with us. So the steps to recover is that make the instance use another key and use that key to log in. Once the key is lost, it's lost forever. We won't be able to recover it. You can't raise a ticket with Amazon. Not possible. They're not going to help. It's beyond the scope. So make the instance use another key. It's only the key that's the problem. You still have valid data in it. You got to recover the data. It's just the key that's having the problem. So we can actually focus on the key part alone and change the key, and that will allow us to log in. So how do we do it? Step-by-step procedure. So first, verify the EC2 config service is running in that instance. If you want, you can actually beforehand install the EC2 config in that service, or you can actually make the EC2 config run through the console. Just a couple of button clicks and that'll make the EC2 config run in that EC2 instance, and then detach the root volume for that instance. Of course, it's going to require a stop and start. So detach the root volume from the instance, attach the root volume to another instance as a temporary volume, or it could be a temporary instance that you've launched only to fix this issue, and then log in to that instance and to that particular volume and modify the configuration file. Modify it to use the new key, and then move the root volume back to its original position and restart the instance. And now the instance is going to have the new key, and you also have the new key with which you can log in. So that's how we go ahead and fix it. Now let's move on to some product specific or S3 product specific questions. A general perception is S3 and EBS can be used interchangeably, and the interviewer would want to test your knowledge on S3 and EBS. Well, EBS uses S3, that's true, but they can't be interchangeably used. So you might face this question, what are some key differences between AWS S3 and EBS? Well, the differences are S3 is an object store, meaning you can't install anything in it. You can store drive files, but you can't actually install in it. It's not a file system. But EBS is a file system. You can install services, install applications in it, and that's going to run stuff like that. And talking about performance, S3 is much faster and EBS is super faster when accessing from the instance, because from the instance, if you need to access S3, you'll actually have to go out through the internet and access the S3, or S3 is an external service, a very external service. You'll have to go through, or you'll have to go outside of your VPC to access S3. S3 does not come under a VPC. But EBS comes under a VPC. It's on the same VPC. So you would be able to use it kind of locally. Compared to S3, EBS is very local. So that way it's going to be faster. And redundancy, talking about redundancy of S3 and EBS. S3 is replicated. The data in S3 is replicated across the data centers, but EBS is replicated within the data center, meaning S3 is replicated across availability zones. EBS is within an availability zone. So that way redundancy is a bit less in EBS. In other words, redundancy is higher in S3 than EBS. And talking about security of S3, S3 can be made private as well as public, meaning anybody can access S3 from anywhere in the internet. That's possible with S3. But EBS can only be accessed when attached to an EC2 instance. Right? Just one instance can access it, whereas S3 is publicly directly accessible. The other question related to S3 security is, how do you allow access to a user to a certain bucket, which means this user is not having access to S3 at all, but this user needs to be given access to a certain bucket. How do we do it? The same case applies to servers as well. In few cases, there could be an instance where a person is new to the team and you actually don't want them to access the production service. Now he is in the production group, and by default he or she is granted access to that server, but you specifically want to deny access to that production server till the time he or she is matured enough to access or understand the process, understand the do's and don'ts before they can put their hands on the production server. So how do we go about doing it? So first we would categorize our instances. Well, these are critical instances. These are normal instances. And we would actually put a tag on them. That's how we categorize. Right? So you put a tag on them. Put a tag saying, well, they are highly critical, they are medium critical, and they are not critical at all. Still they're in production, stuff like that. And then you would pick the users who wants to, or who should be or should not be given access to a certain server. And you would actually allow the user to access or not access servers based on a specific tag. In other words, you can use actually tags. In the previous step, we put tags on the critical server, right? So you would define that this user is not going to use this tag. All right, this user is not allowed to use the resources with this tag. So that's how you would make your step forward. So you would allow or deny based on the tags that you have put. So in this case, he or she will not be allowed to servers which are tag critical servers. So that's how you deny access to them. And the same goes for bucket as well. Right, if an organization is excessively using S3 for their data storage because of the benefit that it provides, the cost and the durability, you might get asked this question, which is organizations would replicate the data from one region to another region for additional data durability and for having data redundancy. Not only for that, they would also do that for DR purposes, for disaster recovery. If the whole region is down, you still have the data available somewhere else and you can pick and use it. Some organizations would store data in different regions for compliance reasons, to provide low latency access to their users who are local to that region, stuff like that. So when companies do replication, how do you make sure that there is consistency in the replication? How do you make sure that the replication is not failing and the data gets transferred for sure and there are logs for that replication? This is something that the companies would use where they're excessively using S3 and they're fully relying on the replication in running their business. And the way we could do it is we can set up a replication monitor. It's actually a set of tools that we could use together to make sure that the cloud replication, region level replication is happening properly. So this is how it happens. Now on this side, on the left hand side, we have the region 1, and on the right hand side we have region 2, and region 1 is the source bucket and region 2 is the destination bucket. Alright, so object is put in the source bucket and it has to go directly to the region 2 bucket, or made a copy in the region 2 bucket. And the problem is sometimes it fails and there is no consistency between them. So the way you would do it is connect these services together and create an cross-replication or cross-region replication monitor that actually monitors your environment. So there are a CloudWatch that makes sure that the data is moved, no data is failing. Again, there's CloudWatch on the other end, make sure that the data is moving. And then we have the logs generated through CloudTrail, and that's actually written in DynamoDB. And if there is an error, if something is failing, you get notified through an SMS or you get notified through an email using the SNS service. So that's how we could leverage these tools and set up an cross-region replication monitor that actually monitors your data replication. Some common issues that companies face in VPC is that we all know that I can use Route 53 to resolve an IP address externally from the internet, but by default the servers won't connect to the other servers using our custom DNS name. That it does not do that by default. So it's actually a problem. There are some additional things that as an administrator or as an architect or as a person who uses it, you will have to do. And that's what we're going to discuss. So the question could be, VPC is not resolving the server through the DNS. You can access it through the IP, but not through the DNS name. And what could be the issue and how do you go about fixing it? And you will be able to answer this question only if you have done it already. It's a quick and simple step. By default, VPC does not allow, that's the default feature. And we will have to enable the DNS hostname resolution before. Now this is for the custom DNS, not for the default DNS that comes along. This is for the custom DNS. So we will have to enable the DNS hostname resolution. So we'll have to enable the DNS hostname resolution so they actually resolve. Let's say I want to connect to server1.simplylearn.com. By default it's not allowed, but if I enable this option, then I will be able to connect to server1.simplylearn.com. If a company has VPCs in different regions and they have a head office in a central place and the rest of them are branch offices, and they are connecting to the head office for access or for saving data or for accessing certain files or certain data or storing data, alright, so they would actually mimic the hub and spoke topology where you have the VPC which is centrally in an accessible region, a centrally accessible region, and then you would have a local VPCs or branch offices in different other regions, and they get connected to the VPC in the central location. And the question is, how do you actually connect the multiple sites to a VPC and make communication happen between them? By default, it does not do that. We know that VPCs, they need to be peered between them in order to access the resources. Let's look at this picture, right? So I have like a customer network or branch offices in different parts, and they get connected to a VPC. That's fine. So what we have achieved is those different offices, the remote offices, they are connecting to the VPC and they're talking, but they can't connect or they can't talk to each other. That's what we have built. But the requirement is the traffic needs to, or they should be able to talk to each other, but they should not have a direct connection between them, which means that they will have to come and hit the VPC and then reach the other customer network, which is in Los Angeles or which is in New York. Right? That's the requirement. So that's possible with some architecting in the cloud. So that's using VPN Cloud Hub. You look at these dotted lines, which actually allows customers, or which actually allows the corporate networks to talk to each other through the VPC. Again, by default, it doesn't happen. Cloud Hub is an architecture that we should be using to make this happen. And what's the advantage of it? As a central office or as the headquarters office, which is in the VPC, or headquarters data center, which is in the VPC, you have control, or the VPC has control on who talks to who, and what traffic can talk to, what traffic can be routed to the other head office, stuff like that. That centralized control is on the VPC. The other question you could get asked is, name and explain some security products and features available in VPC. Well, VPC itself is an security service. It provides security service to the application, but how do you actually secure the VPC itself? That's the question. And yes, there are products that can actually secure the VPC, or the VPC delivers those products to secure the application. Access to the VPC is restricted through a network access control list. Right? So that's an security product in VPC. And a VPC has security groups that protects the instances from unwanted inbound and outbound traffic, and network access control list protects the subnets from unwanted inbound and outbound access. And there are flow logs we can capture in VPC that captures incoming and outgoing traffic through a VPC, which will be used for later analysis, as in what's the traffic pattern, what's the behavior of the traffic pattern, stuff like that. So there are some security products and features available in VPC. Now, how do you monitor VPC? VPC is a very important concept, very important service as well. Everything sits in a VPC. Most of the service sits in a VPC. Except for Lambda and S3 and DynamoDB and a couple of other services. Most of them sit in a VPC for security reasons. So how do you monitor your VPC? How do you gain some visibility on your VPC? Well, we can gain visibility on our VPC using VPC flow log. That's the basic service. As you see, it actually captures what's allowed, what's not allowed, stuff like that. Which IP is allowed, which IP is not allowed, stuff like that. So we can gather it and we can use that for analysis. And the other one is CloudWatch and CloudWatch logs, the data transfers that happen. So this is who gets allowed and who does not get allowed. I mean, the flow logs is who is allowed and who's not allowed, that kind of detail. And CloudWatch gives information about the data transfer, how much data is getting transferred. We can actually pick unusual data transfers if there is a sudden hike in the graph. There's a sudden hike and something happens at 12 on a regular basis and you weren't expecting it. There's something suspicious. It could be valid backups. It could be a malicious activity as well. So that's how you know, by looking at CloudWatch logs and CloudWatch dashboard.
Now let's talk about multiple choice questions. When going for an interview, you might sometimes find yourself that the company is conducting an online test. Based on the score, they can put you to a panelist and then they would take it forward. So we thought we'll also include multiple choice questions to help you better handle such situation if you come across. Alright, when you find yourself in such situation, the key to clear them is to understand the question properly, read between the lines. That's what they say. There can be like a big paragraph with 3 lines or 10 lines. You really got to understand what the question is about and then try to find answer for that question. So that's a thumb rule number 1. And then the second rule is try to compare and contrast the services mentioned, or try to compare and contrast the answers. You can easily weed out 1 or 2 answers and then you will be left with only 2 answers to decide from. So that also helps you with time, and that also helps you with some precision in your answer. So number 1, read between the lines. Number 2, compare and contrast the services, and you'll be able to easily weed out the wrong ones. So let's try answering this question. Suppose you are a game designer and you want to develop a game with a single digit millisecond latency. Which of the following database services would you choose? So we know that the following are database services. Good enough. All right. And it talks about millisecond latency. That's a key point. And the third thing is it's a game. Could be a mobile game. It's a game that you are trying to design and you need millisecond latency and it has to be a database. Alright, so let's talk about the options available. RDS. RDS is a database for sure. Is it good for game design? We'll come back to that. Neptune. Neptune is a graph, a database service in Amazon. So that's kind of out of the equation. And Snowball is actually a storage. Alright, it's a transport medium, I would say. So that's again out of the equation. So the tie is between RDS and DynamoDB. So if we need to talk about RDS, RDS is a platform as a service. It provides cost-efficient, resizable capacity, but it's an SQL database, meaning the tables are kind of strict. It's good for banking and other
type of applications, but not really good for anything that has to do with gaming. So the only option left is DynamoDB. Again, it's the right answer. DynamoDB is actually an fast and flexible NoSQL database service, and it provides a single-digit millisecond latency at any scale. And it's a database at the same time. It's a key value store model database. So the right answer is DynamoDB. All right, let's look at the next question. If you need to perform real-time monitoring of AWS services and get actionable insights, which service would you use? All right, let's list the services. So it talks about real-time monitoring. A firewall manager, what does it provide? Now, firewall manager is not really a monitor, just like the name says, it's a manager. It manages multiple firewalls. And AWS Guard Duty is an threat detection service. It does monitoring. It does continuously monitor our environment, but it monitors for threats. All right, only threats. Now let's talk about CloudWatch. CloudWatch is a service that helps to track metrics. It's a service that is used to monitor the environment and give us a system-wide visibility, and also it helps us to store logs. So at the moment it kind of looks like that could be the right answer. We don't know that yet, but I mean, we have one more option left, that's EBS. So what's EBS? EBS is a block storage, elastic block store. If we abbreviate EBS, it's elastic block store. So all three of them are easily out of the question. The first one is to manage, second one is to find threats. Of course, it does monitoring. So there's, if there is one relation between CloudWatch and Guard Duty, that's monitoring. So easily we can actually find ourselves slipped towards picking Guard Duty, but know that Guard Duty is only for gaining security insight, but not about gaining AWS service insight. So CloudWatch is a service that helps us to get a system-wide or an AWS-wide or an account-wide. And it has a number of metrics we can monitor and get a very good insight of how a service is performing, be it CPU, be it RAM, be it network utilization, be it connection failures. CloudWatch is a service that helps us perform a real-time monitoring and get some actionable insights on the services. All right, let's talk about this 33rd question. As a web developer, you are developing an app especially for the mobile platform. All right, there is a mention that this is especially for the mobile platform. So a lot of services gets filtered out, mobile platform. Right, which of the following lets you add user sign up, sign in, and access control to your web and mobile app quickly and easily? All right, so this is all about signing in to your mobile app. So if we need to read between the lines, that's how we can read sign up or sign in into an mobile platform. All right, so we have like four options here: Shield, AWS Massey, AWS Inspector, Amazon Cognito. So let's try to weed out services which are not relevant to it. So what's AWS Shield? AWS Shield is actually a service that provides a DDoS mitigation or a DDoS protection, denial of service protection. It's a security feature. Let's talk about the second option. AWS Massey is again a security service that uses machine learning to automatically discover and classify the data. It again talks about security, and this security is all about encrypting or saving the data. It does not come close with signing up an mobile platform. All right, let's talk about the other one, AWS Inspector. Now, AWS Inspector has something to do with apps. It definitely has something to do with apps. So kind of looks like that's relevant as of now. So it actually helps with improving the security and compliance of the apps that we deploy in the cloud. So kind of looks like it could be because it has to do with apps. The last one, Cognito. Now, Cognito is a service that actually lets the administrator to have control access over web and mobile apps. And it's a service that helps us to sign up and sign in to an mobile and web app. So that very much looks like we found the answer. So Cognito is a service that helps web app and mobile app for sign up and signing in, and also gives the administrator to have control over access control over the web and the mobile app, Pretty much, we found it. So it's Cognito. Cognito is a service that helps us to set up, sign in, and have access control over the users who would be using our mobile and web app. Alright, how about this question? You are an ML engineer or a machine learning engineer who's on the lookout for a solution that will discover sensitive information that your enterprise stores in AWS and then uses NLP to classify that data and provide business related insights. Which among the following services would you choose? So we have a bunch of services that's going to help us achieve, or one of it is going to help us achieve the above requirement. So it's a service that deals with machine learning. You're a machine learning engineer who's looking for a service that will help you to discover information at your enterprise store. So we're talking about storage, discover information in store, and then classify the data depending on severity, the sensitivity, classify the data. So which service is that? So firewall manager, just like the name says, it's a manager. And AWS IAM, if we abbreviate it, it's Identity and Access Management. So it's Identity and Access Management, nothing to do with identifying sensitive data and managing it. So the first two is already out of the equation. And then the AWS Massey, we already had a quick definition description for AWS Massey, that it's actually a security service that uses machine learning. It kind of looks like it could be it. It's a security service that uses machine learning, and it discovers and classifies the sensitive information. Not only that, it does not stop there. It goes beyond and protects the sensitive data. AWS Massey kind of looks like, but we still have one more option to look at, which is Cloud HMS. Cloud HMS is also a security service. Kind of looks like that could be the answer as well. And it enables us to generate encryption keys and save the data. So kind of 50% of it. It's a security service. It encrypts, helps us protect the data, but AWS Massey is right on spot. It's a machine learning service. It helps us to classify the data and also to protect the data. So the answer for this question would be AWS Massey. So hope you kind of get it how this is going. So first we apply the thumb rule, identify the question that's being asked, read between the lines, and then try to find the service that meets your requirement. And finding the service is by first weeding out the wrong ones, recollect everything that you've learned about the service and see how well that matches with those hints that you have picked up. And if that doesn't match, weed that out, and you'll end up with just two to decide from at some point, and then it becomes easy for you to decide. Click on the question, submit it, and then move on to the other question in your interview. Alright, so how about this one? You are a system administrator in your company which is running most of its infrastructure on AWS. You are required to track your users and keep a look on how your users are being authenticated. Alright, so this is where the problem statement starts. Alright, you need to keep track of how your users are being authenticated, and you wish to create and manage AWS users and use permissions to allow and deny their access to the AWS resources. Alright, so you are to give them permission, number one, and then, if we put them in the right order, first giving them permissions and then tracking their usage. Let's see which of the service will help us achieve it. IAM is a service that helps us to, looking at the permissions, we can actually predict whether the user or the group will have service or not. So that helps us to get a track of who is able to use, who's not able to use certain service and all that stuff. So it kind of looks like, but we have other three options left. Let's look at AWS Firewall Manager. Just like the name says, it's actually a firewall manager. It helps us to manage multiple firewalls. Simple as that. And Shield is a service. It's a service that's used to protect denial of service or distributed denial of service. An API gateway is a service that makes it easy for developers to create, publish, maintain, and monitor and secure APIs. So, it's completely on the API side, very less on user and how you authenticate your user. We can get that by looking at the name itself, right? If we abbreviate it, or if you try to find a definition for the name API gateway, you would get it. It has to do with API. But if we abbreviate AWS IAM, it's Identity and Access Management, pretty much meets the requirement for the problem statement above. It's AWS Identity and Access Management. That's the right answer. Alright, let's look at this one. If you want to allocate various private and public IP address in order to make them communicate with the internet and other instances, you will use this service. Which of the following is this service? So it talks about using public and private IP address. So this service uses IP address, and then this service helps us to allow and deny connections to the internet and to the other instances. So you get the question, is it? Let's pick the service that helps us achieve it. Route 53. Route 53 is actually a DNS service, right? It's not a service that's used to allow or deny. No, it does not do that. VPC uses public and private IP address. Yes. So kind of looks like VPC helps us to allow, the security in VPC, the security group, the network access control list in a VPC, the routing table in a VPC, that actually helps us to allow or deny a connection to a particular IP address or to a particular service within the VPC or outside of the VPC. So as of now, it kind of looks like it could be, but let's look at the other services. What if we find a service that closely matches to the above requirement than the Amazon VPC? Gateway, API gateway. We know that it's a managed service that makes it easy for developers to create, publish, maintain and monitor APIs and secure APIs. So that has completely to do with API, not with IP. CloudFront, we know about CloudFront that it's a content delivery network, and it provides global distribution of servers where our content can be cached. It could be video or bulk media or anything else. They can be cached locally, so users can easily access them and download them easily. All right, so that's CloudFront. Now at this point, after looking at all four, it looks like VPC is the right answer, and in fact VPC is the right answer. VPC has public IP address. VPC can help us with private IP address. VPC can be used to allow, deny connection based on the security group, access control list, and the routing table it has. So that's right answer is VPC. Alright, how about this one? This platform as a service or platform as a DB service provides us with a cost-efficient and resizable capacity while automating time-consuming administrative tasks. So this question is very clear. It's a DB service we got to look for, and it's a service that can provide automating some of the time-consuming tasks. It has to be resizable at the same time. So let's talk about Amazon Relational Database. It's a database. Kind of matches the requirement. We can resize it as and when needed. All right, looks like it's a fit as of now. It actually automates some of the time consuming work. Looks like it's a fit as of now. Let's move on to Elastic Cache and then try to see if that matches the definition that we've figured out above. Elastic Cache, it's actually a caching service. It's again an in-memory data store which helps in achieving high throughput and low latency in memory data store. So it's not a full-blown database, and it does not come with any Amazon provisioned automation in it for automating any of the administration tasks. No, it does not come up with anything like that. Yeah, we can resize the capacity as and when needed, but automation, it's not there yet, and moreover it's not a database. So that's out of the equation. VPC is not a resizable one. Once we have designed VPC, it's fixed. It can't be resized. So that's out of the equation. And Amazon Glacier is a storage but not a database. Right, so that's again out of the equation. So the tie is kind of between Amazon Relational Database Service and Amazon Elastic Cache, because they both aid the database service, but Elastic Cache is not a full-blown database. It actually helps the database, but it's not a full-blown database. So it's Amazon Relational Database. So that's the one which is a platform as a service. It's the one which can be resized. It's the one which can be used to automate the time-consuming administrative tasks. Alright, let's talk about this one. Which of the following is a means for accessing human researchers or consultants to help solve a problem on a contractual or a temporary basis? Alright, let's read the question again. Which of the following is a means for accessing human researchers or consultant to help solve problems on a contractual or a temporary basis? It's like assigning tasks or hiring AWS experts for a temporary job. So let's try to find that kind of service in the 4 services that are listed. Amazon Elastic MapReduce. MapReduce is actually an framework service that makes it easy and cost effective to analyze large amount of data, but that has nothing to do with accessing human researchers. All right, let's talk about Mechanical Turk. It's a web service that provides a human workforce. That's the definition for it. For example, automation is good, but not everything can be automated. For something to qualify for automation, it has to be a repetitive task. A one-time task can't be automated, or the time and money that you would be spending in automation is not worth it. Instead, you could have done it manually. So that does not qualify for automation. And anything that requires intelligence, right? Anything that's a special case. Right? Automation can do repetitive tasks. Automation can do precise work, but it has to be a repetitive task. The scenario, it should have been there already. Only then that can be executed. But if it's a new scenario and it requires appropriate addressing, then it requires human task. So we could hire researchers and consultants who can help solve a problem using Amazon Mechanical Turk. The other 2 are already out of the equation. Now DevPay is actually a payment system through Amazon, and multi-factor authentication, as it says, it's an authentication system. So the right answer is Amazon Mechanical Turk. Alright, this sounds interesting. Let's look at this one. This service is used to make it easy to deploy, manage, and scale containerized applications using Kubernetes on AWS. Which of the following is this AWS service? So it's a service to deploy, manage, and scale containerized applications. So it deals with containers. It also should have the ability to use Kubernetes, which is a container orchestration service. Alright, the first one, Amazon Elastic Container Service. Kind of looks like it's the one. The name itself has the word and the relation we're looking for, Elastic Container Service. So this container service is an highly scalable, high performance container orchestration service. Let's look at the other one, AWS Batch. It's a service that enables IT professionals to schedule and execute batch processing. I mean, the name itself says that that's meant for batch processing. Elastic Beanstalk, that's another service that helps us to deploy, manage, and scale, but it helps us with EC2 instances, not with containerized instances. So that's again out of the equation. Would Lightsail be a good tie for Elastic Container Service? What's Lightsail? Now, Lightsail is a service. It's called as a virtual private server without a VPC. It's called as a virtual private server. It comes with predefined compute, storage, networking capacity. It's actually a server, not a container. Right, so at this point that also becomes out of the equation. So it's Amazon Elastic Container Service. That's the one that helps us to easily deploy, manage, scale container services, and it helps us orchestrate the containers using Kubernetes. Alright, how about this one? Alright, this service lets us to run code without provisioning or managing servers. So no servers, run code. Select the correct service from the below option. Alright, so no servers, but we should be able to run code. Amazon EC2 AutoScaling. EC2 AutoScaling. EC2 is Elastic Compute Cloud, which is a server, and AutoScaling is a service that helps us to achieve scaling the server. So that's the definition for it. Could be that's out of the equation. AWS Lambda. Now Lambda is a service. It's actually an event-driven serverless computing platform, and Lambda runs code in response to the event that it receives, and it automatically manages the compute resource that's required for that code. As long as we have uploaded a code that's correct and set up events correctly to map to that code, it's going to run seamlessly. So that's about Lambda. It kind of looks like it could be the answer because Lambda runs code. We don't have to manage servers. It manages servers by itself. But we can't conclude as of now. We have other 2 services to talk about. AWS Batch. Alright, Batch is a service that enables IT professionals to run batch job. We know that. And about Inspector, Amazon Inspector, it's actually a service that helps us to increase and identify any security issues and align our application with compliance. Well, that's not the requirement in the question. The the requirement and the question was run code without provisioning a server. And without any more space for confusion, AWS Lambda is a service, or is the service that runs code without provisioning and managing services. Right? The right one would be AWS Lambda. Let's get started. So in an environment where there is a lot of automation, infrastructure automation, you'll be posted with this question: how can you add an existing instance to a new autoscaling group? Now this is when you are taking an instance away from the autoscaling group to troubleshoot, to fix a problem, to look at logs, or if you have suspended the autoscaling, you might need to re-add that instance to the autoscaling group. Only then it's going to take part in it, right? Only then the autoscaling is going to count it as part of it. It's not a straight procedure. When you remove them, it doesn't get automatically re-added. And I've worked with some clients when their developers were managing their own environment, they had problems adding the instance back to the autoscaling group. Irrespective of what they tried, the instance was not getting added to the autoscaling group, and whatever they fix that they were provided, or whatever fix that they have provided, were not getting counted in the autoscaling group. So like I said, it's not a straight a click button procedure. There are ways we'll have to do it. So how can you add an existing instance to the autoscaling group? There are a few steps that we need to follow. So the first one would be to, under the EC2 instance console, right, under the instance, under actions in specific, there's an option called attach to autoscaling group, right? If you have multiple autoscaling groups in your account or in the region that you're working in, then you're going to be posted with the different autoscaling groups that you have in your account. Let's say you have 5 autoscaling groups for 5 different applications. You're going to be posted with 5 different autoscaling groups, and then you would select the appropriate autoscaling group and attach the instance to that particular autoscaling group. While adding to the autoscaling group, if you want to change the instance type, that's possible as well. Sometimes when you want to add the instance back to the autoscaling group, there would be requirement that you change the instance type to a better one, to a better family, to the better instance type. You could do that at that time. And after that, you have completely added the instance back to the autoscaling group. So it's actually a 7-step process, adding an instance back to the autoscaling group. In an environment where they're dealing with migrating the instance, or migrating an application, or migrating an instance, migrating an VM into the cloud, if the project that you're going to work with deals with a lot of migrations, you could be posted this question: what are the factors you will consider while migrating to Amazon Web Services? The first one is cost. Is it worth moving the instance to the cloud? Given the additional bells and whistles features available in the cloud, is this application going to use all of them? Is moving into the cloud beneficial to the application in the first place? Beneficial to the users who will be using the application in the first place. So that's a factor to think of. So this actually includes cost of the infrastructure and the ability to match the demand and supply transparency. Is this application in high demand? Is it going to be a big loss if the application becomes unavailable for some time? So there are a few things that needs to be considered before we move the application to the cloud. And then if the application needs to be provisioned immediately, is there an urge? Is there an urge to provision the application immediately? That's something that needs to be considered. If the application requires to go online, if the application needs to hit the market immediately, then we would need to move it to the cloud. Because in on-premises, procuring, or buying an infrastructure, buying the bandwidth, buying the switch port, buying an instance, buying the softwares, buying the license related to it, it's going to take time, at least like 2 weeks or so, before you can bring up an server and launch an application in it, right? So if the application cannot wait, waiting means workforce productivity loss, is it? So we would want to immediately launch instances and put application on top of it. In those cases, if your application is of that type, if there is an urge in making the application go online as soon as possible, then that's a candidate for moving to the cloud. And if the application, or if the software, or if the product that you're launching, it requires hardware, it requires an updated hardware all the time, that's not going to be possible in on-premises. We try to deal with legacy infrastructure all the time in on-premises, but in the cloud, they're constantly upgrading their hardwares. Only then they can keep themselves up going in the market. So the cloud providers are constantly updating their hardwares. And if you want to be benefited, or if your application wants to be benefited by the constant upgrading of the hardwares, making sure the hardware is as latest as possible, the software version, the licensing is as latest as possible, then that's a candidate to be moved to the cloud. And if the application does not want to go through any risk, if the application is very sensitive to failures, if the application is very much tagged to the revenue of the company, and you don't want to take a chance in seeing the application fail and seeing the revenue drop, then that's a candidate for moving to the cloud. And business agility, moving to the cloud, at least half of the responsibility is now taken care by the provider. In this case, it's Amazon. At least half of the responsibility is taken care by them. Like if the hardware fails, Amazon makes sure that they're fixing the hardware immediately. And notifications, if something happens, there are immediate notifications available that we can set it up and make ourselves aware that something has broken, and we can immediately jump in and fix it. So you see, the responsibility is now being shared between Amazon and us. So if you want to get that benefit for your application, for your organization, for the product that you're launching, then it needs to be moved to the cloud so you can get that benefit from the cloud. The other question you could get asked is, what is RTO and RPO in AWS? They are essentially disaster recovery terms. When you're planning for disaster recovery, you cannot avoid planning disaster recovery without talking about RTO and RPO. Now, what's the RTO? What's the RPO in your environment? Or how do you define RTO? How do you define RPO? Are some general questions that get asked. RTO is recovery time objective. RTO stands for the maximum time the company is willing to wait for the recovery to happen, or for the recovery to finish when a disaster strikes. So RTO is in the future, right? How much time is it going to take to fix and bring everything to normal? So that's RTO. On the other hand, RPO is recovery point objective, which is the maximum amount of data loss your company is willing to accept as measured in time. RPO always refers to the backups, the number of backups, the frequency of the backups, right? Because when an outage happens, you can always go back to the latest backup, right? And if the latest backup was before 12 hours, you have lost the in-between 12 hours of data storage, right? So RPO is the acceptable amount. If the company wants less RPO is 1 hour, then you should be planning on taking backups every 1 hour. If RPO is 12 hours, then you should be planning on taking backups every 12 hours. So that's how RPO and RTO helps disaster recovery. The fourth question you could get asked is, if you'd like to transfer huge amount of data, which is the best option among Snowball, Edge, and Snowmobile? Again, this is a question that gets asked if the company is dealing with a lot of data transfer into the cloud, or if the company is dealing with migrating data into the cloud. I'm talking about a huge amount of data in petabytes. Snowball and all of the Snowball series deals with the petabyte-sized data migrations. So there are three options available as of now. AWS Snowball is an data transport solution for moving high volume of data into and out of a specified AWS region. On the other hand, AWS Snowball Edge adds additional computing functions. Snowball is simple storage and movement of data, and Snowball Edge has a compute function attached to it. Snowmobile, on the other hand, is an exabyte scale migration service that allows us to transfer data up to 100 petabytes. That's like 100,000 terabytes. So depending on the size of data that we want to transfer from our data center to the cloud, we can rent any of these three services. Let's talk about some cloud formation questions. This is a classic question. How is AWS Cloud Formation different from AWS Elastic Beanstalk? From the surface, they both look like the same. You don't go through the console provisioning resources. You don't go through CLI and provision resources. Both of them provision resources through click button. Right? But underneath, they are actually different services. They aid different services. So knowing that is going to help you understand this question a lot better. Let's talk about the difference between them, and this is what you will be explaining to the interviewer or the panelist. So the cloud formation service helps you describe and provision all the infrastructure resources in the cloud environment. On the other hand, Elastic Beanstalk provides an simple environment to which we can deploy and run application. CloudFormation gives us an infrastructure, and Elastic Beanstalk gives us a small contained environment in which we can run our application. And CloudFormation supports the infrastructure needs of many different types of application, like the enterprise application, the legacy applications, and any new modern application that you want to have in the cloud. On the other hand, the Elastic Beanstalk, it's a combination of developer tools. They are tools that helps manage the life cycle of a single application. So CloudFormation, in short, is managing the infrastructure as a whole, and Elastic Beanstalk, in short, is managing and running an application in the cloud. And if the company that you're getting hired is using CloudFormation to manage their infrastructure, or if they're using infrastructure or any of the infrastructure as a code services, then you would definitely face this question: what are the elements of an AWS CloudFormation template? So it has 4 or 5 basic elements, right? And the template is in the form of JSON or in YAML format. Right, so it has parameters, it has outputs, it has data, it has resources, and then the format or the format version or the file format version for the CloudFormation template. So parameter is nothing but it actually lets you to specify the type of EC2 instance that you want, the type of RDS that you want, right? So EC2 is an umbrella, RDS is an umbrella, and parameters within that EC2 and parameters within that RDS are the specific details of the EC2 or the specific details of the RDS service. So that's what parameters in a CloudFormation template. And then the element of the CloudFormation template is outputs. For example, if you want to output the name of an S3 bucket that was created, if you want to output the name of the EC2 instance, if you want to output the name of some resources that have been created, instead of looking into the template, instead of navigating through in the console and finding the name of the resource, we can actually have them outputted in the result section. So you can simply go and look at all the resources created through the template in the output section, and that's what output values or output does in the CloudFormation template. And then we have resources. Resources are nothing but what defines what are the cloud components or cloud resources that will be created through this CloudFormation template. Now, EC2 is a resource, RDS is a resource, and S3 bucket is a resource, Elastic Load Balancer is a resource, and NAT Gateway is a resource, VPC is a resource. So you see, all these components are the resources, and the resource section in the CloudFormation defines what are the AWS cloud resources that will be created through this CloudFormation template. And then we have version. Version actually identifies the capabilities of the template. We just need to make sure that it is of the latest version type, and the latest version is 0909 2010. That's the latest version number. You'll be able to find that on the top of the CloudFormation template, and that version number defines the capabilities of the CloudFormation template. So just need to make sure that it's the latest all the time. Still talking about CloudFormation, this is another classic question: what happens when one of the resources in a stack cannot be created successfully? Well, if the resource in a stack cannot be created, the CloudFormation automatically rolls back and terminates all the resources that was created using the CloudFormation template. So whatever resources that were created through the CloudFormation template from the beginning, let's say we have created like 10 resources and the 11th resource is now failing, CloudFormation will roll back and delete all the 10 resources that were created previously. And this is very useful when the CloudFormation cannot go forward. CloudFormation cannot create additional resources because we have reached the Elastic IP limits. Elastic IP limit per region is 5, right? And if you have already used 5 IPs and your CloudFormation is trying to buy 3 more IPs, we've hit the soft limit. Till we fix that with Amazon, CloudFormation will not be able to launch additional resources and additional IPs. So it's going to cancel and roll back everything. That's true with a missing EC2 AMI as well. If an AMI is included in the template but the AMI is not actually present, then CloudFormation is going to search for the AMI, and because it's not present, it's going to roll back and delete all the resources that it created. So that's what CloudFormation does. It simply rolls back all the resources that it created. I mean, if it sees a failure, it would simply roll back all the resources that it created. And this feature actually simplifies the system administration and layered solutions built on top of AWS CloudFormation. So at any point, we know that there are no orphan resources in our environment, because something did not work, or because there was an CloudFormation executed some, there are no orphan resources in our account. At any point, we can be sure that if CloudFormation is launching a resource and if it's going to fail, and it's going to come back and delete all the resources it's created, so there are no orphan resources in our account. Now let's talk about some questions in Elastic Block Store. Again, if the environment deals with a lot of automation, you could be thrown this question: how can you automate EC2 backup using EBS? It's actually a 6-step process. To automate the EC2 backups, we'll need to write a script to automate the below steps using AWS API. And these are the steps that should be found in the scripts. First, to get the list of instances, and then the script that we are writing should be able to connect to AWS using the API and list the Amazon EBS volumes that are attached locally to the instance. And then it needs to list the snapshots of each volume, make sure the snapshots are present, and it needs to assign a retention period for the snapshot, because over time the snapshots are going to be invalid, right? Once you have some 10 latest snapshots, any snapshot that you have taken before that 10 becomes invalid because you have captured the latest, and 10 snapshot coverage is enough for you. And then the 5th point is to create a snapshot of each volume, create a new snapshot of each volume, and then delete the old snapshot. Anytime a new snapshot gets created, the oldest snapshot in the list needs to go away. So we need to include options, we need to include scripts in our script, lines in our script that make sure that it's deleting the older snapshots which are older than the retention period that we are mentioning. Another question that you could see in the interview, be it a written interview, be it online interview, or be it an telephonic or face-to-face interview, is what's the difference between EBS and Instant Store? Let's talk about EBS first. EBS is kind of permanent storage. The data in it can be restored at a later point. When we save data in EBS, the data lives even after the lifetime of the EC2 instance. For example, we can stop the instance and the data is still going to be present in EBS. We can move the EBS from one instance to another instance and the data is simply going to be present there. So EBS is kind of permanent storage when compared to instance. On the other hand, Instance Store is temporary storage, and that storage is actually physically attached to the host of the machine. EBS is an external storage, and Instance Store is locally attached to the instance, or locally attached to the host of the machine. We cannot detach an Instance Store from one instance and attach it to another, but we can do that with EBS. So that's a big difference. One is permanent data and another one is EBS is permanent, Instance Store is volatile data, and with Instance Store we won't be able to detach the storage and attach it to another instance. And another feature of instance store is data in an instance store is lost if the disk fails or the instance is stopped or terminated. So instance store is only good for storing cache data. If you want to store permanent data, then we should think of using EBS and not instance store. While talking about storage on the same lines, this is another classic question. How can you take backups of EFS like EBS? And if you can take backup, how do you take that backup? The answer is yes, we can take EFS to EFS backup solution. EFS does not support snapshot. Like EBS, EFS does not support snapshot. Snapshot is not an option for EFS, Elastic File System. Right? We can only take backup from one EFS to another EFS, and this backup solution is to recover from unintended changes or deletions of the EFS, and this can be automated. Right? Any data that we store in EFS can be automatically replicated to another EFS, and once this EFS goes down or gets deleted or data gets deleted, or the whole EFS is for some reason interrupted or deleted, we can recover the data we can use the other EFS and bring the application to consistency. And to achieve this, it's not an one-step configuration. It's a cycle. There are a series of steps that's involved before we can achieve EFS to EFS backup. The first thing is to sign in to the AWS Management Console, and under EFS, or click on EFS to EFS restore button from the services list, and from there we can use the region selector in the console navigation bar to select the actual region in which we want to work on, and from there ensure that we have selected the right template. Some of the templates would be EFS to EFS backup, granular backups, incremental backups. Right, so there are some templates, the kind of backups that you want to take. Do you want to take granular? Do you want to take increment backups? Stuff like that. And then create a name to that solution, the kind of backup that we have created. And finally review all the configurations that you have done and click on save. And from that point onwards, the data is going to be copied. And from that point onwards, any additional data that you put is going to copy it and replicate it. Now you have an EFS to EFS backup. This is another classic question in companies which deals with data management. There are easy options to create snapshots, but deleting snapshots is not always an click button or a single step configuration. So you might be facing a question like, how do you auto delete old snapshots? And the procedure is like this. Now, as best practice, we will take snapshots of EBS volume to S3. All snapshots get stored in S3. We know that now. And we can use AWS Ops Automator to automatically handle all snapshots. The Ops Automator service, it allows us to create, copy, delete EBS snapshots. So there are CloudFormation templates available for AWS Ops Automator, and this Automator template will scan the environment and it would take snapshots. It would copy the snapshot from one region to another region if you want, if you're setting up a DR environment. And not only that, based on the retention period that we create, it's going to delete the snapshots which are older than the retention period. So life or managing snapshot is made a lot easier because of this Ops Automator CloudFormation template. Moving into questions in Elastic Load Balancer, this again could be a question in the interview. What are the different types of load balancers in AWS and what's their use case? What's the difference between them? And as of now, as we speak, there are three types of load balancers which are available in AWS. The first one being application load balancer. Just like the name says, the application load balancer works on the application layer and deals with HTTP and HTTPS requests. And it also supports path-based routing. For example, Simplilearn.com / some web page, Simplilearn.com / another website. So it's going to direct the path based on the / value that you give in the URL. So that's path-based routing. So it supports that. And not only that, it can support port-based :8080, :8081, or :8090, based on that port also, it can take a routing decision, and that's what application load balancer does. On the other hand, we have network load balancer, and the network load balancer makes routing decisions at the transport level. It's faster because it has very less thing to work on. It works on lower OSI layer. It works on a lower layer, so it has very less information to work with than compared with application layer. So comparatively, it's a lot faster, and it handles millions of requests per second. And after the load balancer receives a connection, it selects a target group for the default rule using the flow hash routing algorithm. It does simple routing, right? It does not do path-based or port-based routing. It does simple routing, and because of it, it's faster. And then we have classic load balancer, which is kind of expiring as we speak. Amazon is discouraging people using classic load balancer, but there are companies which are still using classic load balancer. They are the ones who were the first one to step into Amazon when classic load balancer was the first load balancer or the only load balancer available at that point. So it supports HTTP, HTTPS, TCP, SSL protocol, and it has a fixed relationship between a load balancer port and the container port. So initially we only had classic load balancer, and then after some point Amazon said, instead of having one load balancer address all type of traffic, we're going to have two load balancers called as the child from the classic, two load balancer, and one is going to specifically address the application requirement and one is going to specifically address the network requirement, and let's call it as application load balancer and network load balancer. So that's how now we have two different load balancers. Talking about load balancer, another classic question could be, what are the different uses of the various load balancer in AWS Elastic load balancing? There are three types of load balancer. We just spoke about it. Application load balancer is used if we need flexible application management and TLS termination, and network load balancer if we require extreme performance and the load balancing should happen based on static IPs for the application. And classic load balancer is an old load balancer which is for people who are still running their environment from EC2 classic network. Now this is an older version of VPC, or this is what was present before VPC was created. EC2 classic network is what was present before EC2 was created. So they are the three types and they are the use cases of it. Let's talk about some of the security related questions you would face in the interview. When talking about security and firewall in AWS, we cannot avoid discussion talking about WAF, Web Application Firewall, and you would definitely see yourself in this situation where you've been asked how can you use AWS WAF in monitoring your AWS applications. WAF or Web Application Firewall protects our web application from common web exploits, and WAF helps us control which traffic source your application should be allowed or blocked, which traffic from a certain source, which source or which traffic from a certain source should be allowed or blocked to your application. With WAF, we can also create custom rules that blocks common attack patterns. If it is a banking application, it has a certain type of attacks, and if it is simple data management, data storage application, it has content management application, it has a separate type of attack. So based on the application type, we can identify a pattern and create rules that would actually block that attack based on the rule that we create. And WAF can be used for three cases. The first one is allow all requests, and then block all requests, and count all requests for a new policy. So it's also an monitoring and management service which actually counts all the policies or counts all the requests that matches a particular policy that we create. And some of the characteristics we can mention in AWS WAF are the origin IPs and the strings that appear in the request. We can allow block based on origin IP, allow block based on strings that appear in the request. We can allow block or count based on the origin country, length of the request. We can block and count the presence of malicious scripts in an connection. We can count the request headers, or we can allow block a certain request header, and we can count the presence of a malicious SQL code in a connection that we get and that want to reach our application. Still talking about security, what are the different AWS IAM categories we can control? Using AWS IAM, we can do the following. One is create and manage IAM users. And once the user database gets bigger and bigger, we can create and manage them in groups. And in IAM, we can use it to manage the security credentials, kind of setting the complexity of the password, setting additional authentications, like MFA, and rotating the passwords, resetting the password. There are a few things we could do with IAM. And finally, we can create policies that actually grants access to AWS services and resources. Another question you will see is, what are the policies that you can set for your user's password? So some of the policies that we can set for the user password is the minimum length, or the complexity of the password by at least having one number or one special characters in the password. So that's one. And then the requirement of a specific character types, including uppercase, lowercase, number, and non-alphabetic characters. So it becomes very hard for somebody else to guess what the password would be and try to hack them. So we can set the length of the password, we can set the complexity in the password, and then we can set an automatic expiration of the password. So after a certain time, the user is forced to create a new password, so the password is not stale, old, and easy to guess in the environment. And we can also set settings like the user should contact the admin when the password is about to expire. So you can get a hold of how the user is setting their password. Is it having good complexity in it? Is it meeting company standards? Or there are a few things that we can control and set for the users when the users are setting or recreating the password. Another question that could be posted in an interview, so to understand your understanding of IAM, is what's the difference between an IAM role and an IAM user? Let's talk about IAM user. Let's start small and then go big, or let's start simple and then talk about the complex one. The IAM user has a permanent long-term credential, and it's used to interact directly with AWS services. And on the other hand, IAM role is an IAM entity that defines a set of permissions for making AWS service requests. So IAM user is an permanent credential and role are temporary credentials. And IAM user has full access to all AWS IAM functionalities. And with role, trusted entities such as IAM users, application, or AWS services assume the role. So when an IAM user is given a permission, it sticks within the IAM user. But with roles, we can give permissions to applications, we can give permissions to users in the same account, in a different account, corporate ID. We can give permissions to EC2, S3, RDS, VPC, and lot more. Role is wide, and IAM user is not so wide. It's very constrained only for that IAM user. Let's talk about managed policies in AWS. Managed policies, there are two types, customer managed and Amazon managed. So managed policies are IAM resources that express permissions using the IAM policy language. We can create policies, edit them, manage them separately from the IAM user group and roles which they are attached to. So they are something that we can do to managed policies if it is customer managed. And we can now update policy in one place, and the permissions automatically extend to all the attached entries. So I can have like 3 services, 4 services point to a particular policy, and if I edit that particular policy, it's going to reflect on those 3 or 4 services. So anything that I allow is going to be allowed for those 4 services. Anything that I denied is going to be denied for the 4 services. Imagine what would be without the IAM managed policy. We'll have to go and specifically allow deny on those different instances 4 or 5 times, depending on the number of instances that we have. So like I said, there are 2 types of managed policies. One is managed by us, which is customer managed policies, and then the other is managed by AWS, which is AWS managed policy. This question, can you give an example of an IAM policy and a policy summary? This is actually to test how well versed are you with the AWS console. The answer to that question is, look at the following policy. This policy is used to grant access to add, update, and delete objects from a specific folder. In this case, name of the folder is example folder, and it's present in a bucket called example bucket. So this is an IAM policy. On the other hand, the policy summary is a list of access level, resource, and conditions for each service defined in a policy. So IAM policy is all about one particular resource, and the policy summary is all about multiple resources. With IAM policy, it was only talking about S3 bucket and one particular S3 bucket. Here it talks about CloudFormation template, CloudWatch logs, EC2, Elastic Beanstalk services. Summary of resources and the permissions and policies attached to them. That's what policy summary is all about. Another question could be like this: what's the use case of IAM and how does IAM help your business? Two important or primary work of IAM is to help us manage IAM users and their access. It provides secure access to multiple users to their appropriate AWS resources. So that's one it does. And the second thing it does is manage access for federated users. Federated users or non-IAM users, and through IAM we can actually allow and provide secure access to resources in our AWS account to our employees without the IAM user. Now, they could be authenticated using the Active Directory, they could be authenticated using the Facebook credential, Google credential, Amazon credential, and a couple of other credentials, third-party identity management, right? So we could actually trust them and we could give them access to our account based on the trust relationship that we have built with the other identity systems. All right, so two things. One is manage users and their access manage IAM user and their access in our AWS environment, and second is manage access for federated users who are non-IAM users. And more importantly, IAM is a free service, and with that will only be charged for the use of the resources, not for the IAM username and password that we create. All right, let's now talk about some of the questions in Route 53. One classic question that could be asked in an interview is, what is the difference between latency-based routing and geo-DNS or geo-based DNS routing? Now, the geo-based DNS routing takes routing decisions on the basis of the geographic location of the request. And on the other hand, the latency-based routing utilizes latency measurements between networks and data centers. Now, latency-based routing is used where you want to give your customers the lowest latency as possible. So that's when we would use latency-based routing. And on the other hand, geo-based routing is when we want to direct customers to different websites based on the country they are browsing from. You could have two different or three different websites for the same URL. Take Amazon, the shopping website, for example. When we go to Amazon.com from in the US, it directs us to the US web page where the products are different, the currency is different, right, and the flag and a couple of other advertisements that shows up are different. And when we go to Amazon.com from India, it gets directed to the Amazon.com Indian site, where again the currency, the product, and the advertisements, they're all different, right? So depending on the country they're trying to browse, if you want to direct customers to 2 or 3 different websites, we would use geo-based routing. Another use case of geo-based routing is if you have a compliance that you should handle all the DNS requests, or if you should handle all the requests from a country within the country, then you would do geo-based routing. Now, you wouldn't direct the customer to a server which is in another country, right? You would direct the customer to a server which is very local to them. That's another use case of geo-based routing. And like I said, for latency-based routing, the whole goal or aim is to achieve minimum end-user latency. If you are hired for the architect role and if that requires working a lot on the DNS, then you could be posted with this question: what is the difference between domain and a hosted zone? A domain is actually a collection of data describing self-contained administrative and technical unit on the internet, right? So for example, Simplilearn.com is actually a domain. On the other hand, hosted zone is actually an container that holds information about how you want to route traffic on the internet to a specific domain. For example, lms.simplilearn.com is an hosted zone, whereas simplilearn.com is an domain. So in other words, in hosted zone, you would see the domain name plus a prefix to it. LMS is a prefix here. FTP is a prefix. Mail.simplilearn.com is a prefix. So that's how you would see a prefix in hosted zones. Another classic question from Route 53 would be: how does Amazon Route 53 provide high availability and low latency? The way Amazon Route 53 provides high availability and low latency is by globally distributed DNS servers. Amazon is a global service and they have DNS services globally. Any customer doing a query from different parts of the world, they get to reach an DNS server which is very local to them, and that's how it provides low latency. Now, this is not true with all the DNS providers. There are DNS providers who are very local to a country, who are very local to a continent. So they generally don't provide low latency service, right? It's always high latency. It's low latency for local users, but anybody browsing from a different country or a different continent, it's going to be high latency for them. But that's not again true with Amazon. Amazon is a globally distributed DNS provider. It has DNS servers global wide, and like I said, it has optimal locations. It has got global servers, or in other words, it has got servers around the globe, different parts in the globe, and that's how they are able to provide high availability. And because it's not running on just one server but on many servers, they provide high availability and low latency. If the environment that you're going to work on is going to take a lot of configuration backups, environmental backups, then you can expect questions in AWS config. A classic question would be: how does AWS config work along with AWS CloudTrail? AWS CloudTrail actually records user API activity on the account, and any HTTPS access or any sort of access that's made to the cloud environment, that's recorded in the CloudTrail. In other words, any API calls, the time is recorded, the type of call is recorded, and what was the response given? Was it a failure? Was it successful? They also get recorded in CloudTrail. It's actually a log. It actually records the activity in your cloud environment. On the other hand, config is a point-in-time configuration details of your resources. For example, at a given point, what are all the resources that were present in my environment? What are all the resources, or what are the configuration in those resources at a given point? They get captured in AWS config. Right? So with that information, you can always answer the question: what did my AWS resource look like at a given point in time? That question gets answered when we use AWS config. On the other hand, with CloudTrail, you can answer the question, by looking at the CloudTrail, or with the help of CloudTrail, you can easily answer the question: who made an API call to modify this resource? That's answered by CloudTrail. And with CloudTrail, we can detect if a security group was incorrectly configured and who did that configuration. Let's say there happened to be a downtime, and you want to identify let's say there happened to be a downtime and you want to identify who made that change in the environment, you can simply look at CloudTrail and find out who made the change. And if you want to look at how the environment looked like before the change, you can always look at AWS config. Can AWS configure or AWS config aggregate data across different AWS accounts? Yes, it can. Now this question is actually to test whether you have used AWS config or not. I know some of the services are very local, is it? Some of these services are availability zone specific, some of them are regional specific, and some of them are global services in Amazon. And though some of the services are region services, you still can do some changes add some configuration to it and collect regional data in it. For example, S3 is a regional service, but still you can collect logs from all of the regions into an S3 bucket in one particular region. That's possible. And CloudWatch is an regional service, but still you can, with some changes to it, with some adding permissions to it, you can always monitor the CloudWatch that belongs to CloudWatch logs that belongs to other regions. They're not global by default, but you can do some changes and make it global. Similarly, AWS Config is a service that's a region-based service, but still you can make it act globally. We can aggregate data across a different region and different accounts in an AWS config and deliver the updates from different accounts to one S3 bucket and can access it from there. AWS config also works or integrates seamlessly with SNS topic. So, anytime there is a change, anytime the new data gets collected, you can always notify yourself or notify a group of people about the new log or the new config or new edit that happened in the environment. Let's look at some of the database questions. Database should be running on reserved instances. So whether you know that fact or not, the interviewer wants to understand how well you know that fact by asking this question. How are reserved instances different from on-demand DB instances? Reserved instances and on-demand instances are exactly the same when it comes to their function, but they only differ based on how they are built. Reserved instances are purchased for 1 year or 3-year reservation, and in return we get a very low per hour pricing because we're paying upfront. It's generally said that reserved instance is 75% cheaper than on-demand instance, and Amazon gives you that benefit because you're committing for 1 year and sometimes you're paying in advance for the whole year. On the other hand, on-demand instances are built on an hourly price. Talking about autoscaling, how will you understand the different types of autoscaling? The interviewer might ask this question: which type of scaling would you recommend for RDS and why? There are two types of scaling, as you would know now, vertical and horizontal. And in vertical scaling, we can vertically scale up the master database with a couple of clicks. Alright, so that's vertical scaling. Vertical scaling is keeping the same node and making it bigger and bigger. If previously it was running on T2 micro, now we would like to run it on M3, 2 times large instance. Previously it had 1 virtual CPU, 1 gigabit. Now it's going to have 8 virtual CPU and 30 gigabit of RAM. So that's vertical scaling. On the other hand, horizontal scaling is adding more nodes to it. Previously it was running on 1 VM. Now it's going to run on 2, 3, 10 VMs. Right, that's horizontal scaling. So database can only be scaled vertically, and there are 18 different types of instances we can resize our RDS to. Right, so this is true for RDS MySQL, Postgres SQL, MariaDB, Oracle, Microsoft SQL servers. There are 18 type of instances we can vertically scale up to. On the other hand, horizontal scaling are good for replicas. So they are read-only replicas. We're not going to touch the master database. We're not going to touch the primary database, but I can do horizontal scaling only with Amazon Aurora, and I can add additional read replicas. I can add up to 15 read replicas for Amazon Aurora and up to 5 read replicas for RDS MySQL, Postgres SQL, and MariaDB RDS instances. And when we add replica, we are horizontally scaling, adding more nodes, right? Read-only nodes. So that's horizontal scaling. So how do you really decide between vertical and horizontal scaling? If you're looking to increase the storage and the processing capacity, we'll have to do a vertical scaling. If you're looking at increasing the performance or of the read-heavy database, we need to be looking for horizontal scaling, or we need to be implementing horizontal scaling in our environment. Still talking about database, this is another good question you can expect in the interview. What is the maintenance window in Amazon RDS? Will your DB instance be available during the maintenance event? Alright, so this is really to test how well you have understood the SLA, how well you have understood the Amazon RDS, the failover mechanism of Amazon RDS, stuff like that. So RDS maintenance window, it lets you decide when a DB instance modification, a database engine upgrades, or software patching has to occur. And you actually get to decide, should it happen at 12 in the night, or should it happen at afternoon? Should it happen early in the morning? Should it happen in the evening? You actually get to decide. And automatic scheduling by Amazon is done only for patches that are security and durability related. Sometimes Amazon takes down and does automatic scheduling if there is a need for a patch update that deals with security and durability. And by default, the maintenance window is for 30 minutes. And the important point is the DB instance will be available during that event, because you're going to have primary and secondary, right? So when that upgrade happens, Amazon would shift the connection to the secondary, do the upgrade, and then switch back to the primary. Another classic question would be, what are the consistency models in DynamoDB? In DynamoDB, there is eventual consistency read. This eventual consistency model, it actually maximizes your read throughput. And the best part with eventual consistency is all copies of data reach consistency within a second. And sometimes when you write and when you're trying to read immediately, chances that you would still be reading the old data. That's eventual consistency. On the other hand, there is another consistency model called the strong consistency or strongly consistent read, where there is going to be a delay in writing the data, making sure the data is written in all places, but it guarantees one thing, that is, once you have done a write and then you're trying to do a read, it's going to make sure that it's going to show you the updated data, not the old data. You can be guaranteed of it that it is going to show the updated data and not the old data. That's strongly consistent. Still talking about database, talking about NoSQL, DynamoDB or NoSQL database, which is DynamoDB in Amazon. You could be asked this question: what kind of query functionality does DynamoDB support? DynamoDB supports get and put operation. DynamoDB supports, or DynamoDB provides flexible querying by letting you query on non-primary key attributes using global secondary index and local secondary indexes. A primary key can be either a single attribute partition key or a composite partition sort key. In other words, a DynamoDB indexes a composite partition sort key as a partition key element and a sort key element. And by holding the partition key, when doing a search or when doing a query, by holding the partition key element constant, we can search across the sort key element to retrieve the other items in that table. And the composite partition sort key should be a combination of user ID partition and a timestamp. So that's what the composite partition sort key is made of. Let's look at some of the multiple choice questions. Sometimes some companies would have a written test or an MCQ type online test before they call you for the first level or before they call you for the second level. So these are some classical questions that companies ask in their multiple choice online questions. Let's look at this question. As a developer, using this pay-per-use service, you can send, store, and receive messages between software components. Which of the following is being referred here? Let's look at it. Right, we have AWS Step Functions, Amazon MQ, Amazon Simple Queue Service, Amazon Simple Notification Service. Let's read the question again. As a developer, using this pay-per-use service, so the service that we are looking for is a pay-per-use service, you can send, store, and retrieve messages between two software components, kind of like a queue there. So what would be the right answer? It would be Amazon Simple Queue Service. Now, Amazon Simple Queue Service is the one that's used to decouple the environment. It breaks the tight coupling and then it introduces decoupling in that environment by providing a queue or by inserting a queue between two software components. Let's look at this other question. If you would like to host a real-time audio and video conferencing application on AWS, right? It's an audio and video conferencing application on AWS. This service provides you with a secure and easy to use application. What is this service? Let's look at the options. They are Amazon Chime, Amazon Workspace, Amazon MQ, Amazon AppStream. You might tend to look at Amazon AppStream because it's real-time and a video conference, but it's actually for a different purpose. It's actually Amazon Chime that lets you create chat and create a chat board and then collaborate with the security of the AWS services. So it lets you do the audio, it lets you do the video conference, all supported by AWS security features. It's actually Amazon Chime. Let's look at this question. As your company's AWS solution architect, you are in charge of designing thousands of individual jobs which are similar. Which of the following service best serves your requirement? AWS EC2 AutoScaling, AWS Snowball, AWS Fargate, AWS Batch. Let's read the question again. As your company's AWS solution architect, you are in charge of designing thousands of individual jobs which are similar. It looks like it's batch service. Let's look at the other options as well. AWS Snowball is actually an storage transport service. EC2 AutoScaling is introducing scalability and elasticity in the environment, and AWS Fargate is container services. AWS Batch is the one is being referred here that actually runs thousands of individual jobs which are similar. AWS Batch is the right answer. Right, let's look at the other one. You are a machine learning engineer and you're looking for a service that helps you build and train machine learning models in AWS. Which among the following are we referring to? So we have Amazon Sagemaker, AWS Deep Lens, Amazon Comprehend, AWS Device Farm. Let's read the question again. You are a machine learning engineer and you're looking for a service that helps you build and train machine learning models in AWS. Which among the following are referred here? The answer is SageMaker. It provides every developer and data scientist with the ability to build, train, and deploy machine learning models quickly. That's what SageMaker does. Now, for you to be familiar with the products, I would recommend you to simply go through the product description. There's one page available on Amazon that explains all the products, quick, neat, and simple. That really helps you to be very familiar with what the product is all about and what it is capable of. Is it a DB service? Is it a machine learning service? Or is it a monitoring service? Is it a developer service? Stuff like that. So get that information, get that details before you attend an interview, and that should really help to answer or face such questions with great confidence. So the answer is Amazon SageMaker, because that's the one that provides developers and data scientists the ability to build, train, and deploy machine learning models quickly as possible. All right, let's look at this one. Let's say that you are working for your company's ID team and you are designated to adjust the capacity of the AWS resource based on the incoming application and network traffic. How do you do it? So what's the service that actually helps us to adjust the capacity of the AWS resource based on the incoming application? Let's look at it. Amazon VPC, Amazon IAM, Amazon Inspector, Amazon Elastic Load Balancing. Amazon VPC is a networking service. Amazon IAM is an username password authentication. Amazon Inspector is a service that actually does a security audit in our environment. And Amazon Elastic Load Balancer is a service that helps in scalability. That's in one way, indirectly that helps in increasing the availability of the application, right? And monitoring how much requests are coming in through the Elastic Load Balancer, we can actually adjust the environment that's running behind it. So the answer is going to be Amazon Elastic Load Balancer. All right, let's look at this question. This cross-platform video game development engine that supports PC, Xbox, PlayStation, iOS, and Android platforms allows developers to build and host their games on Amazon's servers. So we have Amazon GameLift, Amazon Greengrass, Amazon Lumberyard, Amazon Sumerian. Let's read the question again. This cross-platform video game development engine that supports PC, Xbox, PlayStation, iOS, and Android platforms allows developers to build and host their games on Amazon servers. The answer is Amazon Lumberyard. This Lumberyard is an free AAA gaming engine deeply integrated with AWS and Twitch with full source. This Lumberyard provides a growing set of tools that helps you create an highest game quality applications. And they connect to a lot of games and vast compute and storage in the cloud. So it's that service they are referring to. Let's look at this question. You are the project manager of your company's cloud architect team. You are required to visualize, understand, and manage your AWS cost and usage over time. Which of the following service will be the best fit for this? We have AWS Budgets, we have AWS Cost Explorer, we have Amazon Workmail, we have Amazon Connect. And the answer is going to be Cost Explorer. Now, Cost Explorer is an option in the Amazon console that helps you to visualize and understand and even manage the AWS cost over time. Who's spending more? Who's spending less? And what is the trend? What is the projected cost for the coming month? All these can be visualized in AWS Cost Explorer. Let's look at this question. You are a chief cloud architect at your company, and how can you automatically monitor and adjust computer resources to ensure maximum performance and efficiency of all scalable resources? So we have a CloudFormation as a service, we have AWS Aurora as a solution, we have AWS AutoScaling, and Amazon API Gateway. Let's read the question again. You're the chief cloud architect at your company. How can you automatically monitor and adjust computer resources? How can you automatically monitor and adjust computer resources to ensure maximum performance and efficiency of all scalable resources? This is an easy question to answer. The answer is AutoScaling. Right, that's a basic service and solution architect course, is it? AutoScaling is the service that helps us to easily adjust, monitor, and ensure the maximum performance and efficiency of all scalable resources. It does that by automatically scaling the environment to handle the inputs. Let's look at this question. As a database administrator, you will use a service that is used to set up and manage databases such as MySQL, MariaDB, and PostgreSQL. Which service are we referring to? Amazon Aurora, Amazon Elastic Cache, AWS RDS, AWS Database Migration Service. Amazon Aurora is Amazon's flavor of the RDS service, and Elastic Cache is the caching service provided by Amazon. They are not full-fledged database. And database migration service, just like the name says, it helps to migrate the database from on-premises to the cloud and from one database flavor to another database flavor. Amazon RDS is the service, is the console, is the service, is the umbrella service that helps us to set up, manage databases like MySQL, MariaDB, and PostgreSQL. It's Amazon RDS. Let's look at this last question. A part of your marketing work requires you to push messages onto Google, Facebook, Windows, and Apple through APIs or AWS Management Console. You will use the following service. So the options are AWS CloudTrail, AWS Config, Amazon Chime, AWS Simple Notification Service. All right, it says a part of your marketing work requires you to push messages. It's dealing with pushing messages to Google, Facebook, Windows, and Apple through APIs or AWS Management Console. You will use the following service. It's Simple Notification Service. Simple Notification Service is a message pushing service. Right? SQS is pulling. Similarly, SNS is pushing. Right? Here it talks about a pushing system that pushes messages to Google, Facebook, Windows, and Apple through API, and it's going to be a simple notification system or a simple notification service.
And with that, we have come to an end of this AWS Full Course. I hope it was informative and interesting. If you have any questions about the topics covered in this video, please ask away in the comment section below. Our team will be happy to solve all your queries. Thank you for watching.